everyone, welcome to this video on Python full course. In this video, I will teach you everything you need to know about Python end to end. But before we get started, make sure to hit the like button and subscribe to our channel. You can also hit the bell icon to receive regular updates from our channel. We also have a lot of training programs and certification courses on our website. So if you are interested in them, do check out the links given in the description. Now, before we get started with this video, I would like to first introduce the agenda for today. We will start with Python fundamentals. What exactly is Python? How do you use it? How do you install it and start working with it? And after that, we can see some of the core concepts in Python, like comments, operators, tuple, set, dictionaries, etc. After this, we have loops in Python, where we will discuss some of the commonly used looping structures like while loop, for loop, etc. Next, we will be giving you an introduction to object-oriented programming using Python, and this will be done through Python functions. After that, we will be seeing arrays in Python along with some advanced Python concepts like exception handling, requests, and regex. We will also teach you how to handle files using Python. This will include creating files, deleting files, modifying them, saving them, etc. You will also need to know how to interact with database technologies, right? Like NoSQL, MySQL, etc. This will be covered in Python Databases 101, after which we will move on to Python modules like Numpy, Pandas, Matplotlib, etc. These are very important libraries which you will need to know if you want to get ahead with AI, ML, data science, etc. Now, I really do hope that this video lands you a job. So at the end of this video, I have included a few interview questions and answers. Now, this is pretty much it for the agenda of this video. So let's go ahead and get started with the first topic, which is Python fundamentals.
What is Python? Well, Python is a general purpose programming language which is high level, easy to learn, and dynamically initialized. The development of Python started out as a hobby for its creator, Guido van Rossum, because he wanted to make a language that was beautiful to look at and easy for everybody to read. To do this, he used indentations instead of curly braces to basically describe the blocks of code that came inside the language. The language went on but did not receive love as it was slow compared to the other languages. Now, with the rise of machine learning and artificial intelligence, Python has come into the spotlight, because it makes the work much more productive and much more easy. Why is that? Well, it is because of the amazing computing power that we have. We just want work to be much more productive, even if it takes a lot of time. So that basically wraps up this topic of what is Python. Having that understood, let us move ahead and understand why Python is popular comparing it to the other languages. Python is the best language to get started off with. Its easy syntax and high-level features make it one of the best languages for anybody to get started off with programming. May it be kids or veterans, it is the language for everybody. The next reason is that Python is an open source language, meaning that it is free for anybody to use. Every day, there are thousands of programmers who come together online in making Python better and efficient. You modify the code, you break the code, and you make the code. You're allowed to do it without any problems. Moving ahead, Python can be used to make almost anything. GUI applications, web applications, mobile app server-side coding, artificial intelligence, machine learning algorithms, anything that you want to make, Python will always have the way to do it. Lastly, there is a huge community of people who come together to make the libraries or modules that can be used to obtain your solutions. Just for an example, machine learning algorithms are already available and you can use them to obtain your solutions better. Your productivity right up there. Your code is much more lesser. You can see why people around the world prefer Python so much. Features make a language attractive, and that is what Python is made up of. Features that make anybody want to start coding with it. Let us now see the different features that Python has in store for us. The most well-known feature of Python is its simplicity. Python has made programming fun because it is simple. It makes you think more for your solution rather than the syntax. The next important feature is that Python is an open source language, which means that it is free for anybody to use. Modifications to Python are also allowed without any problems. Which brings us to its next feature, portability. Python supports portability, which means that you can write your code and share it with anybody that you want to, and it would work the same way as it does for you when you run the code. This makes movements of projects and systems much more easier. Our next feature are the embedding properties. Chances are that certain languages may perform certain functions better than Python, but that does not stop you, as Python supports adding code of other languages into itself to run those functions, which makes Python all the more powerful. With that, let us move over to the next feature, interpretation. Python is interpreted line by line, which makes the management of memory and CPU and debugging of the code much more simple. If you wonder by now whether Python is the language to get started off with, let me tell you that it is. Python has a huge library support which would help you to obtain solutions to your problems easier. You can get started off with data science, web development on the go with Python. You may have had questions like how do developers make applications that are so well related to a domain? That is because of object-oriented concepts. Python supports OOPS, meaning that you can model a real-world problem into your code and have security for it such that access to them is restricted, which helps you replicate real-world scenarios. Now that we know all the amazing features that Python has for us, why don't we look at a few of the most well-known companies who use Python? Google is the most known tech giant who uses Python to provide better search features to its users. Dropbox is a cloud platform to save data online. Its client and server applications have been coded using Python. Netflix uses machine learning with Python to learn the taste of its users, cluster them into groups, and then recommend them shows to retain them for longer. The National Security Agency uses Python for cybersecurity analysis and for the encryption and decryption purposes. The BitTorrent application, which is used for peer-to-peer communication, started out as a simple Python file. NASA scientists use Python to perform calculations, which helps them reduce time and makes their work easier. So these are the major companies who use Python. As you may know, Python is a very important language and it would definitely be beneficial if you start learning it. Now you would wonder, how do we get started off with learning Python? Let me help you with that. So to get started off with learning this amazing programming language, you would firstly need the basics, which are variables, data types, and operators, which helps you to understand data and the different data types that you can use, such as numeric, lists, tuples, and so many more. Naming data and performing operations, which can help you to obtain logic or simple addition or subtractions and so forth. Once you understand that, you can move ahead to understand arrays, which can be used to store data in a structured manner. Nextly, understand the flow control working and how you can manipulate it using loops, such as the for loop and the while loop, and conditions, which are the if-else statements. You can then study about how to make methods which are basically used to perform certain functions, which can be as simple as adding numbers to performing the most complex of work that you can think of. Later, learn how files are handled, where you can read data from files and write data to the files. You can then learn about OOPS by understanding classes and objects and what their importance is. And finally, to master it all, you need to practice Python as much as you can, because practice is what makes you better at it. Once you are done understanding the basics, what do? You master it. There are a variety of careers that are at your disposal. Stick to the one that you feel is your goal and start mastering it. Which brings us to the career opportunities that Python holds for us. Web app development is an option that you can choose. You have frameworks such as Django and Flask that can be used to create web applications. Game development is also a career option that is available, where you can create AI enemies and bosses and graphic textures accordingly. Big data analysis is a booming field which can be used to obtain data helpful to make decisions and help take risks for better profits. Web app testing is also an option where you can report bugs and make sure that a website works as needed. Data scientist, machine learning engineer, artificial intelligence are some of the fields that everybody wants to get into, and it is clearly one of the jobs that looks like it would have a long life cycle. Smart IoT devices are another place where you can use Python and build better infrastructure for connecting the world. So those are some of the most well-known career opportunities that Python has for you. There are many more, such as a software developer, automation engineer, and much more.
Python can be obtained from the Python Software Foundation website at python.org. Typically, that involves downloading the appropriate installer for your operating system and running it on your machine. Now to do that, all you can do is open up your browsers and just type in python.org. Go to Downloads and download Python 3.81 for any of the operating systems such as Windows, Linux, Mac OS, or any others. Once you've selected your operating system, just click on Download and you will see that the installer gets downloaded on your PCs. Once the installation is completed, you can run the installer. To do that, just click on the downloaded file. Check the option that says Add Python 3.8 to path. And then click on Install Now. I'm not going to install this right now on my system since I already have Python 3.7 on it. Once the installation is done, just click Finish and you have Python ready to operate on your systems. So now moving on towards the Anaconda installation. Please make a note, guys, that installing Anaconda because I'll be using the Jupyter notebook for all the codes and examples that I'll be showing in this session. So before I actually install this, let me just brief you guys with what exactly is an IDE. IDE stands for Integrated Development Environment. It is a graphical user interface where programmers write their code and produce their final products. An IDE basically unifies all essential tools required for software development and testing, which in turn helps the programmer to maximize his output. Some IDEs are generic, meaning they can support a number of languages such as Sublime Text, Atom, Visual Studio, etc. Language-specific IDEs support a specific language only. They also help you understand when you make syntax errors. Some examples of these are PyCharm for Python, JCreator for Java, RubyMine for Ruby on Rails. Talking about some more important IDEs for Python, it includes Jupyter, Spider, Atom, etc. However, in this tutorial, I'll make use of Jupyter, and therefore, to make use of Jupyter, I'll have to install the Anaconda platform. So in order to install Anaconda, all you can do is go to the official website, that is anaconda.com/distribution. So as you can see over here, I have an option called as Download. When I click on this, you will see that the Anaconda platform is available for Windows, Mac OS, and Linux. Choose the one that will suit your operating system and then click on Download. Here, I'd like to advise you guys to download Python 3.7 version as Python 2.7 has no support anymore. So that was all about the installation. Now moving on towards the naming conventions. Python's naming conventions outline the scheme for naming. Some of these are giving lowercase names to methods, instance variables, global variables, packages, modules, etc. Class names should have the first letter in uppercase followed by lowercase letters. Constants should be completely capitalized. If a name contains two words, it's good to separate those words by an underscore. A single underscore before a name means non-public, and a double underscore tells the Python interpreter to mangle those names of a class so as to avoid a clash with names defined in the other classes. So now moving on towards variables in Python. So what exactly is a variable? In any programming language, a variable is a memory location where you can store a value. The value that you have stored may change in future according to the specifications. Variables in Python can be created as soon as a value is assigned to it. It does not need any additional commands to declare a variable in Python. So now let's move on and take a look at the variable definition and declaration to understand how we declare a variable in Python. To do that, I'll jump onto my Jupyter notebook. So as mentioned earlier, Python has no additional commands to declare a variable. As soon as a value is assigned to it, the variable is declared. Say for example, I have a variable x and I assign a value, say 10 to it. Now the variable x has been declared since I've assigned a value to it. However, there are certain rules that we have to keep in mind while declaring a variable. The variable name cannot start with a number. It can only start with a character or an underscore. Variables in Python are case sensitive. They can only contain alphanumeric characters and underscores. No special characters are allowed for naming variables. So as you can see over here, I've assigned a value of 10 to this variable x. Now in case I want to print this, all I can do is just say print x. To run the code on Jupyter, you can either press Shift Enter or Control plus Enter. When you press Shift Enter, the code gets executed and the command is given to the next kernel. When you press Control Enter, the code gets executed but the command remains in the same kernel. So here I'll just hit Shift Enter, and as you can see over here, I have the value printed as 10. Variables can also hold other values such as float values, string values, etc. So taking a few examples of these, I'll take a new variable, say A, and I'll assign a value of 20.3. I'll take another variable, say B, and I'm going to assign string value to this. I'll just say hello world. So now let me just print out A and B. So as you can see over here, both the values of A and B have been printed. I'll be showing you all the in-detailed functionality of the print function later on in this session. Variables can also be redeclared in Python. This means that you can assign new values to them as and how you proceed with your program. So as you can see over here, I've assigned 10 to X. So in case I want to modify the value of X, all I have to do is just declare X with the new value. So this time, I'll just say X equals Edureka. And now let me print X. So as you can see over here, previously when I printed X, it returned the value 10. Now I've redeclared X with a new value and the new value has been printed. You can either have global or local variables. Global variables are visible throughout the program, but local variables are confined to the class or the function to which they belong. So taking examples of both of these, I'll just take a variable over here, say C, and I'll assign a value to this as hello world. Now I'll create a function over here. I'll just call it as func. However, I'll be discussing about functions later on in this session. So within this function, what I'm going to do is, I'll take the same variable C, and I'll assign a different value to this. Say for example, Edureka. Now, I'm going to run the function I just created as well as print the value of C. So I'll just call the function and then I'll say print C. Just a moment guys, I forgot to print the value of the local variable C. So for that, I'll just say print C. And now I'll run this again. So as you can see over here, the local variable C has returned Edureka, whereas the global variable C has returned hello world. Also, if you can notice over here, I've declared the value of C right in the beginning and then printed it right at the end of this program. This is because global variables are visible throughout the program. In case I remove this print statement from here and just call the function, then the global variable value will not be printed. So as you can see over here, only the local variable's value has been printed. And this local variable is not visible outside the function. So I hope you guys are clear with variables in Python. So now let's move on towards the next topic, which is data types in Python. So before we actually talk about data types in Python, let's discuss about the difference between data types and data structures. A data type is a type of data element defined by the value it holds. Some examples of these are int, float, double, etc. Data structures, on the other hand, deal with data organization, enabling the user to store, access, or modify the data. The important data structures of Python are lists, tuples, sets, and dictionaries. We'll be discussing about the data structures later on, but for now, let's come back towards the data types in Python. The data types available in Python are numbers, Boolean values, and strings. Numbers are nothing but the numerical data types. Numerical data type holds numerical values and it can be divided into integers, floats, or complex numbers. So just to show you guys an example of this, I'll take a new heading. I'll just say data types. Taking an example of the numerical data type, I'll just take a variable, say x, and I'll assign a value to this as 19. So as we all know, 19 is a whole number and this is an integer value. Also, you can assign negative values, say y equal to -4. So what I'm going to do is print out the type of these variables. So I'll just say print type of x and the type of y. So as you can see over here that they belong to the class integer. So as we all know, float values contain decimal numbers. So in case I want to declare a float variable, I'll just take a new variable, say R, and I'll assign some decimal values to this, say 45.6. Now I'm going to print the type of R. So as you can see over here, it says that this belongs to class float. Complex numbers are used to represent imaginary values. Imaginary values are denoted by j at the end of the number. Say for example, I'll take a variable s and I'll assign a value to this as 10 plus 6j. And then I'll just print out the type of it. Let me just copy the statement. And instead of R, I'll say S. So as you can see over here, it has returned that this is a complex number. So now moving on towards the Boolean type. The Boolean data type is used for categorical output since the output for a Boolean is either true or false. Now in order to show you guys an example of this, let me just take a variable, say v, and over here, I'll just take two comparison values, say 2 greater than 6. Once I'm done with this, I'll print out the type of v as well as the value of v. So first I'll print out type. I'll just say type of v. And the value of v. So therefore, it belongs to the class bool and the value is false, which means 2 is not greater than 6. So now talking about strings. Strings in Python are used to represent Unicode character values. Python does not have a character data type. A single character is also considered as a string. String values in Python are declared using single or double quotes. So for an example of a string, I'll just say my string equals Edureka. And then I'll just print out my string. So as you can see over here, it has returned the value of my string. You can also access the values of a string by making use of the index values. So in case I want to access any element that is present in Edureka, what I'm going to do is just type in my string and pass on the index value of the letter that I want to retrieve. So I'll just say 4. So as you can see over here, at index number 4 is E. You can also make use of negative indices. So let's take an example of that as well. So I'll just say my string of -2. So as you can see over here, at index number -2 is A, which means starting from this special character, which is present at -1, A is present at -2. Here, I want you guys to note that positive indexing starts from 0 and increases by 1. Negative indices, on the other hand, start from -1 and move on as -2, -3, etc. So I hope you guys are clear till here. So now moving on towards flow control in Python. Flow control statements basically decide the order of execution of the program, generally accomplished through loops, conditional statements, and function calls. So taking a deep look at each of these, let us first discuss what are loops in Python. Loops allow us to execute a group of statements several times. Suppose you're a software developer and you're required to provide a software module for the employees in your office. For this, you must print the details of payroll of each employee separately. Printing the details of all the employees will be a tiresome task. So instead, you can use the logic for calculating the details and keep on iterating on the same logic statement by making use of the for loop. This will not just save you time, but also it will make your code very efficient. The illustration that you see on the screen is a flow chart for the for loop. The execution starts and then it checks for a condition to be either true or false. Condition over here can be any logic that we want to test in our program. So if it is true, it will execute the body of the loop, and if it is false, it will exit the loop. We shall discuss more about the for loop further on, but for now, let's talk about the conditional statements in Python. Before talking about the conditional statements, let's talk about what are conditions. Conditions in Python are logical conditions which we use in if and else statements. Some of the conditions in Python are the equals condition, not equals, less than or equal to, greater than or equal to. These are the conditions we often use while declaring a test expression for if and the else statements in Python. So what exactly are the if and else in Python? An if statement is used to test an expression and execute certain statements accordingly. Programs can have one or more if statements in them. The subsequent or the penultimate statement that follows is an else statement. This executes a statement in case all the test expressions in the programs are false. To understand the control flow of an if and else statement, take a look at the flowchart of how the execution takes place. So as you can see, the execution starts with a test expression. When this is true, the execution will enter the body of if and execute all the statements present there. But when this expression is false, the execution will move to the body of the else statement and execute the statements in the else block. Just like an if statement, we can also add an else if or an elif statement in Python to test out more expressions in order to optimize the code and increase the efficiency of our code. So now I'll get back to my Jupyter notebook in order to show you guys the syntax of the if-else statements. I'll just create a heading over here. I'll say conditional statements. So like I've already told you all, the if statements come with a test expression. So what I'm going to do over here is just type in the syntax. So it starts with if. So within this, you have the test expression. Now we've entered the body of this if statement. The body of the if condition is going to contain all the statements that are going to be executed if the condition is met. So this will contain all the statements when the condition is met. In case this is not true, and if I have another if statement to be checked for, I can make use of the else if statement. So for that, I'll just write elif, and within this will be test expression 2. So what I'm going to do over here is statements when the else if condition is met. So in case both these conditions are not met, which means if they are false, okay, I'm sorry guys, I just made a mistake over here. Okay. So in case both these conditions are not met, I'll have an else block. So else. And then I'll have the final statements. So I hope you guys have understood this. So now to show an example of this, I'll take another kernel. And over here, I'll just take some variable, say x, and I'll assign a value to this as 12. Then I'll check if the value of x when divided by 3 is equal to 0 or not. So for that, I'll just type in if x mod 3 is equal to 0. I'll just print x is divisible by 3. Else, I'll just copy this print statement and I'll say x is not divisible by 3. So now let me just execute this. So as you can see over here, it says x, which is 12, is divisible by 3. So in case I want to check for this condition to be true for other expressions, what I can do is just add an else if statement. So for that, I'll just say elif x mod 5 equal to 0. I'll say print x is divisible by 5. Let me just change the value of x to a number that is divisible by 5. So now let me just execute this program. So as you can see over here, I have a result saying x is divisible by 5. Now let me take a number that is neither divisible by 3 or 5. So say for example 11. So guys, the else block has been executed, and since I've not made any changes to this print statement, I have the output as x is not divisible by 3. Let me just add on another part of this statement, which is x is not divisible by 3 or 5, and execute it once again. So as you can see over here, the else block has been executed saying x is not divisible by 3 or 5. Let me just explain this once again to you all. So what exactly is happening over here is my variable x holds the value of 11. After this, my program checks if the resultant of x divided by 3 is equal to 0 or not. We all know that if we divide 11 by 3, we're not going to get a whole number, which means the quotient is not going to be 0, and therefore 11 is not divisible by 3. Then my program will enter the else if block. Here it will check if 11 divided by 5 is equal to 0 or not. As we all know, 11 is not divisible by 5, and therefore this block is also omitted. Finally, it gets into the else block. And over here, it prints the final statement. So I hope you guys are clear with this. So now let me take another example and check whether a number is prime or not using the if-else block. So what I'm going to do over here is, I'll take a new variable as a, and I'll assign the value to this as 10. And after this, the first thing that I'll have to do is check if a is greater than 1 or not. So what I'm going to do is type in an if statement. So if a is greater than 1, then I'm going to proceed with the program. So if a is greater than 1, for all the values that are present after 1, I'll have to check if a mod x is equal to 0 or not. So for x, in the range of a, 2, which means starting from 2, I have to go on till a. I will check if a mod x is equal to 0 or not. In case a mod x, which means a divided by x, here the value of x is going to start from 2 and it will go on till 10 without including 10. So the values of x will start from 2 and go on till 9. In case 10 is divisible by any number present between 2 and 9, then a is not a prime number. So what I'm going to do over here is just say print not prime. This way I'll be able to check for all the numbers that are present between 2 to 10. So once this is done, what I'm going to do is just break through this loop. In case this condition is not met, I'll have to type in else, wherein I'll be printing that it is a prime number. So as you can see, my internal if-else loop is completed. Now coming back towards this if statement, which checks if a is greater than 1 or not. So if a is not greater than 1, I'll just print out. So if the value of a is not greater than 1, I'll just inform the user that the value of a is not greater than 1. So I'll just say value of a is less than or equal to 1. So as you can see over here, the value of a that I've given over here is 10. Therefore, when I execute this block of code, I get the output as not prime, which means 10 is not prime. So instead of 10, if I assign the value of a as 1 and execute this program, you see that the output says value of a is less than or equal to 1, which means the final else block has been executed. Now in place of this, if I supply some prime number, say 3. So as you can see over here, when I supplied the value as 3, the output has returned saying that this is a prime number. So I hope you guys have understood this. So now let's talk about the shorthand for if and else. In case you just have one statement to execute or multiple else statements to check for, you can make use of the shorthand if and else. So to show you guys an example of the shorthand notation of if, what I'm going to do is take two variables over here, say a and b, and I'll declare a as 5 and b as 7. Now I'll make use of the if statement. So if a is less than b, I'm going to print a is lesser than b. So previously, if you've noticed, the body of the if statement is starting in the next line with an indentation. In the shorthand notation, you can make use of the statement to be executed in case the condition is met within the same line. So what I'm going to do is just give a space over here and then I'll say print a is less than b. So as you can see over here, my if block has been executed. Similarly, you can also have a shorthand notation for the else statement. Now this is going to be a little different. What I'm going to do is first type in print a is less than b if a is less than b. Else, I'll say print a is greater than b. So as you can see over here, since a is less than b, the if block has been executed. So I hope you've understood the else if blocks completely. So now moving on towards the next flow control statements, that is the for loop and the while loop. So what exactly is a for loop? A for loop is used to execute statements once for each item in a sequence. The sequence can be anything such as a list, a dictionary, a set, or a string. For loops basically have two parts. The block where the iteration statement is specified, and then there is a body which is executed once for every iteration. In a for loop, we actually have to specify the number of iterations that must execute. So let me just get back to my Jupyter notebook to show you guys the syntax of the for loop. Before that, I'll just create a heading and I'll say for loop. So unlike other programming languages, the for loop in Python is a for in loop. So basically, for any iterator variable in the sequence, I will execute the body of the for loop that will have all the statements. So for every iterator present in this sequence, I can execute a single or a number of statements. So just to show you guys an example of the for loop, what I'm going to do is take an example list. I'll just say my list. And I'll give some random values to it. We'll be seeing how to create lists and what are lists further on in this session. But for now, let me just create a list over here. So in case you guys are wondering what exactly is an iterator, a Python iterator is a container having countable number of values. Values in a container can be traversed using the iterators. So in my case, I've taken a list as an iterator over here. Next, I'll just open up the for loop, and for every element that is present in my list, I'll say print that element. So as you can see over here, the for loop traverses each iterable one at a time, and then it executes the body for all the iterables present in my list. So therefore, for every element in my list, I'll print all elements one after the other. So now let me take another example over here. I'll say my string equals hello world. So for every element that is present in my string, I'll print that element. Sorry guys, I missed in over here. Okay. So as you can see, all the elements present in my string have been returned. In case you want to retrieve any specific element, you can make use of the index values. So what I'm going to do is just copy this. And over here, I do not want to return all the values. I just want to return the value present at some index number. Say for example 3, and I'll execute this. So as you can see, at index number 3 is L. In case I want to selectively print a section of the values present in my string, I can make use of the for loop and then slice the values that I want from my string. So for that, I'll just copy this. I'll paste it over here and I'll say print all the values from 0 to 3. So as you can see, from index number 0 to index number 3, I have all the values that are printed. Please make a note over here that it starts from 0, goes on till 3, but it does not print the value present at index number 3. Similarly, in case I want to print all the values that are present after 3, I can slice my string and print all the values that are present after 3. So as you can see, I've not given any value after this colon, which means I want to print all the values that are present after 3. Similarly, you can also make use of negative indices. So I'll just copy this. I'll say print the value that is present at -3. So for our coincidence, the element that is present at -3 also is L. That is because this special character is present at -1, D is present at -2, and L is present at -3. So I hope you guys are clear with this. So now moving on towards the while loop. The while loop executes the set of statements as long as the condition is true. It consists of a condition block and the body with a set of statements. The while loop keeps on executing until the condition becomes false. So in case you want to make use of a while loop, you'll have to keep 3 things in mind. The first thing is to initialize your iterator. The second is to specify the condition. And the third is to increment your iterator. In case you do not increment your iterator, the while loop will go on forever. So what I'm going to do over here is take a small example of the while loop. Before writing down the example, let me just write down the syntax of the while loop. So that is while, some expression, and then the body which contains the statements. So now let's move on towards an example of the while loop. So I'll take an iterator over here, say I, and I'll initiate the value of I to 0. So now my iterator value has been initiated. So this was the first rule for my while loop, which is initializing the iterator. The second is to specify the condition. So I'll just take in the while loop. I'll specify the condition as while the value of I is less than 4, I want to print the value of I. And the last bit of this is to increment the value of this iterator. In case I do not increment this, it will keep on printing the value of I infinite number of times. So I'll just say I plus equal to 1. So I'm incrementing the value of I by 1 each time. So now let me just execute this. So as you can see over here, it prints the value of I unless and until it is less than 4. So therefore, the initial value of I is 0 and the first value in the output is 0 as well. The second value will be taken by incrementing the value of the iterator by 1. Therefore, I becomes 1 and since I is still less than 4, I'll print I. Next, I'll increment the value of I again by 1, which is 1 plus 1 and that will be 2. 2 is still less than 4, therefore I'll print 2. After that, I'll add 1 to 2 again, which will give me 3. The value of 3 is still less than 4. I'll print 3 and then I'll increment the value of I. This time the value of I will be 4. So 4 is not less than 4, which means I'll exit the while loop. So I hope you guys have understood this. So now moving on towards something very important, which is the loop control statements. I'm sure many of you all would have come across the statements such as break, pass, continue, etc. These statements are nothing but the loop control statements. The loop control statements are used to control the flow of the loop or to alter the execution based on a few specified conditions. In Python, we have break, continue, and pass as the loop control statements. The break statement is used to terminate the execution of a loop containing it. As soon as the loop comes across the break statement, the loop terminates and the execution is transferred to the next statement. Here, I'll say for x in Edureka, if x is equal to r, I'll break the loop, which means when I encounter r, I want to break through the loop, and I do not want to continue the loop for the rest of the elements. And then I'll just say print x. And finally, I'll just say print loop has ended. Sorry guys, I just made a mistake in the indentation over here. So as you can see over here, all the elements that are present till r have been returned, which means edu have been returned and then the loop has ended. So now talking about the continue statement. The continue statement is used to skip the rest of the code in the loop for the current iteration. The continue statement, however, does not terminate the loop like the break statement and continues with the remaining iterations. So basically, when a continue statement is encountered, it only skips the remaining loop for that iteration. So let me just try this out over here. So instead of break, I'll say continue. So when r is encountered, the value is skipped, which means when r is encountered, the print statement is not executed. So now talking about the pass statement. The pass statement is a null operation. It basically means that the statement is required syntactically, but you do not wish to execute any command of code. So in case if I change this from continue to pass and add a print statement that is to be printed when r is encountered, I'll just say pass executed. So as you can see, when r is encountered, this print statement is executed and then the loop continues. So talking about nested loops. Python also allows us to use one loop within another. You can use a for loop within a while loop and a while loop within a for loop as well. So to take an example of this, let me just say for x in range of 1, 10, and then I'll take another for loop within this for loop. I'll say for y in the range of x, I'll say print x. So instead of ending this print statement with a next line character, I'm going to use the end parameter as a space character. So for all the values that are present between 1 and 10, each time I take the value and in that range, I'll print the value. So for the first time, I'll have x as 1. So for 1 in the range of 1, I'll say print 1. Therefore, 1 is printed just once. For the second iteration, I'll have the value of x as 2. So for 2 in range of 2, I'll print 2, which means I'll print 2 twice. Now since my output does not look too formatted, what I'm going to do is add another print statement to create some beautiful looking output. So as you can see over here, I've created a number pyramid. So I hope you guys are clear with this. So now let's take an example of a nested while loop. So what I'm going to do over here is take a variable, say a, and I'll assign a list of values to this. So while a is true, what I'm going to do is just print a.pop -1. And then I'll take another variable within this while loop. I'll just say b is equal to some list of string. Let me just take a symbol that will differentiate between these two loops. So next, I'm going to take another while loop and I'll say while b is true, print b.pop of 0. So as you can see, both my while loops have been executed. So I hope you guys have understood this. So next, what I'm going to do is print the Fibonacci series using both the for loop and the while loops. I already have a code for that. So let me just copy it and I'll paste it over here. So as you can see, what's happening over here is I've defined the Fibonacci function, and over here I'm assigning the value of first and second as 0 as 1. Then while this is true, I'm going to yield the value of f. In case you want to know more about the yield function, you can actually check out generators in Python video. So moving on, once the value of f has been returned, which means if the first value has been returned, I'll have to change the value of first as second, and the second will be first plus second. So therefore, first becomes second and second becomes f plus s. Next, I'm taking the for loop for every element that is generated by my function. In case the value of x is less than 50, I'm going to print the value and I'm going to end it with a space character. In case the value of x becomes greater than 50, all I have to do is break the loop. So I hope you guys have understood this. Okay, so now moving on towards the next topic of this session, which is functions in Python. Before discussing what exactly are functions, let's figure out why do we need Python functions. Functions are used to manage inputs and outputs in a computer program. Programming languages are designed to work on data, and functions are an effective way to manage and transform this data. The modifications are generally done to drive outcomes like performing tasks and finding results. The set of operations or instructions required to do so comes from logically functional blocks that can be reused independently from the main program. In fact, the main code is also a function, just a very important one. Every other function is logically aligned and maintained to functionally execute your main code. But if the function has not been defined previously, you'll just have to define one yourself before using it. This is because the function definition lists the steps of operation. So basically, functions are nothing but tasks that the user wants to perform repeatedly. By defining it just once with a name, the user will be able to use the function anywhere in the program. This not just reduces the size of the code, but also helps in debugging. So now coming towards what exactly are Python functions. The functions in Python are classic example of such reusability. So, to serve a wide range of applications from GUI and mathematical computing to web development and testing, Python's interpreter already comes equipped with numerous functions that are always available for the use. Also, you can add on libraries or modules to your program that contain predefined functions readily available for use. So now talking about the types of functions. In Python, you can either have built-in functions, lambda functions, or user-defined functions. So taking a look at each of these in detail. So Python built-in functions. Built-in functions are nothing but the functions that are provided by the Python interpreter. Some examples of these are the print function, the sum function, min-max functions, etc. Now let's get back to our Jupyter notebook and see how you can make use of these built-in functions. The first function that I'll be discussing over here is the print function. I'm sure you all know the print function. Print in Python is a standard function that is used to print the output to the console. Let me just create a heading over here. I'll say functions. To show the syntax of this function to you guys, I'll make use of the help function. So help on the print function will return all the documentation about the print function in Python. So as you can see on the screen, the print function takes a number of parameters. Value is nothing but a value or a set of values that has to be printed out to the console. A separator will decide how the values are separated from each other. The end parameter is used to specify what is to be printed at the end of the output. Default value for the end parameter is /n, meaning next line. Next is the file parameter. This is an optional parameter which comes with a write method. The default value of this is sys.stdout. Flush is also an optional parameter that is used to specify if the output has to be flushed or is it to be buffered. If the output has to be flushed, the Boolean value will be true, and in case if it is buffered, the Boolean value will be false. The default value for this is false. So now let's take a few examples of the print function. So the first thing that I'll print is hello world. Next, I'll take the same function and over here, I'll print it as two different strings. What I can also do is add a plus sign in between this. So I'll just copy this and I'll add a plus sign over here. So as you can see over here, the first statement is printing the hello world string as it is. In the second statement over here, I'm printing hello world as two different strings. In the third example, I've made use of a plus operator, which means I want to add the first string to the second string. I can also add in some numerical values, say 2020, and then print it. So here it is, hello world 2020. Now what do you mean by a separator? In case you want to use a separator, what you have to do is I'll just take this example, and instead of separating them by a space, let me separate them by something else. So I'll just say separator should be a hyphen. Okay, so as you can see over here, in place of a space character, I've got a hyphen. So if I have two print statements, one after the other, I can change the end parameter from next line to something else. So what I'm going to do is, I'll say hello world, Edureka. And in the first print statement, I'll make use of the end parameter and I'll specify it to be a dashed line. So as you can see over here, the outputs of both these print statements have been printed in the same line, but they are separated with this dashed line over here. So I hope you guys are clear with this. So now let's talk about the min-max functions. The min-max functions are also built-in functions that are present in Python. So in case I have a list of values, say A, and if I want to find the minimum and the maximum of this, all I can do is make use of these functions directly. So I'll just say print the minimum of A and the maximum of A. So as you can see over here, the minimum value that's present in A is 1 and the maximum value present in A is 7. Another commonly used function of Python is the sum function. This function will return the sum of all the iterables that are given as a parameter to it. So I already have my list over here as A. I'll just say sum of A. So as you can see over here, it has summed up all the values present in my list and it has returned the value as 28. One more thing I want you guys to note over here is the sum function actually has two parameters. Now to show that to you guys, let me just type in help for the sum function. So as you can see over here, the sum function has two parameters, which is the iterables and the start. Iterables over here is the sum of iterables whose value needs to be summed up. The second parameter is the start parameter, which is by default 0, meaning the sum of all the iterables should be added to 0. So it will be 0 plus sum of all the iterables. In case I specify some value to the start parameter, it is going to add that value plus the sum of all the iterables. So in the previous example, if I have sum of A, 10, it's going to add 10 plus 28 and return the amount. So as you can see over here, it has returned 38, which is 28 plus 10. So I hope you guys have understood this. So now moving on towards the next topic, which is Python lambda functions. Python lambda functions are functions that do not have any name. They are also known as anonymous or nameless functions. The word lambda is not a name, but it is actually a keyword. This keyword specifies that the function that follows is anonymous. How do you actually write lambda functions in Python? A lambda function is created using the lambda operator. Okay, so now let me just type in the syntax of a lambda function. So basically, it will be the lambda keyword, followed by the arguments, and then the expression. Here, arguments are nothing but the variables that are used with this lambda function. expression is a mathematical expression that will decide the output. Lambda functions can take any number of arguments, but they can take just one expression. Arguments can be anything starting from 0, and there is no upper limit. Just like any other function, it's perfectly fine to have lambda functions with no inputs. So now let's just take an example of a lambda function. So I'll just take a variable a, and now I'll make use of the lambda function. I'll just take one argument for the first example. I'll say lambda x, return x star x. And now I'll say print a of 3. So as you can see over here, I've got the output for x star x when a is 3, and therefore the output is 9. Let me take another example with 2 arguments. I'll just say b equal to lambda x comma y, and I'll say print x plus y. I'll pass the parameters for x and y as 1 and 2. I'm sorry guys, instead of taking b of 1, 2, I took a of 1, 2. So here it is. I found the result for x plus y, which is 1 plus 2, and that is 3. So I've taken 2 examples over here, but please make a note that both the functions have a single expression. So now moving on towards user-defined functions. Functions that we define ourselves in a program in order to achieve some tasks is referred to as a user-defined function. So the syntax for a user-defined function will be the def keyword followed by the name of the function and then the arguments. You can have any number of arguments, then comes the body of this function. The body of this function can have any number of statements, so I'll just write statement 1, 2, etc. So as you can see over here, the first thing that you'll have to do is make use of def keyword. Now this keyword will actually help you to define your own function. Next up will be the name of the function. Then you'll have to pass in the arguments of your function, which can be any number of arguments starting from 0. The body of the function can have any number of statements in them. So now let's move on and create some user-defined functions. So what I'm going to do over here is create a function to add 2 numbers. So I'll just say define add function. I'll specify the parameters as x and y. And I'll just say the sum is equal to x plus y. And I'll return the value of sum. After this, I'll just have to call the add function and pass the values of x and y. I'll say 2, 4, and I'll run this. So as you can see over here, I have the output for 2 plus 4, which is 6. So now that you've seen what are user-defined functions as well as lambda functions, let's take a small example wherein you can make use of the lambda function within a user-defined function. So what I'm going to do is define a function over here, say new function, and to this, I'll just give one parameter as x. Now this function will just return one statement, that is the lambda function. The arguments for this function will be y, and I'll specify the expression as x star y. Now take a new variable, say t, and now I'll have to call the user-defined function, which is new function. What I'm going to do is just print t of 5. So as you can see over here, my function takes one parameter as 3. So x over here is 3 and y is 5. Now if you're wondering why 3 is assigned to x and 5 is assigned to y, this is because I'm specifying 3 as the parameter of my new function. Then within this function, I've made use of the lambda function, which takes one parameter. Therefore, this parameter is supplied the value as 5. So I hope you guys are clear with this. So now moving on towards the next very important topic of this session, which is data structures in Python. So what exactly is a data structure? Data structures allow you to organize your data in such a way that enables you to store collections of data, relate them, and perform operations on them accordingly. Python has implicit support for data structures, which enables you to store and access data. These special data structures of Python are nothing but lists, dictionaries, tuples, and sets. Python allows users to create their own data structures as well. The most prominent data structures of this section are stacks, queues, trees, linked lists, and so on. So now talking about the built-in data structures of Python. Lists. Lists are used to store data of different data types in a sequential manner. There are addresses assigned to every element of a list, which is called as the index. The index value that starts from 0 and goes on until the last element is called as the positive index. Negative indexing starts from -1, that is, from the last element that is present in your iterable. Therefore, positive indexing starts from the left-hand side and moves towards the right-hand side. whereas negative indexing starts from the right-hand side and moves towards the left-hand side. So now let's get back to our Jupyter notebook and see how to create lists in Python. To create a list in Python, you can make use of the square brackets and add elements in it accordingly. In case you do not pass any values, the list is going to be empty. So I'll just take a new list over here and I'll assign some random values to it. Okay, I'll take another list. I'll say my list. And I'll not assign any value to this. Then I'll just print the values of both these. So as you can see over here, new list contains a list of elements starting from 1 to 7 and my list is empty. Not just this, you can also make use of the list function to create a list. So I'll just take a new variable, say a, and I'll say this is equal to list of, I'll specify an empty list. Now let me just print out a. So as you can see over here, I've created an empty list making use of the list function. Now since lists are mutable, you can add on values or delete values from lists. In order to add elements to a list, you can make use of the append, extend or the insert functions. The append function can be used to add a single element to your list. The extend function will add a number of elements one after the other to the list. The insert function, on the other hand, will insert an element at a specified index value in your list. So let's take an example of all these three. So I'll just say a.append and I'll specify a value, say 3. Next, to new list, I'll add on a number of values. I'll say new list.extend and I'll give a list of values. Also, I'll make use of the insert function. I'll say new list.insert. I want to insert the value at position 2. And here, I'll insert a string. I'll say Edureka. Now let me just print all these. I'll print a. So as you can see, previously a was empty, but after making use of the append function, I've added 3 to my list. So now in case I want to see what's present in new list, I'll just say print new list. So as you can see, 9 and 10 have been added to the end of my list. And Edureka has been inserted at index number 2. So 1 is at index number 0, 2 at index number 1, and Edureka is present at index number 2. So that was about adding elements to a list. Elements can also be deleted from a list. In case you want to delete elements from a list, you can either make use of the pop function, the remove function, or the delete keyword. Now let's take an example of each of these. For my new list, what I'm going to do, I'll say new list.pop of 2. And then I'll say print new list. As you can see over here, the value that's present at index number 2 has been removed from my list over here. On the other hand, if you make use of the remove function, you have to specify the value to be removed instead of the index number. So over here, I'll say new list.remove and I'll specify the value to be 10. And then I'll just print it. So as you can see, 10 is not present in my list anymore. Similarly, if I make use of the del keyword, I can delete some element that is present at some particular index number. I'll say delete new list of 5 and then print new list. So as you can see over here, the element that is present at index number 5 has been removed. Elements of a list can also be accessed by using the for loop. So in case I want to access all the elements that are present in new list, all I have to do is use the for loop. So for x in new list, I'll say print x. So as you can see, all the elements have been returned one after the other. You can also slice the new list from some particular range. So I'll just print all the elements that are present after index number 2. Sorry guys, I said I want to print all the elements that are present after 2, but here I specified :2, which means I've printed all the elements starting from the index number 0 to 2. There are a number of other functions that you can also use, which is the length function to find the length of the list, the index function which finds the index value of the value passed as a parameter and the first occurrence of it. the count function, which finds the count of the value passed to it. You can also sort the list by making use of the sorted or the sort functions. So now moving on towards the next data type, which is a dictionary. Dictionaries are used to store key value pairs. To understand it better, think of a phone directory where hundreds and thousands of names and their corresponding numbers have been saved. Here, names will be the keys and the phone numbers will be the value pairs for that keys. In Python, dictionaries can be created using the flower brackets. You can also create them by making use of the dict function. So now let's get back to our Jupyter notebook and create some dictionaries over here. I'll just take a variable, say A, and then I'll open the flower brackets. I'll take the keys as numbers. So I'll just say 1 is hello and 2 is world. And then I'll just print out A. In case you do not specify any parameters, an empty dictionary will be created. So I'll just take an example of that over here. I'll say B is equal to flower braces, and then I'll print B. So as you can see over here, an empty dictionary has been created. You can also create dictionaries by using the dict function. So I'll just say C is equal to dict of, and I'll copy the same thing. So as you can see over here, I've created a dictionary by making use of the dict function. So now let's move on and see how you can actually change and add values to dictionaries. Values of a dictionary can be changed by using keys. So the first thing that you'll have to do is access the key and then change the value accordingly. So in case I want to change the value of 2 over here, what I'm going to do is C of 2 is equal to Edureka. And then I'll print C. So as you can see over here, the value for 2 has been changed from world to Edureka. In case you want to delete items from a dictionary, you can make use of the pop function, the pop item function, or the clear function. The pop function will return the value that has been deleted. The pop item function will return a tuple of the key and the value. To clear the entire dictionary, you can make use of the clear function. So let me just show you an example of this. I'll say c.pop, the value present at index number 1. So as you can see over here, hello has been removed from my dictionary. In case I make use of the pop item function, it's going to return both the key value pair. So as you can see over here, the pop item function has returned both the key value pair that has been removed. Now my dictionary is empty. In case I want to delete this dictionary, I can make use of the clear function. So I'll just say c.clear. My dictionary is already empty and I don't actually have to make use of this function. I just typed this function over here to show you guys how to use it. The values of a dictionary can also be accessed. Now to access the values, you'll have to make use of the keys only. To do this, you can either make use of the get function or directly specify the name of the key. I'll just create a new dictionary over here. I'll say D is equal to 1 is to Python, 2 is to Java, and 3 is to C#. Now, I want to retrieve the values that are present for the keys 2 and 3. So what I'm going to do is use the print function, and within this, I'll specify the name of my dictionary, and then in the first example, I'll just specify the key value, and in the next example, I'll make use of the get function. I'm sorry, guys, I've not executed this line over here. So as you can see over here, the value present for key 2 is Java, and that for key 3 is C#. So now talking about tuples. Tuples are actually the same as lists, but with one exception, that the data once entered into a tuple cannot be changed no matter what. To create a tuple in Python, you can make use of the regular brackets. You can also create a tuple by making use of the tuple function. I'll just create my tuple. And in the first case, I'll create an empty tuple. Next, I'll create another tuple, say Z, and I'll assign some values to this. I'll take another variable Y, and then I'll make use of the tuple function in order to create a tuple. Now let me just print out each of these. I'm sorry guys, I've missed regular braces over here. So as you can see, an empty tuple has been created, followed by a tuple using the regular braces, and then a tuple making use of the tuple function. Like I've already told you all before, you cannot alter the values of a tuple. So in case I use any function such as an append function with a tuple, it's going to throw an error. So now just to show this to you all, I'll say y.append, I'll say 3. So as you can see over here, it has thrown an attribute error saying tuple object has no attribute append. In case you want to access the elements of a tuple, all you have to do is make use of a for loop. So I'll say for I in y, print I. So as you can see, all the elements of the tuple have been retrieved. One more thing I want you guys to note over here is that in case you want to add on some elements, you can make use of the plus operator. So now moving on towards the next data structure, which is a set. Sets are a collection of unordered elements that are unique, meaning that even if the data is repeated more than one times while specifying the values, the set data type is just going to take one entry of that element. Sets in Python actually resembles the sets that you've learned in arithmetic. The operations are also the same, such as intersection, difference, union, etc. To create sets in Python, you can make use of the flower braces, and instead of adding the key value pairs, you just have to specify the values. Now let me just get back to my Jupyter notebook and show you all how to create sets in Python. Like I've already told you all, sets are created by making use of the flower braces. I'll just take a variable over here as x, and to this, I'll specify some values. And then I'll just print the set. So as you can see over here, I supplied 8 values, but only 5 values are present in my set. Now this is because I have 3 repeated values, and those values are not printed again in my set. In case you want to add some values to a set, you can make use of the add function. So I'll just say x.add, and I'll pass the value as 8. Now let's just print out x. So as you can see over here, 8 has been added to my set. You can perform many operations on set, such as intersections, unions, difference, etc. Now what I'm going to do is define another set over here. I'll say y. Y is equal to some random values. So in order to find the union of x and y, I can either use a pipeline character or make use of the union function. In case I just want to find the union of x and y, I'll say z is equal to x pipeline y. And then I'll print z. Sorry, I've taken cap C over here, which is small actually. So as you can see, I have the union of x and y present in z. Similarly, I can also make use of the union function. To do that, I'll just make use of the print function, and then I'll say x union y equals x dot union of y. So as you can see over here, I found the union of x and y. Similarly, you can also make use of the difference function, the intersection function, etc. So let me just change this from union to intersection and see what happens. So as you can see over here, I changed the value from union to intersection, and therefore I found the intersection of x and y. I'll just have to make a change over here as well. Okay, so I hope you guys are clear with this. So that was about the built-in data structures of Python. Now moving on towards the next topic, which is user-defined data structures. User-defined data structures can either be arrays, stacks, queues, trees, linked lists, graphs, or hash maps. An array is basically a data structure which can hold more than one value at the same time. It is a collection or ordered series of elements of the same type. We can loop the array easily and fetch the required values by specifying index numbers. Arrays are mutable, which means they are changeable, and therefore we can perform various manipulations operations as required. Stacks are linear data structures which are based on the principle of last in, first out. Here, the data which is entered last will be first to get accessed. It is built using the array structure and has operations namely pushing or adding elements, popping or deleting elements, and accessing elements only from one point in stack, which is called as the top. This top is a pointer to the current position of the stack. Stacks are prominently used in applications such as recursive programming, recursive words, undo mechanisms, in word editors, undo mechanisms in word editors, and so forth. Queues. A queue is also a linear data structure which is based on the principle of first in, first out. Here, the data entered first will be accessed first. It is built using the array structure and has operations which can be performed from both ends of the queue, that is, the head, tail, order, and back. Operations such as adding and deleting elements are called as enqueue and dequeue. Queues are used as network buffers for traffic congestion management, used in operating system for job scheduling, and many more. Trees are nonlinear data structures which have roots and nodes. The root is a node from where the data originates, and the nodes are the other data points that are available to us. The node that precedes the parent and the node after is called as a child. Levels of a tree shows the depth of information. The last nodes are called as the leaves. Trees create a hierarchy which can be used in a lot of real-world applications as HTML pages which use trees to distinguish tags that come under the same block. It is also efficient in searching purposes and much more. Linked lists. Linked lists are linear data structures which are not stored consequently but are linked with each other using pointers. The node of a linked list is composed of data and a pointer called next. These structures are most widely used in image viewing applications, music player applications, and so forth. Graphs. Graphs are used to store data collection of points called as vertices and edges. Graphs can be called as the most accurate representation of real-world map. They are used to find the various cost to distance between various data points called as the nodes and hence find the least path. Many applications such as Google Maps, Uber, and many more make use of graphs to find the least distance and increase profits in the best ways. Hash maps. Hash maps are the same as what dictionaries are in Python. They can be used to implement applications such as phonebooks, populate data according to lists, and much more. So now let's move on and discuss what are algorithms in Python. Algorithms in general are rules or instructions that formulate in finite sequential order to solve problems and get the required results. Give us pseudocode for problems and can be implemented in several languages as they are not language specific. How do you write algorithms? Algorithms are generally written as a combination of user understandable language and some common programming languages. They are commonly written in steps. However, it is not always necessary to do so. There are no distinct rules to formulate algorithms, but you will need to keep the following points in mind. Figure out what exactly is the problem, determine where you need to start and determine where you need to stop. Formulate the intermediate steps, and finally review your steps. Say for example, if you have to formulate an algorithm to check if a student has passed in an exam or not. So after you start, you're going to declare two variables, say x and y, and then you're going to store the marks obtained by the student in x and store the minimum passing score in y. Then check if x is greater than or equal to y. If yes, then return pass, else return fail. And finally, you'll have to stop. So this is an example of an algorithm to check if a student has passed or failed. However, you can manipulate the steps according to your preference. For example, you can assign values to both variables x and y in a single step rather than two steps. So this way, a single problem can have multiple solutions and depends on the problem and programmer to choose the most feasible and reliable solutions. So now, let's understand what are the elements of the algorithm. Good algorithms need to have finite, clear, and understandable steps. There should be a clear and precise description of the input and the outputs. Each step needs to have a defined output that depends only on the inputs in that step or the preceding steps. The algorithm should be flexible enough to mold and allow a number of solutions. The steps should make use of general programming fundamentals and should not be line-specific. So what are the classes of algorithms available for programming? The three major algorithm classes are divide and conquer class, dynamic programming, and the greedy algorithm class. The divide and conquer class divides the problem into subparts and solves each of them separately. Talking about dynamic programming, it divides the problems into subparts, remembers the results of subparts, and then applies to similar ones. This way, there will be less number of repetitions when compared to divide and conquer method. Greedy algorithms involve taking the easiest step by solving a problem without worrying about the complexity of the future steps. So now let's move on and take a look at the important algorithms such as tree traversal algorithms, search algorithms, and sorting algorithms in Python. The first I'll be discussing in this session is the tree traversal algorithm. Trees in Python are nonlinear data structures having a root and node as mentioned earlier. Tree traversal refers to visiting each node in a tree exactly once in order to update or check them. So based on the order in the nodes are visited, there can be three types of traversal, that is pre-order traversal, in-order traversal, and post-order traversal. Before moving on in detail about each of the algorithms, what I'm going to do is jump on my notebook and create a tree that you see on your screens. I'll create a heading here, and I'll just call it as tree traversal. So like I've already told you all, I'll be writing down the code to create a tree first. So for that, let me just create a heading. This will be an h2, so I'll have to have two hashes, and then I'll just say creating the tree. So the first thing that I'm going to do here is define a class called node. So class node. In case you have any issues understanding classes and objects, don't worry guys, because I'll be discussing each of this in detail later on in this session. So for now, I'm just defining a class within which I'll define a function, that is the init function. And then the mandatory parameter, which is self, followed by the value parameter. Now this self parameter will allow me to access the variables of this class. All the details about classes and the self parameter I'll be discussing later on in this session when we go on to oops in Python. So for now, I'll just write self.leftChild, or I'll just say LC, equals none. Now I've specified none over here because right now there is no left child. The first value should be assigned to the root node. And therefore, the left child and right child will contain nothing, and therefore I'm assigning none to it. Similarly, I'll write self.rightChild equals none. Finally, self.nodeData will be equal to value. So now let's move on and create an object of the class. So I'll just call the object as root. And you guys have seen already that in my tree, the first root or the root node is 1. So therefore, I'll assign a value as 1. So once this is done, I'll have a root node that's created. So once the root is created, I'll have to create the left child and the right child for it. So now what I'm going to do is root.leftChild will be equal to node of 2. And root.rightChild will be node of 3. So in my tree, the node 2 has another left child and a right child. So to create that, what I'm going to do is write down root.leftChild is equal to node 4. And finally, the right child of node 2 will be node 5. So I hope you guys are clear with this. Let me just draw this and explain this to you guys. So at the first step, I'll have my root node that is created, and that will be node 1. Following that, I'll have a left child of this node, so that will be 2. And then a right child will be created for 1, that is 3. Now again, node 2 will have 2 childs, because left child will be node 4 and right child will be node 5. So I hope you guys are clear with the concept. So now let's erase this drawing. So now let's move on and see how you actually do the in-order traversal. In-order traversal refers to traversing tree in such a way that you first visit the left nodes, followed by the root and then the right nodes. You begin your traversal from all the nodes in the left subtree, then move towards the root and finally the right subtree. So you have to implement the in-order traversal over here. What I'm going to do is, I'll just create a heading, I'll say in order. Since I have my base tree already created over here, all I'm going to do is just define the in-order function. So the first step of in-order traversal will be to traverse through the nodes present in the left subtree. Then at step 2, I'll have to visit the root and finally the right subtree. So now I'm going to define a function. I'll call it as in order. And then I'll pass a parameter as root. So if a value for root is present, what I'm going to do is call the in order function. And over here, I'll first visit the left child, so root of left child. And then I'll print the value for the root. Okay, sorry guys, if root, I just missed that. So once I visit the left child and the root, I have to visit the right child. So I say in order of root dot right child. After this, I have to call the in order function. So in order of root. So as you can see over here, the in order traversal starts from 4, moves on to node 2, then 5, 1, and 3. So in this tree over here, for the in order traversal, it will start from the leftmost node. And the leftmost node in my tree is node 4. So it starts from 4, then it moves towards the root, and finally the right node. Once I'm done with 4, 2, and 5, my left subtree is completed. Once the left subtree is completed, I'll have to apply the same formula again, which is left, root, right. So therefore, I'll visit node 1, which is the root node, and finally visit root 3, which is the right node. So I hope you guys are clear with this. Okay, so now moving on towards the next traversal, which is the pre-order traversal. In the pre-order traversal, the root node is visited first, followed by the left subtree and then the right subtree. So in this example over here, I'm going to visit the root node first, which is 1, then come towards the left subtree, following which I'll move towards the right subtree. Therefore, the order will be 1, 2, 4, 5, and 3. Now let's get back to our Jupyter notebook and implement this. So I'm going to define a function, that is the pre-order function. And I'll pass root as a parameter. So if root is present, I have to first print the value of the root node. So root.node data. And then I'll have to do the pre-order for the left child first. So root.left child. And then pre-order for the right child. So once this is done, I'll just have to call the pre-order function. So as you can see over here, the first node to be visited is the root node 1, followed by the left subchild 2, and then the left subchild of 2, which is 4. And then I'm going to visit root 5, which is the right subchild of 2. And finally, when the root and the left subtree is done, I move on towards the right subtree, which contains 3. Okay, so I hope you guys are clear with this. Okay, so now let's move on towards the next topic, which is the post-order traversal. The post-order traversal begins from left, then to the right, and finally the root. So in this example over here, what I'm going to do is start from 4, move on towards 5, 2, 1, and 3. Now this is because 4 is the leftmost child, and at this stage, I apply the left-right root formula. So my program is going to check if I have a right node. Towards the right of 4 is 5. I traverse 5 or I visit 5, and then when I've completed 4 and 5, I go to root node, which is 2. Once the left subtree is completed, I have to move towards the right subtree and then traverse it. In my right subtree, I just have one node, which is 3. And after I complete the left subtree and the right subtree, I apply the left-right root logic again, and then I visit the root, which is 1. Okay, so I hope you guys are clear with that. So I'll get back to my notebook in order to implement this. So what I'm going to do is just define a function, that is pre-order, post-order, and I pass the root as the parameter. The first thing that I'll have to do is visit the leftmost child. So for that, I'll just do a post-order for the left child. So root.left child, and then post-order of the right child. Finally, I'll have to print the value of root node. Once this is done, I'll call the post-order function, and I'll pass root as its parameter. Seems like I've made a mistake. Sorry guys, I just missed the if statement to check if root is present or not. If the value for root is present, only then I'm going to do this. So let me just type in a tab for all this, and then I'll execute it. So here it is. My left subtree is visited first, then followed by the right subtree, and then 1, which is the root node. So I hope you guys have understood all of these 3 traversals. So now moving on towards the next algorithm, that is the sorting algorithms. Sorting algorithms are used to sort data in some given order. Sorting algorithms can be classified as a merge sort, bubble sort, insert sort, selection sort, or shell sort. Please take note guys, in this session, I'll be sorting everything in the ascending order. So the first algorithm I'll be discussing in this session is the merge sort algorithm. The merge sort algorithm follows the divide and conquer rule. Here, the given list of items is first divided into smallest until it reaches a point where each list consists exactly of one item. By default, a list consisting of one item will be sorted, and the merge sort algorithm then compares adjacent lists and reorders them in the desired sequence. This process is in repository until it reaches the point where there exists only one sorted list. So let's create a heading over here. I'll call it as sorting algorithms. Or I'll just say sorting. The first algorithm discussing merge sort, so let's call it as merge sort. I already have code ready for this. I'll just copy that code and explain this to you all. So as you can see on the screen, the first thing that I've done over here is defined a merge sort function. Now this function will check if the length of the list is greater than 1 or not. And if this is true, it's going to divide the list by 2. Following that, I'm going to sort both the left half and the right half recursively. Finally, I'll create a new list that contains the sorted elements. So over here, I called an mlist function but not defined. The next thing I've done over here is defined mlist function. The first thing that I've done over here is defined what is left list and what is the right list. Left list contains all the elements from left to middle, and the right list contains all the elements from middle to right. Following that, I've taken 3 variables k, I, and j, where k is the temporary variable that I'm using to fill out my final list. I and j over here help me to get rid of the left list and the right list. So while my left list and my right list contain elements, that is when they're not empty, what I'm going to do is, if the value of the item present in the left list is less than or equal to the value of element that is in the right list, I'll place the element present in the left list into my sorted list. Else, I'll place the item present in the right list in my sorted list. So if the value of left list of I is less than the value of right list of j, I'll place the value of left list of I into k. Else, I'll place the value of right list of j into my list of k. If I place the value of left list of I into my list of k, I'll have to increment the value of I, or else if I place the value of right list of j into my list of k, I'll have to increment the value of j. Finally, when I've placed some value for k, I'll have to increment the value of k as well. So once I have all sorted elements, what I have to do is start merging my list. The final part of my program will help me to merge the sorted sublists. If that is true, all I have to do is swap the elements. So a of y will become a of y plus 1, and a of y plus 1 will become a of y. So as you can see, I've given some random list over here. In this case, the length of this list is 4. Therefore, the value of b will be 3. So for every element present in the range of 3, I'm going to take that element and check if that element is greater than the element that is present towards the right of it. So first, I'll take 3 and check if it is greater than 6. Since 3 is less than 6, I'm not going to swap these values. Next, I'm going to check if 6 is greater than 1 or not. So as we all know 6 is greater than 1, I'm going to place the value of 1 in place of 6, and I'll place 6 in place of 1. Therefore, 6 and 1 will be swapped, and my list will contain 3, 1, 6, and then 8. For the next iteration, I'll check if 6 is greater than 8. So as we all know, 6 is less than 8, therefore they will not be swapped. So for the second iteration, my list is going to look like 3, 1, 6, and 8. Next, I'll have to perform bubble sort on this list again. So what my algorithm will do is check if 3 is greater than 1 or not. Since 3 is greater than 1, the position of 1 and 3 will be swapped. And my list is going to look like 1, 3, 6, and 8. In the next iteration, my program will check if 3 is greater than 6 or not. As we all know that these are already sorted, they will not be swapped. This process is repeated until the complete list is sorted. So I hope you guys have understood the bubble sort program. Okay, so now moving on towards the next, that is the insertion sort. Insertion sort picks up one element of a given list at a time and places it at the exact place where it's supposed to be. Since I already have a program for this, I'll just copy it over here and explain it to you guys. So what I'm doing over here is, first, I'm going to place my pointer at the second element. So whatever input list I have, I'm going to place the pointer at the value that's present at index number 1. Now to do that, I've made use of this for loop. So for x in the range of 1, the length of a, which is the element present at 2, and throughout the length of a, I'm going to set the element present at a of x as the key, and then I'll store the value of j as x minus 1. So in the first case, k will be 56. So 56 is going to be k. And j will be 1 minus 1, so that is 0. So in the first case, k is 56 and j is 24. The next thing I'm going to do is check if j is greater than or equal to 0. Here in the first case, j is equal to 0. So therefore, the first half of the while loop is true. The next thing to be checked if k is less than a of j. So if the value present at k, which is 56, is less than the value present at a of j, which is 24, I'll have to swap these elements. Now since these elements are already sorted, I'm not going to do that. Now once that is done, I have to decrement the value of j. Now this step is done because I'll have to check the value of the key with all the elements that are present in the left sublist. In the first case, I just have one element present towards the left side. But for the second iteration, I'll have two elements present. So therefore, if I do not decrement the value of j, I'll not be able to check this value with all the values that are present towards the left of it. So finally, I'll place the value of a of j plus 1 into k, and then I'll move on towards the next value of x, which will be index number 2. So I'll just erase this. After the first iteration of my program, the list is not going to change since the value of 56 is greater than that of 24. For the next iteration, I'm going to make 1 as the key element since it's present at index number 2. So 1 will become the key, and the value of j will be 56 and 24. Now this is because 56 is present at a of 1 and 24 is present at a of 0. And for all the values that are greater than or equal to 0, I'll have to check if the value of the key is less than that or not. So I know that 1 is less than 56 and 24. So what I'm going to do is just remove 1 from here. Repeat. And then I'll place 56 in place of 1. I'll place 24 in place of 56. And finally, I'll place 1 in place of 24. So for this iteration, I'll have 1 followed by 24 and then 56, which is my sorted list. And for the unsorted list, I have 50 and 17. So once this is done, what I'm going to do is take the next element as the key, which is 50. When 50 becomes the key, I'll have to check this key with all the values that are present in the left side. So I know that 50 is less than 56 but greater than 24. So therefore, I'm going to shift 56 to the place of 50, and I'll place 50 in place of 56. After this, I'll have a list looking like 1, followed by 24, then 50, and 56. And in my unsorted list, I'll have just one element, which is 17. Finally, I'll take 17 as the key, and then I'll check this key value with all the elements present towards the left of it. Since I know that 17 is less than 56, it's less than 50 and less than 24, what I'm going to do is place 56 in place of 17. 50 will come to the position of 56. 24 will come to the place of 50. And finally, 17 will be placed in the place of 24. So I hope you guys are clear with this. Even though there's a lot of mess on the screen, I hope you guys have understood this. Okay, so let me just erase that for now and execute this problem. So as you can see on the screen, I've sorted my list in the ascending order. So now moving on towards the next, which is the selection sort algorithm. The selection sort algorithm divides a given list into two halves, where the first half will be sorted list and the second half will be an unsorted list. At first, the sorted list is empty and all the elements are present in the unsorted list. The selection sort algorithm will look at all the elements present in the unsorted list, pick up the element that is supposed to come first, and then it places it in the sorted list. The step is then repeated by searching the least element present in the unsorted list, and it places it next to the first element of the sorted list. So in my examples, since I'm arranging all the elements in the ascending order, if I have a list of numbers, I'm going to select the smallest element and then place it as the first element of the sorted list. Then I start to search for the next smallest element and place it towards the right of my first element. So I'll get back to my Jupyter notebook in order to implement this. I have the code for this already, so I'll just copy it. So initially, what we have to do is assume that the first element is the minimum element. Then what I'm going to do is check if the first element is less than any element present towards the right of it. So in my list, I'm going to first assign 34 as the minimum value. So what I'm going to do next is, I'm going to check if the value of this minimum is less than any value that is present towards the right. So for every element that is present towards the right of minimum, that is x, if that value is less than the minimum value, I'm going to place the value present at my array of y as the minimum value. So for the first iteration, I'm going to check if 23 is less than 34 or not. Since 23 is less than 34, 23 becomes minimum. So after the first iteration, 23 becomes the minimum value. Next, I'm going to check if 1 is less than 23. Since 1 is less than 23, 1 becomes the minimum value. So after the third iteration, I'll have 1 as the minimum value. Finally, I'm going to check if 1 is smaller than 67 or not. Since 1 is smaller than 67, the minimum value will remain 1. Finally, I'll check if 1 is smaller than 4 or not. Since 1 is still smaller than 4, the minimum value is 1. So the first element to be placed in the sorted list will be 1. My sorted list will have 1 and unsorted list will have all the elements, which is 34, 23, 67 and 4. So this is my sorted list and this is my unsorted list. So once this is done, I'm going to repeat the same thing for the unsorted list again. At this time, 34 will be minimum, and after the first iteration, 23 will become minimum, and for the third iteration, 23 is going to remain the minimum, following which I'm going to check if 4 is less than 23 or not. Since 4 is less than 23, 4 is going to be removed from the unsorted list, and it will be placed towards the right of 1, which will become the second element present in the sorted list. So I hope you guys are clear with this. I'll just erase all these drawings, and I'll run my code. So as you can see over here, I have a sorted ascending order list. Now moving on towards the next algorithm, which is the shell sort algorithm. The shell sort algorithm allows you to sort elements that are apart from each other. The original sequence of the sort elements follows the n by 2, n by 4 sequence, where n is the number of elements present in the unsorted list. For example, if you have a list of 8 elements, the length of that list will be divided by 2 for the first iteration. As we all know, 8 divided by 2 is 4. Now, the first element will be compared to the element that is present at index number 4, and then the gap will be produced by dividing 8 by 4. This time the gap will be 2, and the elements present at these intervals will be compared. Finally, I divide 8 by 8, which gives me the gap as 1. So when I have the gap as 1, I compare adjacent elements, and the final list will be sorted. So what I'm going to do here is just copy a code that I already have written. So my program over here will first divide the length of my array by 2. Then, if the value of gap is greater than 0 for every element that comes in the range of gap, if the elements present after the gap elements are greater than y, we'll have to follow the insertion sort algorithm and swap the elements. Finally, the gap is divided by 2 again. Since in my case n is 7, which is my list contains 7 elements, I'm going to divide 7 by 2 to find the gap. So 7 by 2, which is equal to G, or the gap, will be nothing but 3. Now I'm taking 3 because it's the whole part of 3.5. So the gap over here will be 3. So what I'm going to do is first take this element 23, and then I'm going to check with the element that is present at index number 3. So at index number 3 is 17. Since 17 is less than 23, these values will be swapped. So after the first iteration, 17 will be at the first place. Okay, let me just clear these drawings and then write down the final list. And then after the first iteration, I have 17 followed by 12, 1, 23, which was swapped with 17, 45, 2, and 13. So for the next iteration, I'm going to check 23 with 13. Now this is because I'll have to check after the gap of 3. So since 13 is less than 23, I'm going to swap these elements. So after that, I'm going to have 13 in place of 23, and 23 will be placed at last in place of 13. So once this is done, I'm going to divide the gap by 2 again. So my gap in this case was 3. So therefore, if I divide this by 2, I'll get the gap to be 1.5, wherein I'm going to take the whole number, which is 1. So gap in this case will become 1. So next up, I'm going to check all the elements that are present at gap of 1 and then replace them. I'm going to repeat this until my list is sorted. So let me just clear all these drawings and I'll execute this problem. So as you can see, I have all the elements sorted in the ascending order. So that was all about the sorting algorithms. Now moving on towards the searching algorithms. Searching algorithms are used to search for or fetch some elements present in some given data set. There are many types of search algorithms such as linear search, binary search, exponential search, interpolation search, etc. In this session, I'm going to be discussing about the linear search and the binary search problems. The linear search algorithm is used to successively search for a given element by comparing it with each element of the given array. It is one of the simplest searching algorithms, but very important to understand other searching algorithms. So what I'm going to do over here is get back to my Jupyter notebook. And over here, I'll just create a heading again. I'll call this as searching algorithms. The first one over here is linear search. And I'll just paste the code that I have for it. So first thing that I've done over here is created a function that is going to accept the iterables, the length of the list, and the key element. So if any element present in the list matches the key element, I'll have to return that element. In case the element is not found, I just have to return -1. So for every element present in the range of 0, n, that is starting from the 0th index number, and for all the elements present in the list, I'm going to check if any element present in my list is equal to the key or not. In case the element is present, I will return X, else I'll return -1. Okay, the key that I've supplied over here is 16, and my array over here contains some random numbers. Next thing that I've done over here is assign the value of n as the length of my array. Following that, I take another variable named match, to which I'm going to assign the value of the linear search function. If the value of match is equal to -1, then key is not present in my array, else the key is present at so-and-so index. So let me just erase these drawings and I'll execute this problem. So as you can see over here, my key is 16, which is not present in my array. In case I change the value of this to 12, and then I run this program, you see that the key is present in the given list at index number 0. So I hope you guys have understood this. So now moving on towards the next algorithm, which is the binary search algorithm. Binary search is used to search for some given element in a sorted array by making use of the decrease and conquer algorithm. Here, the key is looked for by first comparing it with the middle element and then dividing the array into half. The left half is searched if the element to be searched is smaller than the middle element and vice versa. The appropriate subarrays are again divided into half and the process is repeated again. Say for example, if you have a sorted list of 7 elements, the key will be compared with an element that is present at the middle or the element present at 7 by 2, which is 3.5. So in this case, the middle element will be assigned as the element present at index number 3. So in case the key element is smaller than that of the element present at index number 3, I'm going to check the left sublist. If the value of key is greater than that of the value present at index number 3, I'm going to search in the right sublist. So I already have a program for this. I'll just copy paste it. So in my program, I've created a function called as the binary search function, to which I'm supplying the list as well as the key element. Left variable is going to point at the first element which is present at index number 0, and the right element is going to be length of my list -1, which is the last element present in my list. Then I've taken a variable to which I've assigned a boolean value as false. Initially, the value of this is going to be false. So until my list is not empty, I'm going to divide my list by 2. So if the value of the middle element is going to be equal to the key, I'll change the value of match from false to true. Else, if the key value is less than that of the value present at the middle, I'm going to make the value of r at middle minus 1, which means I'm going to search only towards the left list. And if the value of key is greater than that of middle, I'm going to change the value of left as middle plus 1, which means I'm going to check only towards the right of the middle element. Finally, I'll return the value of the matched variable. So in this problem, I've taken two examples. In the first case, I've taken an element that is present in my list, and the second, I've taken an element that is not present in my list. Okay, so as you can see over here, for the first case, I have true, and for the second case, I have false. Okay, so I hope you guys have understood this. So now moving on towards something that all of you need to know, which is object-oriented programming in Python. Object-oriented programming is a way of computer programming that makes use of the idea of objects to represent data and methods. It is also an approach used for creating neat and reusable code instead of a redundant one. Here, the program is divided into self-contained objects or several mini-programs. Every individual object represents a different part of the application having its own logic and data to communicate within themselves. So what exactly is the difference between object-oriented programming and procedural-oriented programming? Object-oriented programming has a bottom-up approach, whereas procedural-oriented programming has a top-down approach. In OOPS, the program is divided into objects, whereas in procedural programming, program is divided into functions. OOPS makes use of access modifiers such as public, private, protected, whereas procedural programming does not have any access modifiers. OOPS languages are much more secured compared to those which are procedural languages. The objects created in an object-oriented programming language can move freely within the member functions, whereas in procedural programming language, data can move freely from function to another function. Object-oriented programming supports inheritance, whereas procedural-oriented programming does not support inheritance. So now moving on towards classes, objects, and the pillar of OOPS in detail. So first, let us discuss about objects. An object is a real-world entity such as a pen, book, person, animal, etc. Objects have states and behaviors. In Python, everything such as variables, functions, etc. are considered to be an object. A class, on the other hand, is a collection of objects, or you can say that it is a blueprint of objects defining the common attributes and behaviors. Now the question arises, how do you do that? Well, the class logically groups the data in such a way that the code reusability becomes easy. So for example, consider an office-going employee as a class and all the attributes related to it like employee name, employee age, salary, ID as the objects in Python. So all the details of the employees will be placed in the class employee. This way, you'll not have to write the code repeatedly for all the employees. Instead, a single class will be enough to determine all the details of each employee. So now I'll just jump onto my Jupyter notebook and show you guys how to write down a class in Python. I'll just create a heading. So here I'm going to write down the syntax for a class. The first thing that I'll have to specify is the class keyword, followed by the name of the class. Like I've already told you all in the naming conventions, class names begin with a capital letter followed by small letters. So in case the name of my class is my class, my is going to be with a capital M followed by a small y and cap C followed by small LASS. So this is my class name. Within this class, I can have n number of statements. So I'll just say statement 1 to statement n. So this is basically the syntax of a class. So now talking about methods. Methods are nothing but functions that describe the attributes and behaviors of an object. Now let us take an example to demonstrate a class, an object, and a method. Please make a note over here, guys, that it's mandatory for Python class functions to have a self parameter, unlike other languages in Java. Self is nothing but a reference to the current instance of the class, and it is used to access the class variables. So I'll just create a class over here. I'll say class, new class, and within this, I'll define a function, and I'll call it as new function. So like I've already told you all, the first parameter to this by default should be the self parameter. So when this function is invoked, I just want to return hello world. Now once this is done, I'll come out of my class and I'll create an object of my class. So I'll just say object is equal to class. So this is how you create an object in Python. You just have to give a name to your object and then make use of the class name. Sorry, the name of my class is new class, not just class. Next, I'm going to make use of this object of new class to call the new function. So I'll just say print obj.new function. So as you can see over here, with the help of this object I just created, I've called the function which is present in my new class, and therefore it has returned hello world. Similarly, you can have multiple objects and functions in a single class. So now let's take another example in which I'm going to have more than one functions and objects. I'll just copy this, I'll paste it over here, and I'll take another function named myFunction. I'll specify the self parameter as usual. And for this function, I'll just have one return statement that says welcome to Edureka. So now I have two functions and one object. I'll create another object, I'll say object2. And this is a new class object. And through this object, I'll call my function. So as you can see over here, I have two functions, two objects, and with the help of both these objects, I'm calling both the functions present in new class. Therefore, I have an output saying hello world and welcome to Edureka. So now let us take a more complex example of this. What I'm going to do is create a class named calculating. Here, I'm going to find the sum, difference, product, and quotient for different values using more than one object. So I'll just say class calculating. And within this, I'll define a function, say add. The first parameter should be the self parameter, followed by the variables, that is a and b. Now this function is going to return the sum of a and b, so I'll say return a plus b. Okay, so I'll create a similar subtract function. I'll just copy this, and in place of add, I'll write subtract, and in place of a plus b, I'll say a minus b. Now let's create a function to find the product. So add will become product, and from plus, I'll change it to star. Finally, a function to find the quotient. So this one, add will change to divide, and it will be a divided by b. So now I'm done with this. I'll create an object called as O1, and this will be an object for the calculating class. Now using this object, I'm going to find the result of each of these. So I'll just say print O1.add, and I'll specify some random parameters, say 4, 5. I'll copy this, paste it here, paste it here, paste it here, and I'll change the names of these functions accordingly. So subtract, product, and divide. Let me change the values as well. I'll just say 12, 5, product of 32 and 55, and divide 44 by 5 or 15. So I have one object that is calling all the functions that are present in the calculating class. In case I want to create another object, I can do it in a similar manner. So what I'm going to do is just copy this. I'll paste it over here, and I'll change the name of this object from O1 to O2. Wherever I have O1 in this, I'm going to change it to O2. So I have two objects and 4 methods. Now when I execute this, seems like I've made some error. I've made a mistake in the spelling over here. It's not CLA, it's CAL. So as you can see over here, I've got the output. In case I want to differentiate between the results of both these objects, I'll just write down a print statement over here, and I'll just print a dashed line. So as you can see, the first half contains the result obtained by object 1, and the second half contains the result obtained by object 2. So I hope you're clear with this. So now moving on towards something very important, which is the init method in Python. The init method is a very important method that is always executed whenever a class is initiated. So whenever you create an object of a class, this method will be invoked. The init method is always used in real-world applications, unlike the previous examples that we just saw. So now, to show you an example of the init method, I'll get back to my Jupyter notebook. And over here, I'll define a class, and I'll just call it as Python programming. I'll just use a shortcut. So within this, I'm going to call the init function, or the init method. The init method has two preceding underscores, prefix and suffix to it. So I'll just say double underscore, init, double underscore, and the first parameter should be the self parameter. So here, I'm going to pass in two other parameters, which is name and the age of Python. Once that is done, I'll just bind the self parameter with the name and the age attribute. I'll just say self.name is name and self.age is age. I'm going to define a new function over here. So I'll just say define new function. And again, I should specify the self parameter. And within this, I'll just have one print statement that is going to print both the name and the age. So I'll just say, hi, my name is Python. So that is self.name. And my age is self.age. Sorry guys, I have to specify a plus sign over here. So once this is done, I'm going to create an object of this class. So I'll just say p1 equals Python programming. And then I'll use this object to call the new function. So p1 dot new function. I'm sorry guys, I forgot to pass the parameters itself. So I'll have to pass the parameters. I'll just say name is Python and age is 31. So as you can see, I have an output saying, hi, my name is Python and my age is 31. So now moving on towards object-oriented programming methodologies. Object-oriented programming methodologies are nothing but the pillars of OOPS, which are inheritance, polymorphism, encapsulation, and abstraction. So now let's move on and discuss each of these in detail. The first thing that I'm going to be discussing over here is inheritance. So what exactly is inheritance? The method of inheriting the properties of a parent class into a child class is known as inheritance. It has a number of benefits such as code reusability, where we do not have to write the same code again and again, and we can just inherit the properties we need in the child class. It also represents a real-world relationship between the parent class and the child class. Inheritance is transitive in nature. If a child class inherits properties from a parent class, then all other subclasses of the child class will also inherit the properties of the parent class. So now let me just show you all an example of this. I'll get back to my Jupyter notebook. So I'll just take two classes over here. The first will be the parent class and second will be the child class. So I'll just say class, parent, and then I'll define a function and I'll call this function as first. The self parameter as usual should be specified. And within this function, I'll just have one print statement that informs first function. So next, I'm going to declare another class. Let's just call this class as child. And this child is going to be a subclass of the parent class. So to inherit the parent class, I'll have to specify the parent class within the braces. So I'll just type in the name of the parent class. Within this, I'm going to define a function named second and a self parameter to it. Now this function will also have one statement, that is the print statement saying second function. So once this is done, I'll create an object of the child class. I'll just say obj equals child. And then using this object, I'm going to call the first and the second function. So I'll just say obj dot first and obj dot second. So as you can see over here, this object is able to access both the functions, that is first and second. The first function is not present within the child class, but since the child class is inheriting the parent class, this function is visible to the child class and therefore it is able to execute it. So what we're actually doing over here is subclassing the child class. Calling a constructor of the parent class by mentioning the parent class name in the declaration of the child class is known as subclassing. A child class identifies the parent class by subclassing. So now moving on towards types of inheritance. Depending upon the number of child and parent classes involved, there are 4 types of inheritance. The first is single inheritance, second is multiple, third is multi-level, and finally hierarchical. Single inheritance is when a child class inherits only a single parent class. So in the previous example, my child class is inheriting just one parent. This is an example of single inheritance. In case of multiple inheritance, the child class will inherit more than one parent. So what I'm going to do is just copy this. I'll paste it over here. And then I'll just call this as parent 1. I'll declare another class as parent 2. Even if you do not specify these braces, it's going to work properly. Within this, I'll just define a function. I'll call this a third. And the self parameter. And then I'll just print multiple inheritance. So here my child class is going to inherit parent 1 as well as parent 2. Then my object is going to invoke both these classes. So as you can see over here, in the first example, I just had one parent as the base class. But in this example, I have 2 parent classes and a single child class. The object of this child class is able to invoke the functions present in both the parent classes. So I hope you've understood this. The next is multi-level inheritance. Multi-level inheritance is when a child becomes a parent class for some other class. I just paste the previous code, and over here, I'll create another child class. I'll say class child2, and I'll inherit the child class. I'll define a new function. I'll just call this as function and the self parameter, and I'll print multi-level inheritance. So here, instead of creating an instance of the child class, I'll create an instance of child2, and then I'm going to invoke all the functions using this object. I'll say obj.function, and I'll run this. So as you can see over here, all the functions are accessed by this object. So now talking about the hierarchical inheritance. Hierarchical inheritance involves multiple inheritance from the same base or parent class. So in this case, I'll have two different child classes that are inherited from the same parent class. So what I'm going to do over here is just paste the code, and then I'll have another child. I'll call this as child2 itself. And this is also going to inherit the parent class. This is the hierarchical inheritance. And then I'll create two objects, that is for the child class and the child2 class. So obj.1 will be an object for the child class 2. Let me just change the name of this function. I'll just copy this, paste it over here, and I'll change the name of the function from second to function. Okay, sorry guys, I just forgot to change the name of the object over here. As you can see over here, both the child classes have executed and returned the result accordingly. Similarly, you can also have hybrid inheritance. Hybrid inheritance involves multiple inheritance taking place in a single program. So just to show you all an example of this, I'll take this code, I'll paste it over here, and I'll create another class. I'll say child4, or I'll say child3. And this is going to inherit the child class as well as the parent class. As you can see over here, I have more than a single type of inheritances. The first type you see is a single inheritance, and now I have multiple inheritance as well. Similarly, you can have any other type of inheritance also. So I'll just define a function, say function2, the self parameter, and then I'll print hybrid. Okay, so now let me create an instance of this class. Just copy this. I'll paste it over here. I'll remove these objects since we've seen their output. So as you can see, I can have multiple inheritance as well. So now talking about the super function. The super function in Python allows you to call a method from the parent class. So to show that to you guys, what I'm going to do is take the original two classes, which was the parent and the child class. I'll just paste it over here. And within this function, I'm going to type in something called as super dot the name of the function that's present in the parent class. So that is first. So now let me create an object of this. I'll just say obj equals child, and I'll execute the function present in the child class. So I'll just say obj dot second. Sorry guys, I just made a mistake. I specified capital S in place of small s. So let me just execute that again. So as you can see over here, in the previous example, I had to explicitly specify my object to call both the functions present in the child class and the parent class. But over here, my object is accessing the function present in the parent class by making use of the super function. So now let's move on towards the next pillar of OOPS, which is polymorphism. Polymorphism defines the ability to take different forms. By making use of polymorphism, you can redefine methods in the child class with the same name as that of the parent class. Polymorphism is taken from the Greek word poly, which means many, and morphism, which means forms. It means that the same function can be used for different types. This makes programming more intuitive and easier. In Python, we have different ways to define polymorphism. A child class inherits all the methods from the parent class. However, in some situations, the method inherited from the parent class doesn't quite fit into the child class. So in such cases, you will have to re-implement the method in the child class. This can be done in many ways, such as using different functions, class methods, or objects to define polymorphism. So to understand this clearly, I'll get back to my Jupyter notebook and show you all an example of this. So I'm going to have different classes which will have functions with the same names. So let me just define a class called as apple, and this class will have a function called type. With this, I'll just have a print statement that is going to tell me if this is a vegetable or a fruit. So as we all know, apple is a fruit. I'll just type in fruit. And then I'll create another class called as potato. Here, I'll create a function with the same name, but with a different implementation. And instead of fruit, I'm going to type in vegetable. Let me just change the name from type, since type is a very general keyword in Python. So I'll just say type of. So now, I'll create two objects. I'll say obj1 and obj2. And by using these objects, I'm going to invoke both these classes. So I'll say obj1.typeof and then obj2.typeof. Now I'll just run this code. So as you can see over here, even though I have two functions with the same name, my objects are able to access the right function and return the output. You can also have polymorphism along with inheritance. Polymorphism, like I've already told y'all, defines method in a child class that have the same names as the method in the parent class. So as discussed in inheritance, the child class inherits the methods from the parent class. Also, it is possible to redefine a method present in the parent class in the child class. This process of re-implementing a method in the child class is called as method overriding. So now let's take an example of that. I'll just define a class called as bird, and within this I'll define a function called as information. Now within this, I'll just keep a general print statement, that is to say that birds are very pretty. So now I'll create a subclass of this class. I'll just say class, and I'll specify the bird as parrot. I'll inherit the bird class over here, and I'll define a function, and I will redefine the function information. Here, I'll just print parrots can fly. So now, I'll just create an object of the parrot class, and I'll say obj.information. So as you can see over here, when I've called the function information, which is present in both the base class and the inherited class, the function present in the inherited class has been executed. So that means I have redefined or overridden my method that is present in the base class, and that method has been executed. So that was all about polymorphism. Now let's move on towards encapsulation. Encapsulation deals with binding up the data together with the code that is used to work on that data. This not just makes our code clear, but it also helps in preventing data from being modified as well. In OOPS, a classic example of encapsulation is a class. A class encapsulates all the data and the code such as variables, methods, etc. Data that is encapsulated can have three types of access specifiers in OOPS. These access specifiers are protected, private, and public. Members having public access specifiers are visible throughout the code. Protected members are visible just within the class and the subclasses, whereas private members are visible only inside the class in which they are present. Even the inherited classes will not be able to access them. So one thing I want you all to know over here is that Python in real has nothing such as privacy model. It does not have exclusive access to modifiers such as C++, C#, or Java. Therefore, there are no truly private or protected attributes in Python. Now, I'm sure you'd be thinking, then what is the use of preceding single and a double underscore in Python? Members that have names with the preceding double underscore are mangled in order to protect them from clashes with the inherited classes. Subclasses are also allowed to define their own private members, which will not interfere with those of the parent class. This is why they are considered to be private. They are accessible outside the class, but less is the chance of a clash. Mangling in Python is achieved by prefixing any such name with an extra underscore and the class name. This in turn provides an effective namespace. So in case I have a class named parent, so I'll just say hash parent, and if this parent contains a member with a double underscore, so I'll just say underscore double underscore private member. At the compile time, this private identifier is going to convert to underscore parent, double underscore private member. So as you can see over here, the name has been mangled. So therefore, in case I try to access this private member anywhere outside the class by just making use of a double underscore followed by the private member name, I'll get an attribute error. Similarly, if I have a child class, I'll just say child. And if this child has a private member, then at compile time, it's going to be something like underscore child, double underscore private member. So I hope you guys are getting this. The names of members preceding with a double underscore are mangled such that you have an underscore followed by the name of the class and then the name of the member that has a double underscore. So what I'm going to do over here is I'll define a class, say A. And within this, I'll call the init method. Through this init method, I'm going to invoke the so-called private method. So therefore, I'll have self.double underscore hi. The name of my method is hi. I'll declare another method called as hello world. So this method is just going to print hello world. So here, I've declared a method named hi, but I've not defined it. So I just define double underscore hi, to which I'll specify the self parameter again. And I'll say print welcome to Edureka. Now, I'll create an object of this class. And first, by making use of this object, let me try to call the hello world function. So as we all know, this object will be able to access the hello world function. So I'll just execute this. So as you can see over here, I have both the outputs, which is welcome to Edureka and hello world. As you've seen, I've not called this function which contains a double underscore, but I still have the output to it. Now, if you guys are wondering why the output is seen, now this is because I'm calling the double underscore hi method through the init method. As I've already told y'all, the init method is always executed whenever I create an object of this class. So in case I do not write this method, so I'll just delete this from here. And then if I execute this problem, you'll not be able to see the output for the hi function. In case I want to invoke this function, I cannot directly use obj.hi. I'll have to type in obj.underscore a double underscore hi and then execute this. So I hope you guys are clear with this. The name of hi has changed from double underscore hi to underscore a double underscore hi. So what happens when you have a single underscore? Let me take another example to explain this to you all. So I'll just say class base and then I'll define a single underscore class. I'll just say single and I'll just print saying single underscore. Next, I'll define another class called as double underscore or just double. And then I'll print a message saying double underscore. Now I'll create another class, which is the child class of base class. And through this class, I'll try to access both the functions present in the base class. So here, I'll just type in self dot the name of this function, which is single. Sorry, I forgot to define the function over here. So I'll just say define function1 with the self parameter. I'll define another function with the self parameter. And then I'll say self.double. So now let's create an object of the child class. So I'll say obj equals child. And I'll call obj.function1 and function2. So now let's see what happens. So as you can see over here, the function having a single underscore has been inherited and executed by the child function. Whereas the function that contains a double underscore throws an error saying child object has no attribute named underscore child double underscore double. So in case you want to execute this, all you have to do is just type in the name of the base class preceded by an underscore. So I'll say underscore base and then I'll hit run. So as you can see, now both the functions have been executed using the object of the child class. So I hope you guys are clear with this. Now moving on towards the final topic of this session, which is data abstraction in Python. So abstraction basically means to show the necessary data and hide the implementation details. This not just increases the efficiency of the code, but it also reduces its complexity. For example, consider your washing machines. You know what happens when you press certain buttons such as on, off, save water, set water level, change program, etc. But the actual implementation of these programs is hidden from you. You do not know how it's being turned off or turned on. You do not know how it knows to take less water or more. This is called as data abstraction. Abstraction can be achieved by creating abstract classes. Any class that contains an abstract method is called as an abstract class. So what exactly are abstract methods? Abstract methods are those methods which just have names but do not actually contain any function definition. So that means that you declare an abstract class but you do not define it. These functions are also called as unimplemented methods. Therefore, an abstract method does not have any body. In Python, this can be achieved by making use of the pass keyword. However, an abstract method needs to be redefined in a subclass where it's being used. To achieve abstraction in Python, you can make use of the ABC module, that is the abstract base class module. So to show an example of this, I'll get back to my Jupyter notebook. I'll just type in a heading. So the first thing that I'm going to do is import everything that's present in the ABC module. So I'll say from ABC import star. So this is going to import all the necessary functions that are present in the ABC module. I'll create a class over here called as bank, within which I'll have a function that describes the name of the bank. I'll have another function that is going to find the location of the bank. But this function is going to be abstract, or I'm not going to have any function definition. Next, I'm going to define a child class called as location, through which I'm going to redefine the abstract method. I'll just define the class bank. So the bank class is going to inherit the ABC class. In case you want to know what this ABC class does, I'll just add in a kernel over here and I'll say help on ABC. So as you can see, this is a helper class that provides a standard way to create an ABC using inheritance. So now moving on, I'll define two functions having bank name and the self parameter. I'll just print the name of the bank. I'll say HDFC. And then I'll define another function called as bank location. I'm not going to provide the body of this, so I'll just write pass. Now I'll create a child class. I'll say bank underscore location. This is going to inherit the bank class. And then I'll redefine the bank location function. I'll print the location as Bangalore. Finally, I'm going to create an object of the bank location class. I'll just say obj equals bank location, and I'll call both the functions. So as you can see, both the functions have been executed successfully. What are comments? No, they are not something there just to increase the size of your code. But guys, they are indeed very meaningful. Comments are programmer coherent statements that describe what a block of code means. And they get very useful, especially when you're writing large blocks of code. Say for example, you've developed some software previously. And now you're working on something that's new and completely different. At this point of time, you find that your previous software is throwing some error. You would have completely forgotten what you did and how. So this is where comments come into picture. A good code actually consists of relevant comments. These comments actually increase the readability of the program, not just to the programmer, but to the others as well. Now that you know what are comments, let's move on and see when to use them. The best practice is to write comments as and how you proceed with your code. Comments are very useful, but only if they are implemented wisely. Just keep the following points in mind when you're commenting your code. Make sure your comments are very precise and clear, and preferably short as well. They need to be as specific as possible to the block of code they are included with. Please make sure you use decent language, guys, and do not repeat your comments as they become redundant. Now that you know what are comments and their importance, let's see how to write them in Python. Comments in Python are preceded by a hash character. As you can see on the screen over here, I have a small example with some 2 lines of code. My first line is a comment, and my second line is a print statement. Now let's move on towards a Jupyter notebook and see how this works. Now let's move on towards a Jupyter notebook and write some comments. All I'm going to do over here is I'll open a new Python notebook and I will rename this notebook. To rename your notebook, guys, all you have to do is click on the title, give whatever title you want, and use rename. Like I've told you before, comments start with a hash character in Python. So here I'm going to write a comment preceded by a hash. As you can see my output, there is nothing related to the comment line, and whatever I have printed in the print statement has been returned as my output. Now this is how comments work. They do not show up in your output. Now let's get back to our presentation and see how they are iterated, which is exactly what is our next topic. Whenever the interpreter encounters a hash symbol, it omits whatever is present after that. The hash character actually tells the interpreter to stop reading whatever is present after that until the end of that line. So when you're writing comments, whatever is present after your hash character is going to be omitted by your interpreter. Now what if the hash character was present inside a string? Let's go to our Jupyter notebook and see what happens. I'm including a hash character within a string and I will run this. As you can see, when I run this, the string is returned, which means a hash inside a string means a hash itself and nothing else. So you cannot write comments within a string. Okay, so I hope you've understood how to write comments. Now let us move ahead and see what are the types of comments. Comments can either be single line or multi-line. Single line comments can either appear individually or in line with some other code. Multi-line comments have to be preceded by a hash character in every line they appear. Now let's see a small example of single line comments. Like I've told you before, single line comments can appear either in an individual line or in line with some other code. Now let's move on towards a Jupyter notebook and write some single line comments. I'll just create a heading over here. To create a heading, all you have to do is go to code, select heading, give whatever heading you want as your heading and prefix it by a hash. A single hash tells that it's H1 level heading. 2 hashes tell that it's H2 and so on. You can use the heading level of your choice. Here, I prefixed my heading by a single hash, which means it's of level H1. Now let's write some single line comments. As you can see over here, my first line of code is a comment line. I've prefixed this line by a hash character. And in my last line, I have an inline comment. This inline comment is present with some part of the code. As you can see in the output, none of the comments have been returned. Now let's get back to our presentation and see how multi-line comments work. Like I've already told you, multi-line comments can appear anywhere in your code, but each line needs to be prefixed by a hash character. For example, as you can see on your screens, I have a hash character present in the first 2 lines of my code. After that, I have some code followed by it. You can see in the output that none of these lines have been returned. Now let's go to our Jupyter notebook and write some multi-line comments. As you can see over here, I have 3 initial comment lines and all 3 have been prefixed by a hash. After that, I have some code. And you can see in the output that none of the comment lines have been returned, and whatever code is present after that, an output is returned based on this code. Now, typing a hash everywhere might be a problem, and many of us would not like to do so. Let's look at some shortcut methods of how to comment multiple lines at once. All you have to do is type your multi-line comments first. Hold the control key and left click wherever you want to insert a hash character, just like how I'm showing here. And then type it once and it appears wherever I have inserted the cursor, as you can see on the screens. Now, in case you want to remove multiple hash characters all at once, do the same thing. Hold the control key, click on wherever you want to remove the hash character from and press the backspace key. As you can see, from 2 lines, I removed a hash character in a single go. So these are some shortcut methods to comment multiple lines. Many of us think that comments and docstrings are same. Now let's move ahead and see what are docstrings and whether they are actually comments or not. Docstrings are not actually comments, but they're documentation strings. These strings are written within triple quotes. They're not assigned to any variable, and many a times they are used as comments as well. Now you'd be thinking, what is the difference between docstrings and comments? Docstrings are not omitted by the interpreter, unlike comments. Comments are omitted by your interpreter and nothing present after the hash character is going to be read by it. On the other hand, docstrings are strings that describe something about the code. Docstrings actually tell what some function is going to do, whereas the comments will tell how it is going to do. So this is the difference between docstrings and comments. Now let's go to our Jupyter notebook and see their functionality. Like I've told you before, docstrings are written within triple quotes. As you can see in the output, when I execute this, it returns the string itself. Whereas in case of a comment, when I execute a comment, it does not return anything. Which means the interpreter does not omit docstrings, whereas it omits the comment. Now these docstrings are efficiently used when you want to describe something about a class or a function or something else. Now these docstrings can either appear in your output or they can be omitted based on where you're going to place them. Let's try to place a docstring initially before the code starts. As you can see in my output, the docstring has not been returned. Whereas when I use the docstring individually without any code and I executed it, you could see that it had returned the string itself. But when I include the docstring before the code, and after that I've included some code lines and I run this, you can see that only the output for my code is present and nothing related to the docstring has been returned as my output. Now let's try to include a docstring after some code. As you can see over here, when I included the docstring after the code, it has returned the output for the code as well as the string itself. So when you're making use of docstrings, just be specific of whether you want it to be returned in your output or not. Many a times, these strings are called rather than writing it again and again. So I hope you've understood what are comments and docstrings as well.
So let's try to understand what exactly is an operator. An operator is used to perform operations between two values or variables. Now we can call the operators as constructs or special symbols that are used to manipulate the values of the operands. Now you must be wondering, what is an operand? So the value that we use in an operation are known as operands. These operands can be variables or any data type that we have in Python. So let's take an example here. So we have two operands, operand 1 and operand 2. Now when I add an operator between them, we can get the result according to the type of operator that we are using here. So before moving on to the types of operator that we have in Python, let's briefly discuss variables and data types in Python. The purpose of discussing variables and data types is to get an idea of what exactly is variable and data types. Because while explaining the different types of operators, we are going to use these variables and data types as well. So variables are nothing but the memory locations where we store a value, and these values we may or may not change in the future. According to the properties they possess, there are 6 data types in Python, namely numbers, string, list, dictionary, tuple, and a set. Now let's take it up to Jupyter Notebook to understand these data types briefly. Talking about numbers or numerical data types, they mainly hold the numerical values. For example, a variable, let's say x, is going to hold the value that is 10. So this is going to be a number or a numerical data type. Now in numerical data types also, we have 4 types of data types. First of all, we have integer, which is going to hold the whole numbers. Then we have float data type, which is used for declaring decimal point values. And then we have complex numbers, which are used to declare imaginary part values. For example, we use the j as imaginary part over here. And then we have a Boolean data type, which is used for categorical output, that is true or false. So when I print the Boolean number over here, it is going to give me the value as true or false. So this was all about numbers. Talking about strings now, strings are used to represent the characters or alphabets. We can use the single or double quotes to declare a string in Python. Also, strings are immutable in nature, which means you cannot change a string once you have declared. And to access a value in a string, you can use the index values over here. So when I use the index number 2, it is going to give me the value at the index number 2 here. So this was all about strings, guys. Talking about list, list is a sequence which is ordered and changeable, which means you can change values in a list. To declare a list, you have to give a name for your list, and we use the square brackets to declare a list in Python. List is also indexed just like a string, so we can use the indexes to access the values from a list, and we can store different values in a list as well. For example, I can use numbers over here, give duplicate values as well, and I can use strings over here as well. So when I print my list, it is going to give me the value like this. Now talking about dictionary, dictionary is a sequence just like a list, but we use the key value pair in a dictionary. I'll show you guys. To declare a dictionary, we use the curly brackets. Now I'm going to give the key value pairs over here. So let's say this is my key 1. I'll give a semicolon. Now I'll give the value over here. I'll give one more key value, let's say key number 2. So when I print my dictionary over here, I'll get the values like this. Now since it has a key value pair, it is not indexed, which is why we can use the unique key values as an index to access the values in a dictionary. So what I'm going to do is I'm going to write the index number as my key value, and it is going to fetch me the value at that particular key. So let's talk about set, guys. A set is also a sequence which is unordered and not indexed, which means you cannot access the values using the index number. So I'll just write a few values over here, some duplicate values as well. So when I print my set over here, it is going to give me the values like I have mentioned over here, and it is not going to hold any duplicate values in a set. Also, we use the curly brackets to declare a set. Now talking about tuple, tuple is immutable in nature, which means you cannot change a value in a tuple once you have declared. And we use the round brackets to declare a tuple in Python. So I can give as many values as I want over here, even the duplicate values as well. So when I print my tuple over here, I'm going to get these values that I have declared in the tuple. So the difference between a tuple and a set is not indexed, and it does not contain any duplicate values, but a tuple can contain duplicate values and it is indexed as well. So we can declare duplicate values in tuples, but not in the set. So this was a brief discussion about variables and data types, guys. If you want a detailed discussion about variables and data types, you can check a video on Edureka platform where we have discussed variables and data types in detail, where we have also discussed various operations that you can perform on a data type. Moving on to the different types of operators that we have in Python. So here is a list of all the operators that we have in Python. So first of all, we have arithmetic operators. Then we have assignment operators, comparison operators, logical operators. Then we have membership operators, identity operators, and bitwise operators. So we will be discussing all of these operators in detail. So let's talk about arithmetic operators. Arithmetic operators are nothing but the operators that are used to perform arithmetic operations between variables or two values. So these are the arithmetic operator symbols that we use in Python. So we have addition, subtraction, multiplication, division, modulus, exponentiation, and floor division. So let's take it up to Jupyter Notebook to understand the concept of arithmetic operators. So let's say I have two variables, x. I'm going to give this value as 10. And then I have one more variable, let's say y. I'll give it a value, let's say 20. Now to understand the concept of arithmetic operators, what I'm going to do is, first of all, I'll try to perform addition between these two variables. So I'll just write plus over here. And when I execute this, I'm going to get the addition as my output. Now to perform subtraction, I'm going to use the subtraction operator, and it is going to give me the value as the subtraction over here. Similarly, I can perform multiplication. Then I can also perform exponentiation. So I'll use 2 asterisks instead of 1 for exponentiation. It is that easy in Python, guys. Now we will perform division over here. So it is going to give me the value of the division. Now when I do the floor division, I'm going to get the value over here as well. One more operator is left, that is the modulus. So I'll try to perform modulus as well. So it is going to give me the value, that is the remainder. So this was all about arithmetic operators, guys. So these are all the symbols that we can use for various purposes like addition, subtraction, multiplication, division, etc. I hope you are clear with the concept of arithmetic operators. Now let's try to understand the next operator that we have, which is assignment operator. So you can imagine what an assignment operator is by the name itself. That is assignment. So we use assignment operators to assign values to a variable or any value that we have in Python, right? So we have assignment operators like is equal to, then we have plus is equal to. So all these symbols we have, let's try to understand what all these are used for. For example, let's say we have a variable x which has value 100. Now when I write this x plus is equal to 10, it is going to mean the same as x is equal to x plus 10. Similarly, we can write x minus is equal to, multiplication is equal to, division is equal to, or exponentiation is equal to. Now let's try to understand these operators or the assignment operators in Jupyter Notebook. So first of all, we have is equal to as our first assignment operator. So I'll have 1, let's say I have x. So I have not assigned any value to this. Let's say what happens. Okay, let's try one more variable. I'll write this. So it is showing me a name error, which is saying name A is not defined because I have not assigned a value to it. So in Python, until you assign a value to a variable, it is not going to be declared in Python. So now when I give the value to this variable, let's say I'll write 5 over here, it is not showing any error, which means I have assigned a value to this variable. Now let's try to understand other assignment operators. Let's see. So what does plus is equal to mean in Python? So when I write this, what should be the output, guys? So let's try to understand this. So when I print A, I get the value as 10. So why I'm getting this value? Because I have assigned the value 5 over here. Then I write one more assignment operator, that is plus is equal to 5. So what is going to happen over here is it is going to be same as A is equal to A plus 5. So we have 5 over here and we have added 5 more to this statement, which means we are getting the result as 10 over here. Now let's try to understand other assignment operators as well. So let's say exponentiation is equal to 5. So let's see what the output will be. So when I print this, I'm getting the exponentiation to the value of 5. Since A is equal to 10 and we are doing the exponentiation until 5 digits, so we are getting the output as 100,000. So this was all about assignment operators. Similarly, we can do the division is equal to, then we have minus is equal to. So these are all the assignment operators that we have in Python. Now let's talk about the next operator that we have, which is comparison operator. So comparison operators are nothing but the operators that we are using to compare two values or objects, right? So we have comparison operators like equal, not equal, greater than, less than, greater than or equal to, and then we have less than or equal to as well. So let's try to take an example over here. So when I use the equal operator, I'm going to write the statement as just I've written over here, x is equal to y. So when I'm using the comparison operator, I'm actually using double equal to. So this is the basic difference between assignment operator and comparison operator. So let's take it up to Jupyter Notebook to understand these comparison operators, guys. So let's say I have two variables, value is equal to 10 and number is equal to 20. So to understand the comparison operators, let me take one more variable. I'll say this will be our Boolean variable. So what I'm going to do is I'll write val is equal to number 1. What I'm checking is or comparing these two values. So what exactly I'm doing is comparing these two variables or values that we have, that is val and number 1. So when I print this compare variable, what I'm going to get is either true or false. So it is going to be false because value is not equal to number. So I can do the similar thing. I can check whether it is greater than or I can check if it is less than. So when I write 10 over here, so I can similarly check if it is greater than or equal to. I can check if it is less than or equal to. So these are the comparison operators that we have in Python, which we can use to compare two values or two objects. Now let's try to understand the next operator that we have, which is the logical operators. So logical operators are used to combine conditional statements. So what are the conditional statements that we have in Python? So let's briefly talk about conditional statement, guys. So mainly we have three conditional statements in Python. We have an if statement, then we have an else if statement, and we have an else statement. So I'll give you an example for better understanding. So for these two variables only, I'll write if val is equal to number 1, print equal. Else if val is greater than number 1, print greater, else print smaller. So what happened here is, guys, first of all, the execution will go to the if statement. It will check this condition. If this statement is true, it is going to print this value. If this is false, it is going to move to the next statement. That is the else if statement that we have over here. It is going to check this condition. If it is true, it is going to print this statement. Or if this condition is false, it is going to jump to the next statement, that is the else statement. And I'll give one more condition. So if all of these conditions are false, it is going to jump to this statement and it is going to print not there over here. If all of these conditions are false, it is going to jump to the next statement that we are going to have in the program. But I have not written any other statements, so it is going to end the execution over here only. So this is a basic example using the conditional statements. Now that we are done discussing conditional statements, let's talk about logical operators. So I have told you logical operators are used to combine conditional statements. So what exactly are the logical operators? So we have a logical AND, we have logical OR we have a logical NOT as well. By looking at the example, let's say we have two conditions over here. We have x is greater than 5 and then we have x is greater than 10. So let's try to understand these logical operators in Jupyter Notebook. Now let's say I have two statements. I'll write x is equal to 10 and what I'm going to do is I'm going to check if x is greater than 10. I'll write AND, which is my logical AND operator, and I'll write x is greater than 5. So what is going to happen if I use the logical AND operator? If both of these statements are true, it is going to give the result as true. But if one of these statements is false, it is going to give me the value or the output as false. So let's see what happens if I execute this statement. I'm getting false because one of these statements is false. Now when I write, instead of 10, if I write 8 over here, let's see what happens. Since both of these statements are true, it is going to give me the output as true. Now instead of AND operator, if I use the logical OR operator, let's see what is going to happen. It is showing me that it is true because when we are using the logical OR operator, only one of these statements has to be true. The output will be true. But what happens if both of these statements are false? It is showing me the value that is false. But let's see what happens if both of these statements are true. I'm getting true as well. So one of the statements has to be true when we are using the OR operator. Now talking about logical NOT operator, what I'm going to do is I'll write NOT in the beginning. Now I'll specify the condition. Let's say x is greater than 10 and x is greater than 5. This is the same statement that we have used before, and for this we have got the output as false. So let's see when we use the logical NOT operator, what is going to be the output. I'm getting true as the output here because this statement is negated over here using the NOT operator, and we are getting the opposite value that we should be getting for this statement. So this is the purpose which fulfills by using the NOT operator or the logical NOT operator that we have in Python. So now that we are done with logical operators as well, let's try to understand what are identity operators. So identity operators are used to compare objects. Now you must be wondering what are objects here. So everything in Python is actually an object. So we can use the data types as objects as well. So let's try to understand what are the identity operators in Python. So we have is and we have is not. So these are the identity operators. So what is does is it returns true if both the variables are same object. For example, let's try to do this in Jupyter Notebook. So what I'll do is I'll take, let's say, a list. I'll give it some values, let's say 10, 20 and 30. I'll take one more list, give it the same values, let's say 10, 20 and 30. And I'll write x is equal to list 1. So when I use the identity operators, let's say if I write x is list 1, let's see what is the output that I'm going to get. I'm getting true because x is actually the same object as list 1. Now let's try to write list 1 is list 2. Even though when we have used the same values in list 1 and list 2, let's see what the output will be. It is false because these are not the same objects, right? Similarly, I can use list 1 is not list 2. So here I'm going to get the output as true because list 1 is not exactly list 2. Even though we have the same values, it is not going to be the same object. So this is the concept about the identity operators. Now let's talk about the next one that we have is membership operators in Python. So membership operators are used to check if a sequence is present in an object or not. Now to understand the difference between an identity and a membership operator, okay, let's first understand what are the operators in membership operator. We have in and then we have not in. So it is going to return true if a sequence with the specified value is present in the object, and it will return true if the sequence is not present. So let's do this in Jupyter Notebook. We have already specified these objects. So let's try to do if x in list 1. Let's see what happens. It is going to show me that it is false because we have no values in x. So when I do the same thing with list 1 in list 2, now you see we have the same values over here. Let's see what the output will be. It is false again. Okay, let me do one thing. Now to check a particular value or a particular sequence, what I'm going to write is I'll check if 10 in list 1. So it is going to check if this is going to be present over here or not. It is showing me that it is true. What if I write like this? 10, 20, 30 in list 2. It is false. So this is the basic difference between is, that is an identity operator, and membership operators. So when I write, let's say, it is going to check if this is present in the sequence or not. It is showing false because it is not there. But what if I add this value over here? Let's say. Now when I execute the same statement, I am getting true because this sequence is actually present in the object. Now to understand the difference between is equal to and the identity operator, let's see what is going to happen. What if I write list 1 is equal to list 2? It is showing false. I have made a change over here. So I'll do this once again. So when I print this, it is showing that it is true. But instead of is equal to, if I write is over here, it is going to show me false because these are two different objects. So this is the basic concept of identity and membership operators, guys. Now let's understand bitwise operators. So bitwise operators are used to compare binary values or binary numbers. So this is a rather difficult concept, guys. So I'll be telling you about what are binary numbers first, and then we'll be moving on to the bitwise operators that we have in Python. So these are the bitwise operators like bitwise and, bitwise or. So these are the symbols used for these operators, guys. So this is actually what happens when we are using these operators. So let's try to understand bitwise AND operator first in Jupyter Notebook. So what I'm going to do is I'll just write 10 and 12. So what is going to happen over here? Let's say it is showing me the output as 8, but it is not clear why we are getting this output, right? So let's understand what 10 is in binary numbers. So when I write 10 in binary numbers, it is going to be 1010, and similarly for 12 it is going to be 1100. Now when I use the logic AND operator, what it's going to do is if both the bits are 1, it is going to be 1. So in this case only first bit is 1 over here, so the output will be 1000, and if we convert this to decimal, it is going to be the number 8. So this is the concept between the binary numbers, guys. Similarly, I can use 10 or 12. So what is happening here is I have these values, let's say 1010 for 10 and 1100 for 12. Now looking at first bits here, that is 00, it is going to be 1. So all of these bits in the output will be 1111, which is exactly is equal to 14. So this is the concept of using the bitwise operators. We are using the values as binary numbers. We are comparing the binary numbers. Now let's talk about left shift and right shift, guys. So this is what I write for doing the right shift. So 10 in binary numbers is 1010. So when I right shift these 2 bits, I'm going to be left with 10. And when I convert this to binary, I'm going to get the value as 2. So this is the concept of right shift, guys. Now let's try to understand left shift. So when I write this, I'm going to get the value as 40. Now let's try to understand how I'm getting this value. So 10, if I write it in binary, is going to be 1010. So when I do the left shift, what is going to happen is it is going to shift 2 values, and I'm going to get the value as 101000. So what is happening here, if I convert this binary number to decimal, I'm going to get the value as 40. So this is why I'm getting the value 40 over here. So this is the concept of bitwise operators, guys. I hope you're clear with the concept of bitwise operators. It is a bit complicated because we are using the binary numbers. Even though I'm telling you these binary numbers, you need not mention them while using the operators. For example, for these bitwise operators, all these are written over here. Let's say if you're using the bitwise AND operator, it will set each bit to 1 if both bits are 1, as I've shown you. And then for bitwise OR operator, it is going to be 1 if one of the bits is 1. So similarly for XOR, it will set each bit to 1 if only one of the bits is 1. And then we have bitwise NOT operator, which is going to invert all bits. Let's say if we have all bits that is 1, it is going to convert all those bits to 0. And then I have told you about left shift and right shift as well. So this is about operators in Python, guys. Let's understand what exactly is a tuple in Python. A tuple is an immutable data type in Python, and it is almost similar to a list in Python in terms of indexing, which means we can access the elements of a tuple using indexes, and they can also have duplicate members just like a list as well. And it is a collection data type that stores Python objects separated by commas. And let me show you an example which will explain how we can create or declare a tuple in Python. So let's take it up to Jupyter Notebook, guys. As you can see, now we are in the Jupyter Notebook, and I have a file named tuple in Python over here. So I'll just show you how you can declare a tuple in Python. So I'll just take a variable here, and inside this, let me get a few values inside round brackets. So I'll just go with 1, 2, 3, 4, and 5, because this is a very basic example, guys. And when I print A over here, this is my tuple, guys, which is separated by commas and inside the round brackets. But there is one more approach to this, where you can actually declare a tuple like this. So you simply have to mention some value separated by commas. And when I print A again, I'm getting the same value as I was getting before. So I can follow both of these approaches to actually declare a tuple in Python. So this is how we can create a tuple in Python. Let's take a look at the next topic that we have, which is accessing elements in a tuple. So accessing items in a tuple works similar to a list, and we can access elements in a list using indexes. And we can specify the index value, and it will return the item that is stored at the particular index value. Now talking about indexing, it is a data structure technique to effectively retrieve the information from a data structure. And in Python, several data types support indexing like list, a string, etc. So what happens is, let's see, for example, we have a tuple with 5 natural numbers that have 1, 2, 3, 4, and 5. So the indexing will start at the value 0, where 1 will be stored, and it will go until the end of the tuple, that is the number 5, and the index value at number 5 will be 4. So in Python, we can use the negative indexing as well to access elements in a tuple or any other data type that supports indexing. So let me take it up to Jupyter Notebook, guys, and I'll show you how you can use the index values to access elements in a tuple. So we have A over here. So inside the square brackets, I'll specify the index number. Let's say 4 over here, because we have 5 elements. So it should ideally, give me the value number 5. Okay, I have an index arrow which says index out of range because we have only 3 values over here. So I'll be getting to this also, like reassigning the values to a tuple. So I'll just write 2. Now I'm getting the value 30 over here because in my tuple, that is the variable A, we have values 10, 20, and 30. So the index number at 10 will be 0. So similarly, at the element number 30, we'll have the index value as 2. So we're getting this output. Now talking about negative indexing. So if I write -1 over here, what will be the value I should be getting? I'm getting the same value as 30. So when we talk about negative indexing, it will start with 30. So the negative index -1 will be at 30, and for 20 it will be -2, and similarly -3. So this is all about negative indexing. Now let me talk about slicing, guys. So slicing is basically a technique in which we use a slicing operator, which is colon, and it is used to get a range of elements from a tuple or any other data type that supports indexing for accessing elements. So let me just show you an example. This time I want the variable to be distinct, and I'll just specify the numbers as, let's say, okay, these numbers from 1 to 9. So when I print this, I have a tuple which has values ranging from 1 to 9. Now talking about slicing, it works similar to indexing only. It's just that we'll have to add that slicing operator. So I'll start at the index number, okay, 0, and then I want to go until the end of the tuple. So when I print this, I'm getting all the values inside the tuple. So in this tuple, the ending index is basically 8. So I'll just write 8 over here. And we are getting values until the index number 8. So you can see that number 9 is not included here. So when you are doing a slicing operation, the index number that you write after the slicing operator will not be included in the output. Similarly, we can use the negative indexes as well. I'm getting the same values, and I can use values like these also. So I'll just write -8. The output is the same. So this is all about slicing, guys. Now let's take a look at the next topic that we have, which is changing a tuple. So even though tuples are immutable in nature, but a nested object in a tuple can be changed, or in general, a tuple in Python can be reassigned with a different value. So I'll just show you the example how we can do that. So talking about the Python nested objects, let's say I have a tuple which has values 10, 20, 30, and inside this I have a list as well which has values 40, 50, and 60. So this is my tuple. When I print A, my tuple looks like this. So the first 3 elements in the tuple are 10, 20, and 30. And then the 4th element is basically an object which is a list. Now what I'll do is I'll try to reassign the values inside the tuple. So I'll go to the 3rd index, which is the list. And inside the list, I want to change the value that is 50 to, let's say, 55. So I'll just specify 1 over here and I'll write 55. And now when I print this, as you can see, I have actually changed the value inside the list, guys. Now let me try to do this with other elements. So let's try to change 30 to 35, let's say. So I'll specify the index number 2. Let's say I'll write 35. I'm getting a type error which says tuple object does not support item assignment. So it's basically a way around this error that we will get, like the type error if you are trying to change an item inside a tuple. But for these objects, the nested Python objects, you can actually reassign the values very easily. Now let's take a look at the next topic that we have, which is concatenating 2 tuples. So it might sound a little overwhelming, but joining 2 tuples is a very easy task. So you just have to assign the addition of the 2 tuples to another variable, and it will return the concatenated tuple with the values of both tuples. So let's say you have a tuple with the variable A, and then you have another variable B with another tuple. So what you'll do is you will just assign one more variable, let's just say C, and inside this you can do the addition of both A and B, and you'll get the resultant as a concatenated tuple. So I'll take it up to Jupyter Notebook and I'll show you how you can do this. Okay, we already have A and B. So I'll just take one C variable, and inside this I'll just do A plus B, no errors, and I'll try to print C now. As you can see, I have both A and B inside one tuple. So I have actually concatenated both the tuples inside one tuple. So this is how concatenation works with tuples, guys. So now let's take a look at the next topic that we have, which is deleting a tuple. So being an immutable data type, a tuple in Python does not allow any changes, and you cannot even remove an element from tuple after the declaration. But there is a keyword which is del, and which will delete the whole tuple altogether. So I'll just show you guys. So we have a tuple C over here, which is the concatenated tuple. So I'll try to delete this. I'll just write del C, no errors. Now when I try to print C over here, it's not there because we have deleted the whole tuple over here. So this is how deletion works with the tuple, guys. You cannot delete just one element from a tuple. Instead, you can delete the whole tuple altogether. So let's just go to the next topic, which is tuple methods. So there are not many methods like list or other data types that we have in Python. There are basically a count method and an index method. So count basically returns the count of the items, and index will return the index of the item specified. So let me show you this with an example. So let's just say I have a tuple named A, and inside this I have values, let's just say 1, 1, 1, 1. I have written 5 ones over here because we can have duplicate items inside a tuple. And let's just say 2, 3, 4, and 5. No errors. Now when I print my A here, I have this tuple. Now to show you how you can use these methods, you just write a dot count, and inside this I'll just write 1, and it will return the number of times 1 has been written inside the tuple, which is 6. Similarly, the next method that we have is index. So to check the index value at a particular element, I'll just write 5 over here, and it will return the value of the index at that particular element. But what if there is a duplicate member? So I'll just write a.index. I already know that 1 is written multiple times inside the tuple. I'll just write 1 over here. So it's going to return 0 because it will return the index value of the first item that is being encountered. Even though we have the count as 6 for the element 1, it will give the index value as 0 only. So this is all about the tuple methods. Let's take a look at the next topic that we have, which is list versus tuple. So I'll give you a few different points. So first of all, a list is used for homogeneous data types, and a tuple is generally used for heterogeneous data types. A list is mutable in nature, and tuple is actually immutable in nature, which helps in faster iteration as well. So tuple is basically faster when it comes to iteration, like you're working on for loops or any other loops for iteration statements. So if you're using any iteration statements, tuple is much faster than a list. And a list does not have any immutable elements, but immutable elements can be used as a key for a dictionary while we are using a tuple. Last but not least, we have no guarantee that the data is write protected inside a list. But if you're using a tuple, implementing a tuple with data that does not change guarantees that it is write protected. So these are a few basic differences between list and tuple. So let's take a look at the next topic that we have, which is the tuple constructor. It is possible to create a tuple using a tuple constructor as well. I have shown you the two different approaches you can follow to create a tuple, but there is a tuple constructor which we can use to actually create a tuple. So let's take it up to Jupyter Notebook again. I'll show you how you can use the tuple constructor. Let's just say we have a list, guys, and I have these values 1, 2, 3. So this is my list, and when I print my list over here, I have the values 1, 2, and 3. So using this tuple constructor, I can actually change the list into a tuple, guys. So when I run this, no errors. Now when I print B over here, it will have all the elements inside the list, but this time it's a tuple. So we can actually use a tuple constructor to change a data type for typecasting, and it can be used to create a tuple as well. So this is all about tuple constructor. Let's take a look at the next topic, which is a few other examples. So I'll be showing you two examples, which is iterating through a tuple and a membership test on a tuple. So let's take it up to Jupyter Notebook. First of all, I'll iterate through a tuple. So let's just say I have a tuple, guys, with a value until 9, and let's say for I in A, print I. So this is how you can iterate through a tuple using a for loop, or you can use any other loop as well. And this is a very basic example. Let's take a look at the next example, which is a membership test. So for the membership test, you can use the membership operator, which is in, and in Python we can check whether an element is present in a tuple or not. So the following example is going to show you how you can check if an element is present in a tuple or not. So we'll use this A only. So let me just try to print this A. Okay, we have the same tuple. I'll just print it basically. So I'll check 9 in A, which is true, and I'll just try to check if 10 in A, which is false, and I'll check if a string in A. And I forgot to tell you guys, it's not necessary that you have to use the integers only. You can use the string or any other data type inside tuple. Like I've used the list data type as well.
What is a set? A set is basically a data structure, guys, which is a collection of unordered elements. All elements in a set are unique, which means every element is present just once. Now these values can be of any data type, but they are not indexed. And because of this, you cannot perform indexing operations such as slicing on sets. So now that you know what are sets, let's move on and see when to use sets in Python. Sets can be used when the order of data actually does not matter, but the only concern is your data elements need to be unique. So now let's move on to see how to create sets in Python. To create sets in Python, you can use two methods. The first method is to use the curly braces, and the second is to use the set constructor. I have a small example where I created a set A using curly braces and a set B using the set constructor. Now let's move on towards our Jupyter Notebook and create some sets in Python. The first thing I'm going to do over here is change the name of my notebook. You can give any name of your choice and rename it. Like I've already told you, you can create sets in two ways. The first to use curly braces and the second to use the set constructor. Let's just create some sets using both these methods. I've created a set A using curly braces, and then I've specified some random values to it. You can also notice that all these values are of different data types. After that, I've created a set B using the set constructor. This set constructor has converted a list of values into a set. Hope you're clear with how to create sets. Now let me just show y'all how to create an empty set using the set constructor. All you have to do is give some name to your set, say for example C, and use the set constructor without passing any values to it, and hit 1. Now when you print this set, you can see that the set is empty. It has returned an output which is an empty set. So I hope you're clear with how to create sets in Python. Now let me just show y'all what are all the methods you can use along with sets. To do so, you can use the dir method and supply the name of the set as a parameter to it. When I used dir and passed a as a parameter, which is a set that I've already created, it has returned a number of methods as its output. So all these are the methods you can use along with sets. Now let's get back to our presentation and see what are the operations we are going to perform in this session today. First of all, we'll be finding the length of a set and accessing its elements. After that, we'll be adding or updating elements of a set and then removing and deleting elements from it. Following that, we'll perform the mathematical operations that are union, intersection, and difference of sets. Now let's move on towards the first operation of this session, which is finding the length of a set. To find the length of a set, you can use the len method. The length of a set is the number of elements that are actually present in that set. And this len function will return an integer value which is equal to the number of elements present in the set. I have a small example where I've created some random set with the name mySet and I've passed some values to it. After that, I've used the len function and passed the name of the set as a parameter. Now let's go to our Jupyter notebook and see what happens when I do this. I've already created set A, B, and C. I'll just reprint my set A over here so that it's easy for us to refer to it. Now let's find the length of A. When I used len of A, it has returned 7 as the output, which is equal to the number of elements present in my set A. Now let's get back to our presentation and see how to access elements of a set. Since set contain unordered elements, you cannot use index values to access its elements, but you can loop through it to access the elements of a set. I'll just jump onto my Jupyter notebook and show you all how to access set elements. I'll reprint my sets A and B over here. I've used the for loop to access the elements of set A. All I've done is for every element present in A, print that element. And as you can see in the output, all the elements present in A have been returned one after the other. Now let's get back to our presentation and see how to add elements to a set. To add elements to a set, you can use either the add method or the update method. Now this add method will allow you to add a single element to your set, but the update method will allow you to add a list of values to your set. I'm going to be showing you all how to use both these methods in this session. So here is my Jupyter notebook. When I use the update method, I've passed a list of values to be added to the set C. But here, I've passed 3 again, and 3 has been added just once, and it's not been repeated again. This is because sets contain unique elements and there is no second copy of one element present in a set. So I hope you've understood how to add elements to a set. Now let's move on to understand how you can remove elements from a set. To remove elements from a set, you can make use of the remove, discard, or the pop methods. The remove method takes one parameter, which is the element to be removed from your set. Now, in case that element is not present in the set, this method is going to throw an error. The question is, what if you're not sure if some element is present in your set or not, but you want to make sure that this element is not present and your program does not throw an error? In this case, you can use the discard method. The discard method takes one parameter, which is the element to be removed, and in case that element is not present in the set, this method will not throw any error. Now moving on towards the pop function. The pop method removes a random element from your set. Now let's get back to our Jupyter notebook and use these methods. I'll reprint all the 3 sets over here. First, I'll use the remove method. I've used the remove method and I've specified 2.4 to be removed from the set A. When I print the set A, 2.4 is no more present in my set. Now let me try to pass some value that is not present in the set A. When I use a.remove6, which is not present in the set A, it has thrown a key error and it specified that 6 is the key which is not present in the set A. So I hope you've understood how to use the remove method. Now let's use the discard method and see what happens. When I used b.discard 3, it has removed 3 from the set B. Now let's try to give some parameter to the discard method which is not present in set B. When I used b.discard 90, it has executed but it has not thrown any error. So I hope you're clear with both these methods. Now let's try to use the pop method. When I used a.pop, It has popped some random value from the set A and it has returned it as the output over here. 1 is no more present in the set A. So I hope you're clear with how to add and remove elements from a set. Now let's move on to our presentation and see how you can find the union of sets. Union of sets refers to the concatenation of two or more sets into a single set. But in case you have any common values in these sets, the resulting set will contain just one copy of a common element. You can perform the union operation in two ways. One is using the pipeline symbol and the second is using the union method. I have a small example where I've created a set A and B and then I've used the pipeline symbol and the union method to find the union of these two sets. Let's go to our Jupyter notebook and see how this works. I'll reprint my sets A, B, C over here. I've used the pipeline symbol to find the union of A and B. All the elements that are present in A and B has been returned as a new set, which is the union of A and B. But the common elements are just printed once. Now let's see how to use the union method to perform this operation. I've used the union method to find the union of A and B. Now let's try to find the union of three sets using both these methods. As you can see in the output, I've used the pipeline symbol to find the union of three sets and then I've used the union method to find the union of A, B and C. So I hope you're clear with this. Now let's get back and see what is intersection of sets. The intersection of two or more sets is the formation of a new set consisting only of the common elements that are present in all these sets. You can perform this operation in two ways. One is using the ampersand symbol and the second is to use the intersection function. I'll be showing you all how exactly to do this on our Jupyter notebook. I've used the ampersand symbol to find the union of A and B. And you can see over here the elements that are common between the set A and B are 4 and ABC. Hence the output. Now let's try to use the intersection function. I've determined the intersection of A, B and C using the intersection function and the resultant is a string which is present in all these sets. So I hope you're clear with both these methods. Now let's get back to our presentation and see what is the difference of sets. The difference of sets produces a new set which contains all the elements that are present in one set except the common elements. To make you all understand this concept clearly, let me jump onto my Jupyter notebook. To find the difference of set, you can use either the minus symbol or the difference method. First over here, I'll be using the minus symbol. When I found the difference of A minus B, I've got all the elements that are present in A, but not the common elements of A and B. When I used B minus A, a set has been returned which contains all the elements of B except the common elements of B and A. So I hope you're clear with what is the difference of sets. Now let's use the difference method to do the same. I've used the difference method to find A minus C. And as you can see, all the elements present in A but not the common elements of A and C have been returned as my output. You can use the difference method to find the difference of three sets as well. When I found the difference of A minus B minus C using the difference method, only one element has been returned which is present in A and not present in B and C. Hope you're clear with this. Now let's move on towards our final topic of this session, which is the concept of a frozen set. A frozen set is a set whose values cannot be modified, which means when you freeze a set, it becomes immutable. To create frozen sets in Python, you can use the frozen set method. As you all know, I've created a set A. Just make a note, guys, that you cannot add or remove values from a frozen set. As you all know, I've created a set A, which is a normal set, and I've been using it to add and remove values from it. Now let's freeze this set. I've created a new set D, which is a frozen set, and I've supplied the values of A as a parameter to this frozen set constructor. Now let's see what happens if I try to add some values to this frozen set. When I used d.add3, it has returned an attribute error, which says frozen set object has no attribute add. Therefore, frozen sets are immutable, and you cannot change the values present in the frozen set. Frozen set helps to serve as a key in a dictionary.
So what is a dictionary in Python? It is a collection data type just like a set or a list, but there are certain features that makes dictionary unique. So let's take a look at the features of Python dictionary, guys. First of all, it is unordered and we can change values in a dictionary as well since it is mutable. Also, it has key value pairs, which is like a map that we have in other programming languages, and it is indexed as well since the keys are distinct and can be used as indexes to access or change any values in the dictionary. A dictionary does not have any duplicate members as well. Now that we know what dictionary in Python is, let's talk about why we use a dictionary in Python. First of all, the reason would be is unordered and stores data like a map. So it is one unique feature that Python dictionary has, and it also contains the key value pairs unlike any other data type or object in Python. It is almost similar to a real life dictionary where we have distinct values, and corresponding to these values, there are respective definitions. In case of the dictionary, even though there are no duplicate members, we can mention duplicate members in the values, but the keys has to be unique in order to access these members, since there are no indexes. Also, we use the keys as indexes when accessing these elements. Now that we have learned about why we use a dictionary, let's understand how it is different from a list in Python. So I've listed down these differences between a list and a dictionary. So first of all, list is ordered, but the dictionary is not. Dictionary is actually unordered, guys. The next one is list has indexes, but in order to access elements in a dictionary, we use the keys as indexes. The next one would be the list is a collection of elements, but in dictionary we have the key value pairs as elements, which is unlike any other data type or object in Python. The next one is list is often preferred for ordered data, but dictionary is preferred when the data has unique key values. So this actually differentiates a list from a dictionary, guys. And the next one is list have duplicate elements as well, but in dictionary we do not have any duplicate elements when we are declaring the keys, although we can have duplicate members when we are specifying the values for each key. So these are the differences between a dictionary and a list, guys. I hope you are clear with the difference between those two. Now that we have understood what a dictionary is in Python and why we use it and how it is different from a list, let's try to understand how we implement a dictionary in Python. So first of all, to declare a dictionary in Python, we have to use the curly brackets, just like you can see in the example here. I have the dictionary with the name my dictionary, and inside those I have the key value pairs inside the curly brackets. So let's take it up to PyCharm, guys, to understand how we implement a dictionary in Python. Let's enter the presentation mode, guys. So we will try to implement a dictionary here. Let's take the name of the dictionary as A. So inside the curly brackets, I can give the key value pairs. So I'll give 1 as my first key. So when I'm specifying the key value pairs, I have to use the colon to separate the key from the value. Now I'll give one value over here. Now when we are declaring a dictionary, we have to separate these key value pairs with a comma. Now I'll give another key, give it a value, let's say data science. I'll give one more key and give it a value, let's say Python. So this is my dictionary, guys. This is how we actually implement a dictionary. I've declared a dictionary over here. Now let's try to understand how I'm going to access these elements. So I'll just write A. Inside the square brackets, I'll specify the key value. So I'll put it inside a print statement, guys. Now as you can see, when I run this, I will get the value that is specified in the first key value, which is Edureka. Now I can simply just print all of my dictionary, guys. So this is how I'm going to get the output as when I print the dictionary that I've just specified. Now to access these elements, I can also use the get function, and inside the get function I'll just specify the key value, and when I run this I will get the same output as I was getting using the square brackets, guys. So this is how you access elements inside the dictionary. Now I can also replace values inside the dictionary, guys, since it is mutable. So instead of data science, let's say I want machine learning. So what I'll do is I'll just specify the key value and I'll specify the value that I want to replace it with. Now when I print this, you will see the replaced value inside the dictionary. As you can see here, I have replaced the value inside the dictionary, guys. Now if I want to add one more value inside a dictionary, what I'm going to do is I'll just specify the key value, that is, let's say 4, because we don't have 4 over here. So instead of machine learning, I'll add the value data science that I have just replaced. Now when I print my dictionary here, let's see what all values I'll get. I'll get one more value that I've just added, which is data science. So this is how you actually implement a dictionary, guys. And to access these values, you can either use the square brackets, and inside those square brackets you can specify the key value, or you can just use the get function. And inside the get function you have to specify the key value as well. So now that we have understood how we can implement a dictionary in Python, let's try to take a look at the operations that we have in Python dictionary, guys. So as I've already told you how you can actually add an element to your dictionary, just like this. I've specified a key value and given it a value, and then there is a replacing element, which I have already shown you, guys. So these are all the operations that we have in Python dictionaries. So we will look at them one by one, guys. So let's take it up to PyCharm and understand these operations, guys. So we'll once again enter the presentation mode. So we have a dictionary over here, guys. So first of all, let's talk about clear. So when I use the clear, what it's going to do is it is going to remove all the elements from the dictionary. So when I run this, so I have a dictionary, guys, that I've already specified. So let's try to print the dictionary first, so you will understand what all these operations are going to do. So I have this dictionary which has these values. All right, so I'll do one thing. I'll use the first operation, that is clear. Let's see what it does to our dictionary, guys. When I run this, okay, so now when I print my dictionary, let's see what all values I'll get. It is saying that it is empty because the clear function has actually deleted or removed all the elements from the dictionary. So this is what clear does, guys. Now let's take a look at the another one which we have. Also, I will want to declare this dictionary once again, and when I print this, I should be getting all these values again. Yes, I'm getting these values, so it would be fine if I do one more thing. So I'll just use the copy over here. So what copy does is it returns a copy of the dictionary, guys. So let's say when I print B over here, what is going to happen? It's going to show me a copy of this dictionary that I've just specified over here using the copy function. So let's take a look at the next one we have, which is the values. So when we are using the values function, what it's going to do is it is going to return all the values inside the dictionary, guys. So when I run this, it will print all the dictionary values inside a list, which is Edureka, data science, and Python. So we'll look at the next one we have, which is the update function. So what does update function do? Update function actually updates values of the dictionary with the specified key value pairs. So let's say if I use update just like this, what will happen? we have no updates, which it is showing that we haven't updated anything. So this is what update does, guys. If we have made any updates, it will update the changes into the dictionary. So we'll look at the next function that we have, which is actually get function. I've shown you how to use the get function. We'll just use the get function to get the values, and inside this I just specify the key value, and it will return the value with the specified key, which is actually Edureka. So this is how you actually access the elements using the get function. Next one is the items function, guys. So I just use items over here, and inside this I will get the list for a tuple of each key value pair, guys. So let's run this. So when I run this, I'm getting a tuple of each key value pair. As you can see over here, I have 2, then I have the value, then I have one more key. So this is a tuple of each key value pair, which you can get using the items function. Now coming back to the next one that we have, which is the keys function. So what it will do is it will actually return all the keys inside the dictionary that we have, which is 1, 2, 3, guys. So this is all about keys function, guys. So let's talk about the pop function, guys. So when I use the pop function, what it will do is it will actually pop the value with the specified key. So I just pop this from the dictionary with the value 3. So as you can see, I'm getting that value over here, guys. Now let's take a look at the next function that we have, or the operation, which is pop items, guys. So when I'm using the pop item function, I can actually remove the last inserted key value pair. So I don't have to specify any values over here. As you can see, I'm getting the tuple of the last key value pair I have specified inside the dictionary. So this is what pop item does. Now the next function that we have is set default, guys. So what set default does is it returns the value of the specified key. If the key does not exist, we can insert the key with the specified value. So I'll specify the value over here, let's say 1. Now when I print this, I'm getting Edureka as well. So when I specify the next key, it is showing me, okay, it's a syntax error. I'm getting the next value. So this is what set default is used for, which is returns the value of the specified key, guys. So this is all about the operations that we have in a dictionary, guys. There is one more thing to discuss about the dictionary, guys, which is the dictionary constructor. So the dictionary constructor is actually used to declare a dictionary, guys. So let's take it up to PyCharm again. So I'll show you what a dictionary constructor does. So I'll use I'll use my dictionary as my variable dictionary name, and I'll use the dictionary constructor over here. I'll specify the values. So what I'm going to do is I'll just specify the values. I will use the keys as, let's say, key 1 only, and I'll give it a value, let's say Edureka. Now I can give another key value, let's say 2, and I'll give it a value, let's say Python. Now let's see if I can get a dictionary from this. So using the dictionary constructor, let's see if we have actually implemented a dictionary over here. So as you can see, I have declared a dictionary using the dictionary constructor, guys. So when I run this, I should be getting a dictionary here. So as you can see, I have declared a dictionary using the dictionary constructor. Also, one more thing I have missed over here when I was explaining the operations, guys. So which is the from keys operation. So I'll declare one more dictionary over here, give it a value, let's say 1, 2. I'm giving it a random values, guys. Don't be alarmed. Now when I'm using the from keys keyword, what I do is I'll just say a dot from. Okay, we don't have a over here, so I'll write a from keys. I'll specify my dictionary over here. So let's see what happens, guys. Okay, I'll just use the print statement, and inside this I will use the from keys, and inside this I'll specify my dictionary. Let's see what happens when I run this. So I'm getting a dictionary with the specified keys and values. So as we don't have any key 1, key 2 inside this, so we are getting the none value over here. So this is what from keys does inside a dictionary, guys. So now that we have actually learned what is a dictionary and how we can implement it in Python and all sorts of operations that we can perform on a dictionary, let's try to understand what a nested dictionary, guys. So for this I have a problem statement, guys. So now that we know that ICC Cricket World Cup is just around the corner, guys, so what we'll do is we will implement a dictionary with the stats of the 15 members from the Indian cricket squad for the World Cup 2019, and we will use the concept of nested dictionary in the use case. So what we'll do is we'll implement a dictionary first, and then we will make the unique keys to access those values when we are actually getting the elements from the dictionary, and then we will store the data inside the dictionary, and we will also import a Pandas package and convert those data into a data frame for better display statistics. So let's take it up to PyCharm, guys. So okay, let's exit the presentation mode. So over here I have the value of the dictionary that I've implemented. So let's take it up to presentation mode again. So as you can see, I have this module that I've actually imported from Pandas, and I've given it an alias as PD. So we'll talk about this later. So this is my dictionary, guys, in which I have made 4 more dictionaries, guys, which is actually our nested dictionaries. So first key is batsman. Inside the batsman key, I have all those batsmen like Rohit Sharma, Shikhar Dhawan, and Virat Kohli. And inside those values, I have one more dictionary in which we have the statistics for all those matches, runs, average, highest score. So actually inside this batsman key, I have 2 more dictionary, guys. So this is the concept of nested dictionary. So similarly, I have made for all rounder, and we have wicket keepers and bowlers as well. So this is my dictionary, guys, that I've actually stored all the data using the dictionary, or as you can say, nested dictionary. And then I have all these statements that I've written in which I have converted the data inside the dictionary into a data frame, guys. So I have this print statement. So first of all, let me print the batsman squad, in which we will get the values for all the batsmen that we have inside the World Cup squad. So as you can see, I'm getting a data frame over here. So I have these values. We have Rohit Sharma, Shikhar Dhawan, and Virat Kohli. So as you can see, we have average, highest score, matches, and runs over here. So for Virat Kohli, we have more than 10,000 runs. Shikhar Dhawan has 5,000 runs, and Rohit Sharma has around 8,000 runs, guys. So let's try to understand more from the dictionary that I've just mentioned over here. We have got all the batsmen now. We will try to get all the bowlers. So I'll just print this statement, and it will show me all the bowler statistics, which is Kuldeep Yadav, Mohammad Shami, 𝐏𝐲𝐭𝐡𝐨𝐧 𝐅𝐮𝐥𝐥. So we have all these statistics in which we have average, we have best figures, then we have matches and wickets as well. So as you can see, we have Bhuvneshwar Kumar with the most wickets, which is 118 wickets, guys. So this is what you can actually do using the nested dictionaries, guys. As you can see, this is an unordered data, but we have key value pairs, which actually helps in retrieving the data very easily, guys. So let's say inside bowler, I want Jasprit Bumrah, or for all-rounder, I want Hardik Pandya. All these statements, I can use it for getting all those values inside a data frame.
Why we need loops. Now, let us understand this with an example that is there in front of your screen. Suppose you are a software developer, and you are required to create a software module for payroll processing of all the employees in your office. Now, what are things you need? You need the salary of those employees, the bonus, and the total amount that they'll get after the end of the month, right? So all these things, for each employee, you need to print. So for each of the employees, you need to print all these three details. Now, there are two ways of executing this task. So let us see what are those two ways. So the one way is you can actually write a logic to calculate the total salary of each of the employees. That includes all the fields like salary, bonus, and total. And you are going to write that logic for all the employees that are there in your office. There might be hundreds of employees that are there in your office. So you need to write the logic, or you need to write the code for all of those employees. So this process is actually pretty hectic. You need to repeat the same logic for the total amount of employees that are there in the office. I'm just giving you an example of 3 employees, but what if you have like hundreds of employees? So at that time, this particular process will not work. This will not only increase the size of the code, it'll make it more complex and less efficient. Now, another way of approaching this task would be, you write the logic to calculate the salary. You keep on iterating that logic for the total number of employees that are there. So when this loop runs once, it'll print the salary of the first employee. When the loop runs for the second time, it'll print the salary of the second employee. Similarly, it'll keep on repeating. So if you have 100 employees, it'll repeat for 100 times. Now, what advantage we get here? The major advantage that we get here is, we don't need to write the logic for each employee in order to calculate the salary. We can write one logic and keep on repeating it for all the employees. So this way, the size of the code gets reduced. The length of the code is reduced. At the same time, it reduces the complexity, makes it more efficient, and even increases the speed of execution. So this is just one example in order to show you why we need loops. So there are hundreds of thousands of examples that you can think of why we need loops, right? So this is just one simple example that I've shown you in order to make you understand why we need loops. So let us move forward and see what exactly are loops. Let me explain this with the help of the flowchart that is there in front of your screen. Now, what are loops? Loops basically allows us to execute a statement or a group of statements multiple times. Let me explain you this with the help of an example that is present in front of your screen. Now over here what happens, the control comes here and checks the condition. So if this condition is true, it'll go on and execute the conditional code that is here. This is nothing but the statements that are present inside the loop. So it'll execute that, and again it'll go back and check the condition. So if the condition is still true, then again it'll execute the conditional code of the statement present inside the loop. And it'll keep on repeating until this condition becomes false. And the moment this condition becomes false, the control will move out of the loop and it'll execute statements that are present after that loop. Now one thing to notice here, guys, is that there can be two kinds of loops. One is finite. This is actually the flowchart for the finite loops, and another can be infinite. Now in infinite loops, what happens? The condition will never be false. So at that time, the control will never come out of the loop. So it'll keep on repeating and it'll never stop. That is what infinite loops are. So basically the condition will never be false, and that loop will be executed an infinite number of times. Now there's one more way in order to categorize loops. That is called post-test and pre-test. In post-test loops, what happens? The control will first enter the loop, and then in the end, it will actually check the condition. But in pre-test loops, the control will enter the loop only when the condition is true. So the condition is checked in the beginning of the loop in pre-test loops, but in post-test loop, the condition is checked at the end of the loop. Now in Python, there are no post-test loops present. There are only pre-test loops. So we'll focus on pre-test loops in today's session. So we'll move forward and we'll see various types of loops that are present in Python. So Python basically supports 3 kinds of loops. One is while, for, and nested. We'll look at all these loops one by one, and I'll explain you with examples as well. So first we'll have a look at while loop. So while loop is basically used when you don't know how many iterations are required. So let me explain you this with the help of the flowchart that is there in front of your screen. Now over here what happens, the control will move inside the loop only when this while condition is true. And when it is true, it'll execute the body of the loop. And then again it'll go back and see whether the condition is still true or not. If it's still true, then again it'll execute the body of the loop and it'll keep on doing that until the condition becomes false. And the moment the condition becomes false, it'll come out of the loop and execute the statements that are present after the loop. Now this is the syntax for while loop. First you need to write while, then you write the expression or the condition, then you give a colon and the statements or the body of the loop. Now why we use while loop? Basically I've told you earlier as well, while loop is used when you don't know how many iterations are required. So you don't know how many times you need to execute the statements that are present inside the loop. So that's the reason why we use while loops. Now let me show you that with the help of an example. I'll open my PyCharm and I'll give you a very basic example of using while loop. And after that I'm going to increase the complexity of the code. So first we'll see a very small introductory example of while loop, in which I'm going to print the integer values between 0 to 9. That won't include 9. So it'll print 0, 1, 2, 3, 9, but it won't include 9. So let me open my PyCharm and show you how to do that. Now this is my PyCharm, guys. So over here, as I've told you earlier as well, I'm going to print the integer values between 0 to 9, but that won't include 9. So for that, what I need to do is I need to first define a variable. Let me name it as count, and I'm going to initialize the value to it, that is 0. Now after that, I'm going to use the while loop, and I'll write while, and then I'm going to give a condition which says that when count becomes greater than 9, it should come out of the loop. All right. So now what I'm going to do is I'm going to just type in print let it be number, colon, comma, print count, right? Now I'm going to increment the value of count equal to count plus 1. Yep. Now when I come out of the loop, I want to print, say, goodbye. Yeah, looks fine. Now let me tell you what I've done here. I've defined a variable and I've initialized the value 0 to it. After that, I have used a while loop in which I've given a condition that says that count should always be less than 9 because I want to print values between 0 till 9, which won't include 9. Let me tell you that. So my condition says that the loop should be executed only when the count value is less than 9. The moment it becomes greater than 9, then the control should come out of the loop. After that, it's just a general syntax. I have given a colon and then I have written a print statement that will print the count value. And after that, I have increased the value of my count by 1. And finally, when the control comes out of the loop, I want to print goodbye. So let's see whether it works or not. I'm going to run it. And as you can see that it works. So we have 0, 1, 2, 3, 4, 5, 6, 7, and 8. And finally, when the control went out of the loop, it has printed goodbye. This is just a very small example, guys. Now let me go back to my slides. Now the example that we just saw was a very simple example. So I'll increase the complexity of it. And I'll give you one more example. So let us move forward with that. So over here, what I'm trying to do is I'm trying to code a little guessing game. All right. So what happens in this guessing game? So there will be a random number that will be generated between say 0 to 20. And you need to guess that number. So the number that you have guessed is less than that random number. Then it will print number is too small. If you have guessed the number that is greater than the random number, then it will print that number is too large. And the moment you guess the right answer, you'll exit the while loop and you have won the game basically. So it's just a pretty simple example, but it's a perfect example in order to show you why we use while loop. Because if you notice here, I don't know how many iterations are required in order to guess the correct answer. So at that time, while loop is a perfect solution to this problem. So without wasting any time, I'll actually open my PyCharm and show you how to execute this. So this is the code here, guys. Let me explain you each and every line that is present here. Now what happens first, I need to import a module that is called random in order to generate a random number. Now over here I've defined a variable n and I've given a value to it that is 20. Because I want the random number that is to be generated should be between the range 0 to 20. Now I've taken one more variable and I've named it as to guess. And over here, it should be an integer type. So I've written int. And this logic will generate the random number that I'm talking about. And this will be generated between the range 0 to 20. So how will be generated? It will be generated with the help of random module that we have imported. So it will be n random.random plus 1. This will actually generate a random number between 0 to 20. So after that, what happens? I have defined one more variable guess, and I have assigned a value to it or initialized the value to it 0. Alright. So now comes the while loop. Now in while loop, I have given a condition which says that the number that I have guessed, if it is not equal to the random number, then enter the loop. Now once you enter the loop, you need to input the new number, the number that you want to guess again. Now if that guessed number or the number that you are guessing is greater than 0, then again there will be one more if condition which says that the number that you have guessed is greater than the number that has been generated or the random number that has been generated, then print number is too large. And if the number that you have guessed is actually smaller than the random number generated, then print number is too small. Now there's more condition that is else, which means that when the number that you have guessed is less than or equal to 0, then that means you are giving up. So it'll break, it'll come out of the loop and it'll print sorry that you are giving up. That's when your game is over and you have lost it. Finally, if you have guessed the correct number, then it will print congratulations, you have made it. So I hope you have understood the code that I was explaining here. So let us go ahead and execute this and see what happens. Alright, so it asks me for a new number. So it has to be between 0 to 20. So yep, I'll type 10 and let's see what happens. So it says number is too small. That means it is between 10 to 20. How about 13? Alright, so I've guessed the correct number and it says congratulations, you have made it. Now over here, as you can see, that it took only 2 iterations for me in order to guess the correct number. But what if it would have taken more iterations? I mean, I'm pretty unclear how many iterations it will take for me. So that is the reason why we use while loop, because we don't know how many iterations are required. Now we can run this program again and I can show it to you once more. Ask a new number, so I'll just type in say 14. It says number is too large, so I'll type in 11. Again, the number is too large, that means it is between 0 to 11. So how about 8, guys? Number is too small, so now as you can see that already 3 iterations have occurred. And for the 4th iteration, definitely the random number will be somewhere between 8 and 11. So how about 10? So congratulations, you have made it, and the control came out of the while loop and it has printed congratulations, you made it. So we'll move forward and see for loops in Python. So for loop is basically used when you know the number of iterations that are required. Unlike while loop where you are not sure about the number of iterations that are required, in for loop you know how many times the statements that are present inside the loops need to be executed. The for loop provides you with a syntax that will include 3 fields, basically, or you can say 3 informations. So first will be the Boolean condition, then comes the initial value of the counting variable, and then the incrementation of the counting variable. So as you can see from the syntax as well, first you write for, name of the variable in the range, then you specify the range in which that variable should be, and then you specify the range, that means from which point till which point it should be executed. So you know the number of iterations required, then only you use for loop. Now over here, as you can see from the flow diagram itself, the control comes to this and it'll see the item from the sequence. It'll execute the statement, go back again, and then from the range it'll pick up the next item. Again it'll execute the statement, again go back, and then from the range it'll pick up the 3rd item, and it'll keep on executing until the range becomes over, or that is the last item from the sequence. So when there are no items in the sequence, it will go on and execute the statements that are present after the for loop. So this is how for loop works, guys. Now let me just give you a very small example of how for loop works. I open my Python again and I'll start with a very small example, and then I'm going to increase the complexity of a code like I've done that in while loop. Now over here, what I'm going to do is I'm going to first define a list and I'm going to name it as fruits. So what all fruits you like, guys? I'll first type in mango, then I like grapes, and finally I'm going to write and say apple. Yep. So this is my list which contains 3 fruits, mango, grapes, and apple. Now I'm going to define a for loop, and over here what I'll write, I'll define a variable, say fruit. For fruit, in fruits, give a colon, print current fruit, and type in fruit. Now when you come out of the loop, just print again goodbye. So I have declared a list, and the name of that list is fruits. Now that fruits list contains elements which are mango, grapes, and apple. Now after that I have defined a for loop which says that for a variable named fruit in fruits. So this will give me the range. Fruits will give me the range. As you know that in the fruits list there are only 3 fruits. So I know it will iterate only thrice. First for mango, then for grapes, then for apple. So this is the difference between the while and for loop. In for loop I know that it will take only 3 iterations. After that, print the current fruit. That's all. And when the control moves out of the loop, print goodbye. It's pretty easy, guys. So go on, execute this and see what happens. So yeah, the current fruit first is mango, then comes grapes, then comes apple, and then finally print goodbye. So what I'm going to do is I'm going to increase the complexity now, as I've done that in while loop as well. So I'll show you an example. First, let me go back to my slides. So what I'm going to do in this example, I'm going to calculate the factorial. Now one thing to notice here, guys, again in factorial also I know how many iterations are required. Because if you see, if I'm calculating the factorial of 5 and I know that I need multiplication 5 times. First I need to multiply 5 with 4, then 4 with 3, then 3 with 2, and then 2 with 1. So this way I require only 4 iterations. So I know the number of iterations required. So it's a very good example in order to show you where we should use while loop and where we should use for loop. So let me go back to my Python and execute this practically. So this is the code in order to find the factorial of a number. So over here what happens, first I need to input the number that I want to calculate the factorial of. After that I define a variable factorial and I've initialized a value to it which is 1. Now I have defined a condition. If the number that I've entered is less than 0, then print the number must be positive because I can't calculate the factorial for negative numbers, right? And again I've given one more condition which says that if number is equal to 0, then factorial is equal to 1. And then else condition says that when number is greater than 0, then I've used a for loop. It says that for I've defined a variable I in range 1 to num plus 1. When I write num plus 1, the range will be between 1 to num plus 1, but it won't include num plus 1, so it will only be including 1 till num. Alright, so after that what I've written factorial is equal to factorial into I. So factorial was 1 earlier, then it will multiply by I will also be 1 in the beginning, and then again it will go back and it will become 2. Similarly, it will keep on increasing until it becomes num. So till that time, it will keep on executing the loop, and the moment it becomes equal to num, it will come out of the loop and it will print the factorial value. So let me go ahead and execute this and show you if it works or not. So I need to enter the number. So let's say I want to calculate the factorial of 3, which is 6. So if I want to enter one more number, so what I can do is I can start it once more. So what I'll type, I can type again 4. So it prints 24, which is absolutely correct. So we'll move forward and we'll see what are nested loops in Python. So Python basically allows us to use a loop inside another loop. For example, you can use a for loop inside a for loop, or you can use a while loop inside a while loop. At the same time, you can use a while loop inside a for loop as well, and a for loop inside a while loop as well. So that is basically what is called nested loops. Now we'll have a look at the example of nested loops as well, don't worry. So let us move forward and see one example of nested loops. Now over here what I'm going to do is I'm going to write a code in order to simulate a bank ATM. Alright, so for that I'm going to use nested while loop. And what will happen first, you need to enter the 4-digit PIN, and then you can perform the following functions. You can check the balance, you can make a withdrawal, you can deposit some money, and you can even, if you don't want to do anything, you can tell the machine to return your card as well. So let me show you how it is done. I'll open my Python once more. So this is the code that I've written in order to simulate bank ATM. I'll explain you each and every line, so don't worry about that. So the first line is nothing but a print statement that says welcome to Iron Bank Browse ATM. Alright. And then I have defined a variable restart and I've assigned a value to it that is y. Similarly, chances I've assigned a value that is 3, and this is the balance that I'm going to initialize, that is 67.14. Notice you over here you won't get more than 3 chances in order to write the correct password. Now comes the while loop, which says that when chances are greater than or equal to 0, at that time what it'll do, you need to enter the PIN. So you need to input the 4-digit PIN that you have. And if that PIN is 1234, then it will print that you have entered the correct PIN. Now comes one more while loop, which says that while restart should not be in this particular tuple. That is, the value of restart should not be n, capital N-O, small n-o, or capital N. So it should not lie within this particular sequence, that is n, capital N-O, no, and n. But we know that the restart value is y, so it will enter the while loop. Now over here, what will happen? It will give you 4 options. First option is in order to check your balance. For that, you need to press 1. To make a withdrawal, you need to press 2. In order to pay in some cash or you need to deposit something, you need to press 3. Or you want your card back, you need to press 4. So these are the 4 options that will be given to you. So when you choose option 1, it will print the account balance. So over here, as you can see that your account balance is, and the balance that is there in your account. After that, it'll ask you for a restart. So you need to input that value. So that will say, would you like to go back? And if your restart value lies in this particular tuple, then it'll break and it'll print a thank you statement. But if you want to continue or you want to go back, then you can press anything else apart from small n, no, or this no, or capital N. So if you press any other button apart from these, it'll actually go back. And in the while statement, as you can see, it says that it is not present here. So it'll give you all these 4 options once more. Now, after that, what if you choose the another option in which you need to make a withdrawal? So for that, what will happen? You need to enter the amount that you would like to withdraw, which can be a float number. It cannot be an integer number. So that's why I've used float here. So you need to enter that value. And once you enter that value, it'll check whether it is in this particular list or not. That is 10, 20, 40, 60, 80, or 100. Now, by default, it'll give restart y because you need to enter the amount once more. So again, it'll go back and it'll give you all 4 options. So you can choose the withdrawal option again, and you can choose a number which is present in this particular list. Now, when you choose withdrawal equal to 1, at that time, it'll again ask you, please enter the desired amount. So this is for option 2. Now, when you talk about option 3, it is pretty much similar to the couple of options that we have discussed before. So it's pretty much similar to that. Over here, again, whatever the amount that you want to pay in, how much amount that you would like to pay, and balance plus the amount that you are depositing. So it'll print the balance that will be equal to balance plus the amount that you're depositing. Again, it'll ask you for restart. If you press anything apart from this particular tuple, then it'll go back to the while statement and it'll give you all these 4 options. Similarly for option 4 as well. Now, what happens when you enter the incorrect pin? So there's one more condition in the end which says that if the pin that you have entered is not equal to 1, 2, 3, 4, then it will print that incorrect password and it will decrease the chances by 1. So earlier you had 3 chances. If you press the incorrect pin once, it will decrease the chance and it will make it as 2. Again, if you write the incorrect password, again it will make it as chances equals to chances minus 1, which will become 1. And if the third time also you do the same thing, then the chances will become 0. And the moment it becomes 0, then it will print no more tries, break, it will come out of the loop. That's all, guys. So let us go ahead and execute this and see what happens. So please enter your 4-digit pin. So I'll just write 1, 2, 3, 4. And it'll give me 4 options, which is 1 for balance, 2 for withdrawal, 3 for paying, 4 to return a card. So if I want to check my balance, I'll put in 1. So it has printed my balance, which is 67.14. And then the restart value that I was talking about, it is asking for that. Let me just make it big for you. Yeah. Would you like to go back? So if I press N here, it'll come out of the loop and it'll break. And if I press anything apart from small n, capital N, or small n, or capital N, it'll actually go back and give me all the 4 options that were there. So if I press Y, it'll again give me all the 4 options that are there. You can see that press 1. So again, if I want to make a withdrawal, I'll press 2. How much amount that I would like to withdraw? Say I want to withdraw 10. So my balance has reduced from 67.14 to 57.14. So would you like to go back? So I'll again press Y and it'll give me all 4 options. If I want to pay in something, if I want to deposit something, I'll press 3. How much amount that I would like to deposit? I'll say 10. So my balance became again 67.14. Again, it'll ask me, would you like to go back? No, I don't want to go back. So I can type in N. So yep. So it says thank you. And again, asking me for 4-digit pin. So let me show you what happens if I write the incorrect pin. Say if I write 111, incorrect pin. If I write that pin again incorrect. Again incorrect, so we have no more tries. It'll come out since I've exceeded the chances that I was given. So I was given 3 chances. I couldn't write the correct pin in those 3 chances. So it'll come out of the loop and it'll stop. So this is an example of nested while. Now let me go back to my presentation and I'll show you an example of for loop as well. So this is an example of nested for loop. So over here what I'm going to do is I'm going to write a code in order to print the Pythagorean number between a particular range. So what happens is, suppose if I want to enter number 20, that means I want the Pythagorean numbers between 1 to 20. So Pythagorean numbers are nothing but the integers which satisfy a square plus b square is equals to c square. So at that time, it will print all the Pythagorean numbers that are possible between 1 to 20. 3, 4, 5. You can see that 3 square, 4 square is equals to 5 square. 9 plus 16 is equals to 25. Similarly, it goes for 5, 12, 30, 6, 8, 10, 8, 15, 17, 9, 12, 15. Similarly for 12, 16, and 20. Don't worry, guys. I'll go back to my pie chart and I'll explain you how you can do that. So this is the example of a nested for. So first, over here, I need to import certain modules in order to use a square root function. So from math module, I'm going to import the square root function. After that, it'll ask me for the number. In the example, if you can remember in the slides where I've written 20, so it has printed the Pythagorean numbers between 1 to 20. That same number it will ask me, and it will print the Pythagorean numbers between 1 to n. So whatever the number n that I'm going to put in or give an input. After that, it will run a for loop, and it will say that for a, which is a variable, in range 1 to n plus 1. That means 1 to n. That means 1 to n plus 1, but don't include n plus 1. After that, there's one more variable b, which is in the range a, n. That will not include n. It will only include till n minus 1. So the square root c square, I've defined one more variable c square is equal to a exponent 2 or a to the power of 2. Similarly, b raised to the power of 2. Alright, and then what I'm going to do is I'm going to calculate the square root, and then what I'm going to do is I'm going to define one more variable c, and it'll be an integer that will be the square root of c square. So if that c square is minus c square is equal to 0, then print abc. It's pretty simple logic, guys. Okay, I'll explain it once more, Neil. So this is an example of nested for. So here what I'm going to do is I'm going to first import the square root function from the math module. After that, I'm going to input a number. So if you can remember in the slides, I've given it as 20. So it will print the Pythagorean numbers between 1 to 20. Over here also, it will print the Pythagorean numbers between 1 to n. So whatever the value of n you input, that will be depending upon it. So the Pythagorean numbers will be depending upon the values that you input. So it will be printing the Pythagorean numbers present between 1 to n. After that, I'll run a for loop which says that for a should be in the range 1 to n plus 1. That will not include n plus 1, guys. It will only include n. So 1 till n plus 1, but don't include n plus 1. After that, I've defined one more for loop which says that for b in range a, n. It won't include n, it will be till only n minus 1. I've defined one more variable here which is equal to c underscore square. That is equal to a square plus b square. Now after that I've defined one more variable c, and this will be actually the integer of the square root of the c underscore square. Alright, so whatever value that you'll get here, the square root of that value will be converted to an integer value and will be assigned to c. Now one if condition I'll be using here which says that if c underscore square minus c square is equal to 0, then print abc. That means that will be a Pythagorean number. So this is a pretty simple logic, guys. If you have understood it, just give me a thumbs up, or you can ask me any questions that you have in your mind. Alright, so I hope you have understood the code that I've explained to you here. Now let us go ahead and execute this and see what happens. Yeah. So the first number that I'm going to type in, say 5, and it'll give me all the Pythagorean numbers present between 1 to 5. So we have only one Pythagorean number, that is 3, 4, 5 in that range. Now I'll execute this once more and I'll type in 10 here. So we have two Pythagorean numbers that are 3, 4, 5 and 6, 8, 10. Similarly, if I execute it once more and I type in a big number, say 25. Yeah. So we have these many Pythagorean numbers present between 1 to 25. We'll again go back to our slides and we'll have a look at one more example. Now in this example, I'll actually be using a for loop inside a while loop. So what is this example? I want the bulk reservation of train tickets. So I have like a group of people who are traveling somewhere and I want to give their details such as name, age and sex. I want that to happen in bulk. I don't want to give it one by one. I just want it to happen in bulk. So for that, what I'm going to use is I'm going to use a for loop inside a while loop. As I told you earlier as well, you can even use a while loop inside a for loop. But for now, I'll use a for loop inside a while loop and see what happens. So let me go back to my PyCharm. So this is the code in which I'll be using a for loop inside a while loop. So first I have defined a variable traveling. So in which you need to input whether yes or no. So if you're traveling, you'll say yes, obviously, and then we'll have a while loop which says that while the condition is traveling equal to yes, that means if you're willing to travel, enter the number of people who are traveling. So you need to enter the number of passengers that are traveling, and that will be assigned to a variable num. Now there'll be a for loop which says that for num in range 1 to num plus 1, but it won't include num plus 1, enter the name, enter age, and finally whether a person is male or a female, and then print all those values. Now one more thing here is, again it'll ask you whether you have missed someone or not. So you need to input that. Oops, forgot someone. So at that time you can write in yes if you have forgotten someone. Then again it'll execute the loop. Again it'll ask you the number of people traveling and all these details. If you type in anything apart from yes, that means you have not forgotten anyone and it'll come out the loop. So it is a very small example, but a very good example to understand how for loop can be used inside a while. So let me go ahead and execute this. Whether you're traveling, I would say yes, I am traveling. Number of people traveling, I would say 3. Name is Saurabh. Age is 78. Male. Alright, so again it will ask me for one more name, so I'll say Neil. Age is 90. Male or female? Male. Yeah. So one more name I need to type in, say I will type in Jagati. Age is 98. Male or female? Female. And yeah, it will print all those details for me. So now it is asking, have you forgotten someone? So if I type in and say yes, then it'll again ask me the number of people traveling. That means it's again executing the while loop. So if I would say the number of people traveling is 1, and I would type in the name of the person that was traveling, so I would just say Siddharth, whose age is 77 and he's a male. Yeah. Again, it will ask me, so if I type anything apart from yes, say if I type n, so yeah, it'll come out of the loop, and this is how you can actually use a for loop inside a while loop.
Why we actually require functions. So guys, here I have for you a really simple use case. Consider this program, right? So let's say you actually write a program in which you input a Celsius number, let's say temperature of course, and this must be converted into Fahrenheit multiple number of times. What would you do? We first obviously start with the logic, right? So Fahrenheit is equal to 9 by 5 into the particular Celsius number plus 32. So this is the logic to calculate for Fahrenheit. Well, here's the program to calculate for the
new number, so I'll just type in say 14. It says number is too large, so I'll type in 11. Again the number is too large, that means it is between 0 to 11, so how about 8 guys? Number is too small, so now as you can see that already 3 iterations have occurred, and for the 4th iteration definitely the random number will be somewhere between 8 and 11. So how about 10? So congratulations, you have made it, and the control came out of the while loop and it has printed congratulations, you made it. So we'll move forward and see for loops in Python. So for loop is basically used when you know the number of iterations that are required. Unlike while loop where you are not sure about the number of iterations that are required, in for loop you know how many times the statements that are present inside the loops need to be executed. So for loop provides you with a syntax that will include 3 fields basically, or you can say 3 informations. So first will be the Boolean condition, then comes the initial value of the counting variable, and then the incrementation of the counting variable. So as you can see from the syntax as well, first you write for, name of the variable, in the range. Then you specify the range in which that variable should be. And then you specify the range, that means from which point till which point it should be executed. So you know the number of iterations required, then only you use for loop. Now over here, as you can see from the flow diagram itself, the control comes to this and it'll see the item from the sequence. It'll execute the statement, go back again, and then from the range it'll pick up the next item. Again it'll execute the statement, again go back, and then from the range it'll pick up the 3rd item, and it'll keep on executing until the range becomes over, or that is the last item from the sequence. So when there are no items in the sequence, it will go on and execute the statements that are present after the for loop. So this is how for loop works, guys. Now let me just give you a very small example of how for loop works. I'll open my PyCharm again and I'll start with a very small example, and then I'm going to increase the complexity of our code like I've done that in while loop. Now over here what I'm going to do is I'm going to first define a list and I'm going to name it as fruits. So what all fruits you like, guys? I'll first type in mango, then I like grapes, and finally I'm going to write and say apple. Yep. So this is my list which contains 3 fruits, mango, grapes and apple. Now I'm going to define a for loop, and over here what I'll write, I'll define a variable, say fruit. For fruit in fruits, give a colon, print current fruit, and type in fruit. Now when you come out of the loop, just print again goodbye. So I have declared a list and the name of that list is fruits. Now that fruits list contains elements which are mango, grapes and apple. Now after that I have defined a for loop which says that for a variable named fruit in fruits. So this will give me the range. Fruits will give me the range. As you know that in the fruits list there are only 3 fruits. So I know it will iterate only thrice. First for mango, then for grapes, then for apple. So this is the difference between the while and for loop. In for loop I know that it will take only 3 iterations. After that print the current fruit. That's all. And when the control moves out of the loop, print goodbye. It's pretty easy, guys. So go on, execute this and see what happens. So yep, the current fruit first is mango, then comes grapes, then comes apple, and then finally print goodbye. So what I'm going to do is I'm going to increase the complexity now, as I've done that in while loop as well. So I'll show you an example. First let me go back to my slides. So what I'm going to do in this example, I'm going to calculate the factorial. Now one thing to notice here, guys, again in factorial also I know how many iterations are required. Because if you see, if I'm calculating the factorial of 5, and I know that I need multiplication 5 times. First I need to multiply 5 with 4, then 4 with 3, then 3 with 2, and then 2 with 1. So this way I require only 4 iterations. So I know the number of iterations required. So it's a very good example in order to show you where we should use while loop and where we should use for loop. So let me go back to my PyCharm and execute this practically. So this is the code in order to find the factorial of a number. So over here what happens, first I need to input the number that I want to calculate the factorial of. After that I've defined a variable factorial and I've initialized a value to it which is 1. Now I have defined a condition. If the number that I've entered is less than 0, then print the number must be positive because I can't calculate the factorial for negative numbers, right? And again I have given one more condition which says that if number is equal to 0, then factorial is equal to 1. And then else condition says that when number is greater than 0, then I've used a for loop which says that for I've defined a variable I in range 1 to num plus 1. When I write num plus 1, the range will be between 1 to num plus 1, but it won't include num plus 1, so it will only be including 1 till num. Alright, so after that what I've written, factorial is equal to factorial into I. So factorial was 1 earlier, then it will multiply by I will also be 1 in the beginning, and then again it will go back and it will become 2. Similarly, it will keep on increasing until it becomes num. So till that time it will keep on executing the loop, and the moment it becomes equal to num, it will come out of the loop and it will print the factorial value. So let me go ahead and execute this and show you if it works or not. So I need to enter the number. So let's say I want to calculate the factorial of 3, which is 6. So if I want to enter one more number, so what I can do is I can start it once more. So what I'll type, I can type again 4. So it prints 24, which is absolutely correct. So we'll move forward and we'll see what are nested loops in Python. So Python basically allows us to use a loop inside another loop. For example, you can use a for loop inside a for loop, or you can use a while loop inside a while loop. And at the same time, you can use a while loop inside a for loop as well, and a for loop inside a while loop as well. So that is basically what is called nested loops. Now we'll have a look at the example of nested loops as well, don't worry. So let us move forward and see one example of nested loops. Now over here what I'm going to do is I'm going to write a code in order to simulate a bank ATM. Alright, so for that I'm going to use nested while loop. And what will happen, first you need to enter the 4-digit PIN, and then you can perform the following functions. You can check the balance, you can make a withdrawal, you can deposit some money, and you can even, if you don't want to do anything, you can tell the machine to return your card as well. So let me show you how it is done. I'll open my PyCharm once more. So this is the code that I've written in order to simulate a bank ATM. I'll explain you each and every line, so don't worry about that. So first line is nothing but a print statement that says welcome to Iron Bank of Bravo's ATM. Alright. And then I have defined a variable restart and I've assigned a value to it, that is y. Similarly, chances, I've assigned a value that is 3, and this is the balance that I'm going to initialize, that is 67.14. Notice over here you won't get more than 3 chances in order to write the correct password. Now comes the while loop, which says that when chances are greater than or equal to 0, at that time what it'll do, you need to enter the PIN. So you need to input the 4-digit PIN that you have. And if that PIN is 1234, then it'll print that you have entered the correct PIN. Now comes one more while loop, which says that while restart should not be in this particular tuple. That is, the value of restart should not be n, capital N-O, small n-o, or capital N. So it should not lie within this particular sequence, that is n, capital N-O, no, and n. But we know that the restart value is y, so it will enter the while loop. Now over here what will happen, it will give you 4 options. First option is in order to check your balance. For that you need to press 1. To make a withdrawal you need to press 2. In order to pay in some cash or you need to deposit something, you need to press 3, or you want your card back, you need to press 4. So these are the 4 options that will be given to you. So when you choose option 1, it will print the account balance. So over here as you can see that your account balance is, and the balance that is there in your account. After that it will ask you for restart. So you need to input that value. So that will say, would you like to go back? And if your restart value lies in this particular tuple, then it will break and it will print a thank you statement. But if you want to continue or you want to go back, then you can press anything else apart from small n, no, or this no, or capital N. So if you press any other button apart from these, it will actually go back, and in the while statement as you can see it says that it is not present here, so it will give you all these 4 options once more. Now after that, what if you choose the another option in which you need to make a withdrawal? So for that, what will happen? You need to enter the amount that you would like to withdraw, which can be a float number. It cannot be an integer number. So that's why I've used float here. So you need to enter that value. And once you enter that value, it'll check whether it is in this particular list or not. That is 10, 20, 40, 60, 80 or 100. Now by default, it'll give restart Y because you need to enter the amount once more. So again, it'll go back and it'll give you all four options. So you can choose that withdrawal option again, and you can choose a number which is present in this particular list. Now when you choose withdrawal equal to 1, at that time, it'll again ask you, please enter the desired amount. So this is for option 2. Now when we talk about option 3, it is pretty much similar to the couple of options that we have discussed before. So it is pretty much similar to that. Over here again, whatever the amount that you want to pay in, how much amount that you would like to pay, and balance plus the amount that you are depositing. So it'll print the balance that will be equal to balance plus the amount that you're depositing. Again, it'll ask you for restart. If you press anything apart from this particular tuple, then it'll go back to the while statement and it'll give you all these four options. Similarly for option 4 as well. Now what happens when you enter the incorrect pin? So there's one more condition in the end which says that if the pin that you have entered is not equal to 1234, then it will print that incorrect password and it will decrease the chances by 1. So earlier you had 3 chances. If you press the incorrect pin once, it will decrease your chance and it will make it as 2. Again, if you write the incorrect password, then again it will make it as chances equals to chances minus 1, which will become 1. And if the third time also you do the same thing, then the chances will become 0. And the moment it becomes 0, then it will print no more tries, break, it will come out of the loop. That's all, guys. So let us go ahead and execute this and see what happens. So please enter your 4-digit PIN. So I'll just write 1, 2, 3, 4 and it'll give me 4 options, which is 1 for balance, 2 for withdrawal, 3 for paying, 4 to return a card. So if I want to check my balance, I'll put in 1. So it has printed my balance, which is 67.14. And then the restart value that I was talking about, it is asking for that. Let me just make it big for you. Yeah. Would you like to go back? So if I press N here, it'll come out of the loop and it'll break. And if I press anything apart from small n, capital N-O, small n-o or capital N, it'll actually go back and give me all the 4 options that were there. So if I press Y, it'll again give me all the 4 options that are there. You can see that press 1. So again, if I want to make a withdrawal, I'll press 2. How much amount that I would like to withdraw? Say I want to withdraw 10. So my balance has reduced from 67.14 to 57.14. So would you like to go back? So I'll again press Y and it will give me all 4 options. If I want to pay in something, that is I want to deposit something, I'll press 3. How much amount that I would like to deposit? I'll say 10. So my balance became again 67.14. Again, it is asking me, would you like to go back? No, I don't want to go back. So I can type in N. So yep. So it says thank you. And again asking me for 4-digit PIN. So let me show you what happens if I write the incorrect PIN. Say if I write 111, incorrect PIN. If I write that PIN again incorrect, again incorrect. So we have no more tries. It'll come out since I've exceeded the chances that I was given. So I was given 3 chances. I couldn't write the correct PIN in those 3 chances. So it'll come out of the loop and it'll stop. So this is an example of nested while. Now let me go back to my presentation and I'll show you an example of for loop as well. So this is an example of nested for loop. So over here what I'm going to do is I'm going to write a code in order to print the Pythagorean number between a particular range. So what happens is, suppose if I want to enter the number 20, that means I want the Pythagorean numbers between 1 to 20. So Pythagorean numbers are nothing but the integers which satisfy a square plus b square is equals to c square. So at that time, it will print all the Pythagorean numbers that are possible between 1 to 20. 3, 4, 5. You can see that 3 square, 4 square is equals to 5 square. 9 plus 16 is equals to 25. Similarly, it goes for 5, 12, 13, 6, 8, 10, 8, 15, 17, 9, 12, 15. Similarly for 12, 16 and 20. Don't worry guys, I'll go back to my PyCharm and I'll explain you how you can do that. So this is the example of nested for. So first over here I need to import certain modules in order to use the square root function. So from math module I'm going to import the square root function. After that it'll ask me for the number. In the example, if you can remember in the slides where I've written 20, so it has printed the Pythagorean numbers between 1 to 20. that same number it will ask me, and it will print the Pythagorean numbers between 1 to n. So whatever the number n that I'm going to put in or give an input. After that, it will run a for loop, and it will say that for a, which is a variable, in range 1 to n plus 1. That means 1 to n. That means 1 to n plus 1, but don't include n plus 1. After that, there's one more variable b, which is in the range a comma n. That will not include n. It will only include till n minus 1. So the square root c square, I've defined one more variable c square, is equal to a exponent 2 or a to the power of 2. Similarly, b raised to the power of 2. Alright, and then what I'm going to do is I'm going to calculate the square root, and then what I'm going to do is I'm going to define one more variable c, and it'll be an integer that will be the square root of c square. So if that c square is minus c square is equal to 0, then print ABC. It's pretty simple logic, guys. Okay, I'll explain it once more, Neil. So this is an example of nested for. So over here what I'm going to do is I'm going to first import the square root function from the math module. After that I'm going to input a number. So if you can remember in the slides I've given it as 20. So it will print the Pythagorean numbers between 1 to 20. Over here also it will print the Pythagorean numbers between 1 to n. So whatever the value of n you input, that will be depending upon it. So the Pythagorean numbers will be depending upon the values that you input. So it will be printing the Pythagorean numbers present between 1 to n. After that I'll run a for loop which says that for a should be in the range 1 to n plus 1. That will not include n plus 1, guys. It will only include n. So 1 till n plus 1, but don't include n plus 1. After that I've defined one more for loop which says that for b in range a comma n. It won't include n, it will be till only n minus 1. I've defined one more variable here which is equal to c underscore square. That is equal to a square plus b square. Now after that I've defined one more variable c, and this will be actually the integer of the square root of the c underscore square. Alright, so whatever value that you will get here, the square root of that value will be converted to an integer value and will be assigned to c. Now one if condition I'll be using here which says that if c underscore square minus c square is equal to 0, then print ABC. That means that will be a Pythagorean number. So this is a pretty simple logic, guys. If you have understood it, just give me a thumbs up, or you can ask me any questions that you have in your mind. Alright, so I hope you have understood the code that I've explained to you here. Now let us go ahead and execute this and see what happens. Yeah. So the first number that I'm going to type in, say 5, and it'll give me all the Pythagorean numbers present between 1 to 5. So we have only one Pythagorean number, that is 3, 4, 5 in that range. Now I'll execute this once more and I'll type in 10 here. So we have two Pythagorean numbers that are 3, 4, 5 and 6, 8, 10. Similarly, if I execute it once more and I type in a big number, say 25. Yeah. So we have these many Pythagorean numbers present between 1 to 25. We'll again go back to our slides and we'll have a look at one more example. Now in this example, I'll actually be using a for loop inside a while loop. So what is this example? I want the bulk reservation of train tickets. So I have like group of people who are traveling somewhere and I want to give their details such as name, age and sex. I want that to happen in bulk. I don't want to give it one by one. I just want it to happen in bulk. So for that what I'm going to use is I'm going to use a for loop inside a while loop. As I've told you earlier as well, you can even use a while loop inside a for loop. But for now I'll use a for loop inside a while loop and see what happens. So let me go back to my PyCharm. So this is the code in which I'll be using a for loop inside a while loop. So first I have defined a variable traveling, so in which you need to input whether yes or no. So if you're traveling, you'll say yes obviously, and then we'll have a while loop which says that while the condition is traveling equal to yes, that means if you're willing to travel, enter the number of people who are traveling. So you need to enter the number of passengers that are traveling, and that will be assigned to a variable num. Now there'll be a for loop which says that for num in range 1 to num plus 1, but it won't include num plus 1, enter the name, enter age, and finally whether the person is male or a female, and then print all those values. Now one more thing here is Again, it'll ask you whether you have missed someone or not. So you need to input that. Oops, forgot someone. So at that time you can write in yes if you have forgotten someone. Then again it'll execute the loop. Again it'll ask you the number of people traveling and all these details. If you type in anything apart from yes, that means you have not forgotten anyone, and it'll come out of the loop. So it is a very small example, but a very good example to understand how for loop can be used inside a while loop. So let me go ahead and execute this. Whether you're traveling, I would say yes, I am traveling. Number of people traveling, I would say 3. Name is Saurabh. Age is 78. Male. Alright, so again it has asked me for one more name, so I'll say Neil. Age is 90. Male or female? Male. Yep. So one more name I need to type in. Say I would type in Jagriti. Age is 98. Male or female? Female. And yep, it'll print all those details for me. So now it is asking, have you forgotten someone? So if I type in and say yes, then it'll again ask me the number of people traveling. That means it's again executing the while loop. So if I would say the number of people traveling is 1, and I would type in the name of the person that was traveling, so I would just say Siddharth, whose age is 77 and he's a male. Yep. Again it has asked me, so if I type in anything apart from yes, say if I type N, so yep, it'll come out of the loop, and this is how you can actually use a for loop inside a while loop.
Why we actually require functions. So guys, here I have for you a really simple use case. Consider this program, right? So let's say you actually write a program in which you input a Celsius number, let's say a temperature of course, and this must be converted into Fahrenheit multiple number of times. What would you do? We first obviously start with the logic, right? So Fahrenheit is equal to 9/5 into the particular Celsius number plus 32. So this is the logic to calculate for Fahrenheit. Well, here's the program to calculate for the Fahrenheit, right? So we collect the input from the user, we enter the Celsius value, again the value in Fahrenheit has been converted and it has been printed. Well, it is really good, right? So this has been done once. But what if you actually want to do it multiple number of times? Well, let's say you have 1 Celsius value, then definitely it is really easy, right? So let's say you have 3000, 5000, let's say you have 1 lakh values that needs conversion in real time as well. So when this happens, you wouldn't want to repeat the same lines of code, right? Well, this is the number one cause of inefficiency and ambiguity, guys. Well, I'm sure you already would have guessed it, right? So Python functions definitely solves this. Let us check out how it can be done. Well, just before that, let me give you another instance. We have something called as dry. Well, dry is don't repeat yourself. In the sense, when you're actually writing your own functions or when you're writing any methods, make sure that the reusability of it is really high. Functions not only reduce the code in your main program, but they also tend to make your code run faster and better. So what does this do? This actually increases the readability of your code and then makes it very easy for debugging and documentation as well. Consider this easy example, right? So every time you turn on or turn off your television, there are certain functions built in, right? So as soon as you flip the channels or say adjust the volume, there isn't anyone in the backend writing a code at every point of time to actually adjust the volume or flip the channels for you. There is a particular code which repeats itself and doesn't create any new instances when you actually adjust the volume or flip the channels, correct? So this is again very good efficiency. So as soon as you change the channel, there is a function which runs which says that the user has changed the channel. So let me do these certain set of codes. Again, similarly for the volume as well. So if you have increased the volume or decreased the volume, the function gets an input of what you're actually doing. And then this function actually works on your input and then decides an action. In this case, it's volume. Pretty simple, right? Well, now that we know why we need functions, right? So let us check out what functions actually are. So what are functions, guys? I'm pretty sure every one of us has an idea at this point of time. So head to the comment section below and let me know what you think of it. I'd love to interact with you guys there. So coming back, what are functions? Guys, functions are actually a way to break problems or processes down into smaller and independent blocks of code. Straightforward, right? So it's basically a block of organized reusable code that is used to perform some similar task. In our last case in television, it was either adjust the volume or change the channel. Well, coming back to Python, it can be called by its name when its task need execution. You can also pass the values to it and have return results to you. Do not worry, I'll be walking you through a range of functions so you'll have a better clarity at this point of time. Well, at this time, all I want you guys to do is to know about the def keyword. Guys, def stands for define, and this keyword is actually used before the name of the function. And its name is followed by the parenthesis before a colon. Well, this defines an entire function. Check out this particular example code I have for you. So we have def function underscore name, and this function does nothing and pass. Definitely, right? So we haven't passed anything there for the function to do anything. Well, def is the keyword here. Function underscore name can be anything. It can be my name Anirudh, it can be Edureka, it can be anything that you like, right? It's as simple as that. So let me quickly introduce you to another concept called as docstring. So guys, what is docstring? It's actually called as a documentation string. So it's basically the first string after the function header is called, right? So this particular thing is called as the docstring. Again, as I mentioned, it is short for documentation string. Check this particular example out, right? So we have print greet dot underscore underscore doc underscore underscore. What does this do? Well, this function greets to the person passed into the name parameter. So if there's a name parameter in the documentation, the function actually greets the person which is passed by the name. Simple. Now check out this important flow I have on the left side for you guys. Again, we're going to come back to this, but right now you need to know this. We actually first define a function followed by the function name. We have a certain set of code, right, in the function or away from the function or anything. Well, good, we actually wrote the code until now. Well, later when we actually need to use it, we actually call the function by its name. As you can see, define function name will actually define that particular function and what that function actually should do. To call the function, and by calling the function I mean to actually make use of the function, we just use the name of the function. So here instead of def function name in the second line of code, we have function name. So this is where we'll actually be using the code. So this sort of flow is actually important and I want you guys to note this at this point. So now that we're good with the basics, next up I want you guys to check out the different types of functions available in Python. So guys, there are two main types of functions in Python. First one is built-in functions and the second is user-defined functions. Well, as you might have already guessed it, built-in functions are already available with Python natively, and user-defined functions are something which are defined by the users, right? So there are n number of built-in functions for almost all the users, guys. So for the sake of simplicity in this tutorial, I have considered the built-in functions which are actually part of the native Python package. Well, with Python, as you already know, there are n number of libraries. So each library has multiple functions on its own. So as soon as you go into the depth of one single library, you'll get access to all of their functions as well. And in user-defined functions, again, as the name suggests, you can define whatever you want. So basically, let me give you a quick simple example, right? So consider the example of a calculator. So let's say 3 plus 5 is equal to 8, right? So let's say a plus b equal to c. You've written a function. You're going to pass the values a plus b, and then you have a function which automatically gives you the value of c. And you don't have to write a plus b equal to c all the time. So we are basically trying to reduce the amount of effort put in by the user and increase the readability as well. So there is absolutely nothing to lose when you make use of functions and its advantages from the start to the end. And it's all advantages from start to the end. So let me quickly walk you through some of the major built-in functions which are available in Python. So guys, the first function I have for you is the absolute function. I am sure many of you can guess what the absolute function already is, but let me walk you through this function, right? So first I have the definition for you. So basically the absolute function returns the absolute value of a specified number. Well, that's confusing. What do we mean by absolute value? Consider this particular syntax and example. Well, the syntax is abs of n. Here abs is the keyword and n is the parameter passed. So n can be anything, right? So it can be 0, it can be 100, it can be anything. It has to be an integer here, guys. That is really important to note. So here all we're trying to do is we're trying to return the absolute value of a number. So consider the example, right? So we have a complex number here. X is equal to absolute of 3 plus 5j. Well, what does this do? So this basically calculates a number for us, which is actually a complex number in this particular case, and then provides the absolute value for it. So let's say instead of a complex number, we had absolute of minus 7. What do you think was going to be the answer, right? So it's going to be 7, obviously. So in this case, it was minus 5.83. And since it's absolute, minus has been removed and it's here. So what is the answer to x is equal to absolute of minus 10.5? Can you guys take a guess? Well, definitely it is 10.5, right? So there is no negative in terms of absolute. Simple and straightforward. Here, the parameter which is n, it is actually a number. So make sure you don't put any string input such that you can avoid all the errors. So the first function is done. So let's quickly move on to the second one. So guys, the second function I have for you is the all function. Well, the definition actually says this: the all function returns true if all of the items in an iterable are true. Otherwise, it returns false. But what are the iterable items that we're talking about, right? So it can be lists, it can be tuples, and it can be dictionaries as well, right? But you need to note one thing about the all function. So if the iterable object is actually empty, then the all function will still return true. So let's quickly take a look at the syntax and the example and the output as well. So syntax, all of iterable, you already know that the all here is actually a keyword. Check out the example. We have a list here, right? So my list is equal to true, true, true. And x is equal to all of my list. Well, it's basically telling us that all of the elements present inside our list is actually true and it matches. So as soon as you check out the output, it says true. Why? Because everything is true. This is the same case for lists, tuples, and dictionaries as I mentioned. So make sure you note that as well. Pretty simple, right? So we already covered two functions in such a short amount of time. Let us quickly jump into the third one. So this third function is a very interesting function, guys. So it is ASCII. I am pretty sure many of you actually know what ASCII is, right? So ASCII actually stands for American Standard Code for Information Interchange. And all it does is it is a character encoding standard, guys. So it is basically used by computers to actually understand. So we understand A to Z and 1 to 1000 or 1 to million, right? So how can computers make sense of this information in their low level language is exactly through ASCII. So what does the ASCII function do in Python? Well, the ASCII function actually returns a readable version of any of the objects. Here objects are strings, tuples, and lists or anything, right? And the ASCII function will actually replace any non-ASCII characters with escape characters. So if it's an ASCII character, well and good. If there is no ASCII character, it will actually escape that particular character, guys. So here's the syntax. Check it out. We have ASCII of object, again ASCII being the keyword and object being the parameter. So what is the object parameter here, right? So it's a string, it can be a list, it can be a tuple, it can be a dictionary, and anything you want in your particular instance. Check out this simple particular example here. So we have an x equal to ASCII and my name is Tale. The A here is spelled very differently and it does not have an ASCII value mapped to it, right? So if it was just Tale, then you would actually get the ASCII output. Well, since here it is not a valid ASCII character, Python actually puts an escape sequence there and it actually escapes that particular thing and prints out the rest of the thing. Simple, right? Well, I'm going to assure that all of the functions are actually as easy as this, and then it would make your life easier to know what each of these functions. And at the end of the day, it will make your life really easy knowing what all of these functions do. So on that note, let me quickly move to the next function. So the next function I have for you guys is bool. Well, bool actually stands for boolean. Can you quickly take a guess again? Cool, I am sure you would have guessed it by now. The bool function actually returns the boolean value of a specified object. Well, it will actually return true unless it meets empty parentheses or empty brackets, or if the object is false, if the object is 0, and if the object is none as well. So all these cases are when it can be false, but any other time it will actually return true. So let me quickly walk you through the syntax. Bool of object, bool being the keyword, object being the parameter. So what is the object in this particular case? It can actually be string, it can actually be list, it can actually be number or anything, right? So check out this particular example. X is equal to bool of 1. So as soon as that happens, since it doesn't match with any of our false criteria, we got it as true. Simple, right? And now that we are actually done with the bool function, let us quickly check out our next function. Next function is enumerate, and this is definitely interesting, guys. So the short form of enumerate actually stands for enum, but in Python we actually use enumerate. So in case you're coming into learning Python from an other different language, say C, C++ or Java or something, you would realize that enumerate here is the same as enum there. Again, let me quickly show you the definition of it. So the enumerate function actually takes a collection. Again, a tuple is a collection, right? And it takes this as input and returns it as an enumerate object. The enumerate function adds a counter as the key of the enumerate object. Let me give you some better clarity on this. Check out the syntax, right? So enumerate, and it has two parameters instead of one. So one is iterable and the other one is start. What is iterable? So we already checked out what iterable objects are. And then we have something called a start. Well, start is actually a number. We're trying to define the start number of the enumerate object. Well, if you don't put anything, it will be 0. Well, check out this particular example right in front of you, right? So we have x is equal to apple, banana, cherry, and y is equal to enumerate of x. So again, the default value is 0. So Python already counts from 0 instead of 1, right? So obviously apple becomes 0, banana becomes 1, and cherry becomes 2. And you can actually play with all of these key mapping values and then operate on them later as well. But at this point of time, all you need to know is this. Python starts from 0 and the first object there, first iterable object there actually starts from 0. So apple maps to 0 and so on from there, guys. Simple, right? And now that we are actually done with the enumerate function, let us quickly check out the format function. So what does the format function actually do? So guys, the format function actually formats a specified value into another specified value. Well, that was a bit complex, right? So let me quickly simplify that for you guys. So check out the syntax. We have format and we have two parameters, value and format. Well, a value can be a value of any format, guys. And then we have something called as format. Guys, I'm talking about the parameter here and not the keyword. So basically we have multiple parameters, guys. So we have lesser than. So lesser than basically left aligns the result, and then we have right align, and this actually aligns the space. Then we have is equal to. So this basically places the sign to the leftmost position. And we have minus. So this is actually used for a negative value, as you already know it. Then we have B. B actually converts it to binary. C converts it to Unicode. D to decimal. F to a fixed point number. G to general point, and so on, guys. And if you want more, it is basically O for octal, lowercase x for hex, uppercase x for uppercase hex format, N for number format, % for percentage format. But in this particular case, check out this example. We have x is equal to format of 0.5 and percentage, right? So 0.5 in percentage is what? So it is basically 50%, right? So it is basically half. So 50% is your answer. Another function, done. So what is the next function I have for you guys? Guys, the next function is actually get attributes. So basically it is shortly called as get attr. Again, a keyword. So what does this function do? Guys, the get attr function actually returns the value of the specified attribute from a specified object. Again, looking at the syntax, we have get attr, we have the object, attribute, and the default parameter. The object is compulsorily required because we need to know what we are working on, right? So this is the compulsion, and then next we have the name of the attribute, right? So basically it is the name of the attribute from which you want to get the value from. And next we have default. Guys, default is optional here. So what does it do? Basically it is the value to return if the attribute does not exist. So in case there isn't any particular attribute to return to, it returns to this default value. Check out this really simple example I have for you guys. So we have a class called person, name equal to John, age equal to 36, country equal to Norway. X is equal to get attribute of person and age. So at this point of time, what we're trying to do is move into the class person, find me the age of this particular instance. So in this particular case, John's age is 36, and that is exactly what we see in the output. Pretty easy, right? And now that we're done with the get attribute function, let's see what's next. So this is an interesting function, guys. So I have the identity function for you guys. So guys, this is an interesting one, the identity function. Also for short, it's called as the ID function. So what is the definition of this function? Guys, the ID function actually returns a unique identifier for any specified object. So all the object in Python has its own unique identification, right? So the ID is actually the object's memory address, and it will be different for each time you run the program. Check out the syntax and the example, guys. So ID of object, as you can already tell, ID is the keyword, object is the parameter. Here the object can be anything, guys. It can be a literal object, it can be a string, it can be a number, it can be a list, it can be a class or anything as such. Check out the example. X is equal to apple, banana, cherry. Y is equal to ID of X. Well, this particular object created has the identification as this. So when you actually perform operations on this particular object on X, and then Python basically tracks it in the background using this particular identification, guys. So every object in Python is actually mapped to a particular unique identifier. It may not be the same every time, but what is important to note that it actually has a unique identifier. So if I probably ran this program twice and then showed you the same output, it would actually not be the same because another identification number would have been provided. So identification function is as simple as that, guys. So let us quickly move on to the next function. So the next function I have for you guys is the length function, and it is shortly called as len. So guys, the length function basically returns the number of items in an object. So consider this, right? So when an object is a string, the length function actually returns the number of characters in that particular string. Check out the syntax. So we have len of object, right? Again, object is definitely a mandate here because we need to know what we're trying to find the length of, right? So either it must be a sentence, it must be a string, or it must be a generic object, or it can be a sequence, or even a collection as well. So check out the easy example I have keyed for you, right? So my list equal to hello. So we have one word here, right? So it consists of 5 letters. So as soon as you print x equal to len of my list, it realizes that this is a string and it prints the number of characters. In hello, there are 5 characters, and as you can see, the output is 5. Well, length function done. Guys, the next function I have for you guys is the map function. Can you quickly take a guess on what the map function actually does? So guys, the map function basically executes a specified function for each item in an iterable sequence. So this basically tells us that the item is sent to the function as a parameter, right? So we need to know what we are actually doing here. So check out the syntax. Map is the keyword and we have 2 parameters, which is function and iterable, guys. So function is definitely required because we need the function to execute for each particular item, right? And then we have iterable. Well, in this particular function, again, iterable is also a compulsory requirement because we need to know, right? We need a sequence or we need a collection or an iterator object or something to work on. So you can basically send as many iterables as you can and just make sure that the function has only 1 parameter for each iterable. Quickly check out the example and the code, and I'm pretty sure you guys will figure it out on your own. So basically we have defined my function of n. Again, defining the function name of the function is my function, myfunc, and then the parameter is n. What we are actually going to do is we are actually going to return the length of our input parameter. Check out the next line, x equal to map of myfunc, and then we are passing it 3 values, apple, banana, and cherry, right? So what do you think is the length of this? So each individual object can be iterable, right? So apple has 5 characters, hence 5. Banana and cherry has 6 each, so 6 characters each. Again, pretty simple and widely used, guys. So this function actually helps you a lot when you're actually trying to map something to a key or when you're practically trying to make use of this. So now that that's done, let me quickly walk you through the next function. So guys, the next function I have for you is the min function, min or minimum, right? So this function basically returns the value with the lowest value, or it returns as an item with the lowest value in a particular iterable. So if the values are strings, then alphabetic comparison is actually done. Let us quickly check out the particular syntax here. So we have min of n1, n2, n3, right? So it can be any number of numbers. And then we can have another syntax actually, right? So what do we do if it's an iterable? So instead of n1, n2, and n3 or so on, we're going to have min of iterable, guys. As simple as that. But check out the example here for simplicity's sake. We have x is equal to min of 5 and 10. So it's as simply as saying what is the minimum of 5 and 10. So which value is minimum here? 5, right? So if I had to give you another example, what is the minimum of 1000 and 10,000? So whatever is the minimum number is output, right? So in that case, it was actually 1000. So it is as simple as that, right? So I don't think I need to explain more about this. And you guys got a pretty good idea about it already. So moving on, next I have for you guys is the POW function. POW stands for power. So it's basically exponentiation here, guys. So the function actually returns the value of x to the power of y. Well, in this particular case, x raised to the power of y, guys. So there are 2 parameters present, right? So what is the base and what is the power? So if there is a third parameter, then it returns the x to the power of y and the modulus of z. Quickly check out the syntax and the example, guys. So we have 3 parameters in this case, right? So it is pretty simple to pick up 2 parameters. So let's say what is 2 power 3? The answer is 8, correct? So what is 4 power 3 again? It is 64. If we actually require the modulus of this answer, then that would become our z parameter in this particular case. Since we haven't done it, 4 power 3 remains to be 64, and that is the exact output that we get. Simple, right? It is as simple and as easy as that, guys. So next up I have for you is the print function. This is probably the first thing that you would learn as soon as you start Python, and this is definitely not the last thing. And this is definitely not as easy as it sounds. So it basically prints the specified message to the screen or any other standard output device. Well, most of the time it is the screen, but you can actually do it to other devices as well. So print. So print, we have objects, then we have separators, and we have files, and we have flush, and we have so much around here, right? So let me quickly walk you through all of these in a simple way. So objects basically refers to any object, right? You can have any number of objects you want. All of these will be converted to a string before it is printed. And then we have separator, guys. Guys, separator is actually an optional parameter, and you specify how to separate the objects if there is more than one object present. The default separator is actually double quotes. And then we have end. Well, again, another optional parameter. So we use this to basically specify what to print at the end. The default is actually /n because again, we're going to move to the next line as soon as something is printed. And then we have file. All of these are optional, guys. So basically file and flush, everything is optional here as well. So file is basically an object with a write method. That's it. But what if there isn't anything? Well, the default parameter of the file object is actually sys.std out. So it is the system standard out, guys. And lastly, we have flush. Well, again, flush is another optional parameter as I told you. And this is basically a boolean specifying if the output is true or false. Well, here is a computer science term for you guys. If the output is true, we call it to be flushed, or if the output is false, we call it to be buffered. What is the default output? It is buffered. So what is buffered? Buffered is false. So the default output is false, guys. Again, probably the most widely used example ever I have for you guys is printing hello world. So print, our separator is the double quotes and we're printing hello world. Again, I hope no more explanation is needed for this particular function, guys. So moving on, we have the set attribute function, guys. So this function basically sets the value of the specified attribute of a specified object. Again, object here is required because we need to know what we're working on. The attribute is required because we need to know what attribute we have to set and the value, right? So we need to know what value to what attribute we set. So if you already remember, we actually did the get attr, right? So we actually outputted a function and now we're going to basically set it. So check out the simple code I have for you guys. We have class person and then name equal to John, age equal to 36, country equal to Norway. Same as the previous example, right? So here we're using another syntax set attr of person, age and 40. All we're trying to do is instead of John having his age to be 36, change the age of John to 40. So go into the class person, look for age. So whatever is there, change it to 40. As simple as that. Again, this is a fairly straightforward function, guys. And next up I have for you is the sorted function. What does this do? Well, the sorted function actually returns a sorted list of the specified iterable objects. You can actually specify the ascending or the descending order as per your requirement. The strings are actually sorted alphabetically and the numbers are sorted numerically. As simple as that. But you need to know that you cannot actually sort a list that contains both string values and numeric values. So you either can do it for numeric values alone or string values alone. Got it, right? So check out the syntax. So we have something called a sorted and we have three parameters, right? So iterable, key and the reverse. Iterable is definitely required because we need to know what sequence we need to sort, either if it's a list, dictionary or a tuple. Key is optional, guys. Key and reverse are actually optional here. The key is basically a function which is used to decide the order. Well, what if you don't give any order? Default is actually none. And then we have reverse. So what is a reverse, guys? Again, it is an optional function as I told you, and it definitely is a Boolean function. So false will actually sort it to be ascending and true will actually sort it to be descending. Default is false, so default is actually sorting via ascending method. So check out this particular case I have for you, right? So we have a set of values for A. We have B, G, A, D, F, C, H, E, whatever, right? So X, as soon as we print sorted of A, the default value is false. So in this particular case, what happens is that, so it actually orders it for us in the ascending order. So the values actually went from being gibberish to be neatly sorted as shown here. Again, another easy function, done. So this brings me to the last built-in function for this session. So I have the type function for you guys. So the type function basically returns the type of a specified object. So again, check out the syntax. We have type, which is the keyword. We have object, basis and dictionary, right? So the first one is required. We need the object here because we need to know what we're trying to find out. The basis and the dictionary are actually optional. So basis actually specifies the base class and the dictionary actually specifies the namespace with the definition of that particular class. Well, it is not that you need to worry about this right now, but then definitely this particular parameter, which is dict, is actually useful later. But for now, since I'm introducing functions to you, let's stick to the basics. So check out this particular example. I have A equal to apple, banana and cherry, B equal to hello world and C equal to 33. So as soon as you try to find out the type of A, B and C, you can realize, right? So the first one, as soon as you look at it, it's a tuple. Second one, as soon as you look at it, it's hello world. And third one is definitely an integer, right? So A, B, C respectively. So again, as easy as that, guys. So those were a lot of functions, and I actually recommend that you guys pause the video at every point of time and make a note of all of the important stuff that I've said here, guys. So this will actually take you a long way in learning Python. Well, now that we're actually done with the built-in functions, again, let me quickly give you a recap and then start with user-defined functions, guys. So what are user-defined functions? Again, as I said, we'll be taking the code-first approach here. So here I have for you guys two simple syntaxes. So the first one is how we can actually create a function, and the second one is on how we can actually call the function. So we have actually looked at this when I previously told you, but let me quickly tell it again. So again, define my function, define as the keyword, my function is the name of the function. So what do I want this function to do? I want it to print hello from a function. So this is actually the body of the function, and as soon as the function has been called, it's going to print hello from a function. Well, instead of print, I could actually make it to calculate something for me, or print my name, or print Edureka's name, or anything as such as well, right? So the body of the function is completely left to your freedom, but make sure you check the number of parameters you require and all that you need, right? So now quickly look at how we can actually call a function. So we have defined my function and then hello from a function as well. To call this particular function, all you need to do is call the last line, guys. So basically we need to type out my underscore function and you're good. So how more simpler can you expect Python to be, right? As simple and straightforward as that. So then again, parameters, guys. So parameters are the information passed to functions that you already know. So let me quickly step up the complexity of our examples to one little notch higher, right? So again, check out. So we have defined my function and fname. Here, fname is actually the parameter of us. So we're printing fname plus refsness. So what we're trying to do, we're trying to pass. So this is our function body. So next, what we're actually trying to do is we're actually trying to print it. So we have my underscore function. We have provided three names there. We have Emil, we have Tobias, and we have Linus, right? So as soon as you go ahead and check out the output on the right side, so that is actually concatenated to refsness, right? Again, simple. So you can have any number of parameters and then work on all of these parameters and get whatever return output you want, guys. And get whatever meaningful return output that you want. So what is the default parameter value that we stumble upon all the time? Again, check out the example here. So we have defined my function, country equal to Norway. So I'm specifying in my parameters that the country is equal to Norway. So no matter what you do, right? So in case you haven't provided any value, the default value it should actually consider is Norway. So we're printing I am from and then concatenating a value of the country. We've called the function 4 times, in which the first time we have said Sweden. So it's printing I am from Sweden. The second time it's India. So I am from India. Third time we have just called the function without passing any parameter to it, right? So this is the exact case where it moves to the default value. Since nothing is provided, it is actually printing I am from Norway. And then fourth one, my function of Brazil. Again, it is as simple as that. You've already provided the parameter, so print it as it is. So default parameter value, you got all of this, right? And then the important concept you need to know is the return value, guys. Check out the example. We have my function and x is our parameter. We're returning 5 into x. So basically, as soon as we pass a number, 5 is going to be multiplied to that number and we're going to get the output. My function of 3, 5 3s are 15, 15. So next we have 5. 5 5s are 25, 25 is correct. 9 5s are 45. Again, we have 45 as the output. So we're good with that, right? So let me quickly recap on how the function actually works. So we have one set of code and we actually keep using it in recursion. So recursion is basically a function calling itself. So check out this particular example I have for you guys. We have defined a function. We call it try underscore recursion. We have a parameter k. So if k is equal to 0, then add the result to whatever is lesser than the next iteration of this function. I know it sounds complex, but how you can actually analyze a recursive function is to take a pen, a paper, so to write down the values of k at every point of time and then to actually trace what is available in the memory, guys. So if that is the case and if the result in which k is greater than 0, we print the result. Else we print it to be 0 and we return the result. And lastly, we actually print the recursion example results and we call the function by passing it a value of k, right? So k is 6 in our case. So if k is equal to 0, absolutely 6 plus try underscore recursion of 5. Again, come into the function. Is 5 greater than 0? Correct. Again, go back. Check if 4 is greater than 0. Yes. Keep doing it until the result is 0, right? So it's pretty much obvious at this point of time, guys. So every time you actually run this, one value gets added to your program, right? So again, check out the output and you will understand this better. So we have 1 and then 2 values were added, we got 3. 3 values were added, we got 6. 4 values were added, we got 10. 5 values 15, 6 values 21. So all we're trying to do is add one extra value and print it using recursion. And that's about it, guys. So I hope this has been a good introduction to the Python user-defined functions as well. So next, quickly let us check out the lambda function in Python, guys. So what is the lambda function? Guys, it is extremely simple. A lambda function is basically one small anonymous function. So it can take any number of arguments, but it can have only one expression at the end of the day. Check out the syntax here. So we have lambda, arguments, and expressions. Well, still nothing is working, right? Check out the example. We have x equal to lambda of a, where the expression is a plus 10. So as soon as we want to print something, all we need to do is we need to print x of 5. As soon as we hit x of 5, a gets the value to be 5. So since a gets the value to be 5, 5 plus 10 becomes 15, and we're printing x of 5, which is now 15. Pretty simple, right? So you basically can create tiny functions all on your own using the lambda keyword here. So do know that the syntax is really important because we have the arguments on the left side and the expressions on the right side. So guys, here is another example I have for you. So we have a lambda function that multiplies one argument with another argument. In our case, it is a and b, and we want to print the result. So check it out, x equal to lambda of a comma b, because a and b are parameters here. So what is the expression you want to perform between a and b? It is multiplication, so a cross b. And we're printing x of 5 comma 6. So a is 5, b is 6. What does 5 6 are? It's 30, right? Again, the output is 30. Pretty simple. Check out this other example. So basically we're trying to find the sum of 3 parameters a, b and c and print the result. So x equal to lambda of a, b and c, 3 parameters a, b and c, hence 3. And then we have a plus b plus c. So what is the sum of 5, 6 and 2? It is 13, and that is exactly what you've got in the output. So these are tiny set of functions that you can make use of any time without any dependencies, guys. So that is the important part I want you guys to notice at this point. But when you can have all the regular functions, why would you want to make use of the lambda function, right? I'm pretty sure this was the first thought that came into your head as soon as I explained the concept. Well, the power of lambda is actually better shown when you use them as an anonymous function inside another function. Check this particular thing out. We have defined a function which is called as myfunc. I have one parameter n. And then we're actually performing another function inside our function. And this is basically telling us to return the lambda of a cross n. So whatever n value has been provided, we're going to use the lambda function as in a tiny function there to provide us the multiplication of a value with a particular n value, which is the parameter. Simple. So check out this example, guys. So we basically use that function definition to make a function that always doubles the number that you send in. So we have defined my function of n, lambda of again a into n, right? So it's pretty much the same example. And then we have a variable called myDoubler, which actually is sending the parameter 2 to our n value. So what do you think is going to happen as soon as I print the value of myDoubler of 11? Pretty much simple. 11 gets multiplied by 2 because 11 is passed as a function into the myfunc through myDoubler. So here a and n becomes 2 and 11. So what is the product of 2 and 11? It's 22. Pretty much simple, right? So here's another last example. So basically we can use the same function definition to make a function that actually triples the number that you send in. So what I want you guys to notice is that check out the function definition. It remains the same. So define my function of n, return lambda of a into n, perfectly same. MyDoubler, my function on how many times you want to double it. So double is 2, so 2. MyTripler equal to myfunc of 3. So I want to triple it, so multiply 3 times. As soon as I print myDoubler of 11, 11 into 2, 22 is the first output that I get. Print myTripler, 11 into 3, 33. That is the second output that I get. So what I am trying to convey to you guys is that you wouldn't have to rewrite all of these functions at every point of time, right? So the definition of the function remained same. How we call it and how we get our output is actually depending on us. And that is what makes functions efficient and one of the biggest concepts that you need to learn in Python, guys.
What exactly are lambda functions? Python lambda functions are functions that do not have any name. They are also known as anonymous or nameless functions. The word lambda is a keyword that specifies what follows is anonymous. Now that you're aware of what these lambda functions are, let's move on further to see why they are actually used. The main purpose of anonymous functions comes into picture when you need some function just once. They are created wherever they are needed. Due to this reason, Python lambda functions are known as throwaway functions. They are also used within higher order functions which take a function as an input or return it as an output. Another very good advantage of using these lambda functions is reducing the size of code. And I'm going to be showing y'all in this session how to do this. So now let's move on towards our next topic, which is to see how to write anonymous functions. Lambda functions are created using the lambda operator, and its syntax is as follows. The first thing that you'll need to specify is the lambda keyword. And following that, you'll have to specify the arguments or the inputs. And finally, after the colon symbol, you'll have to specify the expression that needs to be solved. Lambda expressions can take any number of arguments. So as you can see over here, my first example is a lambda expression without any arguments. In the second example, I've taken a lambda expression which just has one argument a1. Finally, I'm demonstrating a lambda expression which has inputs from a1 to an. Just remember that all your arguments or inputs need to be separated by a comma. So now let's move on towards our Jupyter notebook and see how we can actually write these lambda functions. I'll just create a new notebook over here, guys. I'll just open a new notebook over here, guys, and I'll rename it as lambda functions. So guys, now just let me write the syntax as a comment over here. This is going to be good for a referral purpose. So first is the lambda keyword, like I already told y'all. Sorry guys for the spelling mistake. Lambda and the arguments followed by the expression. Okay, so the first thing I'll have to write down is the lambda keyword. Following that, I'll have to specify the arguments. So let me just give one argument to this. And after that, I'll just say I want to multiply this a with itself. So this is my lambda function. But before executing this, I'll require some variable that can hold the value of this. So I'll just specify that x is equal to this lambda function. And after this, I'll say x of 3. And I'll hit run. So as you can see over here, when I used x of 3, it's returned the output to be 9. So guys, if I had to solve the same expression using a normal function, then I would have had to write a larger piece of code than this. Let me just demonstrate this to you guys over here. So I'll just define a function, say new, and I'll pass the parameter as a. Now I'll be using return to return the value of a star a. To call this function, I'll have to use the name of the function and specify some value to the argument that I've already passed. So in place of a, I'll pass the value as 4, or let me take it as 3 itself, like the previous function, and I'll hit run. As you can see over here, using lambda functions, I just required 2 lines of code. Whereas, while using the normal function, I had to make use of 3 lines of code along with this return statement over here. Okay, so guys, I hope you all have understood how to write these lambda functions. So guys, as you all have just seen, I've used lambda expressions in the example along with some other variable x. Now I did this because these functions are nameless and require some name to be called. But doesn't it seem confusing as to why assign a name to a nameless function and what is the need of it? It's a legitimate question, guys, but the point is this is not the right way of using anonymous functions. Anonymous functions, like I've already told y'all, are best used within higher order functions. These functions either take a function as an input or return it as an output. To demonstrate this, let me just move on towards our next topic of this session. The first thing that we're going to study is anonymous functions within user-defined functions. So as you all can see on the screen, I have a user-defined function that takes the lambda function as an input. In this example over here, the normal Python function, which in my case is newfunc, takes one argument x. This argument is then added to some unknown argument which is supplied through the lambda function. Let me just jump on to my Jupyter notebook to explain this in detail. Let me just first create a heading over here, guys. Just remember the number of prefixed hashes tells which heading it is. So if it is h1, it will have 1 hash prefixed to it. If it has 2, then it's h2 and so on. So I'll just create a heading over here of h1 level and I'll give the name as user-defined functions or lambda within user-defined functions. Lambda within user-defined. So I hope you guys know what are user-defined functions. Okay, so as you all know, when you have to create a function in Python, you'll have to use the def keyword followed by the name of the function. I'll just name the function as a and I'll pass one parameter to it, say x. After that, I'll be using the return statement. And within this, I'll specify a lambda function. I'll pass y as the argument to this lambda function and I'll use x plus y as my expression. Now let me just give some value to the variable x and store it in another variable t. So a of 4, and I'll print the value of t of 8, and I'll hit run. So as you all can see on the screen, the lambda function that is used within the function a is called whenever I call this higher order function. And the first thing that I'm doing over here is passing a value to the variable x, and then I'm printing the value of x plus y. So I hope everyone's understood this part. Okay, now let me just copy this function and pass a few other values to this as well. I'll just store a new value in the variable u, and I'll pass the value for x as say 7, and I'll print 2 of 5, and I hit run. Okay, so I hope everyone's clear with this. If you have any doubts, please do let me know in the chat box, and my team is here to help you. Now let's move on towards the next topic, which is using lambda functions within filter, map, and reduce functions. The filter method is used to filter the given iterables, which can either be lists, sets, etc. Now this is done with the help of another function, which is passed as an argument to test all the elements to be either true or false. After applying the function to the set of iterables, if the value is true, then that value is returned in the output. Now let me just jump onto my Jupyter notebook and use the lambda function within the filter method. I'll just give a new heading over here again. Just for your reference, guys, I'll create a heading of H2 level by prefixing it by 2 hash characters. So I'll just use lambda within filter. And since this is a method, like I already told y'all, the filter function needs iterables. Now here I'll just create a list. I'll say my list, and I'll specify some elements to this. The filter method is going to check for all the elements to either be true or false in accordance to the expression that is passed within the lambda function. Like I already told y'all, the filter method is going to check if the expression that is specified within the lambda function is either true or false for all the elements that are present within my list. And it returns all the elements that satisfies the expression. So as a result, I'll have a new list. So I'll just name it as a new list. And I'll use the filter function. And within this, I'll be using the lambda function like I already told y'all. Let me just specify the input as a. And I'll give an expression over here, say a. I just want to check if any of these values when divided by 3 will equate to 2. And I'll pass my list. And I'll pass my list as an argument to this. And since the output is going to be a list, I'll just use the list method over here. And one more point I want you guys to note is the syntax of the filter function. And since I forgot to specify this before beginning the demonstration, let me just specify the syntax of this function over here. I'll say syntax. You'll have to use the filter keyword along with some function followed by the iterables. Okay, so as you can see over here, I have the filter keyword, I have the function which is lambda, and then I've passed my list as the iterables to this function. Now let me just print the new list. And I'll hit run. Uh-oh, sorry guys, I've made a spelling mistake over here. So it's filter. So as you can see over here, I've passed the elements 1, 2, 3, 4, 5, and 6 to this filter method. And after checking if this expression is true for all the iterables, it has returned 6 as the output. Now let me just cross-check over here. So if I divide 1 by 3, I will not get a result which is equal to 2. Similarly, if I divide 2 by 3, I'm not going to get the result as 2 again. Finally, as we all know, if I divide all these elements by 3, only for 6, I'll get the output as 2. So I hope everyone's clear with how to use the lambda function within the filter function. So now let's get back to our presentation and see how we can use the lambda function within the map function. Guys, the map function in Python is a function that applies a given function to all the iterables and returns a new list. So I hope you're understanding what exactly it does. It takes a function as the input and some iterables as well. and then it applies this function to the set of iterables that are passed, and it returns a new list. So now let's get back to Jupyter and do the same. I'll create a new heading, of course. And it's going to be lambda within map. And I hit run. So before moving on towards the demonstration, I'll just write the syntax for the map function. So it has to have the map keyword, of course. And the parameters that are passed to it is a function and the iterables. Now let me just make use of the same list, which I was using previously. And I'll copy that over here. And then I'll just store the output in a new list P. And I'll use the list function since I want the output to be a list. Within this, I'll use the map function, and to that map function, I'll pass a lambda function as the input. I'll just pass one argument to this as A, and the condition I'm going to specify is to check if any element present within my list divided by 3 is not equal to 2. And I'll pass my list as the set of iterables. And then finally, I'll be printing this. Now let me hit run. So as you all can see over here, it has returned a list with some Boolean values. The expression that I wanted to check is A by 3 not equal to 2. Now let me just move on to my list and see what happens when I divide 1 by 3. Of course, I'm not going to get 2, so I have true as the output. Now when I divide 2 by 3, again, I'm not going to have the output as 2, and therefore I have true as the Boolean value for this. Similarly, all the elements present in my list are divided by 3, and it's going to check if the condition is true. Therefore, only for 6, it's going to be false, and I have the output as false. Okay, so I hope you guys have understood how to use the lambda function within the map function. If you have any doubts, please do let me know in the chat box, guys, and my team will revert to you. Okay, now let me just jump on towards our next topic, which is using lambda function within the reduce function. So guys, the reduce function is used to apply some other function that is passed as a parameter to it to a list of iterables, and finally it returns a single value. And to demonstrate this, I'll just jump on to my Jupyter notebook again, and I'll create a heading. This is going to be lambda within reduce, and I'll hit run. So first, let me just write the syntax of this function. It is the reduce keyword, and it takes a function as a parameter. The first parameter is a function, and second is a sequence. Now to make use of the reduce function, you'll have to import the functools library, or from that library, you'll have to import the reduce function. To do this, I'll be using from functools import reduce. You can also directly import the functools library as import functools, or you can also use from functools import star. These are just the alternate ways that you can also use over here. Okay, so now I'll be using the reduce function, and within this I'll specify a lambda function, and I'll pass two parameters, say A and B, and let me just print the sum of A and B. And finally, it has to have a sequence as its input. So I'll just specify a list over here. I'll say the list of values to be 23, 56, 43, 98, and 1. Okay, so now let me hit run and see what it returns. So as you can see over here, guys, I have 221 as my output. So what this reduce function is actually doing is, it first adds 23 to 56. So guys, the first thing that the reduce function does is add 23 and 56. And the output of this is going to be 79. Now after adding these two values to this output, it will add 43. So to 79, it's going to add 43, and it will produce a new output. After finding the output of 79 and 48, it's going to add the result to 98. And finally, it's going to add that result with 1, and returns the final output, which is 221. So I hope you guys have understood how this function is recursively adding each value to the next value that's present in the sequence. Guys, if you have any doubts, please do let me know in the chat box. Okay, now let's move on to see how you can actually use these lambda expressions or lambda functions to solve some algebraic expressions. For this, I'll just go back to my Jupyter notebook and I'll create a heading over here. Sorry guys. I'll just delete these two kernels. And I'll create a heading. I'll just say lambda for algebra. So guys, first we'll be taking some linear equations. So I'll just create a heading as linear equations. So as we all know, algebraic linear equations consists of variables of degree 1, which means they'll have the power as 1. So now let's just use the lambda function to solve some linear equations. I'll just say S is equal to lambda. And I'll pass the argument or the input as A. And the expression I'll specify as A star A. And I'll use S of 4 and I'll hit run. So as you all can see over here, 4 cross 4 is 16. Now let me take a different linear equation. So let me just write the linear equation over here as a comment. So I just want, say, 3x plus 4y. Okay, so if I want 3x plus 4y, so I'll have to specify some name to this. Say d is equal to lambda and x and y as the inputs. And since I want 3 star x plus 4 star y. Okay, I have 3 into x plus 4 into y. Okay, and then I'll pass the values as 4, 7 and I'll hit run. As you all can see, 40 has been returned as the output when I pass the value of x as 4 and the value of y as 7. Now let me take some quadratic equation. So I hope you all know what is a quadratic equation. It's an algebraic equation with the degree 2. Let me just give the heading as quadratic equation. Okay, so now let me just try to solve the very famous a plus b the whole square. A plus b the whole square. So I'll just say part 2, okay? Now let me write a lambda function that's going to return the value of a plus b the whole square. I'll just save it within a new variable x and I'll use the lambda function and the arguments or the inputs are a and b. The expression that I'm going to use is a plus b, and like we all know, we'll have to use double star when we use powers. And then I'll print this x. I'll pass the values of a and b as 3, 4 and I'll hit run. Okay, so as you all can see, I found the value of a plus b the whole square using the lambda expressions. What exactly is an array? An array is basically a data structure, guys, with ordered series of elements. Any variable that is declared as an array can hold more than one value at the same time. All values in an array have a particular address which is specified by its index number. Here, as you can see on the screen, I've declared a variable a as an array and I've stored values from 1 to 100 in my array, which is a. Also make a note of the index values. Indexing always starts from 0 and not from 1. Therefore, a of 0 holds 1, a of 1 holds 2, a of 2 holds 3, and similarly a of 99 holds 100. When the length of my array is n, the index value will be n minus 1. It is always 1 less than the length of the array. So I hope you're clear with this topic. Now let's move on towards our next topic for this session, which is the difference between Python lists and arrays. Python lists and arrays have the same way of storing data, but there is a key difference that you all have to note. Arrays can store only single data type values, whereas lists can store any data type values. So for example, if I have an array of integer values, all values present in that array will be integers and nothing else. On the other hand, if I have a list, then it can store integers together with float and chars and strings, etc. Now when you try to perform some operations like slicing or looping, it will be similar for both. But when you try to perform different operations, like if you want to multiply your array values by 2 or you want to divide it by 2, you can do so easily when you have an array. But if you try to do the same with a list, it will throw an error because naturally you cannot multiply chars and strings or divide them. So I hope you're clear with the difference between these two. So now let's move on towards the next topic, how to create arrays in Python. Unlike other programming languages, if you want to create arrays in Python, you will have to import the array module. Now this module has all the functions that are necessary for creating and performing various kinds of operations on arrays. To import the array module, you can use three ways. First is to import the array module by its original name, which is array. The second method is to use an alias name. This is the most widely and commonly used method as well. In my demonstrations, I'm going to be using this method. The third way is using star. From array import star. What this does is, it's going to import all that is present in your array module. Now let's go to our Jupyter notebook and try to do this. Please do it along with me, guys. I'll open a new notebook and I will use the first method to import the array module. As you can see, when I hit run, no error has been returned, which means this is executed. Now let's try to create arrays using this method. As you can see over here, I've created an array A using the first method. So I have used array.array of integer values and I've specified some random integer values. Here the first array is the name of the module. The second array is the array constructor. And then I've given a type code. This type code specifies what type of elements my array will hold. As you can see, I've created an array. So I hope you're clear with how to create arrays using the first method. Now let me open a new notebook and try the second method. The reason to open a new notebook is because I've already imported array module in this notebook. I'll rename this notebook because I'm going to be using this method in further demonstrations as well. As you can see over here, when I use import array as ARR here is my alias name. When I use this and hit run, it does not throw any error. Now let me try to create arrays using this method. I'm using int as my data type. You can use any data type of your choice. As you can see that an array has been created with some random integer values. In place of the module name array, I've used ARR. Now let's try the third method. I'll open a new notebook again. As you can see over here, when I'm creating arrays using the third method, I've just specified the constructor name and then the type code and the value list. So I hope you're clear with how to create arrays using all three methods. Okay, so now let's get back to our presentation. Our next topic for this session is accessing array elements. To access array elements, you'll have to make use of the index values. Each index value holds a unique element. Like I've told you before, indexing starts from 0 and not from 1. So therefore, A of 0 holds 1, A of 1 holds 2, and so on. This is the normal traversal order which starts from the left-hand side and moves towards the right-hand side. But here, I want you all to note this point as well, that negative indexing also exists. So negative indexing will start from the right-hand side and move towards the left-hand side. Therefore, 100 will be at A of -1, 99 will be at A of -2, and similarly 1 will be at A of -100. So I hope you're clear with negative indexing. Now let's go to our Jupyter notebook and try to access some array elements. As you can see over here, I've created a heading. To create a heading, all you have to do is go to code, select heading, and prefix your text with the number of hashes based on the heading level you want. So if I want h1, I will use 1 hash. If I want h2, I will use 2, and so on. Here I've created a heading of h1, so I prefixed my text with 1 hash. Now let me try to access some array elements. As you can see over here, when I access a of 2, my output is 3. Let's see where 3 is present in my array. 1 is present at a of 0, 2 at a of 1, and 3 at a of 2. So therefore, when I access a of 2, 3 has been returned. Are you guys clear with this? Just give me a quick confirmation before I move on towards the next topic. Shashank says yes. Preeti says, please try to access something using negative index values. Okay, Preeti, let me show you that as well. So here I've tried to access a of -2. A of -2 has returned 5. Let's get back to our array A and see where 5 is present. 6 is at a of -1 and 5 is at a of -2. Therefore, my output is 5. So Preeti, are you clear with this? Okay, Preeti says yes. Now let's move on towards our presentation and see what is the next topic. Our next topic of this session is basic array operations. Here, I just want to tell you all something. Arrays are mutable, which means they are changeable. So in case you want to add or remove elements from it, you can do so easily. Now coming back to our presentation, our first operation under this section will be finding the length of an array. The second is adding or changing elements of an array. And then we will try to remove or delete elements of an array. And then guys, we will try to perform array concatenation, slicing, and finally we will be looping through an array. Now let's move on towards the first operation. To find the length of an array, you will have to make use of the len function. Now this function returns an integer value which is equal to the number of elements that are actually present in your array. The len function takes one parameter which is the name of your array. As you can see in the example over here, I've created some random array A and I've given some random values. As you can see, I have 3 values over here. And when I use the len function and I specify the name of my array, the output is 3, which is equal to the number of elements that are present in my array. Now let's move towards our Jupyter notebook and see how this works. As you can see over here, when I use the len function and I've given the array name which is A, an integer value is returned which is 6. 6 is the number of elements that are actually present in my array which is A. Okay, so I hope you're clear with this. So our next operation is adding elements to an array. In case you want to add elements to an array, you can do so using the append, extend, or the insert function. The append function is used when you want to add an element to the end of your array. The extend function is used when you want to add more than one element to the end of your array. The insert function specifically adds a new element to a particular position in the original array. Let's have a look at a small example of these 3. As you can see on the screen, I've created some random array A, and then I've used the append function and I've given the value that I want to add to my array. As you can see in the output, 3.4, which is the value I've specified to the append function, has been added to the end of my array which is A. And then I've used the extend function. Please make a note over here that when you use the extend function, you will have to specify the values between square brackets. If you don't use the square brackets, it will throw an error. I've given 3 new values and all 3 values have been added to the end of my array. And then I've tried to use the insert function. Over here, I've specified the index number as 2 and the value to be inserted at that position as 3.4. As you can see in the output, 3.4 has been inserted at C of 2. Now let's go to our Jupyter notebook and we'll do the same. I'll reprint my array which is A so that it's easy for us to refer to it. Since my array A holds integer values, I will give some new integer value to it. As you can see, I've given 8 as the value that I want to insert in my array, and 8 has been added to the end of my array. Now let me try to give some float value to this array and see what happens. As you can see, when I try to append some float value, it gives me a type error. Therefore, I can add only those values which is specific to the type of elements that are present in that array. Now let me try to use the extend function. Like I've told y'all, when you're using the extend function, you will have to make use of the square brackets. As you can see in the output, all the values that I've specified within the extend function have been added to the end of my array. Now let me use the insert function. I've used the insert function, and the first parameter I've specified is the index value, and the second is the element to be inserted at this index position. So at index value A of 2, 6 will be inserted. As you can see in the output, 6 has been inserted at A of 2. So I hope you're clear with how to add elements to an array. Now let's move on towards the next operation. Our next operation is removing elements of an array. In case you want to remove elements from an array, you can make use of the pop or the remove function. The pop function removes the element and returns it, whereas the remove function will remove it but it will not return it. The pop function can either take no parameters or one parameter. The parameter it takes is the index value of the element to be removed. If you do not specify any parameter, it will remove the last element from the array. The remove function takes one parameter, which is the element to be removed itself. Now let's have a look at a small example of this. As you can see on the screen, I've created some random array A, and then I've used the pop function without specifying any parameter. As you can see in the output, when I do not specify any parameter, the last value present in my array has been popped and returned as well. Second time, I've used the pop function and I've given some index value. Now this pop function will remove the element that is present at this index position. As you can see, it has removed 3.1 and returned it as well. After that, I've used the remove function. Like I've told you before, the remove function takes one parameter, which is the element to be removed. And you can see in the output that the remove function has not returned any value. After that, I've printed my array. And you can see all the values that are removed using these two functions are no more present in the array A. Now let's go to our Jupyter notebook and do the same. Let me reprint my array which is A. First, I will use the pop function without specifying any parameter to it. As you can see over here, when I do not give any parameter, it removes the last element that is present in my array. Now let me give some index value to it. I'll reprint my array A because I've removed an element from it. Now let me give some index value to the pop function. As you can see, when I use a.pop of 2, it removes the element which is present at A of 2, which is 6, and it returns it as well. Let me try to use some negative index value for the pop function. A.pop of -1 removes the last element that is present in my array, which is 5. Now I'll use the remove function. Let me reprint my array, guys. As you can see, all the elements that have been removed using the pop function are no more present in my array A. Like I've told you before, when using the remove function, you will have to specify the element that is to be removed. Here, let me remove 8, because there are two occurrences of 8, and let's see what the remove function does. When I hit run, remove function does not return anything. Now let me print my array A and see what is present. As you can see, the first occurrence of 8 has been removed, but the remove function did not return the value. So I hope you're clear with the remove and the pop functions. Now let's get back to our presentation and perform the next operation. Our next operation is array concatenation. Concatenation means joining. So in case you want to join different arrays, you can make use of the plus symbol. As you can see on the screen, I've created some random array A and B, and then I've created some random array C which is empty. Also make a note that all three arrays have the same type code. And then I've concatenated A and B into my empty array which is C. As you can see in the output, all the elements present in A and B have been concatenated into my array C. Now let's go to our Jupyter notebook and perform array concatenation. I'm using int as my data type. You can use any data type of your choice. To create an empty array, all you have to do is specify the type code and leave the value list empty. Here I've created an empty array D and I've concatenated B and C into my array which is D. Now let me hit run. When I hit run, all elements present in B and C have been concatenated into my new array which is D. So I hope you're clear with array concatenations. Let me just show you what happens if I try to concatenate arrays of different data types. I'll just change one of my previously created arrays type code and I'll give it as float. Let's see what happens when I change the type code and I try to concatenate these two arrays. You can see that I've encountered an error and it says type error, which means it cannot concatenate two arrays of different data types. So just be careful when you're concatenating arrays. You cannot concatenate arrays which hold different data type elements. Okay, now let's move on towards our presentation and see what is the next operation. Our next operation is slicing an array. Slicing actually means fetching some particular values from your array. To do so, you can make use of the colon symbol. As you can see on the screen, I've created some random array A and I've sliced it from 0 to 3. 0 specifies from where fetching has to start and 3 specifies where it has to stop. So, it will start from 0, it will go on till 3, but it will not include the value which is present at 3. As you can see in the output, I have A of 0, A of 1 and A of 2 that is present in my output. Now let's go to our Jupyter notebook and we will try to slice our arrays. I'll reprint my array D over here and then I will try to slice it. As you can see, I've sliced my array from 0 to 5. So it will start from index number 0, it will go to 5, but it will not include the value which is present at index number 5. You can also see the same in the output over here. Let me try to use some negative index value. My output when I use 0:-2 contains all the values between 0 and -2, but it will not include the value which is present at -2. Okay, so I hope you're clear with this topic. Just give me a quick confirmation before I move on. Okay, Anil says yes. Shashank has a question. He asks, what does ::-1 mean? Shashank, unlike what many of us think, ::-1 does not reverse my array, but it prints a reversed copy of my array. So let's try to do this over here. As you can see, all the elements present in array D have been reversed. Now let's print our array which is D. The original array D is the same, but ::-1 has reprinted a reversed copy of my array which is D. This method is actually not preferred because it exhausts the memory. So I hope I've cleared your doubt, Shashank. Just give me a quick confirmation. Okay, Shashank says yes. Now let's get back to our presentation and perform the last operation of this session, which is looping through an array. You all might be familiar with these two loops, which is the for and the while loops. The for loop iterates over the items of an array specified number of times, whereas the while loop iterates until some condition is met or some condition is true. When you're using the while loop, you will have to keep three things in mind. One is initializing your iterator. Second is to specify a condition. Third is to increment your iterator. Remember that if you do not increment your iterator, your while loop will go on forever. Let's see a small example of this. As you can see on the screen, I've created some random array A, and then I've used the for loop to loop through my array A. I've used for x in A print x, which means go to every element that is present in A and print it. Let's try to do the same on our Jupyter notebook. Let me reprint my array D. Now let me use the for loop to loop through this array. For x in A, print x, which means go to every element in D and print it. As you can see, all elements present in D have been returned one after the other. Now let me try to slice this array and print specific elements. As you can see over here, I've sliced my array from index number 0 to -3 and I've printed only those specific values using the for loop. Now let's go to our presentation and have a look at the while loop. Like I've told you before, when you're using the while loop, you will have to do three things. One is initializing your iterator. Second is to specify the condition. And third is to increment your iterator. Let's try to perform looping on our Jupyter notebooks. Please do it along with me, guys. Let me reprint my array D. Here I'm using the iterator as temp. You can use any name of your choice. As you can see over here, I've initialized my iterator to 0 and then I've specified a condition wherein I have told whenever the value of my temporary variable is less than d of 2, then print that value. And then I have iterated the value of temp. I can also use temp plus equal to 1, which is same as temp equal to temp plus 1. Now let's try to use the while loop using the len function. Here I will use my array A. So let me reprint it over here. As you can see over here, when I use the len function, my temporary variable will go to all elements present in my array A and print them one after the other.
What is inheritance in Python? If we take a look at a real-life example, inheritance is when a child inherits properties from their parents. It can be the genes or it can be any other property characteristic. So looking at it from the programming point of view, inheritance is when a class inherits properties from another class. The class which inherits the properties is known as the child class or the derived class, and the other class is known as the parent class or base class. Now let's take a look at a few advantages of using inheritance in Python. So first of all, it is mainly used for code reusability so that you don't have to write the same code again and again. And it provides a transitive property and also resembles a real-life relationship between classes. So these are the advantages of using inheritance in Python, guys. So let me take a simple example to explain what is inheritance and how you can do it in Python. So let's take it up to PyCharm, guys. And now I'm going to enter the presentation mode for better visibility. So now what I'm going to do is I'll just take one class, guys, and name it as parent, let's say. Now give it a function. So I'll name the function as function1. And after that, let me give it a statement. Let's say print function number 1. Okay, let's say this is a parent function. Now what I'll do is I'll take one more class, guys, and name it as child. And for this, in the declaration, I have to specify this parent over here. This is also known as subclassing, guys. We do the subclassing because a child class is not able to identify which class it is inheriting the properties from. So we do this by declaring the parent class inside the declaration of the child class only. Now what I'm going to do is I'll just make one definition of a function. Let's say function number 2. And in this, I'll give the print statement as, let's say this is a child function. Now when we are declaring a child class, it must understand from which class it is inheriting the properties from. So we have declared the child class with the parent class in the declaration. And that's how the child class differentiate between a parent class, guys. So now to call the parent class methods, we use the child class objects. So what I'm going to do is I'll just make an object of the child class, guys. Now to call this parent function, which is the function number 1, let's see if I can do that. And I'm getting function 1 and function 2 as well. So I can call both the functions. So first of all, I'll call the function 1, and after that, I'll call the function number 2. Let's see what the output will be. Now the output is this is a parent function and this is a child function. So basically what we have done is we have taken two classes, named it as parent and child. And from the child class, we are inheriting the properties of the parent class here, which is the function number 1. And this is the basic example of inheritance, guys. This is how you can do it. Now that I've shown you a simple example, let's talk about the init function in Python. So what exactly is an init function? Init function automatically gets called each time an object is created for a class. Now when we add an init function to a parent class, a child class will not be able to access the parent class method. So to overcome this, the child class init function overrides the parent class init function. So now let's take a look at an example to understand this. Now to show how init function works, let me first clear this. We'll write a init function over here. Yes. And instead of self, I will add one more variable. Let's say fname and fage. Now what I'll do is I'll just write self dot name is equal to fname and self dot age is equal to fage. Now I'll take one more function, guys. So I'll just name it as, let's say, view. And for view, I want to print the value of fname, self dot name and self dot age. So this is my parent function, guys. And for the definition in the child class, I will also make one init function. So I'll just write it as init self. And again, I have to add fname and fage. And let's say self dot name is equal to fname and self dot age is equal to fage. Now this init function is going to override the parent init function, guys. So let's make one more function. So this is going to be view as well. And in this, let's say I want to print. Okay, before we move on, we have to specify the parent function with the init function as well. And we don't have to mention these variables. Instead, I'm going to add one more. Let's say I want to add last name as well. And I'm going to add it as, let's say, Edureka. Now I'm going to print over here self dot age, self dot last name and self dot, let's say, name. Alright, I have to remove these. Let's make one more object and give it the value. Let's say I want the age to be 23 and last name is going to be Python in the inverted commas. Name we have already specified, so we don't have to give it again. And I'm going to just call the function. Let's see what happens, what is the output will be. So as you can see, I'm getting the output as Python, Edureka and 23. So this is how you can override the parent class init method using the child class, guys. So this is all about the init function. Now let's talk about the next topic that we have, which is the types of inheritance. So depending upon how many types of parent class and child class are going to be there inside the program, following are the types of inheritance in Python, guys. So there is single inheritance, there is multiple inheritance, then there is multi-level inheritance, hierarchical inheritance, and there is hybrid inheritance as well. So we are going to talk about each of them in detail, guys. So first of all, let's talk about what is single inheritance. So when the inheritance involves one child class and one parent class only, it's going to be a single inheritance. The example that I showed you before is the example of single inheritance, guys. And talking about multiple inheritance, it is going to involve more than one parent class, which means we are going to have at least two parent classes and the child class is going to derive properties from both of them. And this is called multiple inheritance. Now talking about multi-level inheritance, let's say we have a single inheritance going on. We have a parent class and we have a child class. But the child class also act as a parent class for another child class. That is going to be a multi-level inheritance, guys. And talking about hierarchical inheritance actually involves multiple inheritance from the same parent class. And talking about hybrid inheritance, if a program has more than one types of inheritance, let's say we have a single and multiple inheritance going on simultaneously, it's going to be a hybrid inheritance, guys. So let's take a look at examples for each of them. So let's go to PyCharm, guys, and I'll remove all this. So I'll start with single inheritance, guys. So I'll just take a parent class and give it a function. Let's say function1, and give it a statement. Let's say this is function1. Now let's take another class, guys, class child, and give it the value of the parent class. And after that we can move for another function, let's say function number 2, and give it a statement. Let's say print this is function2. Now make a child class object and call the function. So we can call both of these functions. So I'll just call function1, give it the output, and we are getting the output as this is function1. So this is a basic example of single inheritance, guys. Now talking about multiple inheritance, what I'm going to do is I'm going to make one more class over here. Let's say class parent2. Now what happens is, let's say give it a function number 3, let's say, and print statement this is function3. And in the declaration over here, I'm going to just specify two classes, and when I call the functions, I can call function number 1 and I can call function number 3 as well, guys. So let's see what is happening here in the output. I'm able to call the function number 1 and function number 3 as well from the child class object. So this is the example of multiple inheritance, guys. Now talking about multi-level inheritance, so what I'm going to do is I'm just going to specify parent over here, and from this, let's say it doesn't have any declaration of parent1, which is this class, so it is not able to inherit any properties from that. But what I'm going to do is I'll just specify parent2 over here, and I can still call these functions because there is an inheritance going on between them, which is multi-level inheritance, which basically means this class, the parent1 class, is actually giving properties to parent2 class, and parent2 class is giving properties to the child class. So this is example of multi-level inheritance, guys. Now talking about hierarchical inheritance, guys, what I'm going to do is instead of parent2 over here, I'll just specify parent. So for these two child classes, I have the same parent class. And now let's see if I can have the same output or not. I'm not going to get the properties from the parent2 because I have not specified it in the inheritance. So I'll just remove this and let's see what happens. I'm getting the output as this is function1. Okay, let's make the object for parent2 as well. Alright, give it 1 and ob1 dot. Let's say what functions we can have. I can have the function number 3 and I can have the function number 1 as well. So I'll just print function number 1, and from both the child classes I'm able to print the function number 1. So this is the example of hierarchical inheritance, guys. I'm using the same parent class to give the properties to both parent2 and child class as well. And now talking about hybrid inheritance. Hybrid inheritance actually involves more than one inheritance going on in the single program. So we have a single inheritance over here. So let's say I want to have multiple inheritance as well. So I'll just specify parent2 now. And this is the example of hybrid inheritance, guys, because we have a single inheritance going on over here. And in the child class, I'm inheriting both the parent1 and parent2. And this is the example of multiple inheritance. So this is a hybrid inheritance example, guys. Okay, we are getting a type error which is saying cannot create a consistent method resolution order for base parents, parent1 and parent2. Okay, let's say instead of this, I'll make one more class over here. give it a value, let's say parent number 3, give it a function, let's say 4, and print statement, this is function 4. Now instead of parent number 2, what I'm going to do is I'll just take parent number 3, guys, and with the child class operator, let's see if I can actually get the function number 1, and let's say I want function 4 as well. I'm able to do that. So in the output, let's say what I get, I'm getting the function 1 and function 4. So this is a simple example of hybrid inheritance, guys. Now that we are done with the type of inheritances, let's take a look at what all we have now. So we're going to talk about the super function, guys. Super function actually calls the parent class method directly. So let's take a look at a simple example, guys, how it works. So I'll just remove all this. Now what I'll do is I'll make a, let's say, parent class and give it a function 1. Again, the print statement. Now what I can do is, instead of calling the parent function from the object, I can just use the super function, and over here I can just call the function 1. Now I'll just print this is function 2. Let's make a child class object. Now let me see if I can call the function 2 or function 1. I can do that. So I'm going to call the function 2, guys. Let's see what the output will be. So I'm actually able to call the function 1 directly from the super function over here. So this is the function of super function, guys. It can directly call the parent method. And now that we are done with the super function, let's take a look at the next topic that we have, which is method overriding in Python. So method overriding can also be achieved to change the functionality of the parent class function. So let's take a look at an example to understand how we can actually achieve method overriding in Python, guys. So instead of naming them separately, I'll just name them as same. So when I create the child class constructor, and if I call the function now, okay, function 1, which is, so when I'm calling this function, technically it should call the parent function, but what happens is it overrides the parent method. Okay, to specify this, run it again. Now I'm getting the output as this is function 2, even though I'm calling this function 1, which should be ideally calling the parent function, but it is printing out the function which I have specified in the child class. So this is how I have overridden this parent class method, and this is how we can perform method overriding in Python, guys.
Why we need exception handling? Well, to understand the concept, let me quickly walk you through a very simple scenario. Consider the case where you're dividing any number by 0. What will happen? Can you divide a number by 0? You cannot, correct? But how would a kid approach this problem? The kid would think that you can actually use regular division to divide something by 0. So you're dividing something by nothing, so it stays the same. Something like this, right? Little does the kid know that this is wrong. Now check out how a programmer would approach the same concept. Well, it is established that dividing by 0 is not possible mathematically. So as programmers, we know it is not correct. So this basically leads to two cases, either an exception or an error. So a Python program terminates as soon as it encounters an error. Well, in Python, an error can be either a syntax error or an exception. And it is as simple as that. Well, let us actually divide by 0 for fun, guys. So this is what happens in Python. Python presents us with this beautiful error message saying that it cannot divide something by 0. Well, in fact, let us head to PyCharm, which is my IDE for coding in Python, so we can actually walk through this practically. So guys, here I am in my PyCharm. So let me quickly go ahead and type out some simple code for you guys. So let us start with y equal to 10. We can actually print y by 0 now. So let me quickly go ahead and run this in the console. So as you can check out, it says 0 division error. Division by 0 is not possible. So you cannot divide anything by 0. So let's establish that at this point, guys. That was good enough, right? So let's get started then. Let us quickly check out what exception handling actually is. Well guys, to get a clear picture of what that is, we need to start with understanding the definition for both exception and exception handling. Well, what is an exception? Guys, an exception is an event which occurs normally during the execution of a program that disrupts the normal flow of the program's instruction. So instead of the program actually executing evenly and nicely, there is actually a disruption in between the code. So this we basically call as an exception. So next, what is exception handling? Guys, this is the process of actually responding to an occurrence of an exception. As simple as that. So basically the process of responding to the occurrence during compilation of exceptional statements which require special processing is actually what is exception handling, guys. So this is basically done because of the change in the normal flow of the program execution. Well, it is a very simple concept, and I'm sure at the end of this session you guys will agree. Well, at this point, what do you think of exception handling in Python, guys? Head to the comment section and let me know what you think so we can interact there. And now that we know what exception handling is, we need to understand how the entire process of exception handling works. So let us check it out. First, let us walk through what happens in Python. So let us say the user makes an error. What happens next? Guys, when you think about it, it is either the user that finds out the error or Python will actually tell you what the error is, correct? So once you know what the error is and you know where it is, you can basically start analyzing it to know if it is fixable or not. Well, if it is fixable, how can you go about doing that? Well, if it isn't, nothing to worry. Guys, Python is so good that no matter on what level you mess up, there is always a way out of it, guys. So now if it's fixable, how can we handle the exception? Check out the image on the right side. So we need to first find the error. If we cannot do it, Python will find out for us. Well, next is to make sure you take caution while coding if you think that there is going to be an error in that particular piece of code. Well, remember the word try at this point, alright? And later we'll actually fix the error and we call this as catch. Just remember the keywords for now and we'll be walking through these in detail in the following slides. In fact, let us begin by checking it out right now. So guys, these are some of the important terms that you need to take a note of before starting to code and understanding exceptions. So first we have try. Well, try is basically the keyword which is used to keep the code segment under check. So whatever code you put under try is actually the code under scrutiny, guys. And next we have except. Well, except is the segment which is actually used to handle the exception, guys. So how do we know that the exception has occurred? If our piece of code in the try block has actually caused an exception, then we can handle it in the except block. And how do we use else? Well, else is basically run when no exceptions exist, guys. And lastly, we have finally. Finally will run even if there is an exception. Finally will run if there is not an exception as well. So I want you guys to note this at this point of time, and this will help you a lot on the coming slides, guys. So now coming back to Python, this is what it visually looks like. We first have the try block where we run a piece of code. And next we have the except where the code actually runs only when there is an exception in the try block. And if there are no exceptions, then we run the else block, guys. And lastly, no matter what, exception or no exception, we run the finally block always, guys. Sounds simple, right? Well, it actually is. And now that we are familiar with the process of exception handling, let us check out how we can go about understanding this using Python practically, guys. Well, syntax errors occur when the parser detects an incorrect statement. Well, check out the tiny arrow on the left side here. Well, this is basically to indicate where the parser ran into the syntax error. Well, in this particular example, there were too many brackets, right? So there was an extra closing bracket. Well, if you actually remove it and run it, you will actually get a different error this time. Well, check on the right side part of the code. Well, this time you actually ran into an exception error. Well, this type of code occurs whenever syntactically correct Python code results in an error, guys. So the last line of the message indicated is what type of an exception error that you actually ran into. Well, in this particular case, it is zero division error, and it says that the integer division or modulo by zero is not possible. So this is basically the same case that I showed you in PyCharm a while ago. But instead of showing the message exception error, Python details what type of exception error was encountered. Well, as I mentioned, in this case, it was a zero division error, right? Well, Python comes with various built-in exceptions as well as the possibility to create self-defined exceptions as well. And now that we are clear with that, let us check out how we can go about raising an exception on our own. So we can basically make use of raise to throw an exception if a condition occurs. The statement can be complemented with a custom exception. Well, if you want to throw an error when a certain condition occurs using raise, you can actually go about it like the following piece of code you actually see on the screen. And when you run this piece of code, you'll be greeted with the following output, guys. So it says exception x should not exceed 5 and the value of x was 10. So let me quickly jump back to PyCharm and we can execute this there. So guys, I'm in my PyCharm right now, so I've quickly typed out the code for you guys. So let me quickly go ahead and run it and we can check out the error. As you can see, it says exception x should not exceed 5 and the value of x was 10. Perfect, right? So let's quickly jump back to the presentation to check what's next. So the program basically comes to a halt and displays our exception to screen, right? So this basically offers clues about what went wrong. And now that we're clear with that, we can actually proceed to checking out the assertion error, guys. So instead of waiting for a program to crash midway, you can actually start by making an assertion in Python. Well, we assert that a certain statement is actually met. And if this condition turns out to be true, then excellent, the program can continue. But if the condition turns out to be false, you can have the program to throw an assertion error exception for you guys. Well, have a look at the following example on your screen. Well, this is basically where it is asserted that the code can be executed in a Linux system, guys. So if you run this code on a Linux machine, the assertion passes. If you were to run this code on a Windows machine, the outcome of the assertion would be false. And what would happen? Well, definitely the result would be something like this, right? So it would basically present us with an assertion error and says that this code runs only on Linux, right? So I'm using a Windows desktop in this particular case. So let me quickly open up my PyCharm and then we can actually run this piece of code to check out our exception, guys. So I'm back in my PyCharm and I've typed out the code, guys. So let me quickly go ahead and run this. As you can check out, since this is a Windows machine, it says this code can run on Linux only. But this particular case, this assertion would be true if you were actually running this on a Linux machine, guys. So if any of you guys are using Linux machine, make sure to try it out. And on that note, let's quickly come back to the presentation, guys. Well, in this particular example, throwing an assertion error is the last thing that the program will do. The program will definitely come to a halt and it will not continue, guys. But what if that is not what you want? What if you want something different from this, or that you want the program to continue while displaying an exception for you guys? Well, now that we actually have a fair idea about how we can go about understanding exceptions, let us dive right into the heart of exceptions now. Yes, I'm talking about the try and except block, guys. So basically, the try and except block in Python is used to catch and handle exceptions. Well, Python basically executes code following the try statement as a normal part of the program. The code that follows the except statement is the program's response to any exception in the preceding try clause, guys. Well, as you saw in the earlier example that I actually showed you, when syntactically correct code runs into an error, Python will throw an exception error. And this exception error will actually crash the program if it is unhandled, guys. So the except clause determines how your program responds to these exceptions, guys. So instead of actually crashing our program, we can actually tell Python what to do when this particular exception occurs. We'll check out the following function, guys. So this function can basically help us understand the try and the except block. Well, the Linux interaction function can only run on a Linux system. The assert in this function will actually throw an assertion error exception if you're using it on any other operation system apart from Linux. Well, we can actually give this a try in PyCharm. So let me quickly open up that. So guys, I'm quickly here in my PyCharm. So let me quickly go ahead and select this and run it. Well, this won't say anything right now because, well, if it was actually a Linux platform, the message would have been printed, right? So let's quickly jump back to the presentation. So basically, if we run the tiny piece of code you see on the bottom, the way we actually handle the error in this particular case is because we gave out a pass, right? Well, if you were to actually run this code on a Windows machine, you would get the following output, which is already on your screen, right? So it is a blank output. You get nothing. Well, the good thing here is that the program actually did not crash, but it would be nice to see if some sort of exception occurred when you actually ran your code. Well, to this end, you can actually change the pass into something that would generate an informative message like this. Check it out. So let me quickly go ahead and run this in PyCharm. Well, as you can check it out, it says the Linux function was not executed, right? So basically this happened because I am on a Windows machine, guys. So let's quickly go back to the presentation. And guys, when an exception occurs in a program running this particular function, the program will continue as well as inform you about the fact that the function call was not successful. Well, what you did not get to see was the type of error that was actually thrown as a result of this function call, guys. So in order to see what exactly went wrong, you would need to catch the error that the function threw. Well, check out this particular piece of code I have for you guys. So here is basically where we actually capture the assertion error and we print the output message to the screen. So we have a try block, we have the same function, and we have except as error, right? So we're going to print what type of an error it is, followed by a message for us, right? So running this particular case on a Windows machine will actually give us this following output, guys. So it says function can only run on Linux system, and whatever you have chosen in the print block is actually being printed for us. So let me run this in PyCharm. So as you can check it out, we have the message printed, right? So it was the same as I told you. So it was the same message as I told you before. So heading back to the presentation. Well, in the previous example, we actually called a function that we wrote ourselves, right? And after that, when we actually executed the function, we caught the particular assertion error exception and then we printed it on the screen. Well, I have for you another example where you actually open a file and use a built-in exception, guys. In fact, let us dive into PyCharm and we can actually run this and we can come back and take a look at the output. So guys, I actually came into PyCharm and I actually ran that particular piece of code. Why does it say could not open file log? Well guys, basically if the file.log does not exist, the block will give you this output, right? So it says the file could not be opened. Well, this is an informative message and our Python program is actually still able to continue to run. It has not crashed, right? Well, actually in the Python documentation, you can see that there are a lot of built-in exceptions that you can make use of. And here is one exception that I have for you guys that you can check it out. So it says exception file not found error, right? So basically this is raised when a file or directory is requested, but that doesn't actually exist. And this is just one among many that Python offers to us, guys. Well, to catch this type of an exception and to print it on the screen, we would actually use this following piece of code, guys. So in the try block, we're actually going to open it as file and we're going to read something present in it, guys. We're going to accept it by pushing a file not found error as an object, and later we actually end up printing that object, right? So let me quickly go into PyCharm and we can check it out. Well, as you can check it out, we have error number 2, which says no file or directory, right? So it's perfect. Well, you can have more than one function call in your try clause actually, guys, and anticipate catching various exceptions as well. Well, a thing to note here is that the code in the try clause will actually stop as soon as an exception is encountered. But there is one important thing that I want you guys to note down is that while catching an exception, it basically hides all of the errors, guys. Well, definitely there are some unexpected errors in your program, right? When you're catching an exception, and even these are completely hidden from you. Well, this is why basically you should avoid using bare except statement clauses in your Python programs, guys. So instead, basically what you can do is you can refer to the specific exception class that you want to catch and then handle those particular exceptions, guys. So look at this following piece of code I have for you. So here basically you first call the Linux interaction function and then later actually try to open a file, guys. So let us quickly jump into PyCharm and we can actually check it out. So as you can see, I actually executed the program, guys. Again, if the file doesn't exist, running this code on a Windows machine will give you that output, right? So it basically says that the function can run only on a Linux machine, and then we have actually printed something, guys. Well, what we actually did here is inside the try clause, we directly ran into an exception immediately, and we did not get to the part where we'll actually try to open our file.log, right? Now, basically, when you actually run it on a Linux machine, it's going to say no file or directory found. Check it out here, guys. So this is the Windows output that you get, and this is the Linux output, guys. Well, at this point, let us take a quick break and check out what are the key takeaways of this particular module, guys. So basically, a try clause is executed up until the point where the first exception is encountered. And inside the except clause or the exception handler, what we basically call it, we can actually determine how the program actually should respond to that particular exception. And we can actually manipulate multiple exceptions and differentiate how the program should respond to each of them, right? And lastly, we actually learned why we should avoid using bare except clauses, guys. And now that you're clear with this, next up I have for you is the else clause, guys. So basically in Python, using the else statement, you can instruct a program to execute a certain set of code only in the absence of exceptions, guys. Well, check out this following diagram on your screen. So basically in the try part, we have the code except when we actually want to handle the exception, or else in case there is no exception, we're going to run the piece of code that comes in under else, guys. So let me quickly walk you through the code, guys. So here is basically the same Linux interaction function, and we have an assertion error here, and we actually are going to print the error, right? So else, if there is no assertion error, so we're going to have an else clause and we're going to print saying executing the else clause, right? So let me quickly open up my PyCharm and we can run this piece of code, guys. So as soon as I go ahead and run this, it says function can only run on a particular Linux system, right? So as you can check out the output, it says the function can run only on Linux systems, right? So in this case, I have a Windows machine, so we are actually not printing the except clause here. But if you were running this on a particular Linux machine, this is the output that you would get, guys. So it says doing something and executing the else clause, correct? This happened because the program did not run into exceptions, any exceptions, right? So else clause was actually executed. Well, you can actually try to run the code inside the else clause and catch possible exceptions there as well. Well, again, we have the same Linux interaction here. We're going to print it, right? So the Linux output says doing something and no such file or directory found. Well, this is basically for the else clause, and we're using the same file example here, but then we're actually trying to catch an exception in the else block as well. So the output is pretty much straightforward as well, right? Well, from the output, you can actually tell that the Linux interaction function actually ran. Well, because no exceptions were encountered, an attempt to open file.log was actually made, and that file did not exist. And instead of opening the file, you actually caught the exception, which is the file not found exception. Pretty simple, right? And I hope you guys are clear with all of the concepts that we discussed until now. And next up, we need to check out how we can actually use the finally clause, guys. Well, to begin with, imagine that you always had to implement some sort of action to clean up executing your code, guys. Well, Python basically enables you to do so using the finally clause. Have a look at the following example, guys. Check out the workflow on your screen. I'm pretty sure we're all familiar with try, except, and else at this point of time, right? So this is the chronological order that you need to go into. First, we have the try to check for an exception. Then we actually handle if there is an exception using the except, or else if there is no exception, we're going to print whatever is there in the else block. And lastly, we have something called as finally, guys. So no matter what, we're going to execute this. In case if there is an exception, the finally block is going to run. In case there is no exception, finally block is going to run there as well. So let us quickly check out a coding example, guys. So basically, this is the particular code I have for you guys. And let me jump back into my PyCharm and we can actually execute this. So guys, I'm back into my PyCharm. So let me quickly go ahead and run this. Well, as you can check it out, it says that the function can only run on Linux machines. This is because I'm on a Windows machine right now. And no matter what, right? So exception or no exception, we have this message which is cleaning up irrespective of any exception, guys. So this is basically the use of finally, guys. And that is as simple as it gets. So it's pretty much simple, right? Well, try, except, else, finally, all of this is a really simple concept. And once you understand what it actually does, you can go about doing a lot using Python, guys. Well, no matter what the Python application is, there is a very good chance that you'll actually make use of exceptions, guys.
What is Python requests? Request in Python is a module which can be used to send all kinds of HTTP requests. It is very easy to use and has features like passing parameters in the URL and passing custom headers as well. It is a human-friendly HTTP library, as it also suggests on the official documentation page as well, and it is one of the most downloaded Python library with more than 400,000 downloads every day. So you can imagine the popularity of Python request, guys. It was written by Kenneth Wright and has a license under Apache 2.0. So this is about Python request, guys. I hope you are clear with what exactly is Python request. So now that we have learned what is Python request, let's take a look at the advanced features that Python requests come with. So first of all, we have keep alive and connection pooling, and then we have elegant key value cookies. Then coming on to the next one, we have international domains and URLs and automatic decompression as well. And then we have sessions with cookies persistence and Unicode response bodies. Then we have browser style SSL verification and HTTPS proxy support as well. There is automatic content decoding and multi-part file uploads. And then there is basic authentication and streaming downloads as well. And last but not the least, we have connection timeouts and chunked requests. So these are all the advanced features, guys. Don't worry. We'll be learning about how we can use Python requests. So let's talk about why exactly do we need Python requests, or why are we using Python requests? So the reason behind this is pretty simple, guys. We use Python requests because you don't have to manually add the queries to your URLs and form encode post data. And that is a reason enough to use Python requests, guys. And if you're not able to understand this reason behind using the Python request, you'll be able to understand this later on in the session when I'll be showing you the use case. So hang in there. Now that we are done with the reason behind why we are using Python request, let's try to understand how you can install Python request on your system or on the project that you're working on. So first of all, you have to install the pip environment on your system, and then you have to run this command that I'm going to tell you inside the terminal, which is pip install request, guys. So let's take it up to PyCharm and I'll show you how you can install request on your project or on your system, guys. Now, as you can see, I have a new project over here inside PyCharm. So I'll show you guys how you can install request on your system. So you have to open the terminal here. Just write pip install requests and you will see that the files are being installed here. It will take some time, guys. And there is one more approach to this. If you are using PyCharm, you can open the settings, and inside the settings you will find the project interpreter. And over there you can simply add the request library and that will do the job for you, guys. It is same as running this command inside terminal. Okay, I'll show you that as well. So you open settings and here you will go to the project where you will find the project interpreter, and over here you can simply just add your file. Let's search requests here, and this is by author Kenneth Wright that I have told you guys. So I'll just install this package and it will not take so much time because we have already installed it. And as you can see, we have requests over here inside the, so you can see request over here which has all the files and everything for our project. So I'll just type OK, close the terminal, and over here I will make one demo file, guys, to show you how you can make get and post requests. So we have this file. Let's enter. Okay, let's first of all talk about making get and post request, guys. So we have installed request on our system, guys. So let me talk about get request. What exactly are they used for and how are we going to use them inside the tutorial I'm going to show you, or the use case as well. So get requests are basically used to request the data from the server. So what you have to do is, I'll show you the syntax as well. So you just have to import the request library, and then you will have to make one response object, in which in this case R is the response object, and you are going to use the request library and make the get request. And inside the get function you have to mention the URL that you're going to make the request from. So let's take it up to PyCharm, guys. I'll show you how you can make the get request. So let's enter the presentation mode for better visibility. So I'll just import the request library. Yes. And I'll make one response variable or response object, and inside this I will use request.get, and inside this I will have to specify one URL, guys. So I'll just show you what URL I'm going to use. So what I'm going to do is I'll just copy the URL over here, and when I make the print statement I will use the response object, and let's get the text over here using the response object whatever we have on the server. And when I run this, I will be getting the text for this URL that I've just provided, as you can see over here. So this is how you can make a get request, guys. Now let me show you how you can actually pass parameters inside your URL also. So what I'll do is I'll just make one variable, let's say payload, and inside this I will specify a dictionary with some values, let's say key 1 and value 1. Okay. So when I pass this inside the get function with the parameter, that is params is equal to, that is the parameter variable, guys. So I'll just pass payload over here, and when I get the URL now, I should be getting this parameter that I have just passed inside the URL. So you will be getting this dictionary of the value that I've just passed as a parameter inside the URL. So this is how you actually pass parameters inside your URL, guys, while you're making the get request. Similarly, you can also pass custom headers as well. I'll be showing you that later on in the session. So we have talked about making get request, guys. So let me just talk about how you can make the post request as well. So we'll talk about what exactly post requests are used for. So basically post requests are used to submit the data to be processed to the server. So let me show you an example with the syntax. First of all, you have to import the request library, and then you have to use the post function as well using the request keyword. After that, you have to mention your URL and the data that you want to give it as a payload or something like that. And then you have the response variable as well, or response object. So let me take it up to PyCharm, guys. You'll be able to understand this better in PyCharm. So instead of get request, we'll get post over here. And instead of parameters, we'll just pass this as data. So instead of text, okay, we'll just get the text again. So let's see what are we getting. So we don't have post request allowed inside this. So instead of get, we'll just write post over here. Run it again. As you can see, so we have this dictionary that I added using the post request, guys. These are the headers, and then we have cookies as well. No, we don't. And this is how you can actually make a post request, guys. I hope you are clear with making the post request and get request, guys. So this is all about making a post and get request, guys. Also, I want to show you what are all the content or the response content that you get using these requests. So let me just take one response object again. I'll make a get request. So I'll just pass the URL over here, and we're good to go. So we will print whatever we'll get. So using the response object, let's see the content type or what all content we can get. So we can get text, we can get headers, cookies, and then there is status code. Let's check the status code first, guys. If the status code is 200, we are good to go. It is 200, guys. So we'll get some more content from this. So we'll get cookies now. It will be showing us the cookies inside a cookie jar. Yes, we are getting the cookies inside the cookie jar, and we can also pass our own cookies. I'll be telling you about that later on in the session. Don't worry, guys. So then there is headers as well. You'll see all these headers inside a dictionary, guys. So this is how you actually access the headers inside a URL. And then there is the content format also. You can get the content in the format of JSON. As you can see, we're getting the content as JSON objects. So this is all about response content, guys. Now let me get to the next topic that we have, which is cookies and headers, guys. So I've just shown you how you can get the cookies and headers inside using the response variable. So let me just talk about what are cookies and headers, guys. So we can view the server's response headers using a Python dictionary, which I have just shown you guys. So the dictionary is special though. It's just made for the HTTP headers. And similarly, you can get the cookies as well. If a response contains some cookies, you can quickly access them, and to send your own cookies to the server, you can just use the cookies parameter, and cookies are returned inside a request cookie jar, which acts like a dictionary but also offers a more complete interface suitable for over multiple domains or paths. So let's try to understand this inside PyCharm, guys. So what we'll do is we'll just get some cookies here, and when I run this, we're getting a cookie jar. Okay guys, what I've done is I have actually changed the URL. So what I'll do is I'll run this command now, and you will be seeing the cookies over here, which is inside the request cookie jar. And what I can do is I can also pass my own cookies. So I'll take a variable, name it cookies, and give it a dictionary, guys. And inside the dictionary, I'll specify some values. Let's say key1 is equal to value 1. And then over here, using the cookies parameter, I will just pass cookies here. So I'll just write text over here, and when I run this, I should be getting a dictionary with the cookie jar, which actually has the cookies named as key1 and value1. So this is how you can actually make your own cookies inside a web server. And then I'll show you what you can do with headers as well. So let's get the headers here. When I run this, I should be getting the headers inside this URL, which are all these headers over here inside the dictionary. So this is how you can actually access the headers inside the URL, guys. So let me talk about session objects, guys, which is the next topic that we have. So session object actually allows us to persist certain parameters across requests. So it also persists cookies across all requests made from the session instance, and will use the URL library 3 connection pooling. And if you're making the several requests to the same host, the underlying TCP connection will be reused, which can result in a significant performance increase. And also a session object has all the methods of the main request API as well. So let's try to persist some cookies across the request, guys. So we'll move to the PyCharm again. So we have come to the PyCharm now. What I'll do is I'll make one variable, let's say session object, that is. So I'll use request.session, and after that I'll just use a get statement where I'll just use s.get, pass the URL, and we're good to go. Then what I'll do is I'll make a response object, and inside the response object I will pass one more variable or URL, which is this one. Now what I'll do is I'll just print response.text. Let's see what happens. As you can see, we have persisted one cookie. So this was all about session objects, guys. And any dictionaries that you pass to a request method will be merged with the session level values that are set, and the method level parameters override the session parameters as well. And you have to consider that method level parameters will not be persisted across requests even if making a session as well. So now that we are done with session objects, let's take a look at errors and exceptions that we have for Python request, guys. So first of all, in the event of a network problem, for example, a DNS failure or a refused connection, request will raise a connection error exception, and it will raise a HTTP error if the HTTP request returned an unsuccessful status code, which is actually 405 or 404 as well. Now, if a request times out, a timeout exception is raised, and if a request exceeds the configured number of maximum redirections, a too many redirects exception is raised. So this is all about errors and exceptions that we have in Python request, guys. So now that we are done with errors and exceptions, let me talk about a small use case that I have made using the Django app. So we will exit the presentation mode over here, and I will open the project that I had made. So as you can see, I have a Django file over here with all the init settings.py, urls.py. So I have over here the URL configurations and everything. And I have a views.py file inside my app that I had created. So this has the code for making a request to a web API. And inside that, I will be able to search for a particular city, and I will be getting the description of the weather and the temperature over there and the condition of the weather over there. So I will show you this, and this is my template, guys. So let me run the server, guys. And if you're wondering how you can actually make a web app, I suggest you check out the Edureka tutorial for Django web applications, where you will be able to learn how you can make a web app from scratch, guys. So when I run my server, I should be getting a URL, guys. So that's where I have to actually make the request. So as you can see, I have a city London over here specified first of all. So when I open this, first of all, I have a heading which is saying what is the weather like. Then I have the icon which is saying it has broken clouds. Then there is London city name and the temperature in Fahrenheit. So let's see if I can do that. Since I'm making request to the API, when I change the city over here, I should be getting the temperature of the city again. So when I refresh this, now as you can see, I've changed the city as well, but I'm getting the temperature of the city that I have just specified, guys. So as you can see how easy it is to make request to a web server and get these values. So I'm making this request to this URL, guys, which I have specified over here, Open Weather Map API. This provides us the API, and I'm able to search for cities over there inside the request that I'm making. And this is how you can actually make a simple Django app for calculating or getting the weather of a city using the request library, guys.
Let's take a quick look at the time module and its built-in methods. The time module consists of all time-related functions that are required to perform various operations using time. It also allows you to access several types of clocks required for various purposes. The time module begins recording time from the epoch. Epoch literally means a time in history, and it begins on 1st January 1970. As you can see on the screen, I've listed down some of the most important functions that are available in this module. So talking about the first function, which is time, it returns the number of seconds that have passed since the epoch. The cTime method returns the current date and time by taking the elapsed seconds as its parameter. Sleep stops the execution of a thread for a given period of time. The local time method returns the date and time in the struct time format by taking the number of seconds passed since the epoch as the parameter. GMTime, on the other hand, returns the current date and time in the UTC format. The mktime method is inverse of local time. It can take a tuple of maximum 9 parameters and returns the seconds passed since the epoch. And finally, the ASCTime method, which can also take up to 9 parameters and returns a string representing the same. Okay, so now I'll jump onto my Jupyter notebook and show you all how this works. So the first thing that you'll have to do is import the time module. So I'll say import time and I'll hit run. Okay, so first I'll be making use of the time method present in the time module. So I'll just say time.time and I'll hit run. So like I've already told y'all, this method returns the number of seconds that have passed since the epoch. So I'll hit run. Okay, so here is the number of seconds that have passed since the epoch. Now, if I want to convert it to the current date and time, I can make use of the ctype method. So I'll just have to use time.ctime. Now, if I want to convert this into the current date and time, I can make use of the ctime method. To do this, I'll just use time.ctime. And I'll have to pass the number of seconds as a parameter to this. So as you all can see on the screen, I've passed the number of seconds which was returned by the time method to the ctime method, and I've got the current date and time. If you want more information about these functions and methods, all you can do is use the help method. So I'll just say help time, and if I want to fetch data about the time method, I'll just say time.time and I'll hit run. So as you all can see, it says that this method returns the current time in seconds since the epoch. Similarly, if you use help on any method or function, it will return the corresponding information about that function. Okay, so moving on, I'll be making use of the local time method and see what it returns. So I'll just say time.localTime and I'll hit run. So as you can see on the screen, I've got the current date and time in the struct time format. Now to make you all understand what this struct time class is, let me get back to my presentation. Okay, so as you all can see, the struct time class basically has 9 attributes, starting from the year, whose value starts from 0 and goes up to 9,999. The second attribute is month, whose value will be anything from 1 to 12. After that is mday, which means the day of the month, and the values can range anything from 1 to 31. Similarly, hour, minutes, and seconds have the values 0 to 23, 0 to 59, and 0 to 61. The weekday value can be from 0 to 6, where 0 is Monday. Y-day or year day can be anything between 1 to 366, and the final attribute is daylight saving time. It's 1 if it's summer, 0 if not, and -1 if unknown. Okay, now that you're aware of what this struct time format is, let's come back and see what our output actually means. Year is 2019, month is 8 or August, the date today is 8 as well, and so on. So I hope you're clear with this. Okay, so now, in case you want to fetch the number of seconds that have passed since the epoch. So to do this, you can make use of the mktime method. Okay, so all I'm going to do over here is first store the local time in a variable, say A, and after that I'll take another variable B, wherein I'll be using the mktime method, and I'll pass the parameter to it as A. Finally, I'll just print out B. So as you can see on the screen, the mktime method has returned the number of seconds that have passed since the epoch till now. So now, in case you want to fetch the current date and time from the struct time format and return it in local format, you can make use of the ASCTime method. So like I've already told you all before, the local time method returns the current time in the struct time format. I'll be using the variable A, which stores the struct time format of the current date and time to convert it to the local format. And to do this, I'll create some new variable, say C, and then I'll use ASCTime method. So time.asctime, and I'll pass the parameter to it as A. And then I'll just print out C. Okay, so as you all can see over here, it has taken the struct format and has returned the local format of date and time. Python also allows you to format and pass strings using the strftime method and the strptime method. The strftime method can take a tuple containing 9 parameters and returns a string representing the same depending on the format code used. The strp method passes a string and returns it in the struct time format. To show you all what these format codes are, I'll just use the help method, and I'll pass time.strftime as a parameter to this, and I'll hit run. Oh, I've made a spelling mistake over here, sorry guys. It's strftime. So as you all can see over here, I have a number of format codes which I can use to format my date time strings. Okay, so first let's make use of the strftime method. So as we all have seen, I've created a variable A in which I've stored the current time in the struct time format. So let me just print this out again. Okay, so now I want to format this output in a manner which is convenient for me. So to do this, I'll use the strf method. So I'll just say time, I'll take another variable, say x is equal to time.strftime. I'll use the strftime method within which I'll be using the format codes to format the date as per my choice. So first I want to print out the month. So I'll use the format code mod m. It's small m guys, please be careful because this is case sensitive. And then between this I just want to see a slash. After this I'll just print the date. I'll use mod D and then the year. So I'll use mod Y. Sorry for the spelling mistake. I'll just print X. So as you can see on the screen, I've returned the current date in the month, day, year format. Similarly, you can also pass a string and return it in the struct time format. To do this, you can make use of the strptime method. To do this, I'll take another variable, say Y, and I'll pass a string to this. I'll say 8th August 2019. And then I'll make use of the strp method to pass this string. So I'll just say time.strptime, and I'll pass Y as a parameter to this and the format of it, which is day, month, and year. Capital B means the full name of the month. And now hit run. Okay, so as you all can see over here, I've passed a string using the strp method and returned it in the struct time format. So now let's get back to our presentation and take a look at the DateTime module. The DateTime module is similar to the time module, consisting of all the required methods that are essential for working with date and time. Some of the important methods present in this module are the DateTime method, which is a constructor, and it consists of two methods, which is today and now, that will return the current date and time. The date method will help you create a date, and the time method will help you create time, which includes hour, minutes, seconds, microseconds, and the time zone information. The DateTime module also consists of a FromStamp method, which converts the seconds to return the corresponding date and time. Another very important function that's present in this module is time delta. Time delta basically returns a duration, which will be the difference between two different times. Okay, so now let's get back to our Jupyter Notebook and see how this module actually works. I'll just create a heading over here. Say date time. And I hit run. The first thing that I'll have to do is import this module. So I'll say import DateTime. After this, I'll be making use of the DateTime constructor to create some date. So I'll say DateTime. And then I'll pass some values to this, starting with the year, which is 2019, and the month as 6, date as 7, time as 4, minutes, seconds, and milliseconds. And then I'll just print this out. So as you can see on the screen, I've created some random date using the DateTime constructor. Now, in case you want to fetch the current date and time, all you can do is use the today and the now methods like I've already told you all previously. So I'll say DateTime. So I'll just copy this. And then I'll use the today method. So as you can see over here, it has returned the current date and time along with milliseconds, which is very precise. I can also use the now method instead of today method over here. So I'll just say now and I'll hit run. So as you can see, both these methods return the current date and time. Now in case you want to access some particular value from this date, all you can do is use the attribute name to access that particular value. So in case I want to access the year and the month, all I can do is save this into a variable, say v, and then I can use v.year to access the year. So as you can see, I've accessed just the year from the current date. Similarly, you can access anything of your choice. So if I say print v.month, and then I'll say print v.hour, and I'll hit run. So as you can see, the month and the hour have been returned. Similarly, you can access any values of your choice using these attributes. Now in case you want to set only date without time, you can use the date method. So you just say DateTime.date and then pass the date as a parameter. The time method can be used to create time without date. So I'll just say it's 3 hours, 45 minutes, and 23 seconds. So now moving on towards time delta, which is a very important method that's present in this module. Like I've already told y'all, this method represents a duration which can either be the sum or the difference between two different dates. Now to make use of this method, I'll just take some variable, say b1, and I'll say DateTime.time delta. And I'll pass the number of days as 20 to this. You can also pass other parameters like microseconds, minutes, etc. Okay, I'll take another variable, say b2, and I'll use the same method again. And to this, I'll pass the number of days as 30. Now, I'll take another variable, say b3, within which I'll just store the difference of b1 and b2. So I'll say b1 minus b2, and then I'll print what is b3 and the type of b3. So as you can see over here, the difference between b1 and b2 is minus 10 days, and the time, since I've not specified anything, is 0. And the type of b3 comes under the time delta class.
why exactly we use regular expressions. We are going to focus on various problems that regular expressions helps us to solve. So this is the first problem, guys. So over here what happens, you have a log file, and from that log file you want only date and time. And as you know, with the format of the log file is not understandable to everyone. So here's a guy who only wants date and time from that log file. So what he can do, he can make use of regular expressions, identify the pattern, and he can actually get the date and time for that particular log file. So this is the first problem. We'll see a lot of more problems which irregular expressions help us to solve. So we'll move forward and we'll see the second problem. Now this is the second problem that it helps us to solve. Imagine yourself as a salesperson and you have a lot of email addresses and many of them are fake. So what you can do, you can make use of regular expressions, and all the email addresses have a particular pattern. They have a format. So with the help of regular expressions, you can verify that format and you'll get to know what all email addresses are correct and what all email addresses are fake ones. So as you can see, obviously schash.com is a fake email address. So using the pattern that is there in all the email addresses, you can verify whether that email address is correct or not with the help of regular expressions. Alright, so let's move on and see what are the other problems. So this is the third problem that it helps us to solve. We'll take the same sales guy's example that we have taken in the previous slide. Now over here, that guy has a data of various customers' phone numbers. And we know that a lot of time people don't give the correct phone number because nobody wants a sales guy disturbing them at odd timings, right? So that salesperson has a problem. He wants to know that what all phone numbers are correct and what all phone numbers are fake. So every correct phone number will have a particular pattern or a format. So using regular expressions, he can identify what all phone numbers are correct and what all phone numbers are wrong. And at the same time, different phone numbers that belongs to different countries or different location will have a different format. So again, taking that thing into consideration, he can again use regular expressions and identify to which area it belongs to. Now in this particular example, what I've shown you is, I've shown you two geographical areas. One is India, another is USA. So with the help of regular expressions, you can actually find out what all phone numbers belong to USA and what all phone numbers belong to India. So I hope this is clear to you. So this is the fourth problem, guys. Now over here what happens, you have a student database and that contains name, age, address. Now what happens, there are a lot of students who live in a particular area and the area code of that area is 59006. But what happened, the area code has been updated and it has become 59076. Now if you go manually update that for all the students, that'll take a lot of time. So instead of that, what you can do, you can make use of regular expressions and find out all the area codes from the student database, and after that you can replace it with the updated area code or the pin code. So as you can see, with regular expressions you can even replace a particular string. We'll move forward and we'll see one more reason of using regular expression. So now this is one more reason to use regular expression, because even if you don't have a Python background, if you have any other programming background like Java, PHP, C#, Groovy, Swift, Ruby, you can use regular expressions because it is compatible with all of these programming languages. And it is even compatible with JavaScript, although it is not written here, but yeah, it is even compatible with JavaScript. So till now we have seen various reasons to use regular expressions, but I know you guys must be wondering what exactly regular expressions is, right? So don't worry guys, we'll move forward and we'll see what exactly regular expression is. So a regular expression is basically used for describing a search pattern. So you can use regular expression for searching a specific string in a large amount of data. You can even verify that that string has a proper format or not. You can find a string and replace it with another string, and you can even format the data into a proper form for importing, for example. So these are all uses of regular expressions. Now over here I've shown you an example. Here there's a string which is present in which they have written Janice is 22 and Theon is 33. Gabriel is 44 and Joe is 21. So as you can see, what all useful data that I can find from here? Only name and age. I don't want the rest of the things that are present in this string. So what I can do, I can identify a pattern, and with the help of regular expression, I can convert that to a dictionary, and in that dictionary only the name and age will appear. Now my question is to you all guys, can you identify a pattern in order to get the name and age? Just give a guess. You just need to identify the pattern. Alright, so Sarah says all the ages are in the form of integers. Alright, Sarah, that's a very nice observation, but what about the names? Alright, so I've got a couple more answers and they say the same thing, that the age is represented with the help of integer numbers, so you can get the integers. For the name, they have no idea how to get it. Don't worry guys, it's totally fine, just give a guess. Alright guys, so let me tell you. So basically if you notice that every name starts with an uppercase first letter. So the first letter of all the names is an uppercase letter. And when we talk about age, all of the age are represented in numbers. So what you can do with the help of regular expression, you can actually find out the 2-digit numbers, and at the same time you can find out the words that starts with an uppercase letter and then it goes on to lowercase letters. And the star actually represents all of them. So you don't need to worry about the syntax that is there in front of your screen. I'll be actually explaining you these things in detail. So you don't need to worry about that. So I hope you have understood the pattern that I'm telling you. Alright, so we have a question from Devon. He's asking, what if this may contain a name of a place? Alright, Theon, so this string does not contain a name of a place. That's all I can say right now. If there was a place present here, then we have to look for a different pattern at that time. So basically with RegEX, you have to make sure that you identify the pattern for the string that you want. So it is very important. So let us move forward and I'll open my PyCharm and I'll tell you how to get age and name. Alright, so let's do it. So this is my PyCharm guys. So over here what I need to do is I need to first import the module for regular expressions. For that I'll type import RE, and now I'm going to type in the string that was there in the example. So I'll type in name age equal to, and now I'm going to write it Janice is 22 and Theon is 33. Now the next line I'll write Gabriel is 44, so I forgot the space, and Joey is 21. Now close it. So now for age, I'm going to type in ages equal to, now you don't need to worry about the syntax that I'm going to write. I'm going to tell you all these things in detail. So this is just an example that I'm giving you, that with the help of regular expression you can actually get the name and age. After that I'm going to discuss each and every operation in detail. So what I'm going to type in, you don't need to worry about that. I'm just showing you that you can actually do it. I'm just giving you an example. re.find all r 1, 3, because all of my ages are 2 digits, are of 2 digits, and then write the name of the string. And for names, what are you gonna do? You're gonna type in names equal to, similar to that, re.find all r, and my first letter is an uppercase letter, that is between A to Z. After that I have lower cases, so I'm going to type in A to Z in lower cases, and then I'm going to put in a star that will actually include all of those, and finally the name of that string, that is name age. Now what I'm going to do is I'm going to define a variable and I'm going to name it as ageDict equal to curly braces. Let's keep it empty right now. And now one more variable I'm going to define, that is x is equal to 0. Now I'm going to use a for loop. I'll type in for each name in names ageDict, each name ages x plus equal to 1. Now print this ageDict. Yeah. So if you're not able to understand what exactly for loop is and what are dictionaries, so you can go and watch the previous tutorial videos on Python and then come back again. Now let's go ahead and execute this. So yep, you have got the dictionary that includes only name and age of that person. So what I've done here is, what is the pattern? I'm repeating it again. So for all the names, the first letter is an uppercase letter and all the ages are expressed in terms of numbers. So using that pattern, I have got only name and age. So this is just an example. We'll actually see how to perform various operations using RegEX or regular expressions. So I'll go back to my slides. Now let's move forward and understand the cursor operation of regular expression. So basically in both strings and regular expression, both of them have their own cursors. So what happens is, suppose you are searching for R and your regular expression includes R. So your cursor is at R in the regular expression, but for text, it will check for B, it is not equal to R, then E, then again, when it comes to R, it will see that this is what you are searching. So it will stop right there. The moment you search for S, it will go on and it will come towards S. And same goes for N as well. So this is a pretty basic operation, but it will really help you to visualize how things work with regular expressions. So we'll move forward and we'll look at various operations that you can perform with regular expressions. So first we'll find a word in a string. So we have a string that says we need to inform him with the latest information. And we need to find the word inform. So let us go ahead and execute this practically. I'll again open my PyCharm. So yeah, this is my PyCharm, guys. Let me just first clear it. So let's begin by importing our regular expression module. So for that, I'll type import RE. And now we have a sentence and we want to find a word inform there. So what I'll do, I'll just type in if re.search inform, and our string is we need to inform him with the latest information. So this is our string, give a colon, and now I'm going to type in print there is inform. So let me tell you what I've done here. First, I've imported the regular expression module, and after that I've defined a condition which says that if it is able to search inform in this particular string, that is we need to inform him with the latest information, then it will print there is inform, otherwise it won't print anything. So as you can see that inform is present here, so it should print there is inform. So let us go ahead and execute this. So yep, you can see that it has printed there is inform. Now let's be more specific and suppose we want to find all the matches here. So let's write a method that will do it for us. So for that I'm going to use find all, which will return a list of matches for me. So for that what I'm going to do is I'm going to write in here, let me first remove this. And now what I'm going to do is I'm going to write in all inform, which is nothing but a name that I've given. You can give whatever name you want. re.findAll, and I've told you earlier as well, find all will return a list of matches. Now over here what I need to find inform, from which string? The string is we need to inform him with the latest information. Alright guys, and so now I'm going to type in a for loop which says that for I in all inform, give a colon, print I. That's it. So now what I've done here, you can see that I've imported the regular expression module. Then I'm using find all, in which it will return all the matches. And what I'm finding inform, and from which string I'm finding inform, this is the string that I'm using. And finally I've used for in order to find all the matches. So let's go ahead and execute this. So yep, it has found inform twice, because you can see that it is available here as well, inform, and even information over here you can see that inform is present. So this is how basically you find a word in a string by the help of a regular expression. So let me first go back to my slides. So we have seen how to find a word in a string. Next, we are going to understand how to generate an iterator. So basically what I'm going to do is I'm going to get the starting and the ending index for the word that I'm searching. Over here I'm searching inform, so it'll give me the starting as well as the ending index for all the matches that it finds. So let us go ahead and execute this practically. I'll open my PyCharm once again. Let me remove all of this. And over here I'm going to define a string. So what I'm going to write here is I'm going to write here we need to inform him with the latest information. Yeah. So now what I'm going to do is I'm going to generate an iterator by using find iterator, and it is going to return the iterator of the matching objects. So basically I'll be printing the starting and the ending index of the matching object. So for that I'll use the for loop. So I'll write in for I in re.find iterator, and I want it for inform, so I'll just type in inform, and now I'm going to type in the name of the string, that is str colon. Now I want that to be converted into a tuple, so for that I'm going to type in lockup equal to I.span, and finally print lockup. So basically it will print the starting and the ending index of the matching object. So let us see if it does that. So yep. So as you can see that for inform the starting index is 11 and the ending index is 17. For information it starts with 38 and ends at 44. So this is how you can actually generate an iterator by using find iterator. And this will return the starting as well as the ending index of the matching object. So if you have any doubts, you can write it down in your chat box. It's pretty easy, guys. So we'll move forward and we'll have a look at the other operations that you can perform with RegEX. So now what I'm going to do is I'm going to match words with a particular pattern. So we have a string in which we have sat, hat, mat and pat. So now my question is to you all guys, what is the pattern that you can see in this particular string, that is sat, hat, mat and pat? So let me go ahead with it and I'm going to show you how you can match words with a particular pattern using RegEX. So first I'm going to open my PyCharm. Let me remove all this. So let me define a string once more. I'll type in str. So we have sat, mat, hat, mat, and we have pat. This is our string. Now I want to match anything that ends with at. So for that I am going to define a variable all str, and now what I'm going to do is re.findAll. Now what I want words that start with S, H, M and P. Alright, and after that it should end with at. So I've written at. It's very simple, guys. And now what I'm going to type in, I'm going to type the name of the string, that is str. So this bracket where I've written SHMP, it shows that I'm matching specifically for the words that starts with S, H, M and P. Now I'm again going to use a for loop in which I'm going to type in for I in all string, give a colon, print I. It's that simple. Go ahead and execute this and see what happens. So yep, it prints hat, mat and pat. But one thing to notice here, guys, it will not print sat. Why it is not printing sat? Because it is an uppercase letter. So if I go here and I make it as capital S and go ahead and execute this, so yep, you can see that even sat has been printed. So let me go back to my slides and see what all other operations that we can perform with regular expressions. Now over here, what I'm going to do is I'm going to match series of range of characters. Now what does that mean? Let me explain you with the example that is there. So now what I want here is I want all the words in which the first letter is between the range H to M. So all the words whose first letter comes in the range H to M should be printed and it should be ending with at. So basically it should print hat and mat because P comes after M, so does S. So it won't print sat and pat. Now let's go ahead and see in our PyCharm whether this happens or not. Now over here what I'm going to do is I'm going to remove this S, so does P. Throw in a hyphen here and execute this. So yep, it has printed hat and mat. So if I want all these things to be printed, what I can do is I can write in here Z and execute this. So yep, it has printed hat, mat and pat, but it has not printed sat. Why? Because it starts with an uppercase S. So if I make it as S and I'm going to print this, so yep, it has printed sat as well, because between H to Z all S, H, M and P lies. So it has printed all the range of characters whose first letter is present in the range H to Z. So now I can use a caret symbol that will include all the words apart from ones which have the first letter between the range H to M. So let me first make it as M, and now I'm going to use a caret symbol. Yeah. So when I use this caret symbol, this means everything apart from this range, that is H to M. Go on and execute this and you can see it has printed sat and pat but not hat and mat because of the caret symbol that I've just shown you, right? So I hope you all are clear with how to actually find a range of characters in a string. And now what I want to replace a particular string. So as you can see in the example, I have a string in which we have hat, rat, mat and pat. But I want to replace this rat. I don't like rats. Alright, so jokes apart, I want to replace this rat and I want to replace it with the word food. Now let me show you how actually you can do that. I'll again open my PyCharm. Let me first remove all of this. I'll define a string. I'll name it as food. Although there won't be any food items in it, but yeah, just for the demonstration purpose. Hat, rat, mat and pat. Now I want to replace rat with food. So now I'm going to compile our regular expression into what are called pattern objects. And pattern objects provides us with additional methods, and one of which is substitute. Let me show you how you can do that. Just type in RegEX, for example. Yeah, RegEX equal to re.compile, and I want to compile R, which ends with at, and now in the string food I want to substitute it. So I'll type in regex dot sub. What I want to substitute food. In which string I want to substitute? I want to do that in the string food itself. So yeah, and now finally go on and print it. So as you can see, we have hat, food, mat and pat. So we have replaced rat with food. So this is a pretty simple examples that I'm giving you right now, but with these basics you can actually go on and find out a pattern and you can perform a lot of operations. Now there's one very important thing that I want to talk about. It is called solving the backslash problems. Now let me show you what I'm talking about. So I have a string. Let me name it as a random string. So I'll write it rand str equal to, here is Drogba. Alright. So when I go on and print this, let me show you what comes. So we got only single backslash, but we have typed in here double backslashes. So this is what I'm talking about. Now in order to solve this problem, what I can do is I can make use of regular expressions. So let me show you how you can do that. So all you need to do is you need to type in re.search. So this is re is basically, we call it as a raw string. So raw string will treat backslashes as special. So let me show you how it will do. I'll just type in re.search, then r quotation Drogba, comma, and the name of the string, that is random string. Go ahead and execute this. So yep, it has solved our problem and you can see that double backslash appears over here. So this is what I'm talking about, the backslash problem. Alright, so we have no doubts. Let me open my slides again and we'll have a look at the other operations that you can perform with random strings, that you can perform with regular expressions. Now what I'm going to do is I'm going to match a single character. So I have 1, 2, 3, 4, 5 as my string, and now I want to print only the 5th digit, so it should print 5. But before that, we'll have a look at a couple more examples in which I'll be telling you about how to deal with white spaces. So let me open my PyCharm again. Let me remove all of this. Yeah. So now I'm going to define one more string. Let me name it as random string equal to keep the blue flag flying high, and Chelsea, this is nothing but my favorite club. And let me just print this random string. So that's printed keep the blue flag flying high. Now let's go ahead and remove the new lines with a space. So for that, what I need to do is, again, I'm going to define a variable. Let me name it as regex equal to re.compile. We have talked about compile in the previous example, so I hope you can remember it. So the symbol for new line, that is a \n. Then I'm going to type in the random string. equal to regex, substitute it with what? What do you want to substitute it with? Just a space, right? So just give a space in between. That's pretty easy, and just type in here random string. Now go ahead and print this random string. Yeah. So as you can see earlier, it was like this: keep the blue flag in one line, flying high in one line, Chelsea in one line. But with the help of regular expression, I have replaced the new lines with a space. So this is how you can work out with white spaces. So this is how you can work with white spaces. Now there are other white spaces that you'll be able to work with. For example, let me just show you. So you have a \b that stands for what? It stands for backspace. Then you have \f for form feed. Then you have \r for carriage return. Similarly, you have \t for tab, and you have vertical tabs as well. So for that we have \v, vertical tab. So these are the white spaces that you can work with. Now let's see how to match a single character that we have discussed in our slides. So let me first remove all of this. Alright, so let me define one more variable. I'll name it as random string again. And I'm going to type in here 1, 2, 3, 4, 5. And now what I'm going to type in print matches. I'm going to give a colon, and then I'll type in length re.findAll \t in a random string. Now over here you can notice that we have \t. So basically this \t will match any numbers, any numbers which are present. But if I write a capital D over here, so it will match anything but a number. So let me keep it as \t and print this and show you what it will give us. So we have 5 matches. As you can see that we have 5 digits. Now if I make it as capital D, so that will return me everything but the digits. So let me just show you. I've converted this to capital D. Go on and execute this. So we have 0 matches now. So now if I want to match a specific digit, I'll be using curly braces. So let me show you how you are going to do it. So in the curly braces, just type in 5 and it should print that for us. So yep, it has found one match that is present over here. So I'll clear this again, and I'm going to define in one more variable. Say let it be num. Over here I have 1, 2, 3. Then I have 1, 2, 3, 4. Then I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and 7. Now we can even match digits with a certain range. Let's say our range is between 5 to 7. So for that, what I'm going to type in, a print statement, and again I keep it as matches, give a comma, and now I'm going to type in length re.findAll. What I'm searching for digits, so \d. And what is my range? Range is between 5 to 7. Give a comma and then type in the string name, that is num. Go ahead, execute this, and it finds 3 matches. Because over here we have 5, over here we have 5 and 6, over here we have 5, 6 and 7. So it has found the 3 matches that we were talking about. So this is how you can perform basic operations using regular expressions. Now we have seen all basic operations that you can perform with regular expressions. Now how about I show you what are the various applications of regular expressions. I'm going to take in some use cases, a problem statement, and I'm going to show you how you can use regular expressions in order to solve those problems. How about that, guys? Alright, so I see a lot of people are interested in that. So without any further ado, let us move forward and see how you can do that. Alright, so we have a first problem in which we need to verify the phone numbers. So we have a list of phone numbers, and the general format of a phone number is it should start with 3 digits, then a hyphen sign, then 3 middle digits, and the 3 digits in between and a sign, and then 4 digits in the end. So this is what our basic format of a number is. So let us go back to our PyCharm and verify these numbers with the help of regular expressions. Let me remove all of this. So before I start writing down the code, let me explain you something. So we have \w. So basically what it does is, it is same as writing down lowercase a to z, uppercase a to z, even numbers and underscore. So lowercase w is actually equal to this thing that I've typed here. So it will match anything that is inside the brackets. When we talk about uppercase \w, it will match anything but the things inside the braces. So it is similar to using a caret inside the brace. So I'll just show you. So it will match everything but the things that are present inside the braces. So this is what I'm going to use in order to write the code for validating phone numbers. So let me just make a string that has my phone numbers. So I'll just type in as phone and I'll put here 412 555 and say 1212. Alright. Now I'm going to use a condition statement that says if re.search, so anything that has 3 digits, then it should have a hyphen sign. Then again anything that has 3 digits, then again a hyphen sign, and anything that has 4 digits, give a colon, go on and print it is a phone number. Now basically instead of \w, I can even use as \d because all of these are digits. But let me just keep it as \w only and go on and print this. So yep, it is a phone number. But what if I am going to change here and I'm going to make it as 5551? Let me show you. It is not printing anything because our regular expression says that it will take only 3 digits. Now as I've told you earlier as well, W takes A to Z lowercase and uppercase as well. So even if I replace it with D, it won't matter. Let me show you. Go on, execute this. So yep, it has not printed anything, but if I go on and remove this 1 and print it again, so yep, it has printed a phone number. Now if I would have added here A as well, it won't print that. So yeah. So basically I wanted to tell you what \w is. That's why I've written it over here. Now let me tell you a use case of this \w as well. So if you want to see that a full name is a valid full name or not, so what you can do is you can use \w at that time. So basically why I've explained you \w is this is how you can use \w. Alright, I'll give you one more example. So now let me remove all of this. And now we'll see if the full name is valid or not. Basically there should be a space between first and last name. So for that I'm going to use a \s, which is same as writing down \f, that is form feed, or a \n, that is a new line, or a \r, that is a carriage return, or a \t, that is tab or vertical tabs. So it is pretty much similar to that. So it is exactly the same. Similarly, if I write here an uppercase S, can you guess what it will be? Alright, so everybody almost guessed it. So basically it will be equal to a caret and form feed, new line, \r, tab, as well as vertical tabs. So it will include anything but \f, \n, \r, \t, and \v. Let me just comment this. Alright. So now let us go ahead and validate whether a valid full name is present or not. So for that what I'm going to do is I'm going to type in a condition if re.search. Now over here what I need to do is, can you guys tell me? Alright, so first I'm going to type in W and range of W should be between 2 to 20. Then in between I want a space, so I can just type in as Now in between what I want, I can have either a new line or a tab or a vertical tab, anything like that. So I can give a \s and one more \w for the last name, and the range of the last name can be from 2 to 20. And finally, I'm going to write the name. I'm going to write my own name, give a colon, and print full name is valid. Go ahead and execute this. So yep, as you can see that it has printed the full name is valid. So if I convert this lowercase s to an uppercase s, it will basically be equal to a caret and form feed, new line, vertical tabs, so anything apart from all of these. So I hope you have understood the concept that I've explained to you till now. Alright, so we have no doubt. So now I'm going to move back to my presentation again. So now this was one use case. Now a second use case is we need to verify the email addresses. So our email addresses should have 1 to 20 lowercase and uppercase letters, numbers, plus, period, underscore, percentage, plus, minus. It should have an @ symbol. Then again 2 to 20 lowercase and uppercase letters, numbers, plus, period, and a hyphen. Then we should have one more period, and then 2 to 3 lowercase and uppercase letters. So let me go ahead and show you practically how you can do it. Let me remove all this. And let me first write a list of emails. So you can write it as sk@aol.com. I can have md@.com, @seo.com. Now I can have one more and I can name it as dc@.com. Let me just remove the space. Alright. So now what I'll type in print email matches, give a colon, and after the space I'm going to type in length re.findAll, open the parentheses, and over there in the square braces, what I want first, I want anything, then I want a period, I want underscore, percentage, plus, hyphen, close the braces, and it should range between say 1 to 20. After that what I want @. After @ I want anything, so for that I'll type \w dot, that is period, then I want a hyphen, and what should be the range? It should be between 2 to 20 characters. After that I want a period, and then I want uppercase and lowercase letters, then it should range between 2 to 3. Email. Alright guys, go ahead and execute this. So it has found only one match, so which is sk@aol.com. Now if I actually copy paste this once more in the end and print this, so yep, we have 2 matches. So this is how you can match the email address. You just need to identify the format of it and you can do it. Alright, so we have no doubts. Now let us move forward and see the third application of Python regular expressions. So you can perform web scraping using regular expressions. Now what is web scraping? Let me explain you with a flow diagram that is there in front of your screen. So we have websites, right? And obviously these websites contains multiple web pages. Now if I want to scrape some useful information from those web pages, I can use web scraping and extract that content, and I can save it wherever I want. I can save it in an XML format or a CSV, basically however I want to save. So you can do that with Python regular expressions. So in our case, what we are going to do, there's a website, and that website we have phone numbers, we have addresses. So what we are going to do, we are going to write a code in order to get only the contact numbers from there. And how are we going to do that? We are going to do that with the help of a regular expression. So for that, I'm again going to open my PyCharm. So guys, I've already written the code. So over here, I've imported a couple of libraries in the beginning, which are used to perform web scraping. I mean, they are used basically to read the web page. Then we have findAll, which we have discussed earlier as well. Now this is the URL that I'm talking about, right? So let me just copy this and I'm going to show it to you in my browser how it looks like. So this is how our web page looks like. So we have name here, we have the address, then finally we have the phone numbers. Now notice the pattern in the phone number. We have 3 digits inside the parenthesis. Then again we have 3 digits. Then we have a hyphen, and then finally we have 4 digits. Just keep this pattern in mind, and we are going to write a code in order to scrape only the phone numbers from this particular website. Now let me close right now. All right, fine. So now you've seen the URL, right? So apart from that, whatever things that are there, actually we have covered that in the web scraping tutorial, so you're pretty much aware about it. So what is this? We are basically reading the content that is there in our particular website. Now we'll focus on the regular expression part. So you know what exactly find all is. We have discussed that. Now since we want only digits, so we are going to make use of this particular identifier, and inside the curly braces I have written 3, which means that there'll be 3 digits inside the parenthesis. After that there's a space, then again we have 3 digits, then we have a hyphen, and then finally we have 4 digits. Then save it in HTML str, and then finally print it. Now let us go ahead and execute this and see what happens. So we have scraped all the phone numbers that were there. This is how it looks like, and we made use of regular expressions. So you can use regular expressions for web scraping as well.
Why we require file handling? Well guys, think about this situation. You have a server running and you need to give access to someone who needs to access it remotely, right? Or basically you need to work with these files in general and say you need to have some import into your program where you're actually configuring an input for it. Well, if I had to answer this personally, how would I go about it? I would be using files for a lot of my deep learning models to import my datasets into the program at all the time. So basically by doing this, I'll be making use of files a lot. So coming back to the basics again. How can we input something into Python? The standard input? The usual keyboard input, right? So you can key in anything you want. Well, there's another case as well. Maybe even command line arguments to input some parameters into the code, correct? But what if you had to read lots and lots of data, which is not practical to type in at every point of time, or even that it doesn't make sense at all to type it all the time? The easiest way out of this here is to actually store whatever input you want in one place and keep using it as long as your requirement is met. So what's the answer? The answer is files, guys. So guys, this concept is actually very easy. I'm sure everyone who's joined will take away some really interesting stuff about Python that you can practically use. Working with files basically opens another door among thousands. And each door with Python opens up to n number of opportunities again. So now that we're good with this and we started off on a really high roll, let's keep it going. Next, we'll be taking a look at some of the types of files available in Python. So guys, let's keep this session very interactive. Head to the comments section and keep the energy going. So can you quickly name all of the types of the files that you know? So again, let me help you here. So we have images, we have audio, we have video, we have text, we have script, and so much more, right? There is a key difference here I want you guys to note. Check this out. Windows supports all of these files that I told and more. Well, virtually unlimited to be honest. But again, I won't get ahead of myself here because there are limitations here as well. Now check out Python. There are two types of files, binary and text. So whatever is not text is binary, as simple as that. So either a file gets to be a binary which contains obviously zeros and ones, or it can have some literal text. Well, text as in strings or anything valid for that matter. Text files are structured as a sequence of lines where each line includes a sequence of characters, and this is what we call as code or syntax, right? And every line is terminated with a special character, what we call as the EOL. What is the EOL? Guys, it's the end of line character. A binary file is any type of file which is not a text file, as I mentioned. And because of their nature, binary files can only be processed by an application that knows and understands this file's system structure. In other words, they must be applications that can read and interpret binary, right? And now that we know what are the types of files are, so we can start looking into more of this. Guys, formally speaking, I think it can be consolidated as the operations performed on a file, right? So what all can we do? Check this out. It's called as the CRUD operations. What is CRUD? Well, create, read, update and delete, guys. These are the operations which can be done with files. Well, again, there are many other operations as well, such as copying a file, changing the properties of a file or anything. But for simplicity's sake, I have planned to keep this session really easy for all of the audience. So let us dive into Python now. So let us quickly see how we can go about understanding the file handling capabilities of Python. Check out this flow diagram to give you a quick picture of what needs to be done. First, we create a file and later we open that file. We work on the file. Well, working on it is basically reading or writing or anything for that matter. And lastly, we close the file when we are done using it. Coming to Python now. Creation of a file can be done manually by the user or through Python. For now, let us consider that we will do it manually by going into the location and creating a file, say like a text file. Later in this session, I'll show you how easy it is to make Python create the file for us. So make sure you stay tuned till the end. So now we concentrate on how we can open a file with Python. Guys, it is very simple. So we have an inbuilt function called as the open function, which is used for this exact purpose. The open function takes in two parameters as seen here. One is the file name and other is the mode. And this on your screen is the syntax for the open function. So what do the two parameters mean? One is the file name that you want to open. It can be anything at this point of time, right? So it has to contain the extension of the file type as well. So this is compulsory and important. So make sure you keep this in your mind. And second, we have the mode. We know this means something that has to do with opening the file, right? So check the screen. So basically, these are various modes available to open a file. We can open it in the read mode, the write mode, the append mode, and even the create mode as well. Pretty straightforward. But do note that the default mode is always the read mode. And guys, note that you can open a file in read mode only if it exists as well. If you try to read a file or something that doesn't exist, then Python will greet you with a beautiful error message. And in addition, if we want to specify if the file should be handled as a binary or a text mode, then along with the mode as well, we can actually push in two categories for it. Check this out. So we have T for text and B for binary. T is the default value and B is for binary modes. So we can have something as WT. So what does it mean? So it basically says that the file needs to be opened in the write mode and the file that the Python opening is a text file. So we're basically making the job of Python to be really easy in this case. So check out the example code I have here for you guys. Even if we do not give a mode, as I said, the default is the read mode. So these two tiny snippets I have for you are one and the same. And yet, make sure something exists before reading that, guys, or else you're sure to hit that error. So check this out, right? So I have f equal to open and the file name is demofile.txt. I don't have a mode here. This is exactly equal to having the read mode in the next example. And it is as simple and straightforward as that. So now we know how we can actually create a file and open it, right? So let's begin working on it. Let us start with creating on how we can actually do a read operation using Python. So the read operation is very easy, guys. So basically, just like all the other functions and handling files in Python, we make use of the read function for this very purpose. But then again, there are so many ways to read a file too. So let me break it down for you, all right? So we can do many things here. We can read an entire file, or read a few characters, or read a few lines, or any number of characters and lines together, and so on. Check out this example code here. So we have a variable, right? We call it file. And then we are opening the file. It's called textfile.txt and opening it in the read mode. Later, we are actually going to make use of the print function to read the contents of the file and print the same on the Python console. Now, similar to the previous code that I just showed you, we have something slightly different here. Can you notice that 5 on your screen? What do you think the 5 indicates here, guys? Let me help you out. So it basically tells the Python interpreter to read the first 5 characters from the file and nothing else. Now check the old syntax. So here we don't have the 5. So we are basically telling the interpreter to read every single valid character present in our file and print it out for us. So you got a good picture of what is happening with the file now? Well, let's quickly take a tour into seeing this practically. So I'll open up my PyCharm now, which I use as the IDE to work with Python, where I'll show you the code for all of these. Guys, you can basically make use of any IDEs that you're comfortable with, and even the console as well. It is your call. I am comfortable working with PyCharm, so I'll go ahead with that. So let me quickly open up the IDE and we can see the basic code to read the file. So as you can check out, I'm here in my PyCharm right now. Importing the OS module is the first line. This is currently being unused right now, but I'm going to talk about this in the future session. So basically, we're opening a file, right? So we have a variable file. We're going to open it and we're providing the entire path to the file present. So here, the file is demofile.txt. This is the name of the file. W is the write mode that I already told you about. Let me quickly go ahead and run this. That ran fine. But you cannot see anything on the output, right? That is because we just opened it, overwrote everything that is present in the file, and we just closed it. So we're not seeing absolutely anything here. Check out example 2. Importing the OS module, file equal to open. Again, we are providing the same file. Here we had write mode and now we are having the read mode. And here we are actually printing it using the file.read. Again, I'll be walking you through file.read in a second, but right now all you need to know is this will print the output on the screen for us. If I go ahead and actually run it, nothing is going to be printed. Why do you think this happened? This happened because we actually used the write mode and we actually blanked out the entire file. Quick fix is to actually open the file. As you can see, nothing is present there. So let me type in something. So we love Edureka. Let me save that, quickly minimize it, go back to my PyCharm. Now as soon as I run this, it is supposed to give me that exact output which says we love Edureka. Perfect, right? So with absolutely 3 to 2 lines of code, you can actually print something on your screen. How simple is this, guys? Well, check out the next case. So again, it's the same thing, opening the file, using the read mode, and then you're printing file.read of 5. Guys, file.read of 5, right? So I actually explained this to you. So let me just go ahead and run it. We'll check the output. We got the first 5 character, right? So W, E, a blank space, L and O. Let us try to make it more nice to look at. Let me just quickly open up the file. Hello world. This is a perfect candidate for our example. Yep, the quick typo. Save it. Exit, back into the code. Now I'm going to run this old code, right? So you're going to get the entire output here. Check it out. Hello world. Perfect. Because we have read of blank. Now we're going to actually run this. Because we're telling the interpreter to read only the first 5 characters of the first line for us, it is just printing hello. How simple is this, guys? So now that we are actually done with this, let's quickly jump back to the presentation to see what's next. Well guys, next I want you guys to check out this syntax, right? So this is what I love about Python. amazing readability, and you can almost guess what it means, and you can be certain of it, say 90% of the time. So we saw how to read characters. Now let us look at how we can read lines. Well, readLine will actually read each of the lines and give us a line by line output. ReadLine of 3 will tell the Python interpreter to read only the third line and absolutely nothing else. But what if we wanted to return every line in a file which is properly separated and nice to look at? Well, you can actually use the same function only in a new form. This is called as file.readLines function. Again, let's take a quick jump back into the code so we can see this in action. So check out example 4 on your screen. I have the same file demo-file.txt. I'm opening it in the read mode and I'm using readLine. Soon as I go ahead and run this, I will have the same output as hello world. Okay, let us step it up a little. Let me just change this. Hello world. We love Python. And we love Edureka. So I have 3 lines here. All good, right? So I'm going to save it. I'm going to close it. I'm going to come back here. I'm going to run the read line. Again, we're reading only the first line. Cool. Check out example 5 now. This is where things get interesting. Import again, it's all the same, guys. So basically, instead of the read line, I have read lines over here. So the S is extra and it's going to read all of these lines and it is going to put it in a really beautiful way for us to see. Check this out. Hello world is an entity. We love Python as an entity. We love Edureka as another entity. And that's nice to look at, right? So instead of just getting a gibberish output of everything in the line, separating it actually makes a lot of sense. So now that we're done with this, another quick hop back to our presentation. So guys, next we need to check out a tiny concept on how we can actually loop over a file object. Well, this is another simple concept, so let me teach you this. We're using the for loop for this very purpose as shown. But why would we want to do this? When you want to read or return all the lines from a file in a more memory efficient way and in a faster manner, you need to use the loop over method. So the advantage of using this method is that the related code is both really simple and easy to understand, right? So let me take another quick jump into PyCharm and check the single snippet out. So we are back into PyCharm and check out this for loop example I have for you. So again, we're sitting on the same file, demo-file.txt, reading it in the mode. So for every line in our file object, print read lines. So it is going to print the output for us containing all of the documents of our file. As you can see, we love Python and we love Edureka. That's really simple, right? And with this, we are actually done understanding how to open the files and read them in multiple ways. Next, we need to actually take a look at the write operation, which is again very simple and almost similar to the read method. Let's start. Writing to a file is as simple as using the write function, guys. Similar to the read again. So to write to an existing file, we make use of 2 modes. One is the append and the other is write, which we already checked out earlier. By append, we actually add the contents of the write to a new existing content. And with write, we just add it to the blank file. Now, I am sure there is a question in your mind right now. So what if the file that I'm trying to work on is not blank? What if it contains some previous data and we make use of W instead of append? Guys, this will basically delete everything in the file and overwrite it with what we've just put. And this is exactly the first example case that I actually showed you. So make sure that you use the mode very wisely in every situation, right? So here's a quick example before we dive right back into code. As you can see, we open a file in the write mode and we write 2 lines into it and we close it. It is as simple as that, right? Now again, taking you back to PyCharm and let me walk you through the code. So guys, we are back into PyCharm right now, so check out the first example I have for you. Import OS, I already explained. Opening it in the mode of write. So since we already have some content, all of that content will be overridden with hello world and hello world again. So we're opening it, we're using file.write to write two content into it, and then we're going to close it. Let me run this. Again, no output because we're not printing it to our console. How do we check if everything is working? Open the demo file. Hello world and hello world again, right? So this is exactly what we wanted. But then again, this looks a bit gibberish as I told you, right? So we use read lines to actually make it look nice for us. Heading back to PyCharm again. Check out the next example I have for you. So now this is to prove that we are actually overwriting it again, which I've already told you and it is simple, but still let me walk you through this. So we're working on the same file, we're using the W mode, and then we're writing it to it saying, oops, we have overwritten it. Run it, it ran, no output, but in the sense the file is changed. So it says, oops, overwritten instead of hello world and that old message that we printed. Let me head back to the PyCharm again. And this is for creation and we'll be coming back to this in just a second. So let's quickly go back to our presentation and then we're going to be coming back to PyCharm again. So we're down to the last two concepts that we will check out in this session. The first one among that is for us to create a new file using Python. Well guys, even for the creation of the file, we need to make use of the open method. We already know that A is used for append and W is used for write. And now we have X, which is used to create a file. But do note that you cannot create two files of the same name, guys. So basically it means that you cannot create a file which already exists. Check out the example on your screen and you will definitely get a better picture of it right there. So you cannot have two files with the same name, testfile.txt. This is not right. So again, Python will give you a beautiful error message and it won't be so beautiful at the end of it. Let me dive back to PyCharm and we can check out the example over here. Let me change this. We have something else, right? So let me type edureka.txt. I'm going to print new file into Edureka. Opening it, we are opening it in the X mode, so we are actually creating this file physically. Write mode to write something into it and close it. So let's run it, no output. Check out the file. Where is the file called Edureka? It is here. New file of Edureka. So it's perfect, right? Let me quickly head back to the presentation and we can check out what's next. And then the next simple concept I have for you guys is showing you on how deletion operation works with respect to files using Python. Guys, deleting a file is very simple and straightforward. We'll require the os.remove function just for this purpose. So yes, importing the os module is a compulsion here. I've been using it all along because it is just a good programming habit to use the os module when you're playing around with the file system. The biggest mistake I have seen people do is that they usually go on to delete a file which doesn't exist. Again, Python pushes in an error message and that is not good at the end of the day, right? So it is very vital to know for sure that the file exists. To do this, we just check if the path exists and if it does, cool, remove the file. Else, print that the file doesn't exist so you cannot remove it. What does this say? Guys, this is a very simple case of an exception handled by the user and this is a really good programming habit too. So all good, but can we delete a folder? Yes, we definitely can. A folder with all the content inside it can be deleted using the rmdir command. What does rmdir stand for? It basically stands for removing directory and the parameter here is basically the path. And by the path, it includes the name of the folder which needs to be removed. And this is all of the operations you can do with Python by making use of files.
Introduction to Python and MySQL. Well, as you already know, Python is one of the most widely used programming language and in demand among developers. But you can't merely develop any application without having to know where to store the data. So this is where database management system comes into picture, and one of the most widely used DBMS server that is also used in the industry practices is MySQL DB server. Let me move ahead and talk a bit about integrated connection. Alright guys, this is just a glimpse of how the bigger picture will look like. What I'm trying to do is I'm basically trying to integrate my Python with my backend database server and then do the further manipulations. Now let me move ahead and explain you the internal working logic behind when you establish a connection between Python and MySQL DB server, or I can say that I'm basically going to explain you the internal working logic, that how does it actually connect or work. So as you can see, there are numerous pictures given in this slide. On my extreme right hand side, there's a picture of a database, and on my extreme left hand side, there's a picture of a Python application, and in between lies the MySQL connector Python API. So MySQL connector Python API is nothing but acts as a bridge between my front-end Python application and my back-end database server. Now when I say this word Python application, think of any Python application. Let's say suppose think of a website which a user has developed, which lies in the front end. Now my front-end Python application will basically send a connection request to the MySQL connector Python API. Then the API will forward the same request to the database, further which the database will accept the request and send the connected message, and then my Python application will send a cursor connection request. So over here, think of connection as a method and cursor as an object, which basically lets you communicate through your entire MySQL DB server and also lets you create your own database. Finally, my Python application will execute a certain SQL statement or a certain SQL query, and for that my backend database server will fetch the result data. So guys, this was it with the internal working logic that basically works behind when the Python and MySQL DB server connection is taking place. Now let me move ahead and talk a bit about operations which I'm going to perform with Python and MySQL. So guys, I'm basically going to perform CRUD operations, which simply means create, read, update and delete with my Python and MySQL. So let me move ahead and show you the implementation of CRUD operations from coding point of view. So let me quickly open my PyCharm. Alright. Guys, before diving deep into the coding perspective, my first and foremost step is to basically import the MySQL connector package. And how do I do that? I'll click on File, click on Settings, click on Project Interpreter. On the extreme right hand side, there's a picture of a plus sign, and then type here MySQL-connector. Alright, click on MySQL-connector, click on Install Package. It will basically take a minute or two to get installed. Essentially, our first step is to install the MySQL-connector package, which forms the stepping stone for our further operations, which I'm going to do. Again, it'll take a minute or two to get installed. Alright, so as you can see, our package MySQL-connector has been installed successfully. Now, one of the other approach to install the same thing is, suppose this is for those set of users who don't use any Python IDE. Suppose you're using a Python command line. So for them, quickly open command prompt. Once your command prompt is opened, quickly go there and type pip install MySQL-connector, which is the package, and press enter. Well, it is going to show me or give me a message that is requirement already satisfied, since I've already imported the package on my PyCharm IDE. But this demonstration I'm showing for those set of users who simply use Python command line. So for them, you can go to your command prompt, type pip install MySQL-connector. Your MySQL-connector package will be installed, and then you can import your same package on your Python command line, and then you can move on with the further operations. So now it's saying me a warning. This is none of our concern, guys. Let me just quickly close it. And as I've already created a file under the name of Python DB creation, I'll move on with my coding demonstration. So let me enter the presentation mode and start off by writing my first line of code. So the first line of code which I'm going to write over here is, I'm simply going to import the package which I installed just now, that is MySQL-connector. I'm sorry, it will be MySQL.connector. Now I'm going to create a local DB instance, that is MyDB, under which I'm going to write MySQL.connector.connect, under which I'm going to pass in the three parameters that are host, which is equal to your local host, then comes the username, that is equals to root, and then comes the password, which is equals to password 123. So root is the default username which I had given, guys, and password 123 can also be customized. So this is the password which I gave. Now I'll merely print this local DB instance, that is MyDB, quickly go ahead and run this code. Yeah, all right. Yeah, so as you can see, the connection has taken place, but how do I verify whether the connection has been established successfully or not? So in order to do that, I'm just going to write two more lines of code. That is, if mydb, then print, that is if it falls or if there's a local DB instance that is mydb, then I'm going to print connection successful, else I'm simply going to terminate this, or I'm going to write print connection, that is if there's a local DB instance that is mydb is coming, or under mydb it is coming, or the parameters are there, then my connection will be successful, else my connection will be unsuccessful. Let me move ahead and run this code. Give me a minute, guys. Well, as you can see, our connection is successful. Now I'll just change one parameter and see whether it's verifying that the connection will be established successfully or not. Now I'm going to change a parameter. Suppose I'm changing the root, which is the default name of user, to RAM, and let's see if the connection is being established successfully or not, or it is being verified or not. Well, as you can see, guys, it shares access denied for user RAM, as because our default username was root, which I had given, so it will not be getting connected to our MySQL DB server. Now let me quickly write back root over here and move on by creating a database. So in order to do that, I'll quickly open file. I'll create a new Python file with the name as Python DB creation. Let me just name it Python DB1 creation. Now I'm going to write my first line of code, that is importing MySQL.connector, which is the package. Then I'm going to write mydb is equals to MySQL.connector.connect, under which I'm going to pass in the three parameters that are host, which is equals to your local host. Then comes your username, that is equals to root, and then comes my password, that is equals to password 123. Finally, I'll move on and I'm going to show you what I'm going to do over here. So I'm going to create an object with the name as myCursor, under which I'm going to pass mydb.cursor, which is pointing towards the location. And finally, I'm merely going to print this object, that is myCursor.execute, under which I'm going to write create database, and let me say my database name is 𝐏𝐲𝐿. Alright, and then I'll quickly move ahead and run this code. Let's see what is the output. Alright, so it says that the database has been created, that is 𝐏𝐲𝐿 has been created. Now I'm going to show you whether this database is existing in our MySQL workbench or not. So in order to do that, I'll just change few parameters and add a for loop. I'll explain you about the for loop part later. So let me just omit this part, 𝐏𝐲𝐿, and instead of create, I'll simply write show over here, and then over here I'm going to write show databases. Now I'm going to write for db in myCursor. I'll simply print the database. Alright, move on and run Python DB1 creation file. Well guys, as you can see from the output, the reason why I used a for loop over there is because once my code enters the for loop, it is basically printing all the databases which are existing in our MySQL workbench along with the database 𝐏𝐲𝐿 that we have just created, which is there in our output. So it's very clear. Now I'll quickly open my MySQL workbench and I'll write the same SQL query over there so that it's crystal clear to you. Alright, let me quickly maximize it. 1 second. Now let me simply write show databases and click on execute. 1 minute, guys. Well, as you can see, our database 𝐏𝐲𝐿 has been created along with all the other databases which are existing in our MySQL workbench. Now let me just refresh the schemas. Alright, so let me just minimize this and I'll move ahead by creating a table under the database. So I think you guys are pretty clear with the concepts which I explained just now. I basically started off by creating or by establishing a connection between our Python and MySQL DB server. Further, I moved on and created a database, and now I am moving on and creating a table under the database 𝐏𝐲𝐿. Now how do I do that? Well, let me create a new file first. 1 second, I'll name it as create tb and python. Alright guys, before moving ahead, I'm going to tell you one thing. The first 3 or 4 lines of code are going to be same everywhere. I don't find it useful by repeating the same first 3 lines of code everywhere again and again. I don't want to bore you guys with the same thing. So let me just copy paste it into the presentation mode. Yeah, Control V. Now I'm going to write myCursor.execute. It's going to be create table. Suppose I give my table's name as employee, under which let me pass 2 parameters. They'll be name varchar 200, salary integer 20. We just close it, move on, execute this code. Well, I have done a very silly mistake, guys, and the error is also very self-explanatory. It says no database selected. I'm going to pass a parameter over here. It's going to be database is equals to ℏDB. And let me quickly move ahead and run this code. 1 second. Yeah. Alright, so when I run this code, our table has been created. Now I'm going to show you the table which I've just created in our database ℏDB. So I'm going to write the same code what I wrote while I was showing you the database. So let me just omit these things and add an S over here. And instead of create, let me just add a show. And let me type a for loop. So it will be for tb in my cursor print your table. Alright, now let me move ahead and run this code. So as you can see, we have created only one table under the database ℏDB. So it is showing that table, which is employee. Now I'll show you the table in our MySQL workbench. So 1 minute, guys. So instead of databases, let me just write tables. Let me just select the ℏDB thing over here. Instead of databases, let me just write tables, select ℏDB, and then execute this. Yeah, so once I execute this, well, as you can see, it is fetching the table, and our table employee has been created on the extreme left hand side under the schemas column. Now I'll quickly minimize this and I'll move ahead by doing the read operation. So before I dive deep into the read operation, guys, let me give you a small introduction about this. So our read operation will basically happen in 2 stages. In my first stage, I'm going to populate my table with some values. And in my second stage, which will be the main stage where I'm going to do the read operation consisting of 2 fetch functions. So I'm going to talk about the fetch functions later. First, let me just, in order to populate my table, I'm going to make use of insert command from the SQL query. So let me just name it as insert op table and move ahead. Yeah, Control V. Before, there's one more parameter which I left. It's going to be database is equals to ℏDB. Now moving on, let me create a new variable with the name as SQL form, and under SQL form I'm going to write the SQL query insert into employee. 1 second, guys. Pass in the 2 parameters which I declared, which were name and salary, values, and make use of, or I'm going to write %s, comma, %s. Well, guys, these %s are nothing but placeholders. You can replace them anytime you want with any other value. Now I'm going to create a tuple. Now the reason why I'm creating a tuple is because, again, in my second stage where I'm doing the read operations, I'm going to make use of 2 fetch functions. So there's one fetch function called fetchAll. So when I'm making use of fetchAll, I need not populate my table with a single value because that will not look good. That's the reason why I'm creating a tuple over here, so that to give you more clarity into what actually happens. Now, let me just name it as Harshit. Let me give my salary as 20,000, comma, Amit, salary as 30,000, comma, Ankita, and her salary as 40,000, comma, space. Yep, I think I need to put this back. Yeah. Now when I move on, I'm going to simply write my cursor dot execute many, because if I use execute, it is just gonna execute a single value. But since I'm making use of a tuple over here, I need to write myCursor.execute many and call in SQL form, comma, employees. And finally, I'm gonna write mydb.commit, which is gonna save my changes from my last executed SQL statement. Now let me quickly move ahead and run this code. So as you can see, our insert operation has taken place and our tuple has been inserted into the table employee under the database 𝐏𝐲𝐿. Now, I'll quickly exit the presentation mode and show you the same in our MySQL workbench. It's going to be the same thing. I'm going to write select star from employee and click on employee, click on execute. 1 second, guys. Yeah, I'll click on the result grid over here. Well, guys, as you can see, this select star from ℏdb.employee, well, it changes nothing. Our concern is to basically view the tuple which we have created, and that tuple is being viewed in the result grid. That is under name and salary, the values which we pass, that are Harshit, Amit, Ankita, with the salary as 20, 30 and 40,000. Let me quickly minimize this, and moving ahead, I'll be creating a new file, and let me just name this file as readop table. All right. Now into the presentation mode once again, copy the first 3 lines of code over here. What I'm going to do is, let me pass the parameter database, which is equals to ℏdb, and then I'm going to start off my read operation by the first function, that is fetch one. So let me write my code, and then side by side I'm going to explain you also why am I writing that part. So I'm going to simply write myCursor.execute. Let's say I'm going to write a SQL query, that is select name column from employee. Okay, this is a very simple SQL query, and let me create a new variable and let me name it as my result. Under my result, I'm going to write myCursor.fetch1. Now guys, this is one of the most important part of my code, because this is the first function of read operation. What fetch1 is going to do is, it is going to fetch me one value from the column name under the employee table. Alright, now when I move on, let me write the for loop, that is for row in my result, print the row, and when I run this code, as you can see, it has fetched the value Harshit from the row name under the table employee, which is again under the database ℏdb. As you can see, this code is pretty self-explanatory. When I make use of the fetch1 function, it basically fetches a single value from the column name under the table employee. Now, let me just quickly move on with my next function of fetch. In order to do that, let me just make few changes in this code. So instead of name, suppose I'm going to fetch the whole tuple. It's going to be select star from employee, and instead of fetch1, let me write here fetch all, and let me run the for loop. So it will be for row in my result, print row. Alright, now when I run this code, I'll explain you why am I doing it, or what does fetch all do. Well, as you can see from the output, the whole tuple has been fetched. Now when I make use of the fetch all function, guys, it basically fetches the whole tuple for us, as because we are writing the SQL query select star from employee. So all the values which are there in the employee table, which was in the form of a tuple when we inserted it a while ago while we were writing the insert code, that whole tuple gets fetched. Now I'll exit the presentation mode. I'll go to the MySQL workbench and rerun this code once again. Well, as you can see, there are no differences. The name is still there with the values Harshit, Amit, Ankita, and salary 20,000, 30,000 and 40,000. Suppose I write this thing, select name from employee. 1 second. I'm going to show you the changes of the fetch1 functions. In order to do that, let me just write name again over here, name, and instead of fetch all, let me write fetch1. Alright, let me quickly go ahead and run this code. So as you can see, it is fetching here Now I'll go to the MySQL Workbench and click on same thing. Well guys, these changes are not taking place over here because we were showing you the changes in the PyCharm, and since we applied a for loop over there, that's the reason why it is doing it. But since when we are using the backend database server, we need not do that because we are not using any loop or we are not doing anything. We are simply fetching the name whole column from the table employee. Now I'll move on and do the update operation. So in order to do that, let me just create a new file, a new Python file, and name this as update pop table. Yeah, let me close this. Let me just click on this, enter presentation mode. Yeah, control V. Let me pass the parameter which was database, that is equals to 𝐏𝐲𝐿. Moving on, let me create a new variable with the name as SQL, under which I'm going to write update employee set 1 second salary. Let me set the salary to 70,000, making use of the where clause, where name is equals to, let's say I'm updating Ankita's salary to 70,000. And finally I'm going to write my cursor dot 1 second execute, call in the SQL thing, and then write my db dot commit. You quickly go ahead and run this code. Our update operation has taken place, and in order to see the changes, let me quickly go back to the read operation. I'll show you the changes on both places, in the PyCharm and MySQL Workbench too. So the last code which I wrote, let me remove this and right here select star from employee. This was fetch all. Okay, enter the presentation mode once again. Yeah, run this code. As you can see from the output, the changes have taken place and Ankita's salary is updated to 70,000, which was 40,000 before. I'll quickly move on and show the same changes in the MySQL Workbench. So it's quite easy. Let me just rerun this code. This should be star over here. Yep, and then execute it. As you can see, Ankita's salary over here is again updated to 70,000. Now I'll move on and do the last operation, that is delete operation, which will also conclude my tutorial. It's going to be delete op, let me name it as table. Alright, enter the presentation mode once again. Copy the first 3 lines of code. I'll pass here the database parameter. Database is equals to 𝐏𝐲𝐿. I'll move on and let me make use of the same variable which we used that time. Say suppose delete from employee where name is equals to, suppose I'm deleting my record guys, which is Harshit, and then my cursor dot execute all in SQL, and then write my db dot commit, which is gonna save the changes from my last executed SQL statement. Let me quickly go ahead and run this code. Well, the database spelling which I used is wrong, I guess. Well, as you can see from the error, it's quite justified. It says unsupported argument database. So the database spelling is wrong. Let me quickly rectify that. 1 second, guys. Yeah, I'm gonna write A over here. I missed it. My bad. And run this code once again. So as you can see, our delete operation has taken place, and I'm going to show you the changes. Exit this. We'll go to read op. I'll enter the presentation mode once again. Run this code. Well, as you can see, the record Harshit has been deleted from here, and the same thing would be, or the same changes would have taken place in the MySQL Workbench. Let me quickly open it and run this code once again. Well, as you can see, the record Harshit is deleted from here too.
What exactly are sockets? Sockets are basically interior endpoints built for sending and receiving data. A single network will have 2 sockets, one for each communicating device or a program. These sockets are a combination of IP addresses and port numbers. Guys, a single device can have n number of sockets based on the port number that is being used. Different ports are available for different types of protocols. take a look at this table for common port numbers and the protocols. As you can see over here, the HTTP protocol uses the port number which is 80. Similarly, FTP uses 20, NNTP uses 119, etc. Let me just jump onto my browser to show you all how this actually works. As you all can see over here, in the address bar, I have the address of google.com. Now we've just learned that google.com makes use of port number 80. Let me just give the address of Google along with port number 80 and see how it works. So I'll just use google.com : and I'll use 80. As you all can see on the screen, when I used google.com with the port number 80, it has returned the same Google page. Now let me change the port number and let me give 20 as the port number, which I know is for FTP protocols. So I'll just type Google over here, google.com : 20. So I hope you're clear with this, guys. When I gave google.com : 80, it returned the same Google page. But when I gave google.com : 20, it has returned that this site cannot be reached. Okay, so I hope everyone's clear with this. So now let's get back to our presentation and see how to create sockets in Python. To achieve socket programming in Python, you will need to import the socket module or the framework. This module consists of built-in methods that are required for creating sockets and help them associate with each other. Some of the important methods present in this module are the socket.socket method, which is used to create sockets. This method is required for both clients as well as servers in order to create sockets for both of them. The socket.accept method. This method is used to accept a connection. It returns a pair of values of connection and address, where the connection is a new socket object for sending or receiving data and address is the address of the socket present on the other end of the connection. Socket.bind method. This method is used to bind the address that is specified as a parameter. The close method is used to mark the socket as closed, whereas the connect method is used to connect to a remote address specified as the parameter. Socket.listen method is used to enable the server to accept connections. Now that you've understood the importance of socket module, let's move on to see how it can serve to create servers and clients. Okay, so guys, before creating them, let's first understand what exactly are servers and clients. A server is either a program, a computer, or a device that is devoted to managing network resources. Servers can either be on the same device or computer or locally connected or even remote. There are various types of servers such as database servers, network servers, print servers, etc. Servers commonly make use of methods like the socket method, bind, and the listen method, etc. to establish a connection and bind to the clients. A client, on the other hand, is either a computer or a software that receives information or services from the server. In a client-server module, client requests for services from the server. The best example for this is a web browser such as Google Chrome, Firefox, etc. These web browsers request web servers to send required web pages and services as directed by the user. Other examples of clients include online games, online chats, etc. Now that you've understood the concepts of clients and servers, let's move on to PyCharm to create them using Python. So I have a new project over here. I'll create a new Python file and I'll name it as server. Or I'll say server1. Like I've already told you before, to achieve socket programming, you'll have to import the socket module. So for that, I'll just use import socket. Okay, so after this, what I have to do is create sockets using the socket method. So I'll just use s equals socket.socket. And within the bracket, I'll specify the address family as AF_INET. So socket.AF_INET. AF_INET refers to address from the internet, and it requires a pair of a host and a port number, where the host can either be a URL of some particular website or its address and the port number is an integer. The second parameter I'll specify is socket.sockstream. Socket_sockstream is used to create TCP protocols. Okay, so the next thing we have to do is write the bind function. Now this bind method accepts two parameters as a tuple, which is a host and a port number. Okay, so now I'll be using the bind method. So s.bind, and as a parameter, I'll use getHostName. Now this method is used when the server as well as the client are on the same computer or device. And after this, I'll just specify a port number. I can specify any of the port numbers greater than 1023, which are non-privileged port numbers. So I'll just give the port number as 1024. Now I've used the bind method because I want my server to bind to the client. Now I'll use the listen method. So I'll just pass the parameter as 5. Okay, now while the connection is true, I want my server to accept the client socket and its address. So I'll just use CLT and ADR for address, and I'll use the accept method for this. Now once I've received this from the client, I want to print it. So I'll use the print method, and over here I'll use the fstring. So guys, fstring is basically a literal string prefixed with an F, and it contains Python expressions within braces. So over here I'll just give some message. I'll just say connection to, and within braces I'll specify the address, established. So once the connection is established, I want to pass some message from the server to the client. So I'll just use clt.send. And since I want it to be bytes, I'll use bytes. And within this, I'll write some message, say, for example, socket programming in Python. So this is the message I want to pass from the server to the client. And since I've used bytes over here, I have to specify what kind of bytes. So I'll say UTF-8. Okay, so our server is ready now. Now let's move on to create our client. So I'll just open a new file in the same directory. And I'll give the name as client1 again. Okay, so as you all know, the first thing you'll have to do is import the socket module. And after that, use the socket method to actually create a socket for the client. I'll just copy this from here and I'll paste it over here. So now I want my client to connect to the server, so I'll use the connect method. So s.connect, and I'll specify the parameter as getHostName. And over here as well, I have to specify the same port number which I've used in my server. So I'll just cross-check what number I've used over here. It's 1024. I have to specify the same port number on the client side as well. After this, all I have to do is save the message that I'm receiving into some variable. So in my case, I've just named it as MSG. And then I'll have to use the receive method. To this receive method, I can specify any number of bytes as a parameter. And that many number of bytes will be received in one communication between the server and the client. So in my first case, I'll just use 1024. Don't get confused, guys. Here, it's just the bytes number and this is the port number. Okay, after this, I'll just print the message that I've received. So MSG dot. Since the message being transferred was encoded, I'll have to decode it using the same UTF-8 bytes. Okay, so our server and client is ready for execution. To execute these two files, I'll just open up the command prompt. And over here, I'll just use py server filename.py. So server1.py. Sorry guys, I've just missed out braces over here. Okay, so I'll just save this and I'll run this again. So as you can see this cursor blinking over here, which means our server is ready. But it does not show anything as of yet because we have to execute the client as well. So to execute the client, I'll open up another command prompt window. And this time I'll just use py client1.py. Oh, our client has not received any message. Let me just go to the window where I executed the server and see what is the issue. As you see over here, I've made a spelling mistake. I'll just jump onto PyCharm. And this is not SNED, it's SEND. Sorry for that. I'll just save this and execute my server again. I'll execute the client again. Okay, so congratulations guys. Our server and client have communicated and the server has passed the message we specified from the server to the client. As you can see on the window where we executed the server, it says connection to the IP address and the port number has been established. And the client has received the message that we wanted our server to send. But wait a minute guys, Let me just go back and change the number of bytes that we've specified. So I had originally specified the number of bytes as 1024. Now let me just change it to some other number, say for example 7. I'll save this and I'll rerun the client again. I hope you see the difference. The first time we specified was 1024 bytes, which was a very large amount of bytes that my client was accepting from the server in one communication. When I reduce the number of bytes to 7, what I've received is just socket, and the remaining message is not received and the communication has been terminated as well. But this is actually an error in real scenarios. Now what should I do to make my client communicate again and again until the message is received from the server? Let's go back to our PyCharm and make our client server communicate until the complete message has been received. I'll keep the number of bytes as 7 itself. So all I have to do over here is include a while loop. So I'll just use while true. This needs to be indented into the block. I'll save this and I'll rerun the client. So I hope you see the difference, guys. The first time we gave 1024 bytes, we received the complete message in a single communication. In the second example, I just changed the number of bytes from 1024 to 7, and all I received was just socket, and the remaining message was not received and the communication was terminated as well. As you can see, after this, when I included the while loop within the client, you can see over here that my client and server have communicated multiple times and the complete message has been received in a number of communications. So first thing that I received was socket. After that, I received program ing in Python. So I hope you're clear with this client and server communication. Okay, so as you can see over here, the complete message has been received in 7 bytes per communication. Our client and server have communicated multiple times so as to receive the complete message. But there is an issue again. The client has not been terminated, and we actually will not know when this client will be terminated. To avoid this, all we can do is go back to our client program and make a small change. So over here, I'll just specify complete information to be received. I'll just store an empty string into this variable, and this will actually allow my client to accept any information that is being sent from the server. Now, after using this receive method, all I'm going to do is use an if block. If the length of the message is less than equal to 0, then I want this loop to break. And if not, I want the complete info to be printed in 7 bytes per transfer. So instead of using this message.decode over here in the print statement, I'll use it over here. And after this, all I have to do is print the complete message. Now, why I'm decoding this over here is because I'm receiving one chunk of the message at once. So I want to decode it as and how I'm receiving it. After that, I'll just print the complete info that's been received. I'll save this program, get back to my server, and once this is done, I want the communication to close. So I'll use clt.close method over here. I'll save this and I'll rerun my server and client again. One more change you'll have to do over here is the port number. Since one communication is already present on the port number 1024, I'll just change it to 1025. I'll have to do it on the client as well as the server side. So I'll just change it to 1025. I'll save this. I'll open up the command prompt and I'll execute our server first. Now I'll open up another command prompt to execute the client. I've missed a colon sign in the if loop. Just open up the client, save this, and I'll rerun again. Sorry guys, I've just missed a less than and a colon size over here. Okay, I'll just save this and I'll go back and I'll rerun my client. So I hope everyone's understood this. I've received the complete message from the server. It's done in 7 bytes per communication, as well as the client has been terminated. Okay, till here you've just got the knack of transferring strings. But socket programming in Python allows you to transfer Python objects as well. These objects can be anything like sets, tuples, dictionaries, etc. To achieve this, you will need to import the pickle module of Python. Python pickle module comes into picture when you're actually serializing or deserializing objects in Python. Before moving on to show y'all how objects can be transferred from server to the client, let me just show you how these objects are actually serialized using the pickle module. I'll jump onto PyCharm again. I'll open up a new file, Python file. I'll just name it as pickle example. Okay, I'll import the pickle module. And then I'll just specify some list over here as my list. So I want to serialize this Python object, which is a list. I'll just store it into a new variable as ser. I'll have to use the dumps method, which is present in the pickle module to do this. As a parameter, I'll specify the list that I've already created. I'll just print the new list which I've saved in ser. Okay, now let's execute this one. So as you can see in the output over here, guys, I have the serialized list. I have the numbers 1, 2, 3, 4 present somewhere in some serialized manner. And this is prefixed with a B. Now this B actually means that this is in bytes. Now that you have a brief idea about this pickle module, let's move on to see how you can use this in socket programming to transfer objects from the server to the client. Okay, I'll just open up the file where I've already written this program and I'll explain this to y'all one after the other. The first thing that I'll have to do is import the socket module as usual, and I'll have to import the pickle module as well. After this, all I'm specifying is some header size as a equal to 10. You can give the header size as anything of your choice. After this, I've just used the socket method again to create a socket for the server side and the bind and the listen method, which I've already explained previously. Following that, I just have a while loop just like before, and in this case, instead of passing the message as socket programming in Python, I've just given some dictionary over here, which is M, and I've used the dumps method present in the pickle module to serialize this object, which is a dictionary. So after this, all I'm doing is incrementing the my message and finally sending it to the client using the send method. Now I'll just open up the client file and explain what's going on over there. The first thing, as we all know, is importing the modules that are required and then specifying the header size, which we've already done in the server side. After that, as usual, I have created a socket for the client and I've used the connect method to connect to the server. Now, the complete information that is received from the server to the client is supposed to be in bytes. So I've just specified B with an empty string. Then I've just specified that the message being received from the server to the client as true. Now while that is true, I want to receive 16 bytes per transfer. And if the message being received is completed, then the receive message variable will be set to false. If not, it will be incremented and the next chunk of message will be received in 16 bytes per transfer again. After this, all I'm checking is for the condition if the complete information received is equal to the length of the message that's originally present on the server side. I'm just printing a message saying receive the complete information. As I already explained before, I used the dumps method of the pickle module to serialize the information I was sending from the server to the client. Now to deserialize the same message, I'll have to use the loads method. So to this method, I've passed the complete information that I've received from the server to the client as a parameter. And after that, all I'm doing is printing the message that I'm receiving from the server to the client. Now let me just open up the command prompt and execute these files. So first I'll execute the server. And I'll open another command prompt to execute the client. So as you can see over here, guys, the complete size of the message is 38 bytes, and this is the serialized form of it. And this is our dictionary that we've passed from the server to the client.
So what is NumPy? NumPy is basically a module, or you can say a library, that is available in Python for scientific computing. Now it contains a lot of things. It contains a powerful n-dimensional array object, then tools for integrating with C, C++. It is also very useful in linear algebra, Fourier transform, and random number capabilities. Now let me tell you guys, NumPy can also be used as an efficient multi-dimensional container for data, for generic data. Now let me tell you what exactly is multi-dimensional array. Now over here, this picture actually depicts multi-dimensional array. So we have various elements that are stored in their respective memory locations. So we have 1, 2, 3 in their own memory locations. Now why is it two-dimensional? It is two-dimensional because it has rows as well as columns. So you can see we have 3 columns and we have 4 rows available. So that is the reason why it becomes a two-dimensional array. So if I would have had only one row, then I would have said that it is a one-dimensional array. But since it contains rows as well as columns, that is, it is represented in a matrix form. That is why we call this as a two-dimensional array. So I hope we are clear with what exactly two-dimensional array is. So let me open my PyCharm and I'll tell you practically how to actually create a NumPy array. So this is my PyCharm, guys. Over here, the first thing that you need to do is first install the NumPy module. And how you're going to do that, click on File, go to Settings tab, and you'll see the Project Interpreter option. And on the right hand side, you'll see a plus symbol. Just go on and type the module that you want to install. So I'm going to install NumPy. Just go there, click on it, and install package. I've already done that, so I'm not going to repeat it. So this is my PyCharm. So first thing that I need to do is import NumPy as NP. Now after that, I need to create a NumPy array. So for that, I'm going to define a variable, let it be A, and I'm going to type in here np.array and certain elements inside it. So I'm going to put in 1, 2, 3 and print it. That's all. So this will actually print a single dimensional array. So 1, 2, 3 has appeared. Now if I want to convert this to a 2D array, so for that I'll keep this in parentheses, and after a comma I'll add one more element, and I'm going to give certain values inside that. So I can give, say, 4, 5 and 6. Now go ahead and print this. So as you can see that it is now a two-dimensional array. So this is how you actually create arrays using NumPy module. So now I'm going to open my slides and we'll move forward and see what is our next topic. Now let us see why are we using NumPy instead of a list. Alright, so many of you might be thinking, why are we using NumPy when we have lists? Alright, so basically we use NumPy because of 3 main reasons. The first thing is it occupies less memory when compared to lists. Then it is actually pretty fast when you compare it with list, and at the same time it is very convenient to work with NumPy. So these are the 3 major advantages that NumPy has over lists. And that is the reason why we use NumPy instead of lists. Now don't worry, I'm actually going to prove it to you practically by opening my PyCharm. So guys, this is my PyCharm again. So first thing that I need to do is import NumPy as NP. And now what I'm going to do is I'm going to import a couple of more modules. I'm going to import time and I'm going to import sys. Alright, done. So our first step is to actually define a list. And the name that I'm going to give to my list is, say, S, and I'll type in here range 1000. So what this will actually do, it'll actually take all the integer values between 0 to 1000 and it will give it to a variable S. So this list will contain the integer values between 0 to 1000, but it won't include 1000. It will be only there till 999, that is 999. And now I'm going to print the space occupied by this particular list. So for that, what I need to do is I need to type in print sys.getSize of any one element. Okay, so you can give 3, 4, 5, anything. I'm going to give it as 5, any one element, and multiply that with the length of my list. That's all. So this will actually give me the space that has been occupied by the list, because sys.getSize of will actually give me the memory occupied by one element, and when I multiply that with length of my list, I get the entire memory that has been occupied by my list. Now the same I'm going to do with my NumPy array as well. Let me give a name to that. I'm going to type in d np.aRange, and the range will be 1000. Now aRange function is pretty much similar to the range which is there. So the same thing will happen here. The integer values between 0 to 1000, but it won't include 1000, will be present in my variable d. So we have created a NumPy array. Now let us print the space occupied by it. So the first thing is I'm going to type in here d.size. So this will actually give me the space occupied by one single element, and when I multiply that with the length of my NumPy array, I get the entire memory that is occupied by the NumPy array. So I'm going to type in here d.item size. That's all. Now go ahead and print this. So this actually shows the memory that has been occupied by my list, and this shows the memory that has been occupied by my numpy array. So as you can see, there is quite a lot of difference between both of them. So we have proved our first point that it actually occupies less memory. Now when I talk about numpy array is faster and more convenient than a list. So the next step is I'm going to prove it to you that numpy array is actually faster and more convenient than list. So I'll remove all of this, and so now I'm going to show you that numpy arrays are faster than lists. And at the same time, it is easier and more convenient in order to work with numpy arrays when compared to lists. Let me show you practically. So first what I'm going to do is I'm going to define a variable, say size, which is equal to say 1000, and then I'm going to define two lists. Now what I'm going to do is I'm going to add those two lists as well as I'm going to add two numpy arrays, which I'm going to define now. And then I'm going to compare the time taken in order to find the sum for list and the sum for numpy arrays. So first let me define two lists and two arrays. So my first list will be equal to range size. Same goes for my second list as well. Just change the name to L2. And now I'm going to define two numpy arrays, A1 equal to np dot a range size. Go ahead and do the same for the second numpy array as well and change the name as A2. So we have two lists and two arrays, and we need to compute the sum of both of these lists as well as arrays. Now before that, I'm going to define a variable, say start, which is equals to time dot time. And now I'm going to calculate the sum. So I'm going to save that in result. And first I'm going to calculate the sum of list, that is L1 and L2. So for that, what I need to do is I need to run a for loop, because if I directly write L1 plus L2, it is going to give me a result which is nothing but the concatenation of both the lists. So in order to calculate the sum, I need to use for loop. Let me show you how to do that. First I'm going to type in x comma y, and we have already studied loops in detail. For x comma y in zip, and the name of the two lists, that is L1 comma L2. That's all. So what will happen here, it will first take the first element of list L1 and then it will take the first element of list L2. It will calculate the sum and it will store in result, and it will keep on repeating until the range has been exceeded. Now this is how you calculate sum in lists. But when you talk about arrays, what you need to do is you need to just write in A1 plus A2. That's all. That's why I'm saying that it is more convenient in order to work with numpy arrays when compared to lists. Now our next step is to define the same variable start and initialize it with time.time. And now I'm going to find the sum of my two numpy arrays, which is nothing but A1 plus A2. That's all. And now print the time taken. So print time.time minus start, and then multiply it with 1000. Because by default it will take it in seconds and I need to convert it into milliseconds. Now I forgot to actually print the same thing for my list, so I'm going to do it over here. So this will actually give me the time taken by my list in order to compute the sum, and this statement will give me the time taken by my numpy array in order to compute the sum. So let us go ahead and execute this and we'll see what happens. So it gives me 0 milliseconds because the size is small. Let me just add a couple more zeros. Let's make it 1,000,000. Now go ahead and execute this. Now you can notice the difference, that there is a significant change. Lists took 208 milliseconds, whereas numpy array took almost 67 milliseconds. So there's a huge difference between the compute time of a list as well as numpy array. That's why I say that numpy array are faster, convenient, and at the same time they occupy less space when compared to list. So that is the reason why we choose numpy arrays over list. So let us go ahead and move forward towards the next topic, that is numpy operations. So let me go back to my slides. So now is the time to see various operations that you can perform with the numpy arrays. So you can find the dimension of your array, whether it is a two-dimensional or a single-dimensional array. Then you can even calculate the byte size of each element. It is pretty easy. I'm going to tell you that practically. You don't need to worry about that. And you can even find the data types of the elements that are stored in your array. So if you want to know what is the data type of the elements, you can do that as well. So let me show you these three operations first, and then we'll move forward to the other operations. I'm going to open my PyCharm once more, guys. Let me remove all of this. So we have imported the numpy module. Now what I'm going to do is I'm going to define a numpy array. I'm going to name it as A, and I'll write here np.array 1, 2, 3. Put that in parentheses. Now add one more element, say 2, 3, 4. Alright, so it's a two-dimensional array. Now if I want to know whether it's a two-dimensional or a single-dimensional array, so I'm just going to type in print a.endim, and it'll give me the dimension. So let me show you that, and I'm going to run this. So it says 2, that means it is a two-dimensional array. So what if I move this part and make it as a single-dimensional array? It should give us the result as 1. Let's see if it does that or not, and yep, it gives us 1 as a result. So this is how you actually calculate the dimension of your array. Now if you want to find the byte size of each of the elements, so what you need to do is, instead of endim, you can call a function called item size. Go ahead, execute this, and you'll get, so each element occupies 4 bytes. After that, if you want to know the data type that is stored in the array, so you can just type in here dtype. Go ahead, execute this. It should give us integers 32-bit. Alright, so this is how you can actually perform these 3 functions that I've told you in my slides. So let us proceed with the presentation. Now let us move forward and see what are the other operations that you can perform with Numpy module. So by using Numpy array, you can actually find the size of your array. How you can do that I'll show you practically. You don't need to worry about that. So when I say size of the array, that means the total number of elements that are present in the array. So if this is an array, so the total number of elements become 4. 1, 2, 3, and 4. Now you can even find the shape of your array. Now what do you mean by shape? So basically the total number of columns and rows. Now over here we have 3 columns and 4 rows. So our shape is actually 3 columns and 4 rows. Now let me show you practically how you can do that. Again, I'm going to open my PyCharm and show you. Let me remove this print statement from here. Now if I want to find the size of my numpy array, I just need to type in print a.size. That's all you have to do, and it'll give the size of your array. So there are 3 elements. So if I go on and add some more elements, say 4, 5, 6, 7, then if I execute this, you'll see that 7 elements have appeared. That means the total number of elements in my array is 7. Then comes the shape part that I was talking about. So in order to find the shape, what you can do is you can just type in here a.shape, and it'll give you the shape. So let us see what happens. So it has 7 columns, but there are no rows, so it has given 7 comma blank. So what I can do is I can close this in parentheses, and I can define one more element, say 8, 9, 10, 11, 12, 13, 14. Go ahead and execute this, and you can see 2, 7 because we have 2 rows and 7 columns available with us. So this is how you can actually find the size of your array, as well as you can find the shape of your array. Now let us move forward and see what are the other operations that you can perform with Numpy module. So we saw how to find the size and the shape of an array. So we can perform reshape as well as slicing operation using Numpy array. Now when I talk about reshape, what do you actually mean by reshape? Geography, alright, fine. So that is absolutely correct, guys. Now over here there is an example. So we have 3 columns and 2 rows, which we have converted to 2 columns and 3 rows. Now let me show you that practically how you can do it. In a variable, and I'm going to start a numpy array, and I'll have 2 elements in that. My first element will be 1, 2, 3, 4, and my other element will be, say, 3, 4, 5, 6. So I have a 2-dimensional array that contains 2 rows and 4 columns. Now I can convert that to 4 rows and 2 columns. Let me show you how to do that. You're just going to type in a is equal to a.reshape, and I want to convert it to, say, 4 rows and 2 columns. Go ahead and print this. So it has converted that to 4 rows and 2 columns, as you can see in front of your screen. Now let me show you that earlier this is not the case. I'm going to type in a print statement here as well in order to show you that how it has reshaped. So earlier we had 4 columns as well as 2 rows, but now we have 2 columns and 4 rows. So this is how you can perform the reshape operation. Now let us talk about slicing. So slicing is basically extracting a particular set of elements from your array. And the slicing operation that happens here is pretty much similar to the one which is there in list as well. So suppose if I want only this particular element, that is 3. So for that, what I need to print, I'll show you, print A and the index value of 3, which is present at 0, comma, and the index is 2. Let me tell you how indexing happened. So this element will be 0, this element will be 1. Now if I want 3 from here, from the 0th element, I want the index 2. Indexing starts from 0, 1 and 2. So that's why I've written 0, 2, and it should print 3 for me. Let us see if it does that or not. And yep, it prints 3. Now say if I want to print 4 and 6. Now for that, what I need to do is I need to remove this 2 here, and I'm going to put a colon that says all the rows including 0, and in that row I want only index 3. So we have only 2 rows, so if I would have written 0, 1, then it wouldn't have included this particular row. So if I have one more element here, so I can actually write here 2, so that won't actually include the element which is present at the second index. So when I say 0, this actually means all the rows that include 0 as well. So we have only 2 rows, it will include both the rows, and at the same time it will actually going to print the third index from both of these rows. So let me show you if that happens or not, and yep, it happens. We have 4 and 6 available with us. Now just to remove confusion, what I'm going to do is I'm going to add one more element, and I'm going to give values to it, say 7, 8, 9 and 10. So now if I want 4 and 6, I can't just write 0, because if I do that, it'll print 10 as well. Let me show you that. Yep, it has printed 10. Now in order to avoid that, what I can do is I can write in here 2. So as I've told you, this is the 0th element, first element and the second element. So when I write 0, 2, it won't include the second element. It'll only include 0th as well as the first element. Now inside that, we have index 3 from both of these rows. That is why we'll actually get 4 and 6. Let us see if that happens or not. And you can see 4 and 6 is now available. So this is how you can perform slicing when we in Numpy arrays. Now what I'm going to do is I'm going to type in a equal to np.line space, and now over here first I'll write 1, say 3, and I want say 5 values between 1, 3. What this will do is it'll actually print the 5 values which are equally spaced between 1 to 3. So let me print this first. I'm going to type in print A and go ahead, execute this, and you can see that we have 1, then we have 1.5, then we have 2, 2.5 as well as 3. So if I would have written here 10, it will actually give me 10 values between 1 to 3. And yep, you can see we have the 10 values between 1 to 3. So this is how you can perform line spacing as well. So we saw how to perform reshaping and slicing. Now let us see what are the other operations. So we are now going to find out the minimum, maximum as well as the sum of our numpy arrays. So let us go ahead and execute that practically. Let me remove all of this, and now I'm going to define one more numpy array, np.array, and I want elements in it, say 1, 2, 3. Now if I want to find the element which has the maximum value, so what I can do is I can just type in here print a.max, that's all, and it'll give me the maximum value in my a numpy array, which is 3 obviously. If I want to find minimum value, so I'm just going to type in here min, and it'll print the same for me, which is 1. Now if I want to calculate sum, it is pretty easy. Just go on and type sum and it'll give you the sum. That's all guys, it's that simple. Whatever I'm telling you, these are all the basics that you require. After that, whatever your requirement is there, on that basis you need to use those basic knowledge that you have and implement it. Now the best way to do that, the best way to understand any programming language is to play around with it. So you know the basics. With the help of those basics, just install PyCharm first, then try out new things like how should I get that, how should I get this, and if I'm not getting it, what is the reason behind it. So go on and try to discover new things. So the conclusion is you need to actually perform things practically. You need to make sure that you are not only getting the theoretical knowledge, you need to perform it practically. That's why I always say that side by side when I'm executing these practicals, you need to do that as well. Although you might find it pretty basic, but with the help of this knowledge, you can perform a lot bigger task as well. Alright, so Janice looks happy now. So let us move forward with our slides. So now comes the axis concept here guys. It is pretty similar. We have a numpy array which looks like this, and the rows are called axis 1 and columns are called axis 0. Now you must be thinking, what is the use of this axis? Suppose if you want to calculate the sum of all the rows, then you can actually use these axes and you can do that. Now let me show you practically how it happens. I'm going to open my PyCharm again and I'm going to show it to you. Let me remove this and let me add one more element here. 3, 4, 5. All right. So if I want to find the sum of axis 0, it's very easy. Just go on and type print a dot sum and type in axis equal to 0. Go ahead and print this and you can see 4, 6 and 8. 1 plus 3 is 4. 2 plus 4 is 6. Similarly 3 plus 5 is 8. If I make this as axis 1 and print this, so it gives me 6 and 12. Because 3 plus 2 plus 1 is 6. Similarly, 4 plus 5 plus 3 is 12. So this is pretty easy, I know. Now let's go back to our slides and see what are the other operations. So there are many mathematical functions that you can perform with NumPy. That is to find the square root of each element. You can even find the standard deviation. So these two operations can be performed with the help of NumPy. You can find the square root, you can find the standard deviation. Now let me show you that how you can do it. This is my PyCharm again. So now I'm going to remove this print statement here and I want to print the square root of each of the elements that are there in my NumPy array, which is actually assigned to a variable a. So I'm going to type in here print np dot sqrt, that is square root of my NumPy array a. Go ahead and execute this. And it is actually printed the square root of each of the elements. The square root of 1 is 1. For 2 it is 1.414. For 3 it is 1.73. Again for 3 it is 1.73. Then for 4 it is 2. Then for 5 it is 2.23. This is how you can find the square root of each of the element. Now when I talk about standard deviation, so you can find that by typing here. So now if I want to find the standard deviation, what I need to do is instead of sqrt, I'll just type in here std. And it'll give me the standard deviation, that is how much each element varies from the mean value of my NumPy array. And this is the standard deviation, guys. It's that simple. So this is how you find standard deviation. Now let us go back to our slides and see what are the other operations that are still left. Now these are the basic mathematical functions that you can perform with NumPy arrays, like addition, multiplication, subtraction and division, and that will actually happen element wise. So basically you are performing matrix addition, matrix multiplication, matrix division, as well as matrix subtraction. Let me go ahead and show it to you practically. It is very simple, guys. So similarly I'm going to define one more array and let me name it as B. Let me remove this print statement. Now if I want to calculate the sum, so what I need to do is I need to type in print A plus B. That's all you need to do. But when I talk about list, again I'm telling you that when I talk about list, if I do that, it will concatenate both the lists. So if I want to print list, that is the addition of two lists, I need to use for loop. So that is where NumPy array stands apart and it is pretty convenient. Go ahead and execute this and you'll see that element wise addition has happened. 1 plus 1 is 2, 2 plus 2 is 4, 3 plus 3 is 6. Similarly 3 plus 3 is 6, then 4 plus 4 is 8, 5 plus 5 is 10. Alright, so this is how you can perform addition. You can perform subtraction by using the subtraction operator. Go ahead, execute this and you'll find all zeros because 1 minus 1, 2 minus 2, 3 minus 3, 3 minus 3, 4 minus 4, 5 minus 5 will be 0 only, right? No rocket science. Now go ahead and multiply it as well and see what happens. So you have 1 into 1 is 1, 2 into 2 is 4, 3 into 3 is 9, again 3 into 3 is 9, 4 into 4 is 16, 5 into 5 is 25. If I go ahead and divide this, it'll give me all ones and yep, it does. So this is how you can actually perform addition, subtraction, multiplication and division using a NumPy arrays. Now let me go back to my slides and see what are the other operations present. So now guys, let me tell you one more thing. If I actually want to concatenate two arrays, I don't just want to add those two arrays. You can say that if my one array is a box, then I want another array on top of it. So let me show you how you can do that. Actually, there are two ways to do that. One is called vertical stacking and another is called horizontal stacking. Let me show it to you one by one. First, I'm going to show you vertical stacking. For that, what I need to do is print np.vstack and a comma b. Let us see what happens when I run this. So we have 1, 2, 3. 3, 4, 5. Then again we have 1, 2, 3 and 3, 4, 5. So this is called vertical stacking. If I want that horizontally, I'll just write in here ℏstack, and I'm going to run this now, and you can see that we have 1, 2, 3, then again 1, 2, 3. That means these two are present added horizontally, and we have 3, 4, 5. Again we have 3, 4, 5. So this is how you can perform stacking as well. Now there's one more thing that I want to show you. If I actually want to convert this particular numpy array, that is A, to say a single column, so how I can do that? Just type in here print a dot revel. That's all you have to do. Go ahead and execute this. So you'll have 1, 2, 3, 3, 4, 5. So you have 1, 2, 3, 3, 4, 5. Let me go back to my slides and see what are the other topics that we are going to cover. Now come certain numpy special functions. Now I'm going to talk about sine function and cosine function first. So what I'm going to do is I'm going to use this cosine and sine function, and I'm going to plot sine and a cosine graph. So for that I'm going to import a module called Matplotlib. So you don't need to worry about that module because I'm going to discuss about Matplotlib in the upcoming sessions. So there'll be a detailed session especially on Matplotlib, so you don't need to worry about what exactly Matplotlib is and how it works and all those things, because that'll be covered in the upcoming session. For now, what we are going to do, we are just going to use sine and cosine function in order to print their graph. So for that, I'll open my PyCharm and let me remove this and import matplotlib dot pyplot as plt. Now we are going to define two coordinates, that is x and y. First, x is equal to np dot arange 0, 3 into np.py, 0.1. Now I'm going to define y. So for that I'll type y np.sine x. Now I'm going to use plt in order to plot the graph x, y. Now finally show the plot. For that I'll type plot.show. You must plot.show to make a graphics appear. So plot.show, and here we go. Go ahead and execute this and you might be able to see a graph, and yep, it is here. Similarly, what if I change the sine to cos and should give me the cosine graph? Go ahead and run this and you can see we have a cosine graph as well. Similarly, if I write in here tan, that is any other trigonometric function, and I print this, so I get the graph for tan as well. So I'll open my presentation once more and we are going to see what are the other special functions that we can use with numpy. Now numpy comes with two very good functionalities, I would say, that is called exponential function and logarithmic functions. Now exponential, this e value is somewhere equal to 2.7 and we all know log. So when I talk about log, it is actually log base 10. And when I'm talking about natural log, that is log base e, I will write it as ln. So instead of that, I've written log, that means log base 10. So you can perform these operations with the help of numpy. Let me show you how you can do that. So I'll open my PyCharm. Let me remove this. And I'm going to define a numpy array. Let it be ar equal to np.array 1, 2, 3. Now I want to calculate the exponential value. I'm going to throw in a print statement and I'm going to write in here np.exp ar, and this will calculate the exponential value for me, and let us see if it does that or not. So yep, as I've told you earlier as well, value of e is 2.71. So e to the power of 1 is actually equal to e, so it has returned the e value, but e to the power of 2 will be somewhere equal to 7.38. E to the power of 3 will be somewhere equal to 20.0855. Now in order to calculate log, what you can do is you can just type in here log. Now this will give you natural log. So when I talk about natural log, it is nothing but ln, or you can say log base e. But if I want to calculate log base 10, so I need to type in here 10. First let me show you how you can find the natural log. Just go ahead and execute this. Alright, so when I talk about 1, so e to the power of 0 will be equal to 1, right? So log or ln ar equals to 0. Similarly, the other values as well. Now if I want log base 10 instead of ln, or you can say natural log, I can just write in 10 and go ahead and execute this and you'll find log base 10 values. So obviously when answer is 1, that means anything to the power of 0 is equal to 1. So the answer will be 0 here, and similarly we have other answers as well. If you're unsure about it, you can open your calculators and do that.
So let us go ahead and take a look at what exactly is Pandas. So Pandas is a Python library which is used for data manipulation, analysis and cleaning. And Python Pandas is well suited for different kinds of data, such as we can work on tabular data with heterogeneously typed columns. We can work on ordered and unordered time series data, arbitrary matrix data with rows and column labels. We can work on unlabeled data, and we can also work on any other form of observational or statistical data sets. Now I'm going to tell you how you can install Pandas on your systems, guys. It's very easy to install Python Pandas. You just go to your command line or terminal and just type pip install pandas, or if you're working on an IDE such as PyCharm, you can just simply type in pip install pandas in your terminal over there, or you can just open the project interpreter and add the library over there. Since we are going to work on Jupyter Notebook, I'm going to tell you how you can install Python Pandas on Anaconda. So you just have to do one thing. So I'll just show you guys how you install Python Pandas on your system. You open the Anaconda prompt. We'll wait for the prompt to set up. So you type conda install. It's already there in my system because I have already installed Pandas, since I have already worked on various data analysis projects, and it's a very integral part of it. Because to work on a data set, to read a data set, you require Pandas, and it's just that you cannot work without Pandas if you're working with any data related project. So this is how important Python Pandas actually is. I'm going to tell you a few applications of Pandas as well. So first of all, you can just say that Python Pandas is an integral part of data, whichever project you're working on. So you can work on economics. You can use Python Pandas for stock prediction. You can use it for recommendation systems. Then you can use it on neuroscience and statistics also. You can use it for, and then there is advertising, so many data coming from different platforms. You can just analyze the data using Pandas, clean the data for irrelevant, inconsistencies in your data. You can do that using Pandas. And then you can use it for analytics as well. That's the very basic use of Python Pandas that I can think of. So right now that we know how Pandas actually is in Python programming and what it is used for, let's go ahead and take a look at the very integral part of Pandas, that is data frames and series. We'll wait for this to install, guys. Meanwhile, I'll just tell you what are data frames and series, guys. So data frame is a two-dimensional, and the size of the data frame is mutable, potentially heterogeneous data, or we can call it heterogeneous tabular data. So the data structure, which is data frame, also contain labeled axes, which is rows and columns, and arithmetic operations align on both rows and column labels. It can be thought as a dictionary-like container for series objects. Now, what exactly is a series, guys? So a series, or a Pandas series, is a one-dimensional labeled array capable of holding data of any type, which is integer, can be string, float, Python objects, etc. And the axis labels are collectively called index, and Pandas series is nothing but a column in an Excel sheet. So let's just take a look at a few examples, and then you'll be able to understand this better, what I'm talking about, like Pandas and series, what exactly they are. We'll be working on an example now. So I'll just take it to Jupyter Notebook, guys. So we have already created a Jupyter Notebook. If you are not familiar with Jupyter Notebook, guys, we have a full tutorial on how to use Jupyter Notebook, all the cheat sheet and everything. So you can just refer to those in our Edureka YouTube channel. And make sure you subscribe to Edureka for more exciting tutorials, because we have a lot of content on Python, guys. So if you want to learn Python inside out, or any other technology for that matter, we have a lot of content on YouTube you can refer. Also, if you are at it, be sure to check out our courses on edureka.co, and we have a full Python programming certification program that you should also check out. So since I have already installed Python Pandas, I'm just going to import Pandas as PD. Run this. I'm not going to face any problem running this command because I have already installed Pandas. Okay. So what this command will do over here, it's going to install the package, the latest release of Pandas for me. I think that's why it's not running. Okay, we have our first statement over here, and we have successfully imported Pandas as PD. So I'm using the alias as PD. I hope you guys know what alias is. So let's just say I'm importing this library. So alias is going to be this one, that is PD. So for importing, I'll tell you why I'm using this. Now if I want to create a data frame, I'll just use df as my variable name for data frame. So I'm going to use the alias. Now when I type tab over here, okay, so this is how I can use my alias to create a data frame. So this is just to tell you how you use an alias. Now I'm going to show you how you can create a series and a data frame. So first I'm going to, I'll have to import NumPy as well, because I'm going to use it to create a null value. All right. So df is equal to, I'm going to make a series, so I'll just write it as s. All right. Series, and I'm going to pass a list of values. Let's say 1, 2, 3, 4, 5, 6. And I'm going to use my NumPy now to create a null value like 8, 9, and one more value, let's say 10. So it's going to create a series. Now when I print s, so we have a series which has indexes which are already there, and all these values that I pass inside a list. So this is how you create a series in Python, guys, using pandas. After this, I'm going to tell you how you create a data frame. So for that also, I'm going to tell you how you create a data frame using a dictionary object, and how you can create a data frame using series as well. So now what we are going to do is we are going to create a data frame by passing a NumPy array with a datetime index and label columns. So I'll take one variable, let's say date or dates. I'll just type it as D, and I'm going to take PD dot. So we're going to take the date range. And after this, I'm going to pass a few values, let's say 2020, and I'm going to pass values like we're in the month of March, so I'll just write it as March. And after this, I'm going to take periods, which is equal to, let's say 10. So this is my date range, guys. Okay, I have an invalid syntax, right? Should work fine now. So when I print D over here, so I have all these values in a date range format. After this, what I'm going to do is I am going to take one data frame, which I am going to take as df for obvious reasons to make it clearer. And I'm going to take data frame, and inside this I'm going to pass a few values. So first of all, I'm going to take a few random values. So I'm going to use np.random number, and inside this I'm going to pass 10, let's say 4. And now I'm going to get the index values as D, and I'm going to have to pass a few more values, which is columns. So I'll pass the columns as a list, and I'm going to take, let's say 4 columns. So I'm just going to take, wait a minute, A, B, C, D. All right, do we have any errors? No. So now I'm going to print my data frame. So I have a data frame, guys, which I've created using, passing a NumPy array, and I have a datetime index with labeled columns, which are A, B, C, and D. This is my index, guys, and I have all these random values using NP array. So this is how you create a data frame, guys. Just a simple example, and I'm going to show you how you can create a data frame by passing a dictionary of objects that can be, converted into a series also. So I'll take, let's say again, df is equal to pd dot data frame, and I'm going to pass a dictionary over here now. So I'm going to take a few values first of all. So first value is, let's say A. Now after this, I have to pass something, right? Okay, I'm going to write, let's say, a list of 1, 2, 3, and 4. After this, my next value is going to be, let's say B, and I'm going to pass a timestamp, let's say. And for timestamp, I'm going to use the same I have used over here, 2020 0301. I have to use the right. And after this, I'm going to pass one more value, let's say C, and I'm going to use a series now, a series object. And inside this, I'm going to pass 1, and the index is going to be, let's say, range Alright, index is equal to a list with a range of 4, because we have only 4 values over here. We don't want any null values. And after this, I have to type in the data type as well, the data type of the series, guys. So for that, I use dtype is equal to, let's say, float 32. Alright, after this, I provide my next value, which is d. Now for d, I'm going to use an numpy array. And for this, I'm going to pass a value, let's say not 3, let's say 5 multiplied by 4, and let's take the d type is equal to integer 32. Yes. All right, now I take my final value, which is going to be e, and inside this I'm going to pass a data frame, or we're going to use the categorical object, guys. We're going to talk about this later on in the session, so don't worry. I'm just showing you how you can create a data frame using all these objects that we have at our disposal, guys. Now, instead of test and train, we can just call it as true or false. It doesn't matter. We are taking categorical object, so it has to be either true or false, or it can be 0 or 1, but it has to be decisive in a way that there are only 2 values. So I take another value, and for this, let's just say I give the value Edureka. Alright, so our dictionary is done over here. So we have created our data frame, guys. There's no error. Now when I print this, so we have our data frame, guys. So A, B, C, D, E, and F. So we have all these values using different data types, or we can call it objects as well. So for that also, we can check the data frame, and we just write d types, and it's going to give us all the data types that we have. So we have date timestamps over here, integer, float, integer, category, and an object, because I have used a string over here. That's why it is giving us an object. But in the new release, that is Python 1.0.0, it's not going to be an object. It's going to show you it is a string. So don't worry, guys. And we have already made a video on Python Pandas 1.0.0 with all the features that have come with the new release, the new stable release released last month. You can check that out as well to check for the new features that we have come across. So now that we have done this, let us take a look at the next topic that we have, which is how to view data. So viewing data is basically, how you actually look at the data, or how you're going to look at the data using Pandas library. So we'll just jump right to Jupyter Notebook, guys, and I'll tell you what kind of functions or all those things you have at our bay that we can use to view our data. So we'll do one thing. First of all, we have data frames already that we have over here. So I'll do one thing. I'll just change it to df1 so that we have different data types, or I'm sorry, different data frames, guys. I'll run this, and this as well. Now when I check for df.dtypes, it should be different, guys, because we have already made a data frame using that. All right, it's not. So I'll run all the So I'll do one thing. I'll restart and run all the cells so that we have 2 different data frames. So first of all, the first very basic thing that you can do for your data frame is to use, I'll just tell you guys, you write df.head. So what this function is going to do is give you the first 5 values inside your data frame, or the first 5 rows. And similarly, for the last rows, you can use the tail method. So this is how you get the first and last values inside your data frame. So it's going to display all the 5 values that you have at your beginning and the end of your data set. After this, we have df.index. So what this will do is it will give you all the values from your index. And similarly, we have df.columns, which is going to give you all the columns from your data frame. So this is how you view your data, guys. And then we have dataframe.toNumpy, which is going to give you a NumPy representation of the data. So I'll just tell you how you can do that. So I'll just write df.toNumpy. Wait, Just a second, guys. Yes. So I'm going to create a NumPy array using this. I actually created a NumPy array, and for df our data frame of all floating point values. Data frame dot to NumPy is actually fast and does not require copying the data. So it is a very best deal for we have. And then okay, I'll just remove this. I don't want this. And then we have data frame dot describe, which is going to give you somewhat like this, which is going to give you the count, the mean, the standard deviation, minimum, 25%, 50%, 70%, and maximum. So these are all values using the describe you can have, which is going to give you an idea or a perspective of how your data actually is and what kind of calculations are already there that you can think of. Then we have sorting by an axis. We can sort our data using an axis. So for that you have to just write, okay, I'll just show you guys. You just have to write df dot sort by index, and inside this you have to give the value of the axis. I'll just give 1, and then let's say ascending, you want it to be ascending. No, I'll just write it as false. So it has given me the data frame by sorting the index. Similarly, I can sort it by the columns as well, or I'm sorry, sort it by values. So I'll write it as values, and I want to give the value as say values, and I'm going to give the value as, let's say, by, I want to sort it by C. It has sorted the values depending on C. So this is how you sort your data frame, guys. And now that we know how we can actually look at our data, I'm going to tell you how you select particular values inside your data, guys. I'm going to show you how you select a single column from your data frame. So we'll write df. It's very simple, guys. To get a value from your data frame using only a single column, you can write A or let's say C. So it's going to give all the values from C over here. It has actually given you frequency. It has given you name, data type as well. So this is how you actually get a single column from your data frame. Now let me show you how you can slice the rows as well. So for that, we are going to use the slicing. If you have actually worked on list comprehension, so we have slicing the data over here. We are going to follow the same principle here as well. So I'll just write df. Now I want my first, starting from my first value to third value. So it has given me only 3 rows, starting from the 0th row, and it has given me third row. And it does not actually include the third row because it starts from 0. So I'm giving 3 values. If I write 6 over here, I'm going to get the 6th value, but it's not going to be at the 6th row because the first row over here is going to be 0th row. I hope you understand this, guys. So I have shown you how you can slice your data, to get particular number of rows. Now let me tell you how you can select the data using the labels, guys. So for that you have to use df dot, there has to be location, loc, and inside this you're gonna pass the values by labels, guys. All right, so let's pass d, that is, and 0. So let's see what the output is, guys. All right, so we have got all the values using the label, that is d over here, which we have passed over there in our previous section where we have declared the data frame. And I'm sure this is visible to you guys. Now the next thing is selecting data on a multi-axis by label. So what we'll do is we'll write df.loc, and after this we write hyphen, and we're gonna create, let's say, A, and we're gonna pass C, right? So it's gonna give me the values accordingly, which I passed over here. So instead of A, I can write B, or I can write D. So this is how you can select multi-axis using labels, guys. And I have written this over here, so I can just write, let's say, 0 to 3. Let's see what happens. Oh, we have an error, guys. You cannot do this. So we'll now move on to the next topic that we have, is showing label slicing. Both endpoints are actually included. So how do we do that? So instead of this, we can just, let's say, copy this, paste it over here, and copy this, paste it over here, remove this. So this is just to show you guys how you can work with it. I'm very certain that the data that you work on is not going to be like this. It's going to be very complicated. So this is just to give you a perspective as a beginner how you can work with pandas. Now I'm gonna tell you how you can reduce the dimensions of the returned object as well. So for that, you just type one thing, guys. You remove all this, get just one value, and this is gonna give you the column number at over there. And this is how you get the values inside a data frame. So moving on, let's say we want to get a scalar value. So for that, we just write, okay, let's say D0. Right, let's see if it works. We're getting the same values, guys, only from the 0th row. For getting the fast access to a scalar, you can just write as df instead of loc, we can just write at. Okay, we have an error, guys. I'll just remove this and let's see if it works. Yes, so I'm getting the exact value at the 0th row at the column number C. Now I'm going to tell you how you select a value from using the position inside your data frame. So for that, we use df.iloc. All right, so let's say 3. Okay, so I'm getting all the values from third column. And similarly, we can slice the data. You can just get it like 3 to 5. All right, we can add more values to this, like 0 to 2. So this is how you select the values from your data frame, guys. Now we have Boolean indexing as well inside our data frames. So I'll just tell you quickly what it is. So for that, you just write df. Now I'm going to check if df column number A, let's say this is interesting, guys. So it has given me all the values inside A where A is greater than 0. If I write it, let's say 2, I have no values because none of the values are greater than 2. So this is how you can get the Boolean indexing. This is actually important when you're applying functions to your data frame, guys. So moving on, let's take a look at another method, which is isIn method. I'll just tell you how it works, guys. So it's basically is to check if the particular value inside your data frame is in there or not. Now there's one more thing. We can set new values inside our data frame. We can set a new column which automatically aligns the data by the indexes. So for that, we can make the series, and we can set the values by label. We can set the values by position, and we can set the assigning with a NumPy array as well. And the result of the settings will actually align with the data frame, where a new operation with the setting can be followed, where you can simply align the data frame with the existing data frame. Now let's go ahead and take a look at the next topic that we have, which is handling the missing data inside your data frame. So let's jump right to it, guys. We'll go to Jupyter Notebook and we'll work with our missing values now. So pandas primarily use the value np.nan to represent missing data. It is by default not included in the competitions, and we're going to see the missing value right now. So first of all, you have to reindex. You have to do reindexing, which is going to allow you to change, add, delete the index on a specified axis, so which is going to return a copy of the data as well. All right, I'll just take df2 is equal to df.reindex. So this is how I'm going to do the reindexing, guys. So index is equal to, let's say, d0 to 4. Yes, I'm going to get the columns after the reindexing, which is going to be equal to list of df.columns, and I'm going to add one more column, which is going to be, let's say, E. All right. Now what I'm going to do is I'll do loc. I'm going to check a few values. So instead of dates, I've taken D, guys. So D of 0 and D of 1 at E is equal to 1. Now let's check what is df2, guys. We have two null values over here. So this is how I'm going to show you how to handle missing values inside your data frame. So we have done reindexing. So first of all, I'm going to check for null values. So we have true over here, and we can get the count as well. Is null and we count these null values. All right. Right now we are going to drop a few columns. So we are going to drop the NA, that is the NA values. So as you can see from our data frame, all the values that had null values are dropped. Actually, the whole column has been dropped. Or we can do one thing, fill in the missing data, guys. Just do one thing. Okay, check df2 we have. So we can do one thing, we can fill the missing values, and we are going to provide some value. Let's say value is equal to 2, right? So we have actually filled the value with some other value. Wherever there is a missing value, we have given a value that is going to fill over there. So this is how you get, or check for all these missing values inside your data frame. After this, you can now actually get a boolean mask where values are NaN, which is null. So for that, you do pd dot is NA df2. So this is going to get you a boolean mask, which I've already told you how you can check using df dot is null. Same thing, but different processes to run this. Now let us move ahead and to the next topic that we have, which is Pandas operations, guys. Pandas operations are nothing but a few operations that you can apply on the data frame or any other Pandas object. So we have descriptive statistics that we can apply. We can apply functions, histogramming is there, and string methods is also there. So I'll tell you what histogramming is when we are talking about it. So let's take it up to Jupyter Notebook again, guys. I'll tell you how you can actually work with Pandas operations. So first of all, I'm going to tell you a basic operation, which is that is a descriptive statistics. So it's going to give us all the mean values. Similarly, we can get one value like df dot mean, provide one value over there. So this is how you get it, guys. Or we can write it as 2, right? All right. So this is how operating with objects that have different dimensionality and need alignment. In addition, Pandas automatically broadcasts along the specified dimension. So for that, let's make a series. I'll tell you just how it works. pd dot series, give it a few values. Let's say 1, 2, 3, np dot nan 5. I'm sorry, 4, 5, and then give the index value. The index is going to be dates. And let's just shift all this 2 places, right? We have made an error, guys. Length of pass value is 6 and index implies 10. So we have to actually put more values. So write 6, 7, 8, 9. Yes. Now when I print s over here, we have all these values. Now we can do one more thing. So we write it as df dot sub, and we pass the s over here, which is our series, and we make an axis, write it as index. So we have operated with objects that have different dimensionality and needed alignment. So in addition, Pandas actually helped us automatically broadcast the specified dimension. So now I'm going to talk about applying functions to the data. So we already have data frame. Let's see what we have. So we have this data frame, guys. So what I'm going to do is I'm going to apply a few functions. So first of all, I'm going to use the apply method over here. And let's see what all do I have. Let's just check. We have absolute import, all close, a max, a minimum, angle, any append, all these functions that I can apply on this. So let's say we have 𝐏𝐿𝐴𝐿. Let's see what this does, guys. All right. So this is how it works. Now let's apply a few more functions, guys. So I'll write lambda x. So we are talking about lambda functions here. I'm sure most of you must be aware of the lambda functions that we have in Python. If you don't have any prior knowledge on lambda function, guys, there is a full tutorial on how lambda function works in Python, guys. So this is how we applied lambda function to get the subtraction between the x max and x minimum. All right, for all the columns we have the subtraction between all these values. So this is how we apply functions to our data, guys. Now I'm going to talk about histogramming. So histogram is a representation of the distribution of data. So this function we have, which is matplotlib.pyplot.hist, on each series in the data frame, resulting in one histogram per column. So what we'll do is we'll make a series and it's going to give us value counts for histogramming. How do we do that actually? So we can just write as dot value counts, right? Let's see if it works. Right, we have one value for each. So this is how we get or do the histogramming with our data, guys. Now I'm going to talk about the string methods. So series actually is equipped with string processing methods in the string attribute that actually makes it easy to operate on each element of the array. So let's just move ahead with the example. So I'll make a series, guys, pd dot, let's say series, and inside this I'm going to pass a few string values. So I'm going to start with Edureka, write Python next. Let's write Jupyter, give it a few null values as well to make it a little or slightly different from perfect. All right, so give it a few values, let's say football. And looking at the current scenario, let's write world. So we have a series over here, guys. Now what we'll do, we'll take or use the string methods. So I'm gonna make it all to lower, which are already lower. So I'll make it to upper, guys, upper letter words. So everything we have changed using the string methods inside our Pandas series. These are all the operations that you can perform on Pandas, guys. So let's move ahead to the next topic that we have, which is merging. So in merging, we are basically going to merge two data frames together. So we have two functions, which is concat and join. So concat pandas objects along a particular axis with optional set logic along the other axis. It can also add a layer of hierarchical indexing on the concatenation axis, which may be useful if the labels are the same or overlapping on the past axis number. So let's take a look at the example for this. So we have our data frame. I'm going to use pd dot data frame. Give it a few values, let's say np dot random number from, let's say, 10 and 4. All right, so we have all these values. Now what I'll do is I'll break it into the pieces. So how to do that? So let's say I write it as df2 is equal to df from first to third row. The next one is df from third to, let's say, seventh row, and then we have df from seventh to the end of the data. So this is how I am going to break it into the pieces. Now when I write it as df2, we have 3 data sets. Now I'm going to use the concatenation function using concat. All right, I'm gonna concatenate df2. So this is how I've concatenated the missing pieces, not the missing pieces, the several other pieces together using the pandas concat function. Now let's talk about the join function that we have. So for this, basically I'm gonna tell you how you can do the left and right join. So for the left join, I'll write left is equal to pd dot data frame, and let's see, first value, let's say a, give it a few values, let's say 1, 2, and then say b, we have 3, 4. All right, we make it for the right as well. So I'm just gonna copy all this, paste it over here. Okay, I'm just going to write it as D. This is going to be, let's say, C, and change a few values. So we have left and right, and I'm going to just type left, and then we get the output for right. So I'm going to join all these two using the join function. So for that, I'm going to use the merge function, and inside this, let's say left, we have right, and on is equal to, I'm going to join it at let's say A. Let's see how it works. Okay, it doesn't. So we have a key error, which is A. So I'll change it to A, guys. So we actually joined using the merge function over here. And another example that I can think of is, let's say we have left and right. We can change the values differently, and we can just group them together. Now what I'm going to talk about is grouping, guys. So how you do the grouping of different data inside your data frame using Pandas. First of all, for that, you have to split the data into groups based on some criteria that you have. And then after that, you apply some functions on them. And then later on, you can combine the results into a data structure. So first of all, you have to get a data frame, guys. So let's see, we have a data frame over here. So we can actually group it by, let's say, right, I'll just write group by, say, A, and I'm just gonna sum. Right, we have an error, guys. So we have a key error, that is A, because we don't have over there. So I'll write it as, let's say, 2. All right, we don't have 2 as well. We have a key error. We don't have 2 over there because it's not a string value, it's an integer value. So we have our values right over here. So we have grouped the data using the column that is number 2. Now we can actually group the data by multiple columns and form a hierarchical index. So for that, I'll just copy this, guys, or over here only I'll just do one thing, 2 and let's say 3. So this is how you actually combine multiple columns to form a hierarchical index. But here again, we don't have actually categorical values for these columns. If we had, we'd be able to do that. You know, if we had, like, let's say true and false, it is going to have created a hierarchical index which will have different values for true columns and for false columns. So that's how you do the grouping, or that's where you actually need grouping using Pandas. Now let's move ahead and take a look at the next topic that we have. Okay, we have already talked about operations, then I have talked about merge, where we have talked about concat and join, and then I've talked about splitting the data, how you apply the functions, and then combining the results together. Merging, we have talked about grouping. Now I'm going to talk about stack and pivot table. So what exactly is a stack, guys, in Pandas? I'm sure most of you must have heard about some of the definitions of stack. So I'm going to tell you about this with perspective of Pandas library here. So the stack function is used to stack the prescribed levels from columns to index, and it returns a reshaped data frame or a series having a multi-level index with one or more new innermost levels compared to the current data frame. So you're going to understand this with an example. So I'm just going to take let's say my tuple is equal to, I'm just gonna take a list, and inside this, let's see, we have values, and we provide, or we get 2 lists over here, a list inside a list, guys. So let's take a few values, take 1, 2, 3, 4, 5, and then again, let's say 6, 7, 8, 9, and 10. Or we'll add a few more values, guys. Let's say 11, 12, and 13. Over here, I will add a few more values. Let's say 17, 18, and 19. So we have our tuple. I'm going to create one more variable index. So we'll have multi-index. So from tuples, and inside this I'm going to pass my tuple, pass the names as well. So the names are going to be, let's say, first and second. So we have our index. Now I'm going to create the data frame, guys. So for this we write pd dot data frame, and inside this I'm going to pass a few values, np dot, let's say, random dot random number. So we have 8 values and 2 columns. All right. So and the index is going to be index, and columns is equal to A and B. All right, we have an attribute error, guys. I made a mistake. So there's no error now, and I'm going to make one more data frame. So inside this I'm going to pass this value. Now I check my data frame. So I have reshaped my data frame with this, the first and the second, and all these values. Now we're going to talk about the stack method, guys, so which compresses a level in the data frame's columns. So we're going to do one thing. We're just going to do df2 dot stack, right? This an attribute error. So this is how we stack or compress a level in the data frame's column, guys. And with a stack data frame or series having a multi-index as the index, inverse operation of stack is unstack, by which default it's gonna unstack whatever you have done with using stack. So we'll do df2 dot stack, and this is how you unstack. Now we'll talk about the pivot tables, guys. Oh wait, let's put it inside a variable, let's say A. Alright, so this is how you unstack, guys. We're getting different values there. Now we're going to talk about the pivot tables that we have in Pandas. So it is nothing but the levels in the pivot table will be stored in multi-index objects. On the index are columns of the result data frame. So we'll take a look at one example, guys, which is going to be pretty clear. So we'll take df again, pd dot data frame, and inside this we're going to take a few values, or we're going to take a list inside a dictionary. So let's go with a few values. Let's say 1, or let's say A. All right, so we write A, B, C, D, we'll remove a few values over here, multiply it to 3. Now we take another value, which is going to be B, and for this we're going to take a list again. So let's say multiply it to 4, take another value, let's say C now, and inside this we're going to pass a few values again. So we're going to pass 6 values. So let's write P, P, and P, Q, Q, and Q. Multiply it to 2 because we want the number to be 12. And now D is going to be np dot random number, and the number we want is 12. And we take one more value E, and we take the same values for this as well, random number 12. no errors, I guess. So we have an invalid syntax, guys. So we forgot to add a comma over here and here and here. Right, so I think it should work fine now without any errors. So we have printed the data frame over here, guys. So this is how it looks. Now we can produce pivot tables from this data very easily, guys. The very reason of creating this data frame was to get the pivot tables. Now what I'll do is I'll just write pd dot pivot table, and I'm going to pass df over here. Alright, df, and the values is going to be, let's say, d, and index is equal to a and b, and columns, let's say, is equal to c. So this is how you create a pivot table, guys. Now that we're done with pivot tables, let me talk about the next topic that we have, which is time series and categoricals. So we have done reshaping, merging, grouping as well. Now we're going to talk about the time series and categoricals. So Pandas has simple, powerful, and efficient functionality for performing resampling operations during frequency conversion, which is, for example, converting secondly data into 5-minutely data. And this is extremely common in, but not limited to, financial applications. So we're going to take a look at a few examples. And for categorical data, data that you collect can be either categorical or numerical. So numbers often don't make sense unless you assign meaning to those numbers. So for categorical data is when numbers are collected in groups or categories. And categorical data is also the data that is collected in an either or yes or no situation. For example, we have 0 or 1, we have true or false. So that's going to be the category over there. So let's take a look at a few examples to understand this, guys, the time series and categoricals. So we'll take a look at a few examples for time series. So first of all, what I'm going to do is I am going to make a time series, guys. So first of all, what we'll do is we'll convert the data into 5-minutely data. So it's very common, guys. So I'll just take the range first of all. So we'll take the dates. All right, I made a mistake. I'll just cut this. So I'll just run this again. We'll get one more column. And now what I'll do is I'll make one variable using the pd.dateRange. Yes, and I'm going to provide the range as, let's say, 2020 01 or 03 01. We want the periods is equal to 100, and let's say frequency is equal to s. All right, let's print dates. Okay, so we have dates over here. I'll just remove this for now. So now we take one more variable, let's say ts is equal to pd dot, I'm going to take a time series, and inside this I'm going to use np dot random and random integer, which is going to be 0 to 500, and the length is of dates, and then we have index is equal to dates. So we have, okay, we have numpy attribute, no random randint. All right, so we have an unsupported date time, so I'm going to have to change this over here. So we'll write it as, let's say, 3 1, or we're gonna write 3 3 2020. Right, so let's see if it works now. It doesn't. So we are getting the unsupported d type. Okay, so we just mention a few more stuff over here. So we'll write it as 0000. So I think I figured out the problem over here. So I've changed this to this format, and now I'm gonna add one more parenthesis here and remove this one, and now I'm not getting any errors, guys. So I'll run it again. Right, So now what I have to do is I will have to make a few changes to that TS, which is time series I've made. So I'll write it as ts.resample, and I want to make it to 5 minutes, right? And I have to sum this. So no errors there, guys. So now I'm going to do the time zone representation. So for that, I'm gonna get one more. Okay, I'll just copy this, guys. This little change to this only, so I'll just copy this, paste it over here, and here I have to make a few changes. That is 0 0. The rest everything is going to be fine, and we'll change this to 5. All right. So now we make another timestamp, and we just use pd dot series, and inside this I'm going to use np dot random number, and the random number is going to be the length of dates and dates over here. All right, so now when I print timestamp, I'm getting the output as something like this. So this is how you get the time zone representation, guys. So you're getting the date, the time, and everything, and the data type is float 64. And then you can also get the UTC as well. So for that, I'll just write ts UTC, and we just write timestamp dot tz localize, and we get UTC, right? It's UTC. Now I'm gonna print this, so we get the UTC as well. So this is how you create the time zone representation. And now after this, I want to show you how we can convert to another time zone. So for that, we don't have to do anything. We just write ts dot, all right, ts UTC dot tz, which is time zone convert, and we write US Eastern. So we have converted into the US time zone. And converting between time span representations also, we can do that. Let's just say that's your exercise. So you have to convert between the time spans representations so that you'll be able to understand this better. For that, you don't have to do anything. You just have to take the date range. The period is going to be 5, and then you write the frequency instead of S, you write it as M. The rest all is going to be the same, guys. Okay, I'll just do it here as well. Just copy this, paste it over here. Instead of S, it's going to be M. We'll have to remove this. All right. Now I make the timestamp, which is going to be the same, guys. Now print the timestamp. This is how we convert. Or after this, we take one more variable, let's say PS, and I'm going to do period. All right. Now when I print PS over here, this is the output I get. So the frequency is M. I've changed the frequency, and now I can just convert it to timestamp, guys. Let's see where it is. This is how you create it into a timestamp. Now converting between period and timestamp enables some convenient arithmetic functions to be used. So for that, we have period, range, and all those things that you can add. Now moving on to the next topic, that is categoricals. So for that, let me just take one more data frame, guys. So I'll write it as df is equal to pd dot data frame. Now I'm going to take a few values inside this dictionary. The first is going to be, let's say, ID. And now I'm going to pass a list with a few values, precisely 6. So I'm going to use 6 values over here. Now my next topic is, or the next key is, let's say raw grade, or just grade we'll write. So we're going to write A, B, C. Let's say again the guy is getting B and this one's getting A. So we have 5 and one more. Let's say one guy has failed. So we have our data frame. Let's print this. Okay, so we have our data frame. What I'm going to do is I am going to get the grade, right? So we'll get the grade is equal to df grade. Now this is going to be the category I'm going to make. All right, now I print df grade. So we have grades like A, B, C, B, A, E. Now I'm going to rename the categories to more meaningful names. So what I'll do is I'll make the change over here only. So I'll write cat dot categories, and I'm going to write the categories as, let's say, good. Instead of pass fail, I'm just going to write very good, and then there is excellent. All right, so we have very good, very bad, and excellent. All right, we have an error, guys. There's something we have done. So we have new categories needs to have the same number of items as the old categories. So how many categories do we have over there? Let's just copy this. So we have categories 4. So we're gonna have to make 4 categories, guys. So I'm just going to add good as well. There shouldn't be any errors. Now what I'll do is I'll just set the categories. So I'm going to set the categories now. Let's say here I'm going to have to give 6 values, guys. So right, very good. Let's say bad, very bad, medium good, very good. Any sort of categories I have to give over here. So I'll just write very bad, good, and let's say medium. Alright, so after this I have set the categories as well. Now I'll just write df grade. Okay, so we have good, very bad, then we have very good, very bad, and good, and then we have NaN because we have not given any other category for that. And we have the 5 objects, so we are getting very good, bad, very bad, good, medium. So that's how you use the categoricals in Pandas, guys. Now I'm going to talk about plotting using Pandas. So that's going to be very simple, guys. For that I'm going to have to import one more library, that is Matplotlib .pyplot. I'm going to use it as PLT. All right. Same thing goes with this as well. All right, this is going to be pyplot. All right, so there should not be any errors now. Okay, so I will close all. Now I'm going to make one series, guys, and inside the series I'm going to provide a few random values like np.random number until, let's say, 1000 or let's say 500, or yes, 500, and the index is equal to pd dot date range. I'm going to take the date range as 1/3/2020, and let's take the periods is equal to 1000. Wait, we have to take it as 500 because we have 500 values over there. I hope no errors. Yes. Now I'm going to take the timestamp and we're going to get the sum. Alright, now ts dot plot. So we have a plot over here using Pandas, guys. This is how we have created one series using the random numbers from NumPy library, and using the pyplot we have plotted a graph for random values which we have taken from 0 to 500 and the random range as well. So this is how you take or get a plot using Pandas, guys. Now last but not the least, we have another topic which is reading and writing to files. So inside this, I'm going to show you how you can read from a file and how you can actually create a file over there. So we have our data frame, guys, or we have our TS. This is our TS, guys. So I can just, convert it to a CSV file, guys. Make it or give it a file name as, let's say, ts.csv, and it's going to save the ts.csv file somewhere in my directory. And similarly, I can read from a CSV file. So for that, I can just write pd.read CSV, and I'm going to have to give the file location for that. So I'll just copy one file location from one of my data sets. So this is one data set that I have. So I'm going to check for the properties, or wait, I'm going to copy this, paste it over here. Okay, we have an Unicode error, so I'll just write R over here, and I'm able to read from the CSV file, guys. Look at this. Instead of CSV, I can write Excel, and it's going to create a Excel file or a CSV file it's going to read from. So that's how we actually read and write from files, like a CSV file, which is a comma separated file basically, or we read from a file.
So why we need data visualization? Now let us take an example. Suppose you work in an organization as an analyst and you have made certain analysis. Now you need to show that analysis to your boss or your CEO, whatever. Now you can understand it by just looking at the Excel sheet and the numbers. But the other person is not an analyst. He's not that technically sound as you are. So what do you need to do? You need to present your analysis or your data in such a way that the other person can understand. And how you can do that? You can do that by representing it in the form of a graph. And it is a well-known fact that human brain can process information easily when it is in pictorial or graphical form. So that is one of the key reasons why we use a data visualization, in order to understand the trend better and make better decisions. So let us move forward and understand one more reason why we need data visualization. Now basically it allows us to quickly interpret the data, like whatever the trend the data is showing us. Now basically it allows us to quickly interpret the data. So just by looking at the graph, we can understand what the data is about and what is the trend. But if you are not from an analytics background and you see just the Excel sheet, then it is very tough for you to understand it. So if it is there in the graphical form, you'll quickly understand it and you can experiment as well. Now what happens if you want to change certain variables and see what will be the outcome? So with the help of the graphical representation of your data, that will give you a very good idea as to what all variables are useful for you and what all variables are useless. You don't need to include in your analysis. In order to perform that experiment in an efficient and a quick way, you need data visualization. So guys, these were the two key reasons why we need a data visualization. If you have any questions or doubts, you can ask me. Or if you understood everything, then you can give me a thumbs up so that I can move forward. Brian says move on, so does Neha, Pooja, Siddharth, Theon, Jason. Fine guys. So we'll move forward and understand what exactly is data visualization. So what is data visualization? So data visualization is nothing but the presentation of your data in a pictorial or a graphical format. Now, why we do that? We do that in order to enable the decision makers of an organization to see the analytics presented visually so that they can grasp some difficult concepts or identify new patterns. Now, since we have discussed a lot about data visualization, so guys, I want answers from you all. Give me some example where I can use data visualization in an organization. I don't need a lot of examples, just 2 or 3, that'll be enough. I just want to know whether you have understood it or not. Alright, so Devon says you can use it in finance. Alright, in what way can I use it in finance? Can you please tell me that, Devon? Alright, so he says in order to find out where should I invest my money. Yeah, that is one perfect use case, I would say. Alright, fine guys. So I'll give you a couple more cases where you can use it. You can use it to identify the areas that need attention or improvement in the organization. You can even use it in order to clarify which factors influence customer behavior. Now, it might depend on the season or anything else basically. Now, you can even use it to understand which products to place where. Now, this is very important, guys. Obviously, you won't be selling jackets or sweaters in summers, right? You won't be selling shaving cream to kids. So you should know what are your target audience and where you are selling your product and to whom are you selling your product. So that is one very important field where we need data visualization, and you can even use it to predict sales volume as well. Fine guys, so we have looked at a lot of examples for data visualization. Now let us understand the diagram that is there in front of your screen. So it basically tells you about how to find insights from your data. Now for that we need data visualization. It plays a very, very important role, and it is one of the major applications of data visualization in order to find insights in data. Now there's a process that has to be followed in order to do that. So it starts with visualize. The first step is visualize. So basically you understand what your data is. You visualize it in a form of a graph and you understand what that data is actually talking about. Now we'll take an example. Suppose you have a data set that tells you about the youth percentage of unemployed youth country-wise from 2010 to 2014. Alright, so you have that data, then you visualize it. The moment you visualize it, you'll get to know that, okay, fine, this country has a lot of unemployed youth, whereas this country is doing pretty good. So accordingly, you just grasp it pretty easily when you visualize it. After that, you make certain analysis. Now, what sort of analysis? Suppose if I take the same example forward, if I want to find out the change in the percentage of unemployed youth between 2011 to 2010, so that will come under analysis phase. So I'll analyze it. After that, what comes is document insight. Now you have done that analysis, but what is the outcome of that analysis? Now I'll see what all countries are doing good. I mean, the percentage of unemployed youth have gone up and which country it has gone down, and from what all countries it is stable. There's no change. So we'll see that and make a document. After that, we transform our data set. Now there might be certain fields in my data that I don't need. So at that time, what I'll do, I'll transform my data set, I'll remove those fields, or there might be certain fields that I need and which is not there. So I'll add those fields. So accordingly, I'll transform my data set. And once I've done that, I'll again visualize it in order to understand what my data is now talking about. And this process will keep on repeating. So this is how you find insights in data, where visualization plays a very, very important role, guys. So I hope you have understood this flow. So we have understood what exactly is data visualization. If you have any questions or doubts, you can ask me. Alright, so Neha is asking, Matplotlib is used for data visualization. Yes, Neha, it is used for data visualization. We are going to see that in the next slide. Any other questions? Alright, so we have no questions, so we'll move forward and understand what exactly is Matplotlib. Now it is very important for us to understand as to how Matplotlib works fundamentally. Now it is pretty easy and pretty basic. You have some data, then your computer will draw that data to a canvas of some sort, but it is only in the computer's memory. Now once your computer has drawn that data, you can show that data. So this is so the computer can first draw everything and then perform the more laborious task of showing it on the screen. Very basic. I know you might find it pretty lame, but it is very important for us to understand how fundamentally Matplotlib works. So you have an example in front of your screen. So again, we have that data in which we have country-wise percentage of unemployed youth. And I've done some analysis and I've shown it graphically, the percentage change in the unemployed youth country-wise between 2010 to 2011. So this is how that plot looks like. It is nothing but a bar plot. Now there are various types of plots available. We'll have a look at few of those in the next slide. So we'll move forward and see what are the various types of plots. So I've listed down 6 types of plots. First is the bar graph. then histograms, scatter plot, pie plot, hexagonal bin plot, and area plot. We are going to plot all these things in today's session with the help of Matplotlib module. So we'll move forward and we'll get started with it. We'll write our first Matplotlib code. So here's the most basic code in order to generate one of the most simple graph. So let me explain to you this code. First of all, what I've done, I have imported pyplot from Matplotlib as PLT. Then I'll use this pyplot in order to plot the graph in the canvas. And then finally, I'll use this PLT, which is nothing but pyplot, in order to show what we have got. All right. So pretty basic, guys. So what I'll do, I'll open my PyCharm and execute this practically. All right. So before I open my PyCharm, we have a question from Brian. He's asking, what are the tools that are used for data visualization? All right, so I'll tell you, we have a lot of tools available in market nowadays. We have Tableau, we even use R, Python. So for Python, we need to import the Matplotlib library. So there are many tools available in the market right now. So I hope this answers your question, Brian. All right, so he says yes. Fine. So I'll open my PyCharm and I'll execute this practically. So this is my PyCharm, guys. So over here, I'll first create a Python file with .py extension, and I'm going to name it as first code. Now over here, I'll first import pyplot from Matplotlib. So for that, I'll type from Matplotlib import pyplot as PLT. Now this PLT is pretty much similar to NP that we were using in Numpy array, if you can recall. So it is not mandatory to use PLT only. You can use whatever you want, but a lot of people use it as PLT, and I'll keep it that way. Now our next step is to plot our graph to the canvas. So for that, what I'll do, I'll type in plt.plot, and I'll write in here my X and Y axis values. So for X axis, I'll keep it as 1, 2, 3. Then for Y axis, I'm gonna add values such as 4, 5, and 1. So this will plot our graph in the canvas. Now final step is to show that plot. How we'll do that? I'll just type in here plt.show, and we'll execute this and see what happens. Run first code, and yep, this is how our first basic graph looks like. So with 3 lines of code, you have got this graph. So we'll move forward and we'll see how to actually add title labels to our graph. For that, I'll open my slides once more. So now, of course, there are some problems with our graph. First off, we have actually learned in school that we are supposed to put labels on each axis. And we need to also add a title to our graph. It actually doesn't make sense. Our graph doesn't make sense if there are no X and Y axis labels and a title. So you don't know what is axis, you don't know what is X axis, you don't know what is Y axis, and what is the graph about. Plus, in terms of programming, it is very unlikely that you'll be actually filling in data to the plt.plot function. Now over here, you can notice that we are actually filling in data like 1, 2, 3, 4, 5, 1. Instead, you will be passing variables into it. All right. So it should be something like plt.plot, and you can say X, Y if you have defined variables X, Y. All right. So now let us show plotting variables as well as adding some descriptive labels and a good title. How does that sound, guys? All right, so I can see a lot of people are pretty excited. So we'll move forward and see how to add title, labels, and plotting variables. Now, the code is pretty much similar to the previous one, but it has few extra fields. Let me explain you that. So of course, I've imported the pyplot from Matplotlib. After that, what I've done, I've defined 2 variables, X and Y, and I have certain values in it. Like 5, 8, 10, and 12, 16, 6. You can put whatever values you want, and this can even contain a data frame, a Pandas data frame that has a data set. After that, what I've done, I've defined plt.plot function in which I have X and Y. Instead of filling the data, I'm putting in variables that actually contain data. After that, I've added a title, which is info, then Y label, which is nothing but Y axis, and X label, which is nothing but X axis. After that, I need to show my plot. So for that, I've done plt.show. And the result is there in front of your screen. We have a title, we have labels for X axis and Y axis. Now let me open my PyCharm and execute this practically. So before I open my PyCharm and execute this practically, we have a question from Siddharth. He's asking, X and Y contains list. Yeah, X and Y actually contains list. We have list of numbers 5, 8, 10 in X variable, and in Y variable we have similarly 12, 16, and 6. So I hope this answers your question, Siddharth. Alright, so he says yes. Fine, so I'll open my PyCharm and execute this practically now. This is my PyCharm again, guys, so I'll remove till here, and obviously I need pyplot function from Matplotlib. So now I will define x and y variable. So in x, it'll have a list of numbers, say 5, 8 and 10. And now I'll define one more variable, y, which again has a list of numbers 12, 16 and 6. 12, 16 and 6. Yep. Now what is our next step, guys? Can anyone answer me? Alright, so I've got a correct answer from Theon. He's saying a plt.plot function, which is absolutely correct. So I'll write in here plt.plot, and instead of filling in data, I'll be passing variables. Alright. And now our next step is to add title and x label as well as y label. So in order to add title, I will write here plt.title and the title of my graph. So I can just write here info. And now I'm going to define x and y labels. For that I'll type in plt.y label and I'm going to name it as y-axis. Similarly for x label, I'm going to do the same thing, x-axis. Alright. Now finally I'll type in plt.show. Now go ahead and run this. So you can see that we have a graph that contains the title info, y-axis as a y label as well as x-axis as the x label. Now I'll again open my slides and we'll see what next are we going to see. So any questions or doubts still here, guys? You can ask me. Any questions? So we have no questions. So what I'll do, I'll open my slides and we'll move forward. Now this graph is pretty much incomplete or ugly, I would say, because what if I want to change the width of this particular line? What if I want to add some grid lines? What if I want to change the color? So all those things, how will I do that? Don't worry, the next slide will actually tell you the same, how to add style to your graph. So how to add style to your graph? For that, first thing that you need to do is import the style function from Matplotlib module. After that, you need to call it style.use ggplot. So whatever plot that you want to use, I'm using ggplot right now. Then again, I've defined 4 variables, x, y, x2 and y2. And all of these contains a list of numbers. Again, I'm telling you, it can be a data frame as well, which contains a data set. Then what I've done, again, I have used plt.plot function. But over here, apart from x and y, there are many other fields. So don't get confused. I'll explain it to you. It's very, very easy. So this thing G actually tells me that the color of my line should be green. Then this is label. So this label is not for your x-axis or y-axis. It is for your curve, which is line 1. You can give whatever name you want. Then we have line width. I want the width of my line to be 5. So I've put in here 5. Similarly, I've done for the next plot as well. Then I've added title, which you know how to do that. Similarly, y label and x label. Now after that, I'm using this legend function in order to add a legend to my graph. Over here, you can notice that we have it present in our graph where I'm pointing with my highlighter right now. So we have line 1 and line 2. After that, what I've done, I've added grid lines to my graph, which is of the color K, which is nothing but black. So you can see it in my graph as well. We have grid lines available. And finally, plt.show. Any doubts, questions still here, guys? We are going to execute this practically in my PyCharm. So before that, if you have any questions or doubts, you can ask me. Alright, so we have no questions. So I'll open my PyCharm again and I'll show you how you can do that practically. So this is my PyCharm again. So this is my PyCharm again, guys. Let me first remove all of this and I need to import the style function. So for that I'll type from Matplotlib import style. That's it. Style.use ggplot. Now define the variables. First will be x, add certain values to it. I'll add in 5, 8, 10. 5, 8, 10, then y, I'm going to add a list of numbers 12, 16, 6. Now one more variable x2, again it will have list of numbers which will be 6, 9, 11. Then I'm going to use y2 variable and I'll add some numbers to it 6, 15 and 7. Alright, so now I'm going to use plt.plot function and over here first I write x comma y Then now given a color to it, I'm going to give it as green. Next, label, line 1. Now line width, which is equal to 5. Now again, for x2 and y2, I'm going to type in plt.plot x2, y2, the color, then label. So I'm going to type in line 2, then comes line width. Alright, so now our next step is to add title to our plot. So plot plt.title, and the title that I'm going to give is info again. Then x and y labels, plt.y label, y axis, then plt.x label, x axis, plt.show. Now go ahead and run this. So over here I've not added any grid lines. I can do that as well. So for that, let me first close it. Fine, so I've defined title, x label as well as y label. Now our last task is to actually add grid lines. So for that I'll type plt.grid and just write in here true, comma, give a color. I want it black, so I'll keep it that way. Finally, show your plot. So plt.show, that's all. Go ahead and run this. So you can see that this is our graph. So we have changed the default line width. We have added grid lines. We have added labels, titles, plus we can add legend as well. So let me show you how you can add a legend. So for that, I'll go back to my code once more. Just write in here plt.legend. Go ahead and run this again and you'll see that legend has been added. So here we have line 1 and line 2 as our legend, and we have changed the default line width, title, y-axis, x-axis labels, plus we have grid lines. So this is how you can customize and add style to your graph. So I hope you all are clear. Alright, so everyone says they are clear. So what I'll do, I'll open my slides again and we are going to look at how to plot various types of graphs. For example, a bar graph or a histogram, all those things. Fine, so first we'll look at how to plot a bar graph. So these are all the linear graphs that we have seen till now. Now we'll see how to plot a bar graph. So before I tell you how to plot a bar graph using Matplotlib, let us understand why we actually use a bar graph. So bar graphs are basically used to compare things between different groups. And when we are trying to measure changes over time, bar graphs are very well suited when changes are larger. So this is why we use bar graph. Now let us understand how we can do that using Matplotlib. Now since we know why we use bar graph, let me explain you the code and how you can do that using Matplotlib. So first import pyplot like we do every time. After that, instead of plt.plot, I'll use plt.bar, and I have filled in data here. You can fill in variables as well that contains data. Then I have defined a label, example1. After that, I have one more plot in which I have filled in data plus a label, and I've given a color as well. I don't want the default color, I want some change, so I've written it as green. After that, I have plotted the legend. After that comes legend and then X label and Y label that you have seen in the previous graphs as well. Then I've added a title and then finally show it. Don't worry guys, I'll execute this practically in my PyCharm now. So this is my PyCharm guys. So over here what I've done, first of all I have imported the pyplot function. Then instead of plt.plot, I'm using plt.bar, and inside that I have data filled in. Instead of that, I can even have variables that contains data. Then comes label, in which I am using example1. Then comes label. For this instance, it is example1. Then again, for one more plot, I have plt.bar. Inside that, I have data filled in, then label, and then in order to differentiate between both of them, I'm using a color green for this particular bar graph. Then comes legend, and then after that I've defined X label as well as Y label. After that I have title, and then finally show it. Now go ahead and run this and see if it works or not, and yes it does. So we have legend here, we have X label, we have Y label as well as X label, and we have a title for our graph. So any questions, any doubts guys? Alright, so we have a question from Dave. He's asking what is the difference between histogram and bar plot. Alright Dave, I'll tell you, in histograms we have quantitative variables. all right? And when I talk about bar plot, they have categorical variables. So let me explain you this with an example. So suppose if I want to plot the GDP growth of every city in a particular country. So at that time, I'll use a bar plot because it has a category, this particular city, like New Jersey, New York, all those things. Now, when I talk about, I'll use histogram when I'm talking about quantitative variable. That means if I'm talking about age group. In that same example, if I want to calculate how much each age group is actually contributing towards the GDP growth, so at that time, I'll be using histogram. So I hope this answers your question. All right, he wants me to repeat it. Fine, I'll do that. So when I talk about histogram, it actually has quantitative variables. When I talk about bar plot, it has categorical variables. Now with an example, if I explain you can take the example of GDP growth. So if I want to calculate how much GDP growth is there for every city in a country, so at that time I'll use bar plot. But if I want to calculate how much each age group is contributing towards the GDP growth of a country, then at that time I'll use a histogram. So over there we had a category in bar plot like cities, but here we have a quantitative variable that is age group. So I hope this answers your question. All right, he says yes, fine. All right, so let us move forward and focus on the code that you have in front of your screen. So let me explain you this code. So over here we have population ages. So we have defined a list in which we have multiple numbers. After that we have defined one more list or a variable bins in which we have multiple numbers again. Now instead of using plt.bar for bar plot, for histogram we use hist, plt.hist. Then comes population ages. Instead of data, I am filling in here variables that contains data. Then bins. Then hist type, I want it to be a bar type. Now when I talk about hist type, I want it to be bar. And then the width should be 0.8. That's all. The rest all you can understand. It is X label, Y label, title, legend, and finally show the plot. Now I'll go ahead and execute this practically in my PyCharm. So this is my PyCharm, guys, and just to save time, what I've done, I've actually copied it already. So over here you can see we have imported the Matplotlib module. Then we have a variable population ages and bins. Now instead of using plt.bar, I'm using plt.hist for histograms. Then comes the two variables, and then hist type is equals to bar, and then I've defined width. Similarly, I've defined X label, Y label, and title like the previous examples. Then comes legend, and then finally show the plot. So let us go ahead and execute this and see if it works or not. Yep, it does. So we'll move forward and understand scatter plot as well. Now before we understand how to plot a scatter graph, we need to understand why we actually use scatter plots. Usually we use scatter plots in order to compare two variables, or three if you're plotting in 3 dimensions, looking for a correlation or groups. So basically you try to find out how much 2 or 3 variables related to each other. So over here, as you can see, there is one point here and there's another point here. So these two are pretty much dissimilar to each other, right? Now when I talk about these 2 points, they're pretty close to each other. So you can say that these two are pretty much similar. And basically what we are doing here, we're trying to find the relationship between the 2 variables. And that is actually called your correlation. Now let us understand the code. Now let me explain you the code. So first of all, we have imported the pyplot function from the Matplotlib module. Then we have 2 variables X and Y, which contains a certain set of values. Now instead of calling plt.plot or plt.bar or plt.hist, I'm using scatter because I'm doing it for a scatter plot, right? Now inside the parentheses, I have X and Y variables. These variables contain data, and I can even write the data instead of just writing the variables as well. Now I've defined a label and then color. Then rest of the things, we have X label, Y label, the title, then legend, and then show. That's all. Now let's go ahead and execute this practically in my PyCharm. Now this is my PyCharm, and over here I've already pasted the code. So I'll just go and run this and we'll see what happens. So this is how our scatter plot looks like. So here we have our legend, then we have the title, then we have our y-axis, then x-axis. These two are the labels for that. So let me close it and see what is the other plot that we are going to focus on. Now once scatter plot is done, we'll have a look at the area plot, or you can even call it as a stack plot. So basically these area graphs are very similar to the line graphs, okay? They can be used to track changes over time for one or more groups. Area graphs are good to use when you are tracking the changes in 2 or more related groups that make up one whole category. You can take an example of, say, public and private groups, okay? So before I explain you the code, let me tell you one thing, guys. The problem here is with polygons, we cannot actually have labels for our data. In order to solve that problem, all we did here was plot some empty lines giving them the same color and the correct labels in accordance with our stack plot. We also gave them a line width of 5, as you can notice here, to make the lines a bit thicker in the legend. Now we can easily see that we are spending our day sleeping, eating, working and playing. So this is how the code works. Now let me execute that practically in my PyCharm. So I've copied the code already just to save time again. Now this is our code. Over here I've already explained to you why are we defining these empty lines, just to add labels. Now let us go ahead and execute this and see what happens. So this is our graph, guys, and again we have legends, title to our graph, and Y label as well as X label. So we'll move forward and look at various other plots. This is called a pie plot. So let me tell you about pie charts a bit. So pie charts are pretty much similar to stack plots, only they are for a certain point in time. Typically a pie chart is used to show paths to the whole and often a percentage share. You can consider the example of percentage of market share and things like that, right? Now let me tell you guys, Matplotlib handles the sizes of the slices and everything. So all we need to do is just feed it the numbers. That's what we have done here. So let me explain you the code here. So over here we use plt.pie to plot a pie chart. We have slices. We have specified slices. Now slices which are nothing but the relevant sizes for each part. Then we specify the labels and then the color list for the corresponding slices. Next we can optionally specify the start angle for the graph. This lets you start the line where you want. In our case we chose a 90-degree angle for the pie chart, which means the first division will be a vertical line. Next we can optionally add a shadow as well. And after that we can even use explode to pull out a slice a bit. So we have explode that says 0, 0.1, 0, 0. So because of that you can see that eating has been pulled out a bit. Now basically we have 4 total slices. So with explode, if we didn't want to pull out any slice at all, we would have just written here 0, 0, 0, 0. Now if we want to pull out the first slice a bit, we would do 0.1, 0, 0, 0. And if we want to pull out the second slice a bit, what we can do is 0, 0.1, 0, 0, like in our case. Now finally we do an autopact. Now this autopact overlay the percentages on the graph itself. So you can see that we have 8.3, 29.2%, 54.2%, all those things written on the graph itself. And then finally add a title and then show it. Now let me execute this practically, guys. Now just to save time, I've already written the code. So I'm just going to go ahead and execute this and we'll see if it comes or not. Yep, here is our pie chart. So we have seen multiple types of plots. We have seen pie plot, bar plot, histograms, area plot. Now what we need to understand is how to handle multiple plots. So at that time, what will you do? Let me open my slides again and we'll move forward with that. So this slide actually tells you how to deal with multiple plots. Now you can notice in the figure as well, we have 2 plots available. Now let me help you out with the code that is there in front of your screen. So in the beginning, we are importing a couple of modules. One is matplotlib.pyplot, which you are already familiar with. After that, there is a numpy module as well. So we have covered numpy modules in the previous sessions. If you have any doubts, you can go through it. Now after that, you might find this part confusing if you're not familiar with numpy. Now let me just tell you what it does. It will create a numpy array that will have elements between 0 till 5 in the steps of 0.1. Now similarly, T2 will also be a numpy array that will have elements ranging from 0 till 5 and in the steps of 0.02. Now after that, the code is pretty much similar to the previous examples that we have seen. But there is one new concept that is called subplot. Now let me tell you what this subplot does. It helps us to plot multiple plots, alright? So when we write subplot 211, this means that we have 2 plots. Horizontally, we have only 1 plot present and vertically we have 2 plots. And in that vertical position, this plot will be our first graph. Now you can notice that we have one more subplot that is 212. So vertically we have 2 plots, horizontally we have 1, and this is the second plot. So what I'll do, I'll open my PyCharm and I'll play around with it a bit so that you'll be able to understand it better. So now this is the code, guys. First I'll go ahead and execute this and we'll see the result. So we have a graph something which is like this, right? We have 2 plots which are aligned vertically. Now what I'm going to do is I'm going to just minimize this and I'm going to change the subplot value so that you'll be able to understand better how we are dealing with multiple plots. Now over here, if I make this as 2 and this one as well as 2, so let us see what we get. So we have got the same graph, but it is aligned horizontally, if you can notice. This is our another graph, and this is our first graph. So you can notice the difference between both of these graphs, right? So this is why we use subplot. So we have certain values in the subplot, right? 2, 2 and 1. Now what this 2 means that we have two graphs available with us. After that, whether I'm aligning it horizontally or vertically. So if I'm doing that horizontally I have two graphs. Then among those two graphs, this is my first graph. This is what it means. Now similarly, when we have 2, 2, 2 here, this means that we have two graphs. Horizontally we have two graphs available, and this is the second graph that is present. So similarly, if I make a change here and I make this as 2, 1, 1 and this as 2, 1, 2, this means that horizontally we have only one graph, and these both graphs are aligned vertically. So we have, this was the first graph and this is our second graph. This is how it works. So this is what basically subplot is.
Basic Python questions. So when you're talking about basic Python questions, there are a couple of specific questions which keep repeating. Okay. Now this is the first question that we have. What is the difference between a deep and a shallow copy? So even before I get into this, let me just check with you all. So can you give me a background as to which particular background do you come from? Do you come directly from Python? And what do you want as a takeaway from this particular session? So I would be happy if you could reply in the questions box, please. A quick introduction into basically what you are looking for in this session as such, and what do you want as a takeaway. Okay, while you answer that, okay, let's tackle a couple of questions there. Okay, so as I said, basic Python questions. My suggestion would be to get yourself familiarized with the various data structures that you have in Python. Okay, that is the most heavily asked. It's heavily asked as such. So you've got questions like what is the difference between list and tuples? What exactly do you mean by mutable? What is immutable? So you've got a couple of questions like that. Okay. All right, so Roma, you basically come as a Java developer. You're expecting to learn Python and know what you should focus on so as to move into Python. That's a great thing to do, because you would find it pretty easy to move into Python as compared to working in Java. So we'll take a look at this. Okay, let's go into the basic Python questions as such, what you would typically come across. So what is the difference between deep and shallow copy? Okay, so let's do one thing. Okay, let me open up a Python prompt. Okay, now, so even before we get into this, let me just give you a background. So what do you mean by a shallow copy? It means that it is used when a new instance type gets created and it keeps the values that are copied in the new instance. So basically we are copying, okay, copying whatever is of the new instance from an existing instance. Okay, so it is used to copy reference pointers, it copies just the top level values. It doesn't copy each and everything and create a new object. So there would be references. Okay, for example, okay, I have L1 is equal to 1, 2, 3, 4. Okay, this is a particular list. Okay, I have a list L1, 1, 2, 3, 4. Now L2 is equal to L1. I'll create a, I wouldn't say it is a copy. It's just a reference of L1 in L2. So if I even do L2.append of 10, so it would reflect both in L2 and L1. Okay, this is this is basically a referencing. Python, Python referencing. Now, when you're talking about copy, we usually have a particular module named as copy. So the shallow copy works this way. So I've got L1. Okay, I've got L3. Okay, I'll create L3 copy.copy of L1. Okay, if you look at L3, it is the same as what we have in L1. Now, L3.append of 11, let's take a look at L1, L2, L3 now. Okay, L1 is at 10, L2 is at 10, and L3 has moved to 11, which means to say it has created a copy. Okay, this is a shallow copy. Okay, so it is used to copy all the reference pointers, it copies all the values, but it creates a new original by itself in a separate memory location. So to check the memory location, you can do this. L1, ID of L2, ID of L3. Okay, you see L1 and L2 are the same, but L3 is different, which means to say that there is a copy which has happened, but the admin structures in copy, so the admin structures of L1 are not copied to L3. Okay, so we will not delve into that depth because there's a whole lot more happening. Okay, there's a whole lot more happening. But what I can tell you is, if you were to tackle the question, this is what you need to say. Okay, L1, so basically your shallow copy copies all the reference pointers, all the values, and it creates a new memory location so as to you have a copy of the entire set which you created. Whereas a deep copy, it takes care of all the references of the references and a whole lot more, which means to say it has to make pointers to each and everything. It has to make clear-cut copies for each and everything. That does not happen in shallow copy. Please remember, that does not happen in shallow copy. Okay, so deep copy gets deeper and deeper. And when you take, copies of instances as such, that is where issues come in when you're using deep copy. So it makes it much more slower to run deep copies. Okay, it makes it much more slower to run, because it has to copy all the references, all the admin structures, all the values, each and everything. Whereas shallow copy does not copy all the admin structures, just the top level references and the original values. That's it. Are you all clear on the copy and the deep copy? Yeah, so the example for deep copy would be something like this. Okay, L4 copy dot deep copy, in case you were asked about that. So L2, okay, L4, ID of L4, you will see it's got a whole different ID altogether. Okay, so this is how you create a shallow copy, and this is how you create a deep copy. Please remember this, because it does come up, not frequently, but it's good to know something like this particular thing. What is the difference between copy, a regular copy.copy, what is a deep copy, and what is a regular reference? Are you all clear? All right, great. So let's move on. Okay, let's move on. So the next question, this is a very frequently asked question, that is, what is the difference between a list and a tuple? Okay, what is the difference between the two of them? Now, we already took a look at list as such. No, let's do it again. These are all lists over here. 1, 2, 3. These are all lists. Animals, marks, and comments are all lists. And the tuples are the one within these lists. So let's go back here. Let's create X or L1 again. 3, 4. Okay. And T1 as a tuple. 2, 3, 4. Okay. So here's the difference. Okay. Lists are data structures which can be modified at runtime, whereas your tuples cannot be modified at runtime. Okay. We have list methods which allow us to do that. For example, list.append of 10 will allow you to do it. This happens at runtime. Okay. But we cannot do that to a tuple. Okay. We cannot do that to a tuple. We'll see that it does not have such attributes. So you might wonder, why do you need tuples when you have lists? Okay, the reason being, when you have fixed data and you know exactly the size of the data which is coming into you, okay, or coming into your server or coming into your application, that is when you use lists, because these take up fixed or static space. Okay, whereas your lists are allocated space which is dynamic in nature. We can append, we can remove. For example, list.l1.remove of 3, and you'll see that 3 has been removed, so you can keep on modifying it. Whereas your tuples are fixed in nature. When you're thinking about fixed amount of data coming in, fixed amount of data going out, and you are thinking about memory intensive tasks, always go for tuples. When you are thinking about buffers, when you're thinking about queues, when you're thinking about stacks, always think about lists. Am I clear on that? So the first question which might come up would be, what is the difference between a list and a tuple? Basically, a list is mutable, a tuple is not. Am I clear? Could you reply with a Y or an N? So for example, okay, still unclear as to where to use tuples. Now you have got a database, okay, MyDB, okay. So for example, I've got fixed columns, okay, column with ID, column with name, and a column with marks. Okay, so the list represents the rows. Okay, so this is one row, this is the second row, something like this. Okay. When you know exactly how many columns you have, you go for a tuple. When you don't know how many rows you have, you go for a particular list. That is how it has been, it is structured. Even all the APIs, MySQL, PostgreSQL, SQLite are all structured this way. Okay, where the columns are represented by tuples and the lists are represented by rows. Okay, so when you are writing in data, you have fixed number of columns, so you have a fixed number of data. You cannot simply tell I want to write n number of columns into an n-1 number of column database. Does that make it more clear, Roma? All right. Okay, so that is about lists and tuples. And there is one more thing. Okay, you might get a question like this. Okay, say L1 is equal to 1, 2, 1, 3, 4, comma, and I would put in a tuple inside this. Okay, so let me ask you a question. Will you be able to modify the list? Okay, so modify the list, or will you be able to modify the tuple? The tuple exists within a list, which is a mutable thing. Okay, and here I'll give you something like this: 1, 2, 3. Okay, so you've got L1 and you've got L2. Okay, will you be able to modify this tuple? Could you all reply? From my explanation, you should be able to answer this. So here's the thing: tuple you will never be able to modify. Will you be able to modify this list which is inside the tuple though? So you say, I don't think so, but it is, you are able to modify it because it is referenced, as I said earlier. So if you see L2 now, it would have been modified. Remember, lists are referenced when even inside this, the structure, the attributes of a list do not change even if they are inside a tuple. It's a tricky question for beginners. It does come across. All right. Now, how do we achieve multi-threading in Python is a question which comes up. Okay. So Python does have a threading package. Okay. So as to, it's got a threading package, it's got a multi-processing package. There are two different concepts. Threads are related to, specifically threads, and multiprocessing is specifically related to the number of cores which you have on your system. Okay. Now, Python has something called a GIL, Global Interpreter Lock. This is a question which comes up. Okay. Typically, when it comes to threading, this is a question which comes up as to what is a GIL. The GIL is a global interpreter lock which makes sure that only one thread can execute at a certain point of time in Python. Okay. So what happens is that the thread acquires the GIL, it completes the work and moves on to the next thread. So if you're talking about multi-threading, this is what typically happens. Okay. You've created multi-threads using the threading package. Okay. What happens is that it moves from one thread to the other thread to the other thread, so that it seems as if it is executing in parallel. Okay, it's executing in parallel. But what is happening is it is actually taking turns using the CPU core. It looks like it is executing faster, okay, but not necessarily all the time. But there is a particular way. It's a dirty hack, if you might say. You can, however, turn off the GIL over here. Okay, it mimics. Okay, so it does not happen parallelly. It mimics parallelism, is what I would say. Okay, it mimics parallelism, but there is a way to do it parallelly also, where you can turn off the GIL. Please remember, this is a very dirty way of doing it. So if you turn off the GIL, your memory management can get messed up. So typically they don't do that. There are other packages which have come in which makes better use of threading. Okay, so you have to be very careful while using the threading package as such. So when you're turning off your GIL, you have to make sure that you write your semaphores, your mutexes properly so that it does not mess with your memory management. Okay, because Python memory is internally managed by the Python interpreter itself, unlike something like C or C++, where you have to do the memory management part. Okay, so is that clear to you all? So GIL can always add an overhead to your execution. Okay, I'm not saying don't use multi-threading. Okay, I am saying multi-threading is heavily used. Okay, it's just that it is used depending on context. So in case you have a lot of cores, it makes sense to use something like threading. Okay, is that clear to everyone? Okay, beside multi-threading, you can make use of multi-processing, where multiprocessing takes advantage of the number of cores you have. So if you say, I have got 4-core processor, you can make use of all those 4 cores and run parallel jobs on all those 4 cores. Okay, so you've got something called multiprocessing for that. Okay, library called multiprocessing. For threading, you have something called threading. Everyone, are you all clear? Okay, great. Now, basic Python questions when it comes to ternary operation. So I wouldn't call it exactly ternary. It behaves like a ternary operation. Okay, so where you have conditionals, if X or Y. Okay, something like this. So how does it work? Okay, so basically this is how you do it. So you've got X and Y. Okay, X comma Y is equal to 25 comma 50. Let's take up this example. Okay, 23 comma 50. We need to find the largest among these. Okay, so you have to be sure as to what you're doing. X, if X greater than Y, else Y. Okay, if X greater than Y, else Y, which means to say it evaluates for X, so it will give X if X is greater than Y, else it will give Y. So when you check big, you would have got this particular answer. Okay, so the expression gets evaluated like this: X less. So in this particular case, this is not X greater than Y, it is X lesser than Y. This is for X, the smaller one. Okay, so it's not big, it should be small instead. Okay, so is true. So if X is greater than Y, return X, else return Y. That is what basically happens here. Are you all clear how to use, how to mimic a ternary operation? Great. Now, what is monkey patching in Python? This is something which appears when you have gotten into classes as such. Okay. Now, so basically it means to say that you're applying a patch at runtime. Okay, or basically dynamic modifications of class or a module at runtime. So basically what happens here? So let's quickly create this example, recreate this example over here, and then I'll tell you what is the use of monkey patching. So please remember, do not follow this particular thing, follow this particular syntax, because I am using new style classes. This is a question which comes up again as well. Okay, do I use old style classes or new style classes? This is something called an old style class. This is using new style classes. Always use new style classes. It is only legacy architecture which makes use of old style classes. New style classes where the classes inherit from objects, an object parent class as such. Def f self. Okay, I'm creating a particular function print. So it says that just print this in case you are invoking me. Now, okay, I will import something like m. So typically I would import it from a separate Python script as such. Over here I'll show it to you directly in practice what exactly you're going to do. Okay, monkey self print monkey f. So basically this is going to be your patch which we want to apply to this particular function in this particular class. Okay, so what you're going to do is my class. So if you do my class.f now, let me instantiate this class first. X is equal to my class x.f. Okay, so you see that f is printed over here. Okay, now my class.f. Okay, so f becomes a function attribute of this particular class. Okay, now is equal to monkey underscore f. So I am forcing this onto this particular function. Okay, now what happens? I will create an object obj, okay, which is my class. Okay, obj.f will give you monkey f. It would have applied this particular patch onto this particular function. Are you clear as to what happened exactly? So we are applying a dynamic change for a particular function in a particular class at runtime. Did you all understand how it is applied as such? We are forcing a particular function into a particular function attribute of a particular class at runtime. Did you all understand? So what happened here is that you have a particular class which contains a particular function f. Okay, so this particular function is completely independent of everything else. which is part of this class. It is only part of this class. Now you create an additional function called monkeyF, so which you want to patch into this particular function of this particular class. Do you follow me so far, Roma? Okay. Now what you are going to do, so initially if you are calling directly from that particular class, my x is equal to my class x.f, it will give you this f, and this is the one which was found earlier, which is naturally a part of that particular class. Okay. Now what you do is you are going to create another function which is not part of this class. Remember, not part of this class. You create a function, okay, and you have a different working of that particular function, and you want to patch it for this particular function which is part of the class. Okay, you are going to force this particular function, which is why you do my class.f is equal to monkey_f, where f is the function of this particular class. Monkeyf is your patch function. Following me so far, everyone? Okay. Now what I do, I create an instance of that particular class after patching, and you see that patch has applied over here. So are you clear? Everyone, are you clear now as to what exactly I did? Okay. So why it is used is basically, it is used as a quick fix in case there are issues, in the code. Self is basically for the, similar to a it's not a constructor, it is a self definition for a particular constructor. Okay, so to create instances as such. Okay, now, so basically what you do is you create, patches so as to get dynamic attributes at runtime, which you were initially not thinking about, or, applying quick fixes so as to, at runtime so that things do not go wrong. Maybe there was a functionality and it is not working right, so you go ahead and apply a patch for that, something like this. Okay, this is how you do it without changing the class itself. Okay, now here is a question. Okay, how can you randomize the items of a list in place in Python? Okay, so this is a question which makes use of something called a random. We have a particular module in Python called random. From random import shuffle. Okay, you've got a whole lot of stuff within random, but we're not going to take it up. So what we'll do is we'll create a list. Just a moment. Okay, so we create this particular list. X is equal to keep the blue flag, individual items. And you want to shuffle this thing in place. Okay, you want to shuffle the original item. You do shuffle of X. When you print X, you see that the items have been shuffled. You do it again, you see that again it has been shuffled. Okay, this is how you shuffle items in place. Are you all clear? All right, super. Now write a sorting algorithm for a numerical data set in Python. So maybe the question is not totally clear. But what we are trying to say here is write a sort for a data set which is a string. So basically integer strings basically. Okay. So 1, 4, 2, 10, 5 are a string, set of strings or list of strings. Okay. Which are all actually integers. So how do you do that? So there are two different ways of doing this. Okay. So let me do this. L1 is equal to 1, 4, 2, 10, 5. So 1, 4, 2, and 5. Okay, so one particular method is doing this. Now you have a string, so if you do L1.sort, so let's do this. Okay, now L1.sort will give you something like this. Okay, it is not the right thing. This is not right at all. Okay, and you wouldn't want something like this. Okay, what you want is 1, 2, 4, 5, 10. So when you do a sort like this, it applies on the ASCII characters as such. So it applies on the first found ASCII characters, which is why 10 will also come out of place. So when you want to do an integer one, this is what you do. This is the first one. L1 is equal to int of I for I in, you might be wondering what this is. So, and L1 dot sort. So now you see that it has been sorted in place. So what we did here is we use something known as a list comprehension, which can, traverse over a particular list quickly and, shorten your code. You create a list in place itself. Okay, which means to say for I in L1, that means we are traversing over L1 first, and we are creating an integer out of that particular thing. We are forcing it into an integer type, int of I for I in L1. First we change all the items into an integer, and then we sort it in place. Are you all clear regarding this now? Okay. Similarly, you can do the same thing in a different way by using another one. So L2 is equal to, you use map, okay, of int comma L2, okay, L2 dot sort, not L2 dot sort. Let's see. First we change it into an integer. This is a very short one. Instead of using a particular list comprehension, you can use a map. Okay, map of int comma L2, and L2 is equal to 1424, and one L2 dot sort will give you the sorted items. So there are two ways of doing it. This is one way, and this is the other way. Okay, are you all clear? So map, what it does is it takes up any function, okay, and it maps it to a particular list of items. Does that answer all your questions that you have in mind, Roma, Madan, Varun? All right. Now you have another set of questions over here, which basically are simple programmatic questions. So let's take a look at that. So T1 is equal to A, B, C, D, and T2 is equal to 1, 2, 3, 4, 5. Okay. There is a data structure. So you want to create a dictionary out of two different lists or tuples which have matching number of arguments. This is how you do it. Zip of T1 comma T2. Okay. What you get is a list of tuples which are zipped together, A, B, C, D, E. When you do date of zip of T1 comma T2, you actually get a particular zipped dictionary which is created from the lists or the tuples. Is it clear with everyone? Okay, so this is the first thing. You want to create a list of items, okay, a list of integers from 0 to 9. You do it like this using a range of 10. Okay, now A2 is equal to sorted of I for I in A1 if I in A0. Okay, what it means to say is, first we are going to traverse over A1, which is 0 to 9. Okay, 0, 1, 2, 3, 4. If I in A1, so I will pick the value 0, 1, 2, 3, 4 till 9. It will check whether the value of I is present in A0. Okay, A0. Where is A0? So basically your A0 is equal to, just a moment. Yeah. So you'll not get that. A0. Okay, so what happens is that you get it as an empty list. Reason being, it searches for, when you check for A0, A0 is a dictionary, okay, and it checks for the keys to be 1, 2, 3, 4, 5, and it is not. It is the values which are 1, 3, 2, 5, 4, whatever it might be. Okay, it is the values, not the keys. All right, which is why you get an empty list. Similarly, A3 is equal to sorted of A0 of S for S in A0. Okay, so we are traversing over A0 first. Okay, we are traversing over A0. We are traversing over the actual keys as such, A, C, B, E, D. Okay, so it checks for A0 of S. Okay, we check for A0 of S. So what happens? We get it as 1, 2, 3, 4, 5. You get the values for all of them. Similarly, A4 is equal to I for I in A1 if I in A3. Okay, so we are traversing over A1 this time, and we are checking if this 0, 1, 2, 3, 4, 5 is present in A3, which is actually present. Okay, and when you do A4, you see that it will give you the values for 1, 2, 3, 4, 5. Now A5 is a dict comprehension. This was a list comprehension. This is a dict comprehension. Now I colon, so I would be your particular key. Okay, I colon I into I. That is, we are creating a particular square of the item for I in A1. A5 will give you 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, so on till 9. Okay, so we are creating a dictionary comprehension by using this for I in A1. Okay, we are traversing over A1, which is a particular range of items. And finally, A6 is equal to, we are creating lists of items I into I for I in A1. A6 will give you the same thing as a list of a list. So are you clear with how these work as such? From a very top level, are you clear with how these work? Very nice. Now, there are some more things. Now, when it comes to regular expressions in Python, okay, how do we do various things in Python? So we've got an RE module. So we've got split uses a regex pattern to split a given string into a list. Okay, so split, it uses a regex pattern. Sub will find all the substrings where the regex pattern matches and replace them with a different string. Okay, and sub n will replace it like it does in sub, but it will give you how many replacements happen. Okay, for import RE, okay, my s is equal to something like blah blah blah, something like this. Okay, you have a regex pattern. Regex pattern is equal to blah, something like this. Okay, so what you do is my s dot re dot split of my s comma pattern. Okay, so the best way of doing it is typically doing a normal split. Okay, so let me do this. Okay, so what it does, it splits over the pattern BLA. Okay, BLA, BLA, BLA. The first one is an empty string, then it gives you H, H, and H. Pattern, comma, the string which you want to do it for. Okay, substitution. Okay, I'll do it for S sub n because it works similar to sub. Okay, re dot sub n, okay, of your pattern, that is blah, comma, your string, okay, which is my s. So you've got your pattern. Okay, replace blah with, sorry, I missed out this, a with pattern and my s. Okay, so it will replace the blah with BL. Okay, it will replace with a particular a. So if we take it the other way around, pattern comma a my s, so it replaces BLA by a, only a. Okay, did you get it? How it replaces a particular pattern? Everyone, are you clear with how it replaces a particular pattern? Okay, so let me go back again. Okay, so you've got your string my s, you've got the pattern which needs to be replaced. Okay, and you have an item, replacement item a. Okay, re dot sub n. Okay, re dot sub n, your replacement item, your pattern which needs to be replaced, and your string, okay, would be this way. But if you go this way, your pattern your replacement item and your string, we'll do it this way. Take your pattern, replace it, replace all the items in your pattern with the replacement item A, and you get AH. So BLA is replaced with AAA, and it gives you how many times it has been substituted. Are you clear now, so Roma? Okay, so let's continue with our questions. What is inheritance in Python? Okay, inheritance is basically gaining the attributes and methods from one class into another. So from the parent class to the child class, or from the base class to the subclass as such. Okay, now, so there are different types of inheritances. Okay, so there is single, there's multi-level, there is hierarchical and multiple. So typically the highly used ones are either single inheritance or multiple inheritance. Now, how does it actually function? So where a derived class acquires the members of a single superclass is known as a single inheritance. Multi-level is, one class derives from another class, which derives again from another class. So basically a derived class is inherited from a base class, and the other one inherits from the previous class as such. So D1 inherited from base class B1, okay, and D2 is inherited from, there's a mistake here, it inherits again from that particular class. Hierarchical is base, one base class you can inherit multiple child classes. So basically it might be something like this, hierarchical. So class, my class, class M class, my class, M2 class of my class. So this is hierarchical inheritance. You have to be careful while using hierarchical inheritance, because if you are instantiating both the classes, you have to be sure as to which one you are going to use. If it is going to be using from M class, or is it going to be from M2 class, if it is deriving from the same one. Okay, you have to be very careful, especially with the functions which have been derived from the base class as such. Okay, now multiple inheritance is where you derive from multiple classes. Okay, it is from multiple classes. So my class, so another class will derive from my class, comma, my C2. Something like this. So child will derive from two different superclasses as such. Are you clear as to what exactly inheritance is? So you've got an example here, V1, V2, child class, parent class, pass, and V1 and V2. Okay, so this is basically what you mean by inheritance in Python. Okay, moving on to the next part. It might not be relevant to everyone, but people who are moving into web application development and specifically to Django might find it relevant. Okay, now this is a question. So mention the Django architecture. So there are various patterns which are available. So you've got MVP, you've got MVC, you've got MVT. Now MVT is a model, view, and template. It is similar to that of MVC, which is model view controller, but here what happens is that model is similar to both of them, both MVC and MVT. The view over here functions as a controller itself. Okay, and this the view in Django functions as a regular controller. It takes care of all the controller aspects, whereas the template, the T, okay, is similar to the view, MVC. So basically view, it is the T, that is template, is similar to the V in MVC, that is the view in MVC, because T is basically the templating part where you have your HTML templates, your text templates. You've got different types of templates, typically your HTML templates. Now you've got your model, which is part of your database, where you define your database as such. Your database schema is defined in the model. the view and the template maps the model. So basically the developer provides a model and the view, and the template then maps it to the URL, and Django does the magic to serve it as such. Okay, you've got the model, you've got the template. It is then taken up into the view and given as a URL through Django to the user. Are you all clear regarding the model view template structure as such? So templates would be your regular HTML pages which contain dynamic elements in them. Okay, for example, let me just give you a simple template as such. For example, I have something like this: HTML/HTML, head, /head, body, /body. Okay, your head can contain dynamic elements. Okay, my title, something like this, a variable called my title, where, let me just do this 1 second. My body, something like this. So my title and my body are information. This is a template. Okay, so the view will pull up information from the model. Probably all the titles and body information is in the model. Just an example, okay, is inside the model, which is inside your database. So what it does is it takes up the title, it will populate it with the title. It takes up the body, it populates with the body, respective body, title, body, title, body. So you can have hundreds of items, and you can have a single template serving different types of templates. Does that answer your question, Roma? Okay, so now explain how you can set up a database in Django. So we'll go with a default database, which is SQLite, which stores data as a single file in the file system. So you can also have databases like Postgre, MySQL, Oracle, MS SQL, other than SQLite. But then you need to use your administrative tools to create a new database. You know, for example, you might have to use something like 𝐏𝐲𝐭𝐡𝐨𝐧 or something like that. Okay, to create your database as such for your project. So basically, either way, with your database in place, it tells Django how to use it. Okay, this is where your settings.py file comes in. So you, in your setting.py file, is where you do all the configuration regarding that particular database, or your web server information. All these things go into your setting.py file. So you've got your databases. So databases will tell you the default, or your standby or your slave or whatever it might be. So the default database, you would typically have a SQLite. So you give the name of the engine, database DB backends, SQLite 3, because SQLite 3 is your particular database, and you direct it to a particular base directory name. So base dir has to be also mentioned over here, and db.sqlite 3 is your actual database. Okay, it is going to be the name of your particular database. Okay, similarly, there might come another question as to where do you where do you have information regarding starting your web server or anything like that. So that comes under something called as manage.py. You've got another file called manage.py. So be sure about setting.py and manage.py. Are you all clear on that? All right. Now, how do you write a view in Django? So we talked about templates. I also showed you a simple template which we have. Okay. How do you write a view? Okay. A view is similar to a controller which pulls up information from your model and your template and serves it to the user. An example is like this. So you have a views.py file where you put from django.http import http response, because you are going to give out an HTTP response. Import datetime. So what this particular view does is that it returns the current date and time as an HTML document. So basically you'll get an HTML response and an HTML file which shows the current date and time. So it will contain, it is now blah blah blah. Okay, say it is now, I don't know what time it is, so somewhere around 11:10. It will give you an output saying it is now 11:10 a.m. or whatever it may be, because it pulls the information from datetime.datetime. Now puts it in the HTML and replaces this %s by that information, and returns you the HTML response. Now you might be thinking, what if I have template files available? So in that particular case, you have to first use the loader to load in the template by doing a get template, okay, and then you have to serve the response over here by rendering the template. Okay, are you all clear? Okay, so you have getting the template, rendering the template, serving your responses, and how to write a view in Django. So what does Django template consist of? So it is a simple text file, as I showed you. It can be of XML type, CSV type, HTML type, and n number of other types as well. It can contain variables like I just showed you earlier, my title, my body. It can be replaced by various values when the template is evaluated, and the tags as well. You can change the tag information that controls the logic of the template. So you've got your database mod, which is controlled by the models.py file. You've got your views.py file. You've got a separate template folder which contains the various templates, and you have your URL or your URL views, which is your particular. So basically, you create your root. These are all your roots, which are your URL. And you pull up your, this URL root through the browser, and it will render the template and give it back to your browser. This is the workflow of a particular, HTTP request as such. But what does a template contain? XML, CSV, and HTML as well. Are you all clear? Now, this is a question which comes up. Explain the use of session in Django framework. Okay. Now, it is possible that you might get a question like, okay, so I have a particular user who's logging in at, say, 11:15, okay, and he probably keeps himself logged in, okay, and he leaves the particular place, okay, and after like another 2 days, he comes back and he sees that he is still logged in, okay. So how do I, this is another way of doing the same thing regarding session. How do I see to it that the user logs out after a particular time? So that is where you make use of something known as sessions in Django. Okay, so Django provides a session that will allow you to store and retrieve data as per site visitor basis. So you will create a random session. It could be a random keyword as such, which would have the session data. For example, it might contain cookies. It will contain session ID cookie, so that it will be put from the client side, pushed to the client, it will serve on the server side. So in case your session cookie has a timeout, it will tell after 2 hours you're supposed to log out by default. So even if the person comes after 2 days and tries to enter that without a cookie is a session, okay, it will tell that you have been logged out, please log in again. That is where session IDs and cookies come into picture. Okay, so this is very good for security as such. Okay, it is very good for security. That way you are not pulling data from the server and storing it on your client side. Are you all clear what a session is? So it is a certain, basically an ID which allows you to keep your users in check. Now, what are the different types of inheritance styles in Django? Okay, so there are 3 possible inheritance styles. So you've got abstract based classes, also known as ABC. You've got multiple table inheritance, and you've got proxy model. So what is an ABC? So the style is used when you want parents class to hold information that you do not want to type out for each child model. So basically you will have a particular parent class, okay, and you would want the parent class to hold information, and you do not want to create it for each and every child class as such. That is where you use an ABC as such. So ABC is also used to create particular classes, okay, which are not completely, implemented as such. It is a better approach than, just creating empty classes as such. Exactly, you cannot instantiate an ABC in Python as well. So you can, you have your child classes derived from ABC because it is an abstract based class, and you will not be able to, instantiate a base class as, abstract class as such. Okay, it has to come from the child classes which are created from that. Okay, similarly, you've got multi-table inheritance. So you've got an existing model, and you want to, create a model based on, that existing table. Okay, another particular model based on that existing table. So you don't have to write each and everything down. You can inherit from multiple table as such. Okay, you want to say, you have a class called book, you've got an article, you've got two different classes. You do not want to create a particular class which has got all information regarding book and article from scratch. Instead, you can just derive from those particular classes as such. You can directly derive from those particular classes. But please remember one thing, you have multiple table inheritance. So by default, so it allows you to override basically existing functions as such, but in multi-table inheritance, it does not allow you to do that. Okay, are you all clear on that? Now, what are proxy models? Now, proxy models, so you can use this model if you want to modify the Python level behavior without changing the models field. So you can create proxies where you are making changes to the actual database via an existing, a proxy of the existing class. So you create a particular model. So model defines a particular table. Now you want to make changes to the table. Okay, you have different behaviors for that table. You can just create proxy models for that. By doing proxy models, you can have multiple behaviors without changing the actual behavior of the base model itself. That is where proxy models come into picture. Now, what is contained in a field class? So as simple as that, what is contained in a field class, a Django field class? So it will contain the database column type if it is integer, string, varchar, or anything like that. The default HTML widget available while rendering a form field, whether it's a text box, whether it's whether it's a particular email, you've got an email text field, something like that. You've got different types of field classes. Okay, you've got a password field, anything like this. So that is the default HTML widget and the minimum validation requirements. So number of characters which you can enter, number of lines which can be in the text box, all of this come in the field class. Please remember this: minimum validation requirements, default HTML widget, and the database column type. Okay, coming to the next section, that is web scraping using Python. These questions now. So how do you save an image locally using Python whose URL address you already know? Okay, so there are various ways of doing it. So this will work directly if you're using from your local. So your local, it would actually work directly. So typically what I would do is something like this: Python port requests, my URL is equal to www http google.com, this requests get URL. Okay, so you see that you are getting response r is equal to request.get. Let's do this with open of image.png comma wb as f dot write. Oh, sorry about that. It should be, let's see, read as right. This, sorry about that. I made a mistake in the syntax. Okay, we need to do encoding also because it is not allowing me to do r.text. It's giving me the encoding of the image. Okay, so this is the encoding of the entire image. We need to encode it and then write, and then you would have your image ready. You'd be able to save your image as such. Okay, you'll be able to save your image. All right. Now, how can I get the Google cache age of any URL? Okay, how do I get the Google cache age of any URL? Let's do one thing using the following format. So if you use webcache.google user content, so I'll open this up. You can actually do this. So your URL, for example, www.edureka.co. So you'll be able to get this information. So you'll be get the cache content. This is the cache content. okay, which has been provided by your CDN. Okay, so this is your cached content, and you will be able to get the cached content by doing this webcache.googleusercontent.com search so and so. Okay, you can do this. Now, you are required to scrape data from IMDb top 250 movie pages. It should have fields, movie names, year, and rating. How do you do this? So this would probably come up as a coding question. Okay, typically not as complex. You might get a simple one. So how do you approach this? So you would have to get into imdb.com first, okay, and get the information first. This particular thing. Are you all following me so far? So you go imdb.com top 250 movies. Okay, so there are various ways of doing it. Okay, but for this you have to start with Beautiful Soup. One is Beautiful Soup. From BS4, import Beautiful Soup. Beautiful Soup is a parser, so basically an HTML parsing library. Okay, it's used for web scraping. It's heavily used for web scraping. Import requests. Request will get your information. Okay, so URL is equal to. So you have your URL. So soup. So you create your response. That is by using request.get URL. So you'll see that you will have a response 200, which means to say you've got the response object, which contains the text, which contains all the information regarding that particular page. Okay, and you need the text from that, and you need to parse the text from that. For parsing it, this is how you go about it. First, open up the page, inspect this page, okay, and check what you need. So what you need is the fields movie name, year, and rating. There are various ways of it. One such way is this particular thing. Soup.find children for movie in tr movie.find. Find is a command to get all the instances of this TD, the TD class containing column name, title, column. So class containing title, column. Similarly, year will be in title, okay, under your secondary info. Again, you have rating column, IMDb. You've got a whole lot of information, but that has to be first passed over here. Okay, so typically I would come here, go over here, and I would first do a check on this. So what I need is the TR content. You will see that you have got various TRs under lister list. Just a second, Roma. Let me just go through this. I'll tell you what exactly Beautiful Soup is used for there. So this is how you do it first. First you get this lister list. Okay, you have a list. So let's do soup is equal to Beautiful Soup. So you've got soup is equal to Beautiful Soup, right? So you are going to do this. Soup is equal to Beautiful Soup of resc.txt. So what is going to happen? It is going to create an object called Beautiful Soup out of the response that you have gotten. The response dot the text part of it. Okay, so if you check soup, it would have pulled up all the information and created a soup of it. Are you following me so far? Okay, now what you need is soup dot. So your question was soup is equal to Beautiful Soup. You need to find something. So soup dot Beautiful Soup. This is what it does. Now we'll do this. Okay, I want lister list. A list is equal to soup dot find. Okay, so dot find class. So you can do this, something like this. We don't want TD, we want tbody. Okay, class is lister dash list. So this is supposed to find me one single item which contains the class lister list. Okay, a list. You'll see it would have pulled up that information regarding the tbody. Okay. Now the tbody, we need tr. Okay, so we have got a list soup dot find all. So TRs, my TRs are going to be soup dot find all TR. Let's check what we need under TR. Okay, TR, we just need the TR information. Okay, we just need the TR information within this particular thing. Okay, TR, not soup dot TR find all. So we want a list.find all. Okay, I think this will not go in with that, or you can use find capital TRs. Okay, it will give me all the TRs in this, all the TR information in this. Okay, now under this we need specific information. So this is how you go about it. Under this, okay, for TR in TRs, okay, print. I'll just give you one example. Okay, post column. Let's take this one for example. Okay, expect. You have something called title column. Okay, class title column. Now you get to the point of title column. Print tr.find class colon find, we want td comma class colon title column. So one by one we enter into this part. Put it within quotations. Okay, so it fetches me all the title column information. Okay, so let's refine this some more. Dot text. Okay, it will give me all the title columns. You see all the title columns here have been pulled up. This is how you pull all the information. Are you all clear on how to approach this particular problem? Okay, next, data analysis using Python. Now NumPy is one of the modules which are heavily used in Python. Okay, so how do you go about using this? So you will get a particular question saying how to get indices of n maximum values in a NumPy array. Okay, so you have to use these particular things. Import NumPy as np. ARR is equal to np.array. You are going to have n number of items. Please remember this: 1 3 5 4 5 4 6 5, something like this. Okay, now you can make use of argsort. There is a particular thing called argsort. ARR.argsort will give you the indices for this particular thing. Okay, in a proper order. Okay, sorted indices. So what do you need? The top 3 positions. Okay, top 3 items. So -3 colon, so 2 4 and 3 of colon -1. So 3 4 and 2 is the answer which I get over here. Okay, what is the difference between the NumPy array and a list? So let me tell you this. Okay, just give me 1 second. So let me recreate this array: 1 3 2 4 5 ARR.argsort of -3 colon of colon -1. Okay, 4 2 3 is the output that you want. Now what do you want? So what you want is the difference between NumPy array and list. So we'll go get to that. Just give me a second. Import NumPy as np. A is equal to np.array. So we'll first do this particular. How do you calculate a percentile with Python? So we'll go to this first. Okay, and then we'll move on to that particular question. We have got a couple of things. Something like this. P is equal to, or we'll just do this, np.percentile. np.percentile of a comma the percentile level. The 50th percentile would be this 5. Okay, so you can return the 50th percentile. So you can directly feed in the percentile level and you will get the information regarding the percentile level. So this is a question which you asked Roma. Okay, what are the differences between NumPy and lists? Okay, so it is much more efficient because all the structures have been written in C with Python. You have vector and matrix operations for free. So basically something like this. Okay, I have got L1 is equal to 1, 2, 3, something like this. Okay, so L1 ARR is equal to np.array of L1. Okay, so we'll create L2 as well. Okay, now if you do L1 plus L2, say you want to add items of L1 to L2, so 1 plus 1, 2 plus 2, 3 plus 3, 4 plus 4, 5 plus 5, and 6 plus 6. L1 plus L2 regularly would give you something like this. But if you create an array with a NumPy array, this is what would happen. L1 ARR plus L2 ARR would give you 2, 4, 6, 8, 12. Does that answer one of your questions, Roma? Okay, so this is one of the examples. Okay, so you get a lot of vector and matrix operations, so that you can avoid unnecessary work of recreating those vector operations. NumPy array is faster. You get a lot of built-in with NumPy, FFTs, convolution, searching, linear algebra, histograms, etc. You've got a whole lot of stuff which is included. So what about the lists? So lists are general purpose containers, effective in regular insertion, deletion, appending, concatenation, etc. And it is dynamic in nature. Okay, but it does not support vectorized operations like element-wise addition, multiplication, division. All these particular operations are not supported, which is what the advantage actually is. Does that answer your question, Roma? Yes. So Roma, so NumPy cannot store different data types in a single array. It is homogeneous when it comes to a single array. But you can have arrays of booleans, you can have arrays of strings, you can have arrays of integer, float, etc. separately. Within a single array, it has to be homogeneous. Okay. Now, what is the difference between NumPy and SciPy? You've got something called NumPy, you've got something called SciPy. These are two different modules. NumPy is a much more raw module as such, if I were to say. So NumPy would contain nothing but the array data type and the most basic operations like indexing, etc. Your numerical code is typically inside SciPy. Okay, but you would see that NumPy and SciPy are quite compatible with each other, because SciPy is built on top of NumPy. So where SciPy has retained all the operations of NumPy, but it's got a whole lot of its own operations. For example, NumPy contains linear algebra functions, even though they are more properly utilized and they more properly belong to SciPy. You can contain integration, differentiation, all these operations are provided in SciPy. Okay, and it's much more easier. SciPy contains more fully featured versions of linear algebra modules. So if you're going to do scientific computing, it is advised to use both NumPy and SciPy together. Okay, which is a recommended thing. So instead of using it independently, you do not want, so it makes more sense of doing something like that. Okay.